I mean, somebody just needs to go do it. Just go out to some water and make some observations. Like, why hasn't anybody done that? Put this whole thing to rest. I mean, it looks flat. The water looks flat, but looks can be deceiving.
No, that'd be the physics of water. Yeah, not just that it looks flat.
The physics of water. Okay, yeah. So the physics of water is that water at rest is going to be flat. Yeah, I'll agree with that.
So then where's the curve if 72% of the Earth is water?
Well, that water's not at rest, though.
No, we're talking, we do have what we call a mean sea level because water lays level. Yeah, we may have some wind and some waves and stuff on the surface, but we have a mean sea level, which all heights are taken above or below that mean sea level. Because water, we use it as level.
Mean sea level.
Yeah.
How do you get it? How does the sea level, the mean sea level, how's that calculated?
It's an average.
It's an average.
It's level, so it's the average height, yeah, of the ocean surface.
Well, it's in the name, mean. And it's not average. It's a different mathematical function, mean than average, right?
Is it? What's the difference?
I don't think there really is a difference.
Mean doesn't include the outliers, right?
Really?
Just Google mean versus average. Yeah.
I thought they were synonyms.
No.
Well, from my understanding, mean sea level is supposed to be the average of the surface, but it's calculated over a longer period, as in
Wait, hang on,
years,
you're wrong.
And smooths out your tides and waves and weather that's affecting that ocean. Yeah.
Mean and average is not the same.
Mean does include outliers. So it seems that average is a bigger group that includes mean. So average can mean mean, but it can also mean median or mode.
The mean and the average are calculated differently. A mean is not the same as taking an average. An average, you just take every quantity and then divide it by the number of that quantity. That's not how you get the mean.
Isn't that the mean?
No, the mean is where you take like the largest and the lowest and subtract them.
That's not the mean.
It's been a while.
What you just described as the average. That's what the mean is.
No, it's not.
Yes.
Well, no, it's
just
not.
Look it up.
The computer, you look it up.
Okay, I just did. I was saying what I said because I looked it up, and you're saying something that is not matching what I found.
Post the definition of mean, and then post the definition of average.
Sure.
Okay, because they're not the same. Mean. The mean is also known as the average, and it is calculated by adding up all the values in a data set and dividing by the total number of values, median.
That's what I said. And you said it's not what it means. You said it means adding the lowest and the highest. That's not. That's wrong.
I'm reading what you fucking put, and you gotta like interrupt me. Come on.
I didn't put anything. What are you talking about?
Oh, okay. Somebody else put that. Okay, that wasn't you. My bad. That was over fences.
That matches what I said. What it says is the mean is what I said is the mean. And then you said mean is something else. You said mean is you add the lowest and the highest value. That's not how you get the mean. You just add all of them and divide by the number of them. That's the mean.
Reading something somebody posted. That's not that wasn't my own thoughts. I was just reading something.
At the end of the day, the mean is a specific mathematical term, yeah? So the mean is the result of adding all values in a set and dividing the number by the values.
Yeah.
So the mean divided by the sum of all values or the number of the values. Your average is just a general informal term. Yeah.
Exactly.
So when
they can mean the same thing. They can mean
I thought that was a proven fallacy.
So if you have a look at any information on mean sea levels, however, they talk about making that calculation based over a long period of time. So I believe most I've seen talk about a 19-year period where mean sea level is the average height of the ocean surface over a long period of time, calculated to smooth out all of your short-term effects. So like your tides, your wind, your waves, etc. So
Yeah. I think I got a mean mixed up with the median.
yeah. So then your mean gives you an average height. Although general is still average is still a general term, yeah. But it's conflated this way, I suppose. That's what you'd say. They measure mean sea level, and then they say that we have an average height after we take away all of the wind, waves, weathers, etc. But regardless, we all know that physics of water states that water is level on the surface. Horizontal, not curving.
I think we just proved Peter wrong on that because he said that the mean and the average weren't the same, and I don't know if he's agreeing with what I said, but we should unmute him because we should see it because pretty much he was wrong about that. Then, right? Let's see what he has to say.
No, I don't know. I
he
think
probably also thought mean meant median. I don't know, because he said that there are no outliers, so I think he was referring to median, not mean.
What say you, Peter? Did you get that wrong? Did you have mean and median mixed up?
Peter?
Yes, I think so. I think I mixed it up with median.
Okay.
That makes more sense.
Because in statistics, there is a situation where you take like the outliers of the bell curve, for example, like the 3 sigma or whatever, and you just ignore them.
Right, but none of those are mean, median, or mode, or average.
I think median, like I know that one way of measuring income, for example, is that you exclude, Bill Gates, and you exclude the homeless person, so the extremes of the bell curve. And that gives you a different insight than an average would, because average in some situations can be heavily impacted by the outlier, right? One big outlier.
I think you're referring to the mean, not average, because average can mean mean, but it can mean median. Like average is a loose term that can mean different things.
Yeah, but mathematically, average.
Does it make the Earth a ball, or does that make the Earth flat? It
doesn't matter. We're kind of going on. We're enhancing our understanding of mathematics right now, unrelated to the shape
terminology.
Of the Earth. So
I think that we sorted that, but it did relate to the shape of the Earth.
Yeah, you nailed it.
The claim was that from myself that water lies flat and level, and we have a mean.
Yeah, absolutely. Like no matter how you slice it, it's flat.
Hey guys, I'm new on this chat. What are you guys like discussing right now?
No, you're not, Mike. Shut up.
Bicycle tires.
So Bacon, I think what I meant was average is always basically add everything up, divide by n, right?
That's the mean.
But then, it's synonymous with average in that sense.
Yeah, but the average is just.
That's what I thought, but it seems the average. Yeah. That's what I thought. I thought mean and average were synonyms, but average can actually mean other things. Like average can mean median, and it can mean mode. I never seen it be used like that, but it seems it can be used like that.
I think median, now that I stand corrected, is
median you sort all the values and you pick the middle one. That's the median.
Oh, okay.
Median is basically the value that separates the bigger half from the smaller half.
Like median in the center lane. Yeah. Okay, but in statistics, there are different ways. I'm pretty sure there's one where you exclude the outliers. But anyways.
Okay. Yeah. removing
If you were to
outliers.
exclude, I got a question about that. If you were to exclude the outliers in the example that you gave earlier, and say we were talking about money, and you said we excluded the extreme poor, or maybe someone like Bill Gates, how does that then give you an accurate figure or understanding by removing those outliers? Is it then?
It doesn't. You're simply asking a different question and looking for a different answer, right? Than you were if you were to ask with.
Let me give you another example.
The outlier skews the whole graph, just like that's why.
It's not like one of the questions gives you the truth and the other one gives you a lie. It's a different question, different answer. That's what math is.
But I think there's a good example.
Starting point, yeah.
There's a different example why you would remove outliers. Let's say you're taking, I don't know, you're noting down, like you're weighing an object and noting down the values, and then you want to take the mean of all those measurements to have a mean value of the weight of an object. If for some reason you forget a zero, so you record a weight that is actually 10 times smaller or 10 times bigger, then that's actually a crappy reading. And if you include that in the mean, then the final answer is going to be much more wrong than if you remove that. So if you have values that are too discrepant, you can just remove them because they're probably bad readings or bad measurements. And they contaminate the mean.
Yes. And obviously that's a good technique if you're taking a lot of measurements, and then you know that inside of them will be a few bad apples, so to speak.
Yeah, outliers usually are bad apples when you're referring to like data that comes from measurements.
As we know from having been taught by Quantum Eraser about the scientific method and, the control variables, independent variables and dependent variables, sometimes you're not aware of the control variables, right? Like there could be some random noise in the sample set, and one kind of crude way of eliminating them is that.
I actually saw a bunch of different ways of eliminating outliers, but not in statistics classes, but in AI classes.
There you go.
Because you want to train models, you don't want to train with outliers in the data set, because that might fuck up the model.
Anyway, who I wasn't talking to. I wasn't looking at who I was talking to originally because I'm working at the moment. I'm doing rosters, but whoever it was, they jumped in and said Earth was a ball. Who was that?
And he's probably ashamed to admit that at this point.
Wasn't it Protect Hate Speech? I think it was Protect Hate Speech, wasn't it?
Yeah, I don't know. I wasn't looking, man. I was typing.
Yeah, sorry guys, that was me. My bad.
That's a very cool handle you have there, Protect, because most people we interact with here who imagine the Earth to be a globe, they usually resort to hate very quickly in their speech. They become anti-flat earthers as a defensive mechanism against their cognites. Right, Bacon?
Yes.
Some of them can be reformed, like myself, and perhaps Bacon, but others just become even more and more kind of...
Your LARP is getting old.
No, your LARP is getting old.
These people would step in here thinking they're going to find like the easiest debate ever, that they're going to debate people that can't defend what they're saying because they're stupid and didn't go to high school, which might be true, but they actually can defend pretty well. And that puts people in a defensive position quickly. They don't want to lose a debate to who they think are high school failure losers.
A lot of them forget the fact that after high school, there are multiple years, like many years, decades even, of research that one can do. So whether you graduated or not, that doesn't mean you couldn't have spent, 20 years doing research after that.
To be honest, I've learnt more since I left school than what I learnt in school.
My point exactly.
But I will say that I've learnt what I have an interest in too, and I think that was my biggest problem at school. If I didn't have an interest in it, I didn't do it.
That's how I went on college. It took me 8 years to graduate because I kept failing the things that weren't interesting.
I've heard the high schools in Australia are crazy, especially on the Gold Coast or the Northern Beaches high schools. Have you ever heard of Cromer High? It's wild. Like they were just partying. Like the teachers are all partying with the students and having like orgies and stuff. Australian high school is crazy.
That sounds like my type of high school, but unfortunately, I didn't go there and I don't know anything about it.
I heard the high school that Crocodile Dundee went to was pretty wild.
I would have been out in the bush in the middle of nowhere, so probably. Oh, no, I don't know where he lived, actually. I'm just thinking about the movie.
Have you ever heard of Chris Dawson? He was a footballer in the 70s, and then he taught at the Northern Beaches high schools in Australia, and he started banging one of the students, then murdered his wife, moved the student into his house, and she just like took over the wife's life.
No, didn't hear about that one.
Was he an Aussie rules footballer?
He played for the Jets. I think he had a twin brother, him Chris Dawson and something else Dawson. They were twins, and they both were professional footballers.
So American football then.
Oh, Australian, yeah, Aussie. Or no, maybe it was rugby. Maybe it was rugby is what they actually were playing. Can't remember.
Easy to confuse them.
What year did you graduate high school, AJ?
I didn't. I finished school in year 8 in 19. I'm going to have to say 1995.
Okay. Well, all these orgy parties on the Northern Beaches, Cromer High School, that was going on, and I think it was like '88 or like '87. So maybe they calmed down by the time you got there.
Yeah, I was in North Queensland anyway. I was nowhere near the Northern Beaches.
Uh,
Are y'all here?
We are here.
So is the discussion over? Or?
Pretty much.
Not sure.
Oh, okay.
You got any evidence for that ball?
Evidence? What?
Yeah, I don't even
Do
know
you-
who I'm talking to. Who am I talking to?
Oh, just a new guy who came in here who's just curious about flat Earth.
Let me have a look. What's your name?
It's B Phil.
What's your name?
Yeah, sometimes I ride motorcycles, and like it tends to have like a little slope on the track sometimes, So
Oh, yeah.
yeah,
So definitely can't be flat then, eh?
yeah, exactly.
Can I post like a video?
I don't know. Give it a try. I don't know if you got the permissions or not, but I can't give them to you.
And how else are we going to research?
It's the best video I've come across in like a year.
Must be good.
That's a bold claim.
Yeah. Well, yeah, for flat Earth veterans,
Unless you meant 2026, then it's a pretty modest.
So, I mean, some of you guys probably already watched it, right?
Dude, we've seen all videos pertaining to the shape of the Earth.
No, it's a documentary about a guy that lives on a boat. Have you seen it?
Does that have something to do with the Earth? Or is it just a guy that lives on a boat?
Yeah, he's like a full conspiracy, knows all of it.
Oh.
Well, I mean, he lives on a boat.
Is it India?
Does India live on a boat?
Yeah,
I don't
he's
know.
like
He would never tell me where he lives.
he's like
refraction while he's on the boat.
Oh man,
Do you
I
guys
fucking lost it.
Do you guys have evidence of like the Earth being flat or something?
Oh, we were just discussing that.
Oh, okay. So I missed out.
We can start with water if you like.
Oh, we got. Well, you know what? I guess like if you come in here and you think it's not flat, I guess that's like your question, right?
No, I'm curious. That's all I am. I'm just curious the evidence you all have that it is flat.
Yeah. Well, give them the best evidence, guys.
Yeah, you just look around. There's water flat. Go make some observations. I mean, what about the Earth to you looks round?
No, I'm asking you. You say water's flat.
Well, I answered water. Yeah, water. We've used it as a level for thousands of years, and it covers 72% of the Earth. So, where does this flat, level, horizontal water curve?
Just give them the best proof. The best proof is that the curvature of the Earth is not measurable. If you measure the curvature of the Earth, it's not true. You can look at distant buildings like the Chicago skyline, and it's not curved. There is no curvature.
Yeah, so I asked because I've like you take a flight from Salt Lake City, you go to Seattle. From Seattle, you go to Seoul. Then from Seoul, you can go into Europe, and then from there you can fly back back to New York.
So what?
So like, I'm just saying I've done that. I'm just. How do you explain that to me? Like I can go.
Well, what do you want to explain? What do you want to explain?
Like, how is that path traversed? Are we like going around in a giant flat circle, or how does that work?
The best perspective that the best people have put forward is that imagine that you live in a huge pond, and that the continents are like islands on the pond. So you're allowed to like traverse between the islands in the pond, right? So that's like, basically how life works.
Right. But if I'm going over the Pacific to Seoul and then I'm going over the Atlantic to New York,
yeah.
Like how so it's just Like, is there a split in the United States of America somewhere, or?
Well, why would there be a split? What does a split mean to you?
Because like if it's all one landmass and the Atlantic and the Pacific are like on opposite ends of the United States of America.
Yeah, you went through the ocean and went to a different land.
So like when does the flatness stop on that though? Like I'm just confused.
Well, I don't know if it stops. I'm saying that if you traverse along a long distance, you go to a different place.
Oh,
it's kind of how it works.
Yeah, do you have like a map that you could show me like how that looks?
How what looks?
Like how that path looks. I'm genuinely confused. Like, you know, I just be fine. I'm a tourist and stuff, and like I've heard some stuff, but like I'm really curious. Like, what would the map look like of that flight path? Do you guys have like a map how that looks, like how the continents are laid out in a flat way where I could fly like that?
I mean, you could even look at a globe. I mean, you could look like they use their own.
So I just have
flat maps. Well, you could. I mean,
because like when you look at Google Maps, right? Like it eventually like repeats on itself.
Really?
Yeah. Like there's like a connection between both of those sides, right? We got the Atlantic and the Pacific, and then you kind of, if you go all the way left, right, you'll eventually end up back at the same spot, which is where I departed from, which is Salt Lake City.
Right.
So like, how does that work without, you know, kind of like?
Well, I mean, maybe you just like think of the Earth as a table, and that you just went from one part of the table to the other part of the table.
Okay, let me see. How does that work? Okay, if I'm going from one part of the table to the other part of the table. Okay. Okay, so Atlantic's right here. If I go right here, I landed Vietnam. I go right here. And I go over here. Yeah, I don't know how that will work on a table. Maybe I'm because like when I look at these land masses, like there's this big like piece of ice down here, Antarctica. And then I see
Did you go to Antarctica?
No, I'm just trying to look at the bounds of this map that I'm looking at, the table that you're saying.
Well, I mean, you made the table.
No, I'm asking if you have a map to show me that, and you said think of it as a table, and so like I'm trying to think of it as a table.
So you posted a flight map. You can just look in the chat; it's right there.
Okay.
Yeah, there's so many different maps. You can look at a picture of a lot of people's description of what a flat Earth map should be. I'm personally agnostic on the map because I think that it is probably not what the azimuthal equidistant map is, but look at the azimuthal equidistant map.
Oh, I see now. Okay, so like we're actually just going in a big circle. Okay. I never pictured it like that. That makes sense now. Okay, that's why maybe I need to go to flight school or something.
Wait, what?
So like what about like
what's a big circle?
What about like the satellites and stuff? Like how do they like I've seen pictures when I was growing up in school and stuff.
Well, and I'll give you my take on satellites. NASA is the highest consumer of helium on the planet. So from my perspective, they have a bunch of balloons with stuff attached to them in the atmosphere right now. And you could call those satellites.
Bunch of balloons. But hold on, can you paint that out for me? Like Like, give me a picture. Because we're humans, like we're very visual creatures.
Yeah.
Right? You're saying like look at the water and look at this and that. So, like paint it.
Like imagine like you're on the ground. You got like this like thing that you want that it's like a computer, and it's got Wi-Fi and all that shit. But it's like you want it to be like available to more people. So you're like, okay, well we'll get it up in the air. So how do we do that? NASA has like these huge balloons that they can take stuff up into the air. And so you're like, okay, well that seems, pretty cool. And so they're down there with like a bike pump, pushing the air into the balloon. and they eventually launch it up into the air, into our atmosphere.
Whoa. Okay.
And that's kind of how it works.
They launch it into the air and atmosphere, and that's kind of how.
You mean like a weather balloon?
I get that. He painted a pretty good picture there. I actually had one more question because I started looking at. I just typed of pictures of Earth from space, just to kind of like paint the picture more of what you're saying, right? And I'm thinking like from the map that was linked.
Hold on.
Huh? What's that?
How many pictures of Earth from space are there?
I mean, on Google. I mean, this looks like a lot. I don't know. I haven't clicked all of them to validate them though. But
like the iPhone was launched with a picture of Earth from space. And everyone's home screen was a picture of Earth from space.
Well, I'm honestly, man, like I didn't get to have an iPhone as a kid. I was kind of, like, and I don't have an iPhone to this day, so I don't know what you're talking about. Exactly.
I thought that there were rich kids for me because I only had like a basic phone.
Was his point?
I was like, I wish I could have an iPhone, but it was like a lot of money back then.
Yeah.
You had to pay for a data plan.
Exactly. Yeah, so I don't know what that picture looked like. That's what I'm just trying to say. And so like when I'm looking at these pictures, they make it look really round, but I mean like I really want to understand this perspective. So like this map is very interesting. So if this water goes on like I guess infinitely in a way because there's probably not an edge, like where does the sun go when it like disappears at night?
It just goes to the other side of the earth. I mean, like in Asia, when it's sunrise in the United States, it's like sundown in Europe.
I know that's what I'm saying.
I hope I'm getting that right.
What is down? What do you mean by down? Like down where?
Looks like it's going down, but actually isn't going down. The sun is always above the surface of the earth. So it only looks like it's going down because of the way the human eye works.
Right. It looks like it's going down, but that just means it's going farther away from you.
So then you're saying the continents are spaced further out apart than we actually have been led to believe.
No, I didn't say anything of that. Sorry, what do you think about that?
Well, because like when you're saying it's getting further away from me, in my mind, like if it's further away, like that's when things start to shrink and it gets smaller. So like if we're all flat and like if I'm looking at this map, then if it goes all the way over here, like let's say China and I'm in the United States, I mean, I'm trying to picture how that would work.
Well, think about like a light in your ceiling. Okay. Like if you have a light in your ceiling and like the light in your ceiling like went further away, wouldn't you have less light when it went away?
That's I don't know if that paints a good picture for me. Just because when you're saying in my ceiling and it went away, like did it move to the left and the right of the box in my room, or like is it going higher up?
All right. Well, all right. The light in your ceiling went out, and there was another light way farther away in the other part of your house that was lit up, right?
Right.
So,
you know what? My bad. My framework for this is a little bit off because I thought the sun was just like extremely bigger than the planet Earth. Oh, it's not.
No.
Okay,
no.
That's damn. My bad.
It's hard to make that claim, but I really appreciate why you're trying to get that image out of your head. In this instance, the Earth is underneath the sun, and because of the ratio of its distance and size, and because of the air that the light is passing through, it could only illuminate a certain portion of the Earth as it moves across it. To us, this is what causes day and night, right? As the sun takes its light across the Earth that it can't entirely illuminate.
Yeah, so like basically, like the light in the sky, the sun, just goes away from you.
Okay, so like on scale, then I guess the sun is actually smaller than Earth.
It would appear so, but it's hard to actually tell.
It's hard.
Probably, yeah, it's probably smaller, and it looks like it's pretty much closer to us, kind of like a terrarium. Do you know what a terrarium is?
A terrarium. Yeah, I do. Yeah, that makes. I've heard of it, and I have a slight picture. But like Eli 5, right? Like, can you Eli 5 that for me?
Well, a terrarium is like if you want to have a pet, and like you keep it into an enclosed space, and it is supposed to have sunlight for a certain amount of time. So you put the bulb above them, and then at other times you like remove the bulb. We are in basically a terrarium where the sun is, rotating around us.
Okay, so like if I have an iguana in like this little enclosure, right? Is that what you're talking about?
A greenhouse is, dude. You know what a greenhouse is? A greenhouse.
Oh, greenhouse is a bit okay.
Yeah. It's an enclosed environment where, because of the environment, stuff is allowed to grow.
So, hold on. Hey, Earth is enclosed?
Yeah.
Hold on, is that just an analogy for picture's sake, right?
It's up for question whether we live in an enclosed space. Some people think that. I don't think that.
It's finite, so it's a closed space.
Yeah, some people think that it's finite.
Hold on, has anyone been to like where the enclosure like ends or begin, like the wall? I don't know. I'm trying to think, like, if it's a greenhouse, right? It's like glass, right? So like obviously
not us. Not us.
Not
well,
us. Okay.
People have theories, and I'm talking to you, so I'll give you my theory. I think that the Earth is bigger than we've been told, and we are living in a localized version of a controlled Earth.
A controlled Earth. Expound on that. What, like, paint that for me. Paint that out, please.
Yeah, I would say that the topography of the Earth is an enclosed system, not physically, but environmentally. And I think
not physically, but environmentally. What's that mean?
No, yeah,
because the environment will be physical.
Well, I mean, the environment of the Earth is not similar to if you stepped outside the bounds of our environment.
What, have you been there? How do you know?
I'm speculating. What do you think?
Well,
I know these things.
This is my point, right? We're talking. I do apologise. Talking to a new gentleman who's got serious questions. Right? It's really good to point out when you're speculating things that you don't know, compared to the empirical truth that you do know about the Earth.
Well, yeah, I agree. No, I agree. I think that you have to speculate because it's so so big.
The reason why some flat earthers say that the Earth is a contained environment is because we have gas pressure. In the heliocentric model, that gas pressure is surrounded by a vacuum. According to natural laws and second law of thermodynamics and entropy, the gas should continue to expand into that available space known as the vacuum.
I don't agree with that.
Talking, dude.
Go ahead. I'm sorry. Go ahead.
So some flat earthers would suggest that there is an enclosure for our system. We are contained. That would, in some cases, cause us to have gas pressure, because gas pressure needs a physical boundary to press against. So for that instance, many flat earthers say the earth is contained and enclosed, indeed finite. Now, that would be antithetical to the claim that there is actually a vacuum in the sky, space and so on, because in that instance, there wouldn't necessarily need to be a physical boundary. But I don't think any flat earthers are making a claim there's a vacuum in the sky.
Right. Well, I think that the idea that we have a atmosphere, everyone agrees with that, right? We live in an atmosphere.
I was more talking to the other guy, dude.
Yeah, no, I'm. So, what's the commonly accepted, or the commonly researched? I guess that everyone has consensus on.
With regard to the flat Earth, that the Earth is measured to be flat and stationary.
No. But as far as what we're talking about here, the gas pressure, or maybe it's an environmental.
Well, Phil, I don't think you should get bogged down in gas pressure. What are you trying to discover? Are you trying to discover that we don't live on a globe?
You said that we live within a contained environment, right?
Yeah, and that's where it's okay, well, if we're in a contained environment, how does that? I told you to paint me a picture, right? And you said something about there's some environmental thing, or sorry, I'm trying to keep up, but there's a lot of words that I'm tracking, and
I think we live in a contained environment, but not for the reasons that the other guy was saying. So I don't know what you want to know.
You mean the firmament?
What's a firmament? Hold on, let me look this up.
Firmament's a biblical reference. So some flat earthers have a biblical understanding of the flat earth. In the Bible, it says there's a firmament in the sky. That's a solid, beaten out, solid structure by God. It's there to separate the waters above, that's the sky, from the waters below. That's the ones we swim and sail on. So it separates what's above from below. So apparently, according to a Bible, there's a firmament, a solid structure in the sky. Many ancient cosmologies believe this. Right, they believe that that's what the stars were affixed to or within. So not just Christian theology, but Sumerians, Babylonians, all across the world, apparently.
So, Mike,
there's a lot of religious flat Earth stuff for sure.
Okay, so yeah, so then now I'm not really for the religious stuff. So then, who are some of the explorers who have actually went out and tried to validate this enclosure, or are there any of those people that I can look to?
I don't know, dude. I don't know. All I can point you to is anecdotal evidence. There's some reference in the Encyclopedia Britannica about some reference to an ice wall in Antarctica.
I would say
this guy wants to continue talking for him, so I let him.
Well, I'm just saying. I hope there are more explorers. I want more explorers to go to the edges of the earth and repeat what they find. I think that's the solution to the conundrum. I mean,
okay, so is it kind of there's not people who can afford a airplane or something like that to go?
Listen, there have been thousands of people that have gone to Antarctica. They're all U.S. military. So take of that what you will. But if you want to go to a new place that's never been visited, I would say fucking go for it. If you're a sailor,
20 seconds.
Do it.
That sounds.
Wait, what about Admiral Byrd? I remember hearing something about him. And then he went on live TV.
Admiral Byrd was 100 years ago. Who cares?
Oh,
I thought that was in the 40s.
Hold on, who is this guy? Who's
yeah? It's like 100 years ago.
Who just mentioned that guy?
Wait, 1940 something. That's not 100 years ago. We're not even in the year.
It's close.
Yeah. If anything hasn't been, if anything hasn't been done in the last 100 years, it's invalid. It's totally bunk.
Hold on.
Well, I'm okay with anybody having any physical evidence of it. I'm just saying, my perspective.
Physical evidence of what?
I think that we should have teams of people going out and exploring the world.
Physical evidence of what?
That there's something beyond the Pacific Ocean or not.
Pacific?
China.
Yeah, because like the map that the guy linked, it looks like all the continents are kind of like in the center, and then like there's just endless water at a certain point, and then if it's an enclosure, then the water laps against the enclosure that we're within, that was explained like a greenhouse, and so then we don't have anyone who's actually like groups of people who have like tried to like boat or fly out there.
Who knows?
And why don't we have those people? I'm actually,
because this isn't the type of thing that you're going to hear on the 6 o'clock news. Something
the government probably did.
This Mike is talking through me again. Sorry, Mike, keep carrying on.
I didn't mean to interrupt you.
So, no problem, Mike.
Go ahead, my bad. Sorry.
No, go on, man. What was your question again?
Yeah. No, it was just like there's no consortiums that have been put together, since, or groups of people like, hey, like, let's go do this. You know what I'm saying? Like, hey, I got, maybe I got my retirement and, I got like this boat, like let's go.
Listen, that's exactly what I want to get out of people here. I'm a sturdy guy, and I would be on the boat for sure. Anybody that actually can do this, I'd be on the boat.
Is anyone in here like in the group right now, like versed in sailing or like take flight classes or anything?
Sorry, what are you guys trying to achieve? What?
Well, I'm just, because like when I look on the internet, again, like I look on the internet and
your source for truth, right?
Yeah. I mean, like,
yeah.
I mean, like, I'm a person who's not very wealthy, or, like I come from a family and I'm just trying to understand. I just came here trying to understand.
What the hell does that have to do with anything? Understand what?
I'm trying to you guys are saying it's a flat earth. And so like everything has been contrary.
No. Sorry, we're not saying that. We're not saying that. It's measured that way by the surveyors and the navigators and the builders. That's not us saying it.
Oh, so you're not saying it's a flat earth?
Yeah.
No, the surveyors are.
Who are the surveyors?
No, sorry to interrupt. What we've got here says is, I think we just got a genuine guy who's come in asking about flat Earth and so on. It's been met by Mike here, Mike Cargo. He's got some ideas. He's going on the internet and just finding out what people are saying about the flat Earth. He's come across a circle map as well, and he's trying to figure out his way around that. So I think he's got a lot of genuine questions, but I think we're struggling to have the conversation with him thoroughly.
He sounds familiar to me. I feel like I've heard his voice before, but I could be wrong. So
I don't think
circle map.
We're struggling to have a conversation. He's talking right now.
Yeah, over fences. He linked this map, and because I was just asking, like, what does that look like? Because go ahead.
An azimuthal equidistant map.
Yeah, I honestly, again, there's a lot of words that have been thrown at me. I don't know the definition of them. So
okay, so it's a map. It's a projection. Projections have nothing to do with reality.
It's the one at 32 minutes past the hour, I believe.
Okay, here. Can I add you? Says who?
Map, just to be clear.
Can I add you? Says who? The one I'm looking at. That I was trying to understand. Or is that
32 minutes after the hour? Let me just go back. 30.
Yeah, over fences.
Oh yeah, that's a map that the U.S. military used during World War II. What about it?
Yeah, and so I was just trying to. We got to the point where we were saying we're in this enclosure, right? There's like some enclosure, like at some point, right? And so, like, I'm trying to visualize how that looks with that map, and then I started asking, like, well, has anyone like tried to venture and like find that bound or that enclosure, like when they explain like a greenhouse in a way.
Why are you trying to visualize something with a projection?
Okay, how should I think of it?
You don't have to think of it anyway. You have gas pressure on the Earth. It requires containment. What it looks like, where it is, what the outer limits of the Earth are, even if there are outer limits, doesn't really matter as far as this topic is concerned.
Are you trying to figure out what the Earth looks like and the continents?
Yeah.
I mean,
at the end of the day, right? Like, I grew up in a certain way, so like I'm just asking questions.
I get you. This is when I jumped into the conversation, right? Pretty much 33 minutes after the hour, just after that image was posted, right? That's just a map. No flat earther is really going to turn around to you and say, that's what the Earth looks like. And the container for that waters will be Antarctica, because that's missing on that map. That will be the circle encompassing the waters. Now, that's just a map. That's not any idea of what we think the Earth is. Some people maybe used to think that that's what it was, but I don't think any flat earther would suggest that that's what it is now. You find it a lot on TikTok and on the internet and so on. But if you talk to genuine flat earthers like us, that's not what we think the world is, my friend.
Okay. So then what is that? So you're saying just don't even think about what it looks like. That's what you're telling me? Or
it's kind of a fruitless endeavor because there's no way for us to validate any distances between points. But what we do know, you'd actually have
anyone, like, why can't we go into the like water on a boat and go like check into these things?
Water on a boat? What do you mean?
Like, why can't we sail to wherever this place is? Like, you're saying, did you just say there's like ice or something?
No, didn't say anything about that.
Like the outer bounds? I think. Is that what you just said, Jedi?
Yeah, that's with regards to the map, right? Antarctica would be the circle surrounding the waters on the map. But there are many different types of maps. That's what I'm saying, right? There are thousands of types of maps.
Okay, and nobody goes to Antarctica. That's like, it's kind of, that's why
nobody said that.
Right? But that's not going to get you to the edge of the world. It's like going to London or to New York, right? Or to America or Australia. This isn't the end of the world. This is a place.
Yeah, I'm not necessarily saying there's some edge of the world or anything. I'm just being curious, like, hey, like what's out there? You know what I'm saying? Like, are there people who have gone out there and like
out where?
Wherever Antarctica, this endless ice thing is?
Yeah, people have been endless ice thing. What are you talking about? Nobody said that.
If we're circled by ice, like, then what?
Nobody said that we're circled by ice. That's a projection. Do you realize there's about 200 projections of the Earth? None of them have accurate distances.
Hold on, bro. I'm just asking questions. Can you just, like, Jesus, being so adversarial? I'm just trying to understand.
I'm not being adversarial. You're just asking questions about things that we haven't said. I would find that adversarial. So maybe you should calm down.
No, he just said there's the boundary of ice.
That's not what we're claiming. I did explain to you a good few times that we're not claiming that.
Okay.
And then you're saying, well, can't we go and find it then?
Hold on.
We're not claiming.
Shut up. Yeah, is you just looking at the map and then you saying Antarctica and you just saying that picture of Antarctica and you just asking questions about that? Because you're going to have to be very specific.
No, there's no map that these two gentlemen, Jedi and Says Who, have because he says it's projection. And
it is a projection.
Jedi hasn't said anything about a map. Like he said, like, kind of a slight description of what it could be and like what some people believe, but no one's like presented a map.
So no one's claiming that.
I'm trying to,
Hold on. Do you understand what a projection is? Do you understand what they're saying?
Like some type of holographic, like, like light projection, right?
No, it's not. It's not that. It's just a projection, bro. It's more of a model, and it's a model. It's a mathematical model.
I can get
Sorry, the projection comes from a three-dimensional object that will be a sphere onto a two-dimensional surface. That would be a map. So you represent the three-dimensional model when you project it onto a two-dimensional surface. You can do this in multiple different ways.
Got it.
Right. So a map, and then a map will be so the map is distorted too as well. So you can't look at it like that's like the actual landscape. You know, they don't really use the map for that.
Okay, so we don't like in Flat Earth, we don't map out what Earth is.
Yes, we do. In actual practicality, we will use a flat Earth to make measurements.
Do you have that?
Right, dude. Let me try and explain.
Okay.
When we make maps,
Fry did it. Sorry, thank you, Fry.
Yeah, that's fine. When we make maps, we will measure a flat Earth. It depends on how we then conjure up any type of reference frame or coordinate system. Right. You've heard the phrase, it's hard to map the Earth onto a two-dimensional piece of paper because it's actually three-dimensional. There are no true flat maps because the Earth is a sphere. Now, the reason why the Earth is a sphere in this idea is because of the coordinate system that's used. It's a spherical one. So, of course, it's going to be spherical if that's the choice of the coordinate system. So just want to put that to a side. What you're really asking is, can we map the Earth and can you show it to me, please? I, personally, me, Jedi, no, I can't do that for you, mate. It's not my expertise, and I'm not going to be able to go around the entire Earth and map it for my own inquiry and then present it to you and everybody else. I can't do that. You understand?
Yeah, you can only use the coordinate systems that's already around right now, which is unfortunately is just a globe projection using measurements that's flat.
Okay.
And again, like you said, like Jedi said, it is just basically a globe projection, right? They're using a mathematical model, but whenever they're doing anything practical, as if taking measurements or angle measurements within the real world, all of those are fundamentally flat because they've taken horizontal measurements while traveling horizontally as well, going back and forth, north, south, east, or west.
Okay.
You know, you asked about going to explore. Right, why can't we do that? It's the same type of thing about as my answer to mapping the world. I can't do that. Some people say that maybe we can just get in a boat and go and sail off somewhere. I mean, we could do for a bit until we ran out of food or fuel and stuff. So we needed to either take all of it with us, which is going to mean a bigger boat, or go and pick it up somewhere, which is going to be hard to do because we're not going anywhere where somewhere would have food for us. So it's a huge financial endeavour, right? And it's also a very technical endeavour as well. You're going to need a crew for your ship, even if it was an airplane. Whatever it is, you're not going to have a finite supply of resources. That's food for yourself and fuel. So it's hard to do so. Who has the ability to do this? This is what we would commonly call maybe the governments of the world, right? The ones that have the militaries, and there are bigger military powers and there are smaller military powers. Now, military, they only tell people what they want to tell people because they're military and secrets and stuff. Now, if they have had the ability to explore beyond, let's call it, the known world, then they're probably not going to come back and tell us what they've discovered on the world that, according to us, is already finite with distances. They're not going to tell us they found an extra bit, that this extra bit like a container or a wall, because that would be antithetical to any idea that they gave us about the Earth being a ball. So maybe someone has, but they're not going to turn around and tell us.
Got it. So like no one here wants to go, no one's curious?
Curious, yes. Understanding that there's absolute fundamental things that we can't cross. The ones that I brought up as well. 2, which direction are we going to go?
I mean, does it matter if you're curious?
Curious.
Like if
Absolutely,
you're
I
like
would love
if
to
you're
know.
curious and like it's
But let's
because
put it
I'm
like
just
this,
saying
Did.
like I've
Did,
done
Did. Let
I've
me
done.
put it like this.
Oh, okay, go ahead. My bad. Go ahead. Yeah.
I've got to go and do things tomorrow because I've got to feed my family and stuff.
That makes sense.
Right,
Okay.
life. All right, I'm not in a position to drop everything and somehow magic the funds and ability to do this. Maybe some people have, not me, mate.
Okay. So just at the end of the day, it's just like it kind of doesn't. It's not that big of a deal. It's
Yeah,
like,
it's a known unknown. I'm curious about it, but I'm never going to find out, mate.
Okay.
But far as that go, as of what we know right now, right, as far as in the experience that we see right now, do it feel like the Earth is moving with like 1,000 miles an hour and flying around in space? Do it looks like that you're traveling on a curve? I mean, if it do you have any evidence of that?
I came here to learn. All I'm saying is when I've been in planes, it doesn't feel. It kind of feels motionless when you're not in turbulence. So,
got you.
It's a similar feeling, right?
When you're flying in a plane, are you traveling with the plane being level, or are you traveling with the plane pitching downwards?
I'm gonna be honest with you. I don't think that deeply into it because I just kind of go for recreation. I just came here just to,
I mean, well, you thought
because I went into Black Planet. I usually come here for Black Planet. And I saw this channel. I saw people in here, so I was actually just curious.
But no, I'm asking you. I mean, you thought deep enough for you to say, "Oh, when I fly in a plane, I can't tell whether or not I'm moving, right?" Yeah, well, whether or not you're moving, you're still flying in a plane, and the plane have to fly level. At least that's what they say, right?
Yeah.
And whenever you're traveling, you are traveling going horizontally. You not basically. Do you see any curves, anything that you could? In the first instance, if nobody never told you anything about the globe, right? If you didn't get taught that in school, would you think the Earth is spinning, going 1,000 miles per hour, flying around in space? And when you jump on planes, you could just jump on the plane, and the plane could stand still in the air, and the Earth would still be moving underneath you, Coriolis effect and things of that nature? Or would you just think like, maybe the Earth is just, not moving and just flat? I'm not walking upside down when I'm in Antarctica.
I honestly, I never thought about that. But if I'm going by my eyes when I've flown on a plane, I mean, when you flying over the Pacific, it just look kind of flat. So I'm
not saying like now. Say that you want you
water.
in the Pacific part of the world. Like so say you in the Pacific part of the world where the plane is supposed to be going down, but you still flying straight horizontal. Like if you at the bottom of the world, you at the south of the equator, you're supposed to be flying upside down. Do it feel like you're doing that?
No.
So if nobody never told you was actually doing that, you would just think that you upside. Right?
Yeah, I mean, yeah. I no one's ever. I mean, when I fly, it just again, like you go over the Pacific and you go into Seoul. I don't feel like I'm flying like upside down. No, I don't even know what that feels like. If I'm hanging from like a jungle, like when I was a kid, like the little handlebar, not the handlebar, the fucking swing thing, the things. Fuck, I don't know the name of it. My brain is fucking. It's too many places right now. It's like a lot of shit I'm trying to track with this conversation. Sorry, my bad. Like when the jungle gym thing, you hang upside down. It doesn't feel like that. So like,
right.
Yeah.
Right. You're actually walking upside down when you south of the equator.
Monkey bars. Sorry. Walking upside down when you're south of the equator. I mean, shit, if I'm in like Texas or something.
Yeah, you're on the globe.
Yeah. Oh, am I on the globe? I thought we were on. We're on a.
No, I'm just saying. And far as what they say, had they not told you that, would you, if you was, let's say you live in South Africa or somewhere like that, or like they say they was in Antarctica, technically they was upside down.
Yeah.
Did it look like they was upside down? Did you think they felt like they was walking upside down?
I don't. It depends. So this is my only thing with that, right? Because there is that thing that everyone that we're taught that's called gravity that sticks you to the earth. And like when it's like, does it look like it's upside down? And I'm like, no, it doesn't look like it's upside down. But like,
I think the point that's being raised is there's no external experience you will have if you got on an airplane, say at New York, and you flew to, I don't know, Sydney in Australia. There'd be no external experience that you had that you were now, when you got to Australia, upside down from when you first started, right?
I haven't been to Australia,
but you understand the concept about flying around a sphere and understanding that really in everyday life we experience the Earth as flat and stationary.
So this is my thing though. Like I haven't done the full trip. Like I'm thinking about doing it in the next year or two. Like going off from the West Coast over the Pacific. I'm gonna go to Vietnam, and then from there I want to go to London to go see a homie, and then from there I'm thinking I'll probably just hitch it to New York because I haven't been in New York in a minute, and then go back to Salt Lake. So I was thinking about doing that. So maybe like I'll keep that in mind when I'm doing it. Like,
yeah, do that, dude.
But no, I've never felt like I've been flying upside. Last time I went to Vietnam, and it's like if I'm looking at let's look at a globe.
Yeah, our everyday experience is the land upon which we live upon is flat and stationary, and the sky is always 90 degrees above our head, above the floor, right? That's our basic lived-in experience. Nothing really would tell us that we're on a ball that moves.
That actually kind of is true. Yeah, from my
The Earth is tilted. They say the Earth is tilted and wobbles. So it's not just spinning. It's tilting, wobbling, and flying in space.
Right. Yeah, I mean they say that, and then like they have, the pic, like you had Elon Musk with the whole his Tesla thing that launched into space, and then like if I go on YouTube right now, there's like live 4K video. Huh?
Are you talking about his rockets or his car?
Yeah, that car, like when he had the little space motherfucker in there, and
yeah, did you buy that?
I mean,
the thing that
I saw it looked cool.
Tell it was real because this is what Elon said, right? Maybe you don't remember, but he said that you could tell it was real because it looked so fake.
Yeah, I remember him saying that. Actually, I remember him saying that. Yeah, I remember that.
The image of the spaceman in his Tesla car with the backdrop of the Earth. All right, let's think about this. You chuck a car into space, into a vacuum. What's going to happen to the car in a vacuum? Vacuum is absence of air pressure, right? So no gas, there's available volume for all gases to fill. What do you think is going to happen to all of the material within the car? Not just the metal, but the rubber around the seatings, the fabric, the fibers. What's going to happen?
I'm no scientist. I don't know the whole vacuum concept.
First thing that's going to happen is all the air is going to try to escape. Right, from the tires, for example, from inside the fabrics, primarily the tires. Right, the tires are going to pop because all that gas is met with an equal pressure outside because there's a vacuum. So that gas can press and press and press and press until boom, things are going to start exploding everywhere. Right, you can't just chuck these things that contain gas into vacuums because action's going to take place. But ultimately, yeah. He said you could tell it was real because it looked so fake. And it did, because it is.
So if I go like on YouTube right now and I'm like live space video, there's like this one right here, live 4K video of Earth and space 24/7. It's by Sen. And it seems like it says the downlinked via NASA the world's first continuous 4K live stream from space.
Yeah.
And it says the ISS and spaceship depart in real time. So like when I look at this, it looks like, and maybe this might be, but I guess it's not zoomed out enough. It's not out enough where I guess you could be like,
is it real? Is it?
I mean, I
believe it is, but you don't know that it is.
I don't know.
But you definitely believe it is. You trust that it is, right?
I mean, I want to believe it because that's what I've been taught.
Yeah, exactly. There's a slight bit of confirmation bias in there. We've all got taught this is what you'd expect, right? To see if you were this far away from such a gigantic ball. We've all held balls before, right? So this is what you would expect. So you buy it, especially when they tell you that it's live because it says so.
Mm-hmm.
And so, yeah, we get why people buy this type of thing. Hidden within this are a few clues, though, as to why it's complete bullshit. One, in this, the Earth is a sphere. That means that we should be able to measure the curvature of the Earth over the distance of the Earth. Because it's a curved surface, we should measure the Earth's curved surface. We don't. We don't measure the Earth's curved surface. What we measure the surface to be is horizontal. Obviously, water's flat on the surface. So, in this image, it shows us a ball. When we try to verify it by measuring the ball, we don't measure the ball.
Mm-hmm.
But that's how we validate this image. It's a claim, right? It says the Earth is a sphere. NASA will tell you that they're orbiting around a sphere because they know its radius. It's got a size. Awesome. So according to that math, we should be able to measure curvature. We don't. So it's not that then.
So then why is Elon Musk and then Jeff Bezos, why do they believe in space as these billionaires and they're trying to build these rockets that go outside of Earth to go to other planets?
Going anywhere, dude.
Oh, they're not going anywhere.
And I'm not saying that they're not like physically doing anything. It's all like screenshots, like inside film studios. But they're hardly going up above the surface of the Earth, mate.
Right. But my next, this is just my curiosity. Sorry, this is why are they trying to go out there when it could be like, well, how about we explore all this other stuff on Earth that that people are talking about? It's just because, like,
I guess space is kind of exciting, more exciting than marine biology, right?
I don't know, man. Like,
I mean, I guess that's subjective, right? There are marine biologists who find it really fascinating. But you understand how space kind of has everyone's imagination, and I guess some people, if they've got enough money and not enough sense, are going to be trailblazers. The first people to do this. Right? We can commercialize this type of thing. The whole thing that's been going on for the last few decades and so. But like I said, these people aren't really going anywhere, dude. Well, if we're lucky, a few miles above the surface of the Earth. Awesome. That's not space.
Okay, so the International Space Station is just like in the sky somewhere.
It's just, if anything, it's just in the sky, if anything at all. If there are people on it, I don't know. But we have to look deeper at the claim. The whole cosmology requires the Earth to be a sphere in orbit around the sun in the vacuum of space. This isn't real. The Earth isn't a sphere. It's not in orbit around the sun. And that space that they've been telling us about, it's got an Earth that's a ball in it, so that can't be real. What's up in the sky is probably different to what they keep telling us, mate. Not sure what it is, but I don't think the cosmology that they're trying to sell us is worth buying.
So then, like, what was the goal of them telling us like the Earth is like circular or something? Like, what was the goal, and like why would we want to convince all of humanity to like?
You gotta
literally, huh?
I think you gotta ask them that.
Who's them? It's just people who written books.
Yeah, I think you probably gotta ask them what's their motivations behind that.
So then, how about like, is there like a group of people in here that are getting together, like who are curious and like maybe have the time every now and again to go and like try and do some exploration, or like have like some life goal to do that?
Most people, when it comes to flat Earth, when they go and do things, they go and measure the surface of the Earth, right? Because that's the primary claim. Going off exploring and stuff, like I asked you earlier, which direction are you going? Where would you go?
I mean, if I could, so I do have some like credit card things like to learn how to fly. So if I was gonna go, I would just start to look at where some of these flight paths are going first. So like, how do I get over the Pacific? Okay, like what does that look like? And how far can I go if I actually did learn to fly and I did get a plane? Like how far can I go without, somebody trying to shoot me out the fucking sky, I guess. Or I don't know. I'm just curious because I'm like, damn, this to me, this kind of intriguing is like, because I'm a single dude, right? Like, and I feel like I'm gonna make this software shit take off. And so, if I make it take off, like fucking why not try to put together a team to go and check this shit out,
Well, the thing is, I mean, you don't got to go anywhere. If you fly in a plane, you will already be able to debunk it once you fly like past a few, maybe like 50, 60 miles. And if the plane remains to fly horizontal level, parallel to Earth's surface.
Yeah, but I'm not trying to debunk the Earth. I'm with you guys now. I'm bought in. So I'm like, well, like what's beyond? Like I'm actually just genuinely curious. Like what's beyond? So like that for me would be probably something I'll probably explore myself because I'm gonna make this software shit take off. I put together a team and then we go out to fucking see if we can get to Antarctica to see what the fuck that would take. Hold on, let me Google this shit. How the fuck do you?
If you're trying to go discovering things, you're gonna have to talk to a lot of governments doing that.
A lot of government. How to get to Antarctica? Damn, can you only sail there? Like, oh yeah, because you got like the takeoff and landing pads, and then it's like, well, motherfuckers control those, so you probably gonna have to get with some people for that, and it's like you're probably not gonna. Unless you're pretty skilled, you're not going to just free land a fucking plane on a bunch of ice.
Yeah, you could be trafficking things, and they're not going to do that.
Well, shit, I'm gonna look more into exploration side once I get this software shit on point, man. I appreciate y'all explaining this stuff to me. Thanks.
B. Phil, my brother, what's up, man?
Oh God.
Who's that?
Who else is it, man?
Hold on, let's see. Say something?
It's the one and only, man.
Oh, who's this Castle Kingside?
What do you mean, who's this Castle Kingside?
No, I said, no, I was just looking like, oh, Castle Kingside. I was reading your name. What's up?
Man, you acting like you don't know me, man. What's wrong with you?
He don't.
He doesn't know me? Oh, wow. All of a sudden. 2026, we forget people, huh? Okay, well, I see. I see how it is. I was listening to this whole conversation. Oh, it was wonderful. Jedi, Refill, Cujo. It was beautiful hearing you guys converse about this topic, the flat Earth, and all these questions I heard from B. Phil. It reminded me of myself a few months ago when I first stumbled across the 24/7 flat Earth room. I had the same kind of questions. And it was just it was entertaining to hear the same answers after you're asking those questions. It was beautiful. I was on mute the whole time just listening. It was just wonderful entertainment, So yeah.
Yeah, B. Phil
Welcome
about to jump
flat Earth.
in.
B. Phil?
What's up?
Yeah, he about to do some exploitation.
Man, I'm like, I'm getting into this AI stuff real heavy, like I got like this agent shit. So like, I feel like once these software developers, they get all fucked, I start making money, taking their jobs and shit, then, I rack up, maybe 1-2 mil. I don't know how much. I haven't looked into like this plane stuff. So like how much like I've heard like people say like a Cessna, but it looked like a small motherfucking plane.
You developing an AI or you just working in the field?
No. So, I mean, I don't want to get off topic. Like this is a Flat Earth channel, so I don't know if you guys get like.
It's cool.
Oh.
Yeah. Oh, okay, cool. Yeah,
no, B Phil. No, hey, hold up. This is all flat Earth over here, buddy.
Okay.
What are you doing over here?
Hey, man, unless you want to talk about it, but I mean, let them talk.
Yeah. No, I mean, like, there's the LLMs, and I've trained a few vision models myself, YOLO V8, a few of those models for just some like oil drilling stuff. So like they have like these anyways, long story short, I've helped some people with some diagrams and being able to make those processes a lot cheaper. So like someone's not sitting there and doing all these damn diagrams where they're tracing these fucking lines on these papers, right? Like I've done models that train that. And right now specifically it's more so the LLM stuff. So like Claude Code, and use Claude Code, and you have these LLMs that are doing a large amount of programming across a large amount of projects. And so like I built a framework for myself that I can be working on 6 projects at once. So, and it works pretty well. Anyways, so I'm thinking like, as I continue to build this up, what I'm saying? Like I have 2 clients right now, so we'll see how this grows. But yeah.
You better do some exploring when you make your millions, B Phil. Find out where the edges are in this flat Earth.
That's what he said.
Yeah, that's what I'm curious about, man, because I don't think I'm gonna get married and have kids. So hey, man, I gotta do something, right? Niggas got what they talk about, like magnus opus or something like that, like your life's work type shit. Yeah. So like, why not?
A couple million, it's gonna be women throwing themselves at you.
God. Man, sometimes it'd be a waste of time, man.
B Phil ain't that guy. B Phil, I know. I already know you, bro. You're not that dude, man.
What dude?
You're not the womanizer type. I know that. You're a super nerd, man. I remember you from the army, bro.
Oh, the army?
Yeah. Not the actual.
I'm sorry, Castro, bro. My bad, bro. If we met somewhere before, bro, my bad, bro. Like I don't.
Are you the same B Phil that used to hang out with Amazing Army?
He don't know you,
everybody. No.
No, I mean, I just be, I don't know. It's called Black Heaven, like this Black Heaven.
No, are you still the same B Phil from the Amazing Army, Amazing Lucas?
Amazing. I've seen that dude before. He's like the political guy, right?
Bro, it's you. I remember you, man. Oh my God, crazy. What's wrong with you, man? Oh,
that's okay.
B Phil, we used to hang out with Chad and everybody. Big Dog.
He trolling you, Phil.
No.
Yeah, I'm like, I know, bro. I'm like sitting here like.
No, Amazing Lucas. He has a channel on YouTube. Remember?
Yeah, I know. Like I said, I've heard of him before. I think
in his Discord chat before, back in the days. This is years ago.
Years ago. I mean, years ago, shit. I was at Amazon, man. I was in the grind, bro. I was like in the fucking building out these little stupid warehouses, deploying IT stacks. I wasn't really on the internet like that.
No, it's you.
Castle, he had a job a few years ago.
I had a job too. Remember, I had a job too. I was a bouncer, a bodyguard. You forgot who I am?
You do.
What's
bouncing?
wrong with you, B?
Hold on, you do bouncing? Hold on, let me look at you. Is this you in the picture?
Of course, it's me.
Oh shit, you look like a suave. You look like a suave ass nigga, man.
I'm in Call of Duty, remember? Oh my God, how do you forget about me?
Hold on, I'm gonna click your link real quick. Hold on, real quick. Let's see. You got a YouTube channel.
It's me.
What is this? Middle Ground? Drunk or sober?
Yeah, that's the Jubilee stuff. Those shows from Jubilee I did.
Hold on, Jubilee? You were on Jubilee?
Yeah.
Oh, really?
I've been on a few of their episodes.
Which ones, bro? That's dope.
The one you just read it out. Drunk or sober, Middle Ground.
Oh, hold on. If I it looks like you're just looking into a camera though.
Yeah, because I'm just talking about my experience of being on the show.
Oh, like do you have the Is
Yeah,
there like
I
a show
usually link
on
it.
you?
I usually link it in the episode. I usually
Okay.
link whatever it is.
Were you on like the Amazing Lucas's channel, like talking about politics or something?
Yeah, I've been on his panels before. Remember?
Oh,
Yo, I know you're the same B Phil from back in the days, man.
You flat earthers are so dumb. It's unbelievable.
Okay, there we go.
wow.
Bring it back to flat Earth. That's what this room
Yeah,
is
yeah,
about.
yeah. That makes sense. Sorry about that. Sorry, y'all. My bad. But not. I appreciate y'all educating me on this stuff, man. Like, it's
If
like,
you're getting educated by flat earthers, something is wrong with your life.
what? Why? What do you
That wants to smoke?
like? Are you not?
Where
Are
you
you not?
guys at?
Hold on, bro. Hold on. Are you not curious?
Curious
Like-
about what? Flat Earth? Are we being for real?
I
He
mean,
just saying, don't worry about it. He always come in here trolling.
oh, okay.
I'm trolling.
Yeah, I mean, this kid about to be a millionaire, bro. You over here talking shit. What you doing with your life?
What are you
Nothing.
talking about? What the fuck is this guy talking about?
You.
No, you're
What are
talking
you
to me. You're asking you what the fuck are you talking about?
I
Stupid
said
motherfucker.
this kid about to be.
Use your brain, buddy.
This kid just developed a program for
I'm not, buddy.
doing a lot of good in life, and you over here is trying to shit
If
on
you
him.
stop eating your mic, we could actually listen to what you're saying. You know that?
Nobody's muting my mic, idiot.
You fat fuck.
You done?
Go ahead. So go ahead and say what you said without eating your mic.
You done? Thank you.
Is that your response?
No,
He's not going to tell me what he's talking about. Really?
see if you're done. You just want to talk. Trying to see if you're done.
So BH, it seems like you understand this guy. So go ahead and just repeat what he said. I wasn't able to understand.
No, you just need to shut up. Hey, that's what you need to do.
Oh, big guy, calm down. Relax.
Oh, I'm not even angry at all. You just need to be quiet. You want to hear what somebody's saying, you got to be quiet, right?
Calm down, buddy. Relax.
If nobody's mad, and you don't want to seem to be.
Again, you're still eating your mic, buddy. Calm down. Okay.
You ain't talking yet.
Calm down.
Nobody's angry, bro.
Good boy.
Nobody's angry. Who are you talking to?
Hey, bro, you don't hold on. Why you come in here on that type of time, bro? We trying to learn, bro.
No, I'm telling him to stop eating his mic. That's all I'm asking for.
I mean, but why you gotta be disrespectful, bro?
Because he's screaming at his mic, and I have no idea what he's saying.
You like came in here on some crazy shit, bro.
Well, I came against the flat earthers, and you're not a flat earther, so I don't have any problem with you.
But check this out. Nobody's screaming in a mic. I don't even know why you're saying that.
You are.
Yeah, he actually just talking. He sound pretty clear. Like doesn't sound like he's.
Well, I mean, stop, Nigerian King, stop the meta fucking bullshit. Yeah.
Oh my God.
I can hear him. He's very clear. You're talking. Yeah. Get on with the conversation.
Exactly, bro.
Yeah, but you gotta realize, hell.
I don't have to realize shit. You need to shut up and continue with the conversation and stop the meta bullshit.
Calm down, big guy. Relax, okay?
We literally just telling you to leave the kid alone.
Calm down. I'm speaking.
Don't tell people to calm down.
Watch your
Nobody's
tone, boy.
being aggressive.
Watch your tone, boy. Calm down.
You watch yours, otherwise you'll be booted.
I'll be booted for what?
That's what he want. He just want to be booted.
He can sit there on mute for a while if he's going to be disrespectful to everybody and moderators.
That dude sounds like a glober.
Yeah, he is. He's more of a troll though. He do this like every time I was in the room with him. He do the same thing. But he's trying to pick on the kid for no reason. I mean, he was very genuine in asking very genuine questions. I don't know why the kid he came in here on that.
Man, I guess some people just aren't curious. But it was nice meeting y'all, man. My girl, she want to watch this thing Dark or some shit, so I don't.
Okay. All right, man. Nice meeting you.
Yeah, nice meeting you too, man. Hey, Castle, man.
Yeah.
Hopefully, maybe I'll see you around, bro. I don't know. You said you know me, so maybe, yeah.
Unless you're a different B Phil from back in the days, yeah. I thought it was you, but I guess not.
Well, if you play Call of Duty, he be on there. You can catch him on there.
Call of Duty. I don't play Call of Duty, man.
I don't play it either. I'm just in it.
Okay, facts. All right, then. Well, y'all have a good one.
Right,
you don't play Call of Duty, bro?
Nah, man. I play fighting games.
Oh yeah, you do. You play Tekken, bro.
Yeah, Tekken, Street Fighter, Mortal Kombat. All the fighters, man.
You ain't good though.
Isn't that subjective?
Cassie, you ain't good. I beat you one time.
Probably.
I beat you like 2 times. I remember.
Oh yeah, I know. This is Chris.
Yeah.
Yeah.
What's good, bro?
Now Chris will tell you I'm basically like his mentor, when it comes to these fighting games.
What?
Taught him everything he knows.
What?
Oh please, don't act like please.
Don't
Please.
go there. Don't go there. Don't go there.
You remember I'm the guy that made Lucas
don't make me turn it on.
throw everybody out of his Discord. Remember? That's me. Don't forget. I'm that guy.
Don't make me turn on the system.
Please do. Please do. I have to download whatever game you want to get beat in right now.
I'm good. I don't want to get beat up.
Yeah, that's right. That's what I thought. What's up, man? You come to learn a little bit about flat Earth?
I know a little bit. I mean, I need to. No, let me stop. Rewind. I know what I know. I just don't know. I don't know much. That's all I can say.
Yeah, I've been around these cats to know enough about what they believe.
What do you mean by that, bro?
Well, it means I'm not a flat earther. I just like to hang with you guys.
By that.
It just means I'm not a flat earther. I just like to hang with you guys. That's it.
So water curves and large bodies, right?
Well, you have to take into consideration how large the Earth is.
Uh-huh.
It's huge, man. Look, Jedi and all these guys know me, man. They know that I believe this place is a globe. It's a sphere. And they're cool with it, man. I'm just
That's
here
what
to
you
listen.
believe, or do you know it?
I have to believe because I haven't been to outer space to confirm my belief.
Yeah.
I can't see the actual curve from where I'm standing on Earth. Personally. So I must believe that this place is round.
AKA welcome to Flat Earth.
Yeah, I know. You see, you guys say the same thing every time. Oh, you can't see that curve? Welcome to Flat Earth. Like, nah, man. I trust the scientists on this one, man. Trust the scientists. They all say that this place is curved. All of them.
Well, you know that will make you a believer, and then at that point, I mean, if you believe in your religion, I guess that's your religion. That globe religion.
Well, I mean, hey, is it really a religion? I thought it was science.
You see, he gets it.
Yeah, I guess. Look, man, I'm with B. Phil earlier talking about why would they want to lie to us? Like, what's the goal of lying to us about the shape of the Earth of all things? What do they get out of that?
Why not? Why not? Why wouldn't it?
Because there's other
Can you
things that
answer
are
that
more
one?
important to lie about. The shape
Like
of the
what?
Earth is not something that you should, be lying
What
about.
what should you lie about? What should you
Well,
lie
you
about?
can
Like,
lie
what
about a
would
lot
be
of
more
things.
important? Like what?
You know,
What would be more
have you
important?
heard of stolen valor with people who say they served in the military, certain positions in the military, but they didn't? They lie about that.
Yeah,
See?
I know that. Yeah, I know about that. But you're
Yeah,
saying
people do
that's
that.
way more important to lie about?
Yeah, like what if you lied on your resume about your qualifications for a job? That's more important because it's making money to provide for you and your family.
Yeah, but
That's
people do
way more
that.
important than lying about the shape of the Earth.
People
Yeah,
do
but this
that
got
too.
Yeah, I
Yeah, it
know.
got to be
That's
way
what I'm saying.
more. There got to be way
There's
more
other things
reasons
that are
than
more
that.
important to lie about. Why lie about the shape of the earth?
I mean, why not? Like he said.
Yeah, why
What?
not?
What do you mean? What? That's like bottom of the barrel stuff, man. Like, there's way more important things to focus on as a human being alive on Earth. You know, like the
Oh,
shape of the Earth. It's not really a big deal. It's
I
what
mean,
you
they
do
making,
on Earth that's a big
I mean,
deal.
I don't know.
wait, is it though?
I don't know. I mean,
dollars.
$62 million a day sounds like a pretty big deal to me.
Yeah.
$62
Who's
million
paying
a
for
day.
that?
What do you mean?
Who's paying for that?
Yeah, who's
Me
getting that
and
money?
you.
That's a lot of money.
It's a whole lot of
Who's
money.
paying the NASA bill per day? Me and you.
Yeah,
Yeah.
the taxpayers.
Yeah,
Yeah.
wow, that's a big
But I
deal,
mean,
buddy.
do you know that that's chump change compared to what they spend on the military?
Ain't Trump
What you
changed it.
mean?
It's not chump change
Yeah,
to
it's not
me,
chump
bro.
change to me,
60
but
Hold on,
$60
hold
a
I
on.
don't
day.
care about money like that, though. First of all,
Casa, hold on.
yeah,
I care about when I go to the store. Everything now is $10.
yeah,
I
I
get
know.
to get 10 things, and that's $100.
I feel your pain.
Not
I'm like that
everybody,
too. I wish I
hold
had
on.
that EBT card. Ooh, I wish I had that.
Casa,
I'd be eating good
Casa,
right now.
not everybody could be a celebrity like you, be on video games and stuff.
Hey, come on, man.
I mean, you
You know
rich.
I only got paid $200 for that. I spent that $200 already. Come on.
You got 200K,
You got
200
No,
million.
$200.
Oh, I'm about to say, bro. What?
He lying. He
No,
lying.
200. I'm not SAG-AFTRA. I'm not union, so I didn't get paid the union fees, man.
What do you mean?
That's
You
what
know,
he.
there's a union, there's a Screen Actors Guild for, all the movie stars are a part of. That's how they get all the big bucks. You have to be a part of that union. Well,
You
I'm not
getting
in the union.
you getting movie star money for being on YouTube?
No, I don't get. In fact, I haven't made
You
my
heard.
first
You heard him
$100 on
talking
YouTube
about
yet. I'm
earlier.
a
You
partner,
heard him
but I'm
talking about
not.
YouTube.
I don't have any money yet from YouTube.
You just
Not
made
It
yet.
ain't come in yet.
No, $200 for the Call of Duty job.
But you lying.
No, I'm not, man. I wish I still had that receipt. Then I could show you the receipt.
I was about to say, show me the receipt.
Nah, I don't have it anymore, man. Threw it away.
At least you making money, man.
Well, hey, listen, I'm an American and I'm thankful to be an American because we've got it good compared to a lot of countries in the world. So I'm not complaining about that $200 because there's people that work a whole month and they'll get $200, So I'm thankful.
Oh, wait a minute. Who's in America?
Yeah, man.
A whole month and not even hit 200?
No, I'm
What
talking
kind of
about
job they doing?
third world countries. Third world countries. Where they work like a whole month and they don't even make
Yeah, yeah.
like
Okay,
what we make in a
yeah.
day. It's crazy, man.
Yeah, that's
So
different. Yeah.
yeah, I'm definitely thankful for everything I've got. I'm not complaining. I'm just saying, like, the corporate greed from Activision is unreal. It's like, yo, you could have at least hooked me up with $5,000 so I could take my family out on a vacation or something. But couldn't even do that. And you know what's sad? They didn't even hook me up with my own skins. They didn't even hook me up with a free copy of the game. I had to buy it myself. See? Come on, man. That's wrong. That's corporate greed
So they be
at
they
its
be
finest.
holding you down too. They be holding you down too.
What do you mean, holding me
That's
down?
wild, bro. I thought
Hey,
you was getting
man.
away with stuff, man.
Nah, man. Hey, I'm just a guy out here. So I'm trying to survive like the rest of us. Yeah.
This
Just
guy.
riding the waves out here until it's all over. Till it's time to go home. You already know. In the meantime, I'm trying to figure out why my brothers over here think this world is flat. I guess it's one of those things, man.
You see it,
Yeah,
don't you?
I get that. I understand that. I feel what they're saying when they say that they don't feel an emotion, they don't detect an emotion, therefore it must be flat, they measure everything by sea level, and I've heard the whole spiel, man. I know
Wait a
the
minute. What
whole
do you
thing.
mean by they measure everything by sea level?
Since the sea level is flat,
You saying they use a
then
measurement or something?
yeah, they can explain it better than I can. I mean, I've been here and I've heard it so many times, and I should memorize it by now. But yeah, it has something to do with that.
Nah, I don't know anything about a measurement, but I hear you.
Yeah, these guys they're cool, man. I don't have a problem with what their beliefs are. It's just we don't agree.
It's not just a belief, bro. Okay, look. Does water need a container?
Well, here we go. Yeah. Water needs a
Pretty simple.
container, right?
Okay, so you don't have to believe that. That's something you can know for a fact, right? Do
Well,
you agree?
so if the water is floating down the river, is it
Mhm.
being contained?
By the sides of the
Look,
river? Yeah.
can you make the water curve?
Can
Wait,
I
you
make
already
the
went
water
over.
curve?
Yeah, Castle. Can you make the water curve? You know how to do that?
Oh, no.
I mean, if you had a containment, you could possibly. I don't know, but without a containment, because this is a open planet, quote unquote.
But out of all the times you say you've been around, you still think we just believe the Earth is flat?
No. You guys do
We
your little
argue.
measurement.
We argue
Your
to know.
measurement.
Yeah.
I know. I've heard these measurements before, man. Been around. I know. I get it. You guys don't feel the Earth moving. In fact, I was just watching that Lord Jamar versus Professor Dave debate again recently, and it was interesting because Lord Jamar sounded just like you guys in here. Talking about water on the side of a ball, and things like that. And the ball spinning at 1,000 miles an hour. You know.
Yeah.
I mean, I
And then
know if I put a basketball on a drill, like it just had it spinning, like on that drill, because the drill is spinning. So I'm making the basketball move really, really, really fast. And then if I decide to pour some water on that ball,
yeah,
that water doesn't stay there,
I
and
understand
then
that.
does it stay there and form with the ball because it's spinning at a such high rate speed. Now I know someone might say, well, you don't have gravity on that ball, and I'm thinking to myself, well, if you're saying I don't have gravity on the ball, but there's gravity on this planet, are we not on this planet where there's gravity? I don't know. Things just don't make sense. So that's why I say I don't know.
Well, hold
I
up.
kind of look at these crazy questions and just wonder, like, that doesn't make sense, but whatever. I just
No,
can't
hold on.
believe what someone else just says, just based off their words.
Well, hold on.
I
You
need
forgot
proof.
the little detail that the flat earthers don't believe in gravity.
But that's my point. That's what I'm saying.
That's not
Because
exactly true, though. That's not exactly.
if no, I know that. Look, I know not all flat earthers are flat earthers. Like, not all flat earthers are the same flat earthers. But that's what I'm saying. It's like if I was to try to make an experiment and cause this water to just curve on something that's spinning fast, like this globe, so to speak. I mean, they say, I don't know how fast it go. I mean, they say some crazy number. I don't know how they measure that shit, but they say that. So if I was to just take an object and try to imitate that, simulate that same speed in such a way, I would think that this water would curve and form onto this so-called like mass. And then, now I can see how, this is how the water curves. I don't know how the experiment works, but I'm not gonna, if I don't see it, I don't know. That's why I asked Castle if you could do it, because if you could do it, oh man, you got to show me.
I have a question. Is Israel flat?
What?
Come on, flat earthers. Is Israel flat?
What do you think?
Well, I mean, if the world is flat, Israel should be flat as well, right?
So why
There's
ask?
topography, yeah? What are you talking about?
Well, I don't know. It looks pretty rough, so I'm pretty sure that pretty soon, in a few days, it will be pretty flat. Or wait, I meant to say flattened.
Congratulations.
Soon.
Good job,
Soon.
buddy. That's so funny.
It is. Thank you. I like the joke. I thought I will make sure that Israel is flat.
All right, well, keep that to yourself, dude. Nobody cares about that.
It's okay. It's okay. I understand. You're an evangelical Christian. You believe in the firmament. And Israel is the firstest thing that ever comes, right? What?
Bro, we're not here to talk
Don't hate.
about
Don't hate.
places. We're here to talk about the earth.
Yeah, I am. And I said Israel will be flat soon.
The shape of the earth.
Yeah, because it seems
Anyway,
like
that's all I wanted to say. Bye-bye.
Yeah, it seems like you're trying to get this room banned. Get out of here.
There's always somebody out there trying to get somebody emotionally charged.
It's a bunch of peanuts today.
Good evening.
What's up?
Not much. Seems like a quiet night.
Oh yeah. How you doing?
I'm doing well. Enjoying the weekend so far. Just got back from work a bit ago.
Okay. You a flat earther or?
No, I think the surface of the Earth is roughly spherical. I'm an anti-flat Earth.
Oh, okay. Yeah, I hear you. Yeah, I'm like that too. I think this place is a globe.
Yeah, me too. But I think it's an interesting conversation. So I'm happy to hear what people say.
Yeah, of course. Now, do you have any reason to believe that this place is a globe other than what you've been taught?
Well, obviously, when I was a kid, it was just because that's what I was taught, and I believed my teachers and that kind of stuff. But now I would say things like it makes sense. I think it's the best explanation for what we see. Stuff we can verify ourselves, like sunsets and moon phases and seasons and GPS and satellite TV and weather satellites, like all that type of stuff. I think it has the best explanation for all that.
I agree.
I don't know. Some people say, how can you prove it's a globe? Well, I think proof is sort of maybe more reserved for mathematics and logic. I would say instead that it's the best explanation, not that we can definitively prove it. But then I would say the same thing of water. Water is H2O, not because I can prove that it's H2O, but that chemistry and physics has a good explanation for why water is made of 2 hydrogens and 1 oxygen. And you can do electrolysis and verify things yourself. So in that sense, I don't think we have to prove that water is H2O, but we can use that explanation as the best explanation for how water acts and reacts in chemistry.
Mm-hmm. Yeah, that's a solid way of thinking about it.
But of course, this whole conversation is more about epistemology. How do we know what's true? What counts as truth? What counts as evidence? So that's why I think it's interesting, because sort of the meta conversation is, how do you know what's true, and how do we know if the Earth is a globe or flat? That could.
Right. Yeah, exactly. And I think ultimately that's what it boils down to for a lot of the guys in here that believe that the place is flat. From what I could gather, the time that I spent here, they just don't like this idea of people telling them what it is. Like the government, I should say. People.
Right. Yeah, and there's some validity to that. Like there may be untrustworthy sources, but that's why I think people could go do their own research, and a dose of healthy skepticism never hurts. But maybe if you take it too far, you can end up believing nothing.
Yeah, it's funny you said do your own research. That's the same thing that the flat earthers like to tell me all the time. Do your research. Go out there and measure it for yourself, Castle. You'll find out.
Yeah, here's something you could measure. You could measure the angular size of the moon all night long and see that it's the same size because it's the same distance all night long. It's not coming towards you as it rises, then going farther away as it sets. You can easily tell that by just taking a bunch of pictures of the moon and counting the pixels in the picture, and you see it's the same size all night long.
Yeah. Trust me, man, I wasn't really buying the whole thing about the sun, and how they think about the sun being small and it's not, you know what I mean? Like, I've heard all the arguments, trust me, I've been around, but I don't buy that stuff,
Yeah, I've seen the sun set over the ocean plenty of times, and it stays the same size, and as it sets over the ocean, it gets cut off from bottom up. Usually, if it's clear enough. I mean, sometimes there's cloud and you can't really see.
Yeah. I thought
Oh.
that the whole flat Earth was debunked when they went to Antarctica and observed the 24-hour sun over there.
Well, that
I
was an
thought it was done
interesting.
data.
Yeah, it was an interesting data point. I would say that it didn't convince that many people. But before that happened, there were some skeptics who said that we didn't have any evidence that there was a 24-hour sun in Antarctica. And now it seems like there's pretty clear evidence that we do, although some people doubt even people like Whitsitt. So, it kind of depends.
Huh. Yeah.
Yeah, I think it's hard to explain how there could be a 24-hour sun in the south if the Earth is flat.
Yeah, man. And I was asking the question, like, what do the scientists have to gain by lying about the shape of the Earth? What's the point?
Which scientists?
You know, the ones that study this stuff?
No, I don't. Nobody's been able to name any yet.
Oh. Really? Are you sure? What kind of scientist would study the shape of the Earth anyhow?
I don't know. You're the one that said it. Scientists are hiding shit.
No, I'm saying, why would they lie about the shape of the Earth?
You're the one who said people lie about it.
Well, the flat earthers believe that this place is flat, not round.
No, it's measured flat.
But most of the world believes that this place is spherical.
That's not my problem.
I understand that. But what I'm saying is, why would they believe it's spherical?
They watch TV. They like the news. They like space stories.
Well, I can tell you why I believe it's spherical. I think it's the best explanation for the observations.
Yeah.
Castle King, what do you public speak about?
Oh, well, I have a channel where I just talk about whatever I'm thinking about. So if I'm thinking about anything in particular, I'll just make a video about it.
Well, I'm sure
And,
My point is, like, as a public speaker, you probably wouldn't tell your audience just to take your word for it. You would want them to do their own research and not just believe what people are telling them. You would want them to know for themselves, you know?
Well, yeah. I mean, just because I have a channel doesn't mean you have to believe everything I'm saying. I'm just
So I'm saying,
expressing
but
how I feel about it.
you're taking the word of the scientists, like you said, and as a public speaker, I don't think you would give that advice to your audience just to believe what the scientists are telling you.
Well, I
So
typically go with experts in whatever field. If if I want to know about something, I usually trust the
What makes
experts.
them an expert?
Well, their education.
What? What kind of space education is there?
I don't know.
Well,
Fucking
I don't
astronomy,
know about space
user
education.
research.
Okay, what else is there?
Well, there's university. You can learn about this stuff.
Yeah. That now you don't learn about the globe in any universities. So what else is there?
Oh, is that because everyone just assumes that this place is a globe, and is that why they don't study in university?
I guess.
Yeah.
I guess you don't need those calculations for anything.
What does the world actually look like then? I would love to know.
Right? Well, as far as I could tell, according to the flat Earth, it's flat.
Like a disc, like a discus I used to throw in track. Like
No, you mean in space? A disc in
block.
space? Is that what you mean? A disc in space?
Well, I don't know. You tell me.
No, space is fake, so not a disc in space.
Oh, space is fake, and how do you suppose that?
Not real. You haven't proven it's real. Yeah, you haven't proven it to be
You
real
haven't
yet.
proven it's not. You haven't proven
I
it's
don't
not.
need to prove a negative.
Why don't you need to prove a negative? Why not? You asked me to prove something. Why can't you prove your views?
It's your claim that space exists.
I didn't claim anything. I asked you. How can you prove that it's
I
not
don't need
real?
to.
I would love to see your. Why not?
All you have
Why
to
don't
do
you
is
want to
prove it
provide the
exists,
evidence?
and then I lose.
Or you could tell me the evidence and enlighten me why I should believe what you
you don't know, since you don't have anything. I don't need to.
you don't. Yep, you're dodging. This is called dodging. All right, you guys are.
It's over already. It's already over.
Over? What's over? Your shitty comedy act? You're boring me. Give me some A material. This is some basic stuff.
Well, this is pretty much it, man. It measures flat, therefore
I
it's
guess that's
flat.
it. Yes, so.
I mean, that works for me.
Guess so.
It measures flat, therefore it's flat.
That's right.
You quiet at the comedy club today.
It's not. It measures flat, therefore it's a ball. That's for sure.
I would say the globe provides the best explanation, therefore it's most likely to be true. That's why I believe it.
That's great. That's like the third time you said it, except it's measured flat.
This reminds me of the one video where the kid is like, "I was born to stay in the hood. The hood is a land of opportunity." Have you ever seen that? He's like, I can get Don Julio, chopped cheese, and Chinese food all in the same block.
I don't know about that. I mean, ultimately, it doesn't really matter that much. The shape of the Earth. It's like Who cares, really? Hmm.
Yeah, hello.
Welcome.
What's
Hey,
up?
Mark.
What's up, Matthew? Are you still grading papers, or?
No, the semester starts on Monday, so I'm getting ready still.
Are you having any good flat Earth conversation?
We were just sort of chit chatting in here, but we said a couple things.
Nice. Any convincing going on, or Matthew? Can I ask you a question? Do you feel like they can be convinced that?
Sure. I mean, I try to hold everything loosely, so I think I could be convinced. I would hope that other people would have intellectual humility to kind of like listen to the evidence. So that's my hope. Obviously, people don't change their minds very often, so it's an interesting question.
I just mean with the flat Earth specifically. Like, do you think many of them are really, really interested in the truth, or are they interested in like a debate, or just kind of like the belief system itself?
Oh, yeah, no, I would say everybody in here is interested in the truth. I suppose that there are some people who just like to argue for the sake of arguing, and that's going to be true in any Discord server. But I would say most flat earthers are wanting to sincerely find the truth and figure out what's going on. And the evidence they see leads them to distrust certain authority figures and structures. And not without reason. I mean, I distrust the mainstream science narrative of unguided, like methodological naturalism myself, because I'm a believer. So I think the supernatural exists. So I think we all have different levels of whether we trust the main narrative or not.
Yeah, maybe they are interested in truth. I just wonder if that's really what motivates people. Maybe a flat Earth guy could comment on this. I don't know. I think
I definitely think they're interested in the truth. That's I don't know any of them who wouldn't be.
Well, it doesn't always seem like it, because you can present a lot of arguments, right? Just empirical arguments, and it doesn't really seem to make a difference. And I don't really think that's like on the debater or something like that. I just think some people are unwilling to listen
Where's
or
Mary?
to learn.
Well, it's
Mary's
probably true on
gone?
both sides, right?
Maybe, but there isn't any evidence that the Earth is actually flat, despite what they claim.
No, sure there is. There's evidence on both sides. You just got to weigh it up.
I mean, well, okay. I guess it appears flat. That's certainly something they have going for them.
Yeah, and it also feels motionless. So that's evidence.
Yeah, I guess.
Well, it's not just looks like, like a measure is flat as well, right?
Yeah, that's the claim that's often repeated. But like an entire state can quote measure flat. That doesn't
Yeah,
mean
so
that it is flat.
why are the surveyors lying then? If it's supposedly a
Plenty
curve,
of
you have to measure
surveyors
the Earth
can measure
flat.
the
Why are
Earth
they
and
lying?
measure the curvature. There's an entire kind of curvature, or excuse me, surveying that does measure the Earth's curvature.
No, it doesn't.
Yep.
So they're calculating it in after they measure it
an
flat.
empirical flat.
Remember?
Yep.
Yeah,
So
they
it's just an
calculate it in
empirical
after.
fact that people have, observed the Earth's curvature. In fact, it's visible, just not, from the surface. It's not
Okay,
like
so
readily apparent.
let's say you and me observe different things from altitude or wherever it is that you're observing, right? You could be in an airplane, I'll be on the same airplane, you look out the window, you see curved, I see flat. What do you think we could possibly do to determine who's correct?
Well, no one sees it. No one sees the curve from an airplane. You're not high enough to really
Well, sure,
see
let's say
that.
we're up at 120,000 feet. Let's say you see flat, I see curved. How can we determine who's correct?
Flat what?
Horizon.
Why is there a horizon at all?
Because the Earth's flat.
So but why is there a horizon?
Because the Earth is flat. That's why we have a horizon.
So do you know much about trigonometry?
A little bit. I wouldn't say I'm as good as Matthew over there, but I'm okay.
Yeah, neither am I. Maybe Matthew can help us out. But I would assume there's some kind of relationship between your line of sight and I don't know what it's called, the trigonometric tangent of the circle, or the sphere in this case. If you were looking at
8 inches per mile squared, that thing?
Hold on.
Well, the thing I'm asking for is, why are you calculating for a sphere? How did you determine that was the case in the first place? To be calculating.
Me personally, I'm not going out and doing calculations about the shape of the Earth, to be honest.
Well, of course not you specifically, but how did they, whoever they are, get that ball in the first place to be calculating for such ball? Because if you're calculating for it, you must have known it was a ball to begin with, right?
Right. You can't calculate the size of the sphere without thinking it's a sphere in the first place. I mean, even Eratosthenes wasn't proving anything. He just sort of did some calculations to kind of figure out how big the circumference of the Earth was.
Correct. Yeah. So he was already calculating for a presupposed globe.
Right. So he had other reasons for thinking the Earth was a globe, as we do. And so once we know that it's a globe, then we can figure out ways to measure how big it is.
Yeah. So that's what I'm asking, Mark. How'd you know it was a globe before any curvature measurements? Or I guess there's still no curvature measurements, but yeah. Go on.
I'm just using inferences, right? I'll just explain to you my thought process, okay? I'm gonna level with you, so to speak. If I sit there and I really ask myself, how do I know that the Earth is flat? Because you're right. I haven't done any major calculations. Okay, when I look at the moon.
Okay, go ahead.
When I look at the moon, which granted is not the Earth, what do I see? Well, I see a curved ball in the sky, essentially, that reflects the sun's light, and that leads me to believe that. again, that's just an inference I'm making. It's probably
Okay.
correct.
I mean, you're just guessing. I could say that it's the backside of a turtle
Right, but that wouldn't be a very
that is
credible
glowing
kind of
with
argument
Hogwarts magic. Why not?
because
Can you go up there and
it's just not
verify it?
how that's just not how things work.
Well, that's what you're saying. You're saying it's a ball, a dusty, dirty ball,
Just
floating in a
based on
vacuum, reflecting Earth's or
yeah,
sunlight to the Earth.
that's just based on sense data, right? I don't see any turtles
Sense
up
data.
there.
What is sense data?
Sensuous impressions, so perception.
So you're just guessing based on what you see.
No, I'm drawing inferences about what is what's true and what's not true based on everything I know, right? I look up at the
Okay.
sun, I look up at the stars, I look up at the moon, and then
Okay.
I look at the evidence that's available from just like Google or whatever, and none of it leads me to believe that we actually live on a plane.
Not even the measurements of the surface
Yeah, you keep
that
saying
depict
that
no
there's
curve.
measurements of the surface that depict no curve. Again, an entire state
Yeah, there's
could
no
quote
direct
measure
drop over
flat.
distance measurements. Yeah, that's correct. I'm not talking about elevation change, right? Because that elevation change would be in reference to the horizontal plane, surface or sea level, which is again the horizontal baseline.
Again, I'm just drawing an inference about what I think is true, which is that the Earth is a globe.
Based
Then
off of
let's
something that's not the
then
Earth.
No, based on
let's
everything I know, the totality of
then
all the things that I know.
let's do this whole thought process again without
Sure.
what you have been told. So if you were a young child and you're outside, unless you
Why would
were
I discount
actually,
what I'm being told?
hang on, if you were to actually look out into the world without anybody of telling you that you live on that ball, would you ever have come to that same inference that you're coming to, or belief, whatever you want to call it, without being told what you've been told?
It's definitely possible, right? Look at the moon. It's curved.
Is it?
Is the moon curved?
Yeah.
It certainly appears so.
Right.
You know, we can grant that every light in the sky could be balls, right? Like, I mean, I guess I can speak for myself. I definitely don't
So
mind
in
granting that.
this assumption, every astronomical object is a ball, which it is.
Yeah, if you
Okay.
assume outer space exists, right, which still has to be proven, and you assume that every light in the sky is a ball, which still has to be proven. If you make those two assumptions, then you're saying that Earth, therefore, then must be a ball, which has no direct measurements proving that it's a ball. So if you make three assumptions, then you come to your conclusion.
Well, I'm drawing on a lot more information than just three assumptions. Like I'm trying to draw on everything that I know. But I wanted to ask you, like, okay, let's say you're right. Like Earth is flat. Let's say that's just true.
Well, I'm not
Which
saying it,
I
just
know
saying
you
that yours are.
I know you believe that. I know you think that. I hear you.
Well, no, I'm
Let's say
going
that.
off of their measurements. Yeah.
Okay.
But this is
Okay.
what they're saying. If you disagree with me, you're disagreeing with them, right?
Okay. Let's
Yeah.
say that's all true. Do you believe that outer space is an object, or is it relations between objects?
A vacuum adjacent to a gas pressure gradient? No, definitely not.
Is it? But in the conception of that, is it an object in itself, or is it a set of relations between things?
How would I go about proving that if I have no access to that?
It's a conceptual question. It has to do with your conceptual framework.
Yeah, so correct. If I have no access to something, how can I prove anything about that something?
Do you agree that like there is space between you and say your phone or whatever device you're on right now?
Yeah, that space, yes.
Okay. In that space, is that a relation between something, between you and your phone? Or is it an object in itself? Or is it a property?
I'd say it's a property.
It's a property. Okay. What kind of property is it?
Physical?
It's a physical property. Okay. Would it exist independently of your faculties of perception?
Yes.
Well, why?
Because it's how I sense things.
It's okay, so it's how you sense things, right?
Yes.
Right. So it's almost like necessary for there to be anything else, right? If there was no space, then how could there possibly be anything else?
Yeah.
I'm not even talking about outer space. I'm talking about the space that's right in front of you.
Oh, yeah.
So it's a form of sensible intuition. Do you disagree with that?
No, I don't.
Okay. All right, then we agree.
Wait, we agree on what?
That it's a form of sensible intuition. You said it's how you sense things.
Oh, yeah. I guess that does make sense. So are you in support of the flat earth truth?
So you know that we were talking about like this space between something, right? Not the outer space vacuum.
Yes. That's what Mark clarified. Yes.
Okay, I just wanted to make sure because I don't. Yeah. Okay.
Yeah. Lats, another like clarifying question for you. Do you think space is infinite or coextensive?
Outer space? Or are you talking about the values, the arbitrary values, units of measurements between you and I?
Well, they're not arbitrary. If they were arbitrary, then any
They're
of them would be
arbitrary.
correct. Okay,
Units
then
of
any
measurement are made up by humans.
well, then if
I
all
could come up
units
with the
of
whole unit
measurement
of
are made
measurement
up,
right
then I
now.
can measure the Earth as curved, and it doesn't make any difference.
Yeah, that does.
Well, you can measure curve with an arbitrary measurement, right? Like if you came up with a unit of measurement called Hak Tui, so you say that I have 1 Hak Tui, 2 Hak Tui, and you just measure a distance using that unit of measurement.
Yeah, but to do that, I would have to go through a synthetic process of assigning a
Well, that's
number
what I'm
to
saying.
it.
Unit of measurements are made up. Do you think that
Right. But they still
so
have
like
some
it was
empirical basis.
a divine being that gave us an inch and a foot?
No, those are obviously conventions. That's not
Yeah,
really
they're made
being
up.
debated. No, that's not being debated. But what I'm asking you is space coextensive? In other words, are parts of space next to each other? And in other words, like, are they
Yeah, we can
just like
have
how?
space next to other space. Yeah. Spaces can
Okay,
coexist next to each other. Like I can have rooms of my house next to each other.
right. Just how time is successive, like it's one time after another.
Okay.
Okay. So space is coextensive and time is successive. But would either of those things be like would either of them exist if your mental faculties weren't there to perceive them, you know?
I mean, I would
Excellent
believe.
question.
So that would be a belief, though, right? Because I'm not here. So, like for example, if I was to be gone today, if I died, would I assume that time would still pass on and space would still exist? Then I would assume yes. I couldn't prove it, though, obviously, because I'd be dead.
Okay.
I will say, Mark, you're making some pretty good points.
Oh, okay. Well,
Wait, points
my
about
phone is
what?
going to die, so I might have to go here.
Oh, okay.
All right, bro.
Yeah.
I guess until next time then.
Yeah, I was on the fence on like if the world was like a sphere or if it was flat, but Mark made some pretty good points. I'm glad that we got educated on it. But
What points
I'm
did he
probably gonna
make
have
that
to
were
go soon
good?
too.
Okay. I guess he made multiple good points, but he wouldn't tell me a single one. I asked him like 4 times. Okay, cool. GG's, I guess. Hope everybody's having a good night. I'm gonna be heading out in a little bit. Oh, good. Hey, what's up, Castle?
What's up, man? Yeah. I always enjoy listening to you guys talk about this stuff.
Oh, yeah, for sure, dude. It's a good topic.
Yeah, I think so. I mean, I guess it depends on who you ask, but yeah, I always enjoy it.
For sure, man. Well, glad you're having a good night. I hope everybody else is as well.
Of
I will
course,
be
man.
dipping out.
You out of here?
Take
All
care,
right, man.
everybody. Yes,
Yeah.
sir. Take care,
Have a
guys.
good one. Yeah, peace. Till next time.
Okay, so when we go to the satellite, all right, Master, when we go to the satellite, can we see the curvature then? What do you see in that then? 40,000, what do you see then? Oh, no, 400,000, sorry.
Well, it depends on the satellite at that height. I don't know if anybody's got any footage from that height, but if you are at that height, that's how much curvature of the Earth, if it's a globe, should be present to your available site.
Bingo. Well, I'm pretty sure people have gone that high.
Really? What, in the satellite?
people.
What the fuck? Who's gone that high, dude? You're talking about people who went to the moon?
I told you, bro. Neil Armstrong.
Neil Armstrong. Okay.
Yeah, in the 60s. Yeah.
How did they know how high the moon is?
Oh, the thing, light speed, takes about 8 seconds. It does, doesn't it? From Earth to go to the moon, doesn't it? The laser.
No, it doesn't.
No.
Okay.
No, that's the.
I'm telling you guys, this guy is drunk and he's just trolling.
I'm not, Peter. I'm not drunk. Don't drink. I've been sober for about 5 years now.
Yeah, 5 minutes maybe.
Except for weekend.
Oh, no, man, I'm serious, bro. I'm sober, bro. I'm serious, man.
This is you not being drunk, then fuck.
Yeah, that doesn't help you. That doesn't help your case.
Yeah, do yourself a favor and stay sober then.
I mean, all jokes aside, right? I mean, look, I believe in the moon landing and stuff like that. I mean, I come on, man.
You're a patriotic American.
Patriotic American.
Go Trump, right? Moon landing.
First of all, the moon has nothing to do with the shape of the Earth. So why do you even bring that up?
Right, Peter. Let me ask you a question then. How long does it take for the sun to hit the Earth?
Like crash into it?
Like prediction is 5 billion years. I think is the prediction.
It takes 5 billion years for sunlight to hit Earth.
Oh, sunlight.
No, you said the sun. Like the prediction is that the sun will expand. The global prediction is the sun will expand and engulf the Earth. I think I might be guessing, but around 5 billion years from now.
Yeah. I mean, yeah. Yeah. So you're a psychic. You can see the future. Yeah. All right. Yeah. All right. But I mean, like the sunlight. I mean, like how long does it take for the sunlight to hit Earth?
8 minutes. I'm educating you on your own model. 8 minutes.
Great. So if I get like a big laser and if I push it towards the moon, how long will it take for it to hit the moon?
1.3 seconds.
Oh, that's how long. That's how you find the distance to it, right, Peter?
Yes, I'm not in disagreement with that. You just said it's like 8 seconds or something. You don't even know your own model. So this here is an advanced flat Earth discussion server. So when you come here, you gotta at least know your own model. And still, you're not gonna prove the globe, but you need to know your own model at least. You're nice and sussed up, Gov. So you're just not in the position to have a serious conversation, especially with people like Jedi.
Okay, Mr. Smarty Pants, I apologise for getting a few seconds off. Not to be sarcastic with me. You're so smart, you know everything, don't you, Peter?
I mean, few seconds, you overestimated it by a factor of 8.
I gave an average approximate. I didn't know it off by heart, right?
All right.
I swear, people like you, bro, I swear, bro. You think know everything, bro.
Again, this is an advanced server.
Oh, come on, bro. What's wrong with you, man?
This is not like
so cringy, bro.
Earth Shape 101, learn the basics. This is, you got serious argument, let's go. Otherwise, just sit
Such
there
a nerd, bro. I swear, man.
Yes, I am a Shape of the Earth nerd, yes.
It's so much fun. And Peter, it warms my heart that you get it finally. Welcome to Flat Earth.
I've always been here.
That's right.
Well, you found your community. Enjoy.
You've been here too, Pantheos. You've been here on Flat Earth the whole time.
I have. I'm even in the server myself. I listen to you guys a lot. But maybe I got a few seconds mixed up. I apologize for that, Peter. Please forgive me. I know you know everything. I know you're so smart. Yes, please forgive me. But
Do you listen to us a
make
lot?
mistakes.
You're forgiven. You're forgiven.
You do realize that, don't you?
Do you listen to us a lot?
Yeah.
Okay.
Yeah,
so,
every now and then. Yeah, I go. Yeah, I go.
Okay.
Yeah.
So why do we say the Earth is flat?
I mean, I don't know, Jedi. You come up with all sorts of stuff, man. I mean, one day you say this, and one day you say that. I mean, they're all over the place. I'm not here to mix the soup. Don't get me wrong,
gosh.
right? But
Who's your favorite flat earther?
My favorite flat earther?
Yeah, do you have
all
a
of you
favorite?
guys. All of you guys. I love you all.
Okay, well, who's the most annoying flat earther? How about that?
The most annoying one? I'm gonna have to go for. Let's see. I think Peter. Yeah, I'm gonna have to go for Peter.
Oh,
yeah.
Peter, I'm sorry.
Yeah. He's the annoying one because he's Mr. Smarty Pants. He thinks he knows everything. Yeah.
Well, think about it. I'm annoying because I'm triggering his cognitive dissonance, so I take that as a compliment.
Oh, are you a psychologist now? Oh, you must be so smart. Can you please give me a therapy lesson? Come on, bruv. I haven't got money to go to a therapist. You're so smart.
Right amount. Can you string the right words in context to form a conductive sentence? You just seem to pick random words and cobble them together. Therapy.
I'll give you a therapy. I'll give you a therapy session for free in 15 seconds, which is less than it took you to ask me to give you the therapy session. So here it comes.
But what?
Just can you shush it for 15? I promise to time box it to 15 seconds. So just put a stopwatch on, and I'll tell you when to click it. Click it now. Here it comes. Go outside, look around. The Earth is flat. You observe it as flat. Deal with it. Actually, it was less than 15 seconds.
Thank you for that. But what you're doing right now isn't evaluating evidence, it's confirmation bias. You've already decided the conclusion.
We evaluated all the evidence
interpreting
with
everything
people
to fit
way
it.
more
Yes.
knowledgeable than you on the topic. So we're just telling you what we already know, and take it or leave it. If you want to confront us on it, be precise, be to the point. Don't just say, ooh, maths doesn't add up. Dude asks you, what maths? Well, it shouldn't be that way. Okay, what maths? I don't know. Yeah, that's your argument.
I wouldn't say that's my argument, but your belief isn't being challenged. Your identity is, and that's why you're defending an interpretation instead of a quote.
Audience. That's how you sound. It sounds like this. Maths doesn't add up. Okay, show us. Well, it shouldn't be. I don't think it works that way. That's your argument. Bro,
I didn't even give a full argument.
You didn't. You just said, well, I thought about it, and something doesn't add up.
Hey, Peter, got a question for you. Does math attract math?
Yes, it does. Math actually generates more math. So in some sense, math attracts math.
Math attracts math.
Yo, Stark, mic up, bruv. I want to have a little chat with Stark. Oh, but I was gone all quiet.
Seriously, no offense, bruv, but you're a little bit of a waste of time, not because we're hating on you, but because you come in here with actually you don't even have the basics about your own model. what can we tell you? Like, you're gonna have these very high level like responses, like, oh, it doesn't make sense. We're beyond that level. Okay, so no offense.
What are you? Are you God or something? What do you mean,
right?
Peter? What are you on
You're in
about?
the Premier. I'll explain it to you. You're in Premier League. You should be in that. What is that? There's Division 1, Division 2, Division 3. Then you guys have some kind of local, amateur clubs. That's the level you're in, and it's actually it's good, right? Those guys can play soccer or football, as you would say it, but they cannot show up and face Arsenal, right? So that's the way it is. Don't worry about it. You're still a good player.
Yeah, but when you start to status shame, right? The thing is, Peter, when you start status shaming, it means that you've run out of content, and your belief is under cognitive threat. So your ego,
on your performance. Yeah. This is I have assessed your performance, and unfortunately, you're not the only one. We get baby glurfs here every 5 minutes. They come in.
Yeah, but I mean, what's your major anyway? I mean, what have you studied, Peter? Like, what's your major? Like, what are you anyway? Are you? And I know you're delusional, yeah, but I mean, what are you supposed to be exactly? Like, are you? What did you study? What's your major? Tell me that. I'm not going to bully you, I promise.
Okay, but why does that matter?
It does matter because the way that you're speaking is very horrible. It's not normal. That's why there's something wrong with you.
And my major, that's just me being an asshole. How does that my major...
Well, I know you're an asshole, yes. But the thing is, you don't know how to have a conversation. That's your problem. You don't know me. I don't know you. Like, what's your issue?
This is the internet, man. It's nobody knows anybody. This is all just random people. And here, at least,
it is. I agree with you, but calling me low level isn't a rebuttal. It's avoidance strategy. Because when reasoning fails, your ego reaches for hierarchy.
I've been
listening. You are a low life.
The evidence of the Earth into the side chat, and we'll discuss.
I mean, there are other Globers that come in here that perform much better than you and in a more engaging way and actually engage on more facts. And, we still don't believe
You've got no emotions, Peter. That's just it. You've got no emotions.
You're just bored.
Yeah, I mean, you're horrible. You're a horrible person.
Okay.
Okay.
Thank you.
Evidence of the Earth, please. Thanks. What is your claim?
Not at the moment. I'm just listening in at the moment.
Well, I'm listening to you cry, and I would like to get back on topic because you don't want to talk.
Yeah, let's get back on topic.
Because apparently, talking about people and their emotions is, proof that you don't have content. Please, you're here to help us make content. What is your evidence of the Earth?
My claim is simple, all right? I mean, I came an hour ago, mentioned it before Peter tried to put me down, right? Gravity, all right? Because, look, I just want to know more about it. I want to know your perspective as well. I come in peace. But people like Peter tried to put me down, right? It's a low life. Anyway, look, my claim is very simple, right? Gravity it's a theory, it is, yeah, but at least it's measured, it's repeatable, and in my opinion, it's our best current explanation that mass energy curve space-time, right? I mean, you don't have to like the explanation, but the predictions work.
All right, so does gravity cause things to be flat or sphere?
I mean, sphere. Yeah, sphere, yeah. Gravity, yeah.
Hold on. Can I ask him? Are you sure?
Water is on the Earth. Hang on.
No. Don't
water
worry
is on the Earth.
Water.
I'm going to let him have his gravity. I don't care to argue about the gravity, right? You have gravity.
But he's
you
wrong
have
about
a
his own model.
You have water on the sphere. Now the gravity is causing the water to actually conform to the shape of the sphere. Now, can you tell me how to measure the curvature of the Earth?
I mean, I personally don't know how to measure it myself. I've never measured it myself, but I mean, according to like my research and what I know, like we look at like huge celestial objects like the moon or something, they're all circle. even though no one's actually touched it, according to you. But you measure the Earth by measuring how the horizon, how it drops with distance. So the higher you go, that's why I was mentioning about that Red Bull guy, Felix, before, right? The higher you go, the more you see. I mean, I don't know the specific measurements. I mean, Peter did have a go at me.
I hear you came back after watching those videos, and I'm the one who brought up Felix. It's flat.
There we go. How you doing, bro? Nice to see you, man. Yeah.
Like Neil deGrasse Tyson said, it's flat, didn't he?
Yeah, I watched it, Professor.
Yes,
look, I watched it.
Welcome to Flat Earth. You're the new Flat Earther. Remember, you said if we give you the videos, you'll go watch them and be a Flat Earther.
Yes, I watched it, but I'm still skeptical. Triangle, look, I'm still skeptical. I am. Like, I mean, I did watch the video and all that, but I mean, I'm just saying, like, stars, right? For example, stars, right? They shift the position depending on the latitude or the longitude, whatever, and the season, right? It only works from curved Earth. It does, and
that only works from a flat surface. Yeah, you can only measure that from a flat surface. You actually can't take any angles from a curved surface. So whoever told you could needs their teaching license taken away.
Okay, this is just my education, I guess. I mean, maybe I'm not on like your level, like, or Peter's level, let's say, the very smart person, the Peter that knows everything. Maybe I'm not on his level, but I mean, I believe that your statement is actually false because you can measure angles on curved surfaces. That's what geometric is. Yeah.
Please describe the method that you would take in order to get an angle measurement to a light in the sky.
Well, I mean, I can't just get a ruler and do it. I mean, you measure the curvature.
Angle to a light in the sky. That you're right. You wouldn't do that.
Yeah, you use a stick, like not like a literal stick. Like use a thing. How do you pronounce it? Gnomon. A gnomon. Yeah.
What do I do with the stick to get an angle measurement to the light in the sky?
All right, so you measure the sun's angle, all right, at the same time of the day. Sorry?
Okay. I thought we was talking about stars. Okay, so I have a stick. I have the sun in the sky. What do I do now?
All right, great. So now you got the stick, and so I'm gonna go step by step, right? 2 sticks, all right, at the same length. The sticks are gonna be the same length, all right. So you level the ground surface, the north and the south. Like
I thought you said I didn't need a flat Earth. Why am I having to level the ground now?
You have to level the ground, you do, because it needs to be like the same length. Like the 2 sticks need to be like the same length, all right? So
it sounds
you tape
what Mr. Triangle was talking about, how you need a flat Earth, and you're like, no, you don't need a flat Earth, you just need to level it.
Well, I mean, yes, you need to level. Yes, you need to level it out. You need to ground it. Like put 2. Like just imagine, right? Have you got 2 sticks?
I don't have 2
sticks. We go step by step. Okay, just imagine it. Like just close your eyes, right? Close your eyes and listen, right? Right. So you get 2 sticks, broom handles, and they need to be the same length. And you ground the surface at each location. You get a tape measure, right? You put stick height and for the shadow length. And then you need to have a friend like somewhere else in like a city, like either north or south, like maybe like 300, 400 miles apart or something. And then you put the stick on the flat ground. You use a plumb line. You know what plumb line is, right?
There you go. You're accusing everybody of using a flat Earth again. You cannot use a plumb line on a ball, and you can't make an angle to something in the sky from the surface of a ball. That's why you got to keep flattening everything out.
Hold on, why can we not use a plumb line on a hypothetical ball?
Because you don't have it. Where's the plumb line going to point to, Peter, the smart guy?
Well, in the globe model, to the center of the globe.
No, yeah, but you don't have any center.
All right, he's got a plumb line. He's made a plumb line fall to the ground. Now what? What's next?
Yeah, okay, but this plumb line, it works on any surface, all right? So flat, curve, it works on any surface, right? It doesn't care if the ground is flat or curved. It aligns with, what does it align with? Tell me. Gravity, all right? Yeah.
Okay, perfect vertical. Now we have vertical. What's next?
Okay, so now so now you got the sticks. So now we got a measure from the thing, the sun, right? So what we're gonna do at two different locations, your friend let's say is in the north and you're in the south, and you use the stick and you measure the shadow angle relative to vertical. Now, how do you do that? I'm not a scientist, okay? Like this is not my major in this, but I'm sure you have the coordinates for this because I mean I don't know it off by heart. I'm not gonna lie, but I'm sure Peter will know because Peter's really smart. Maybe we can get some advice from Peter. Maybe Peter, could you tell us please the exact maths on this because you know you're so smart.
Yes, I could, and I will. So first of all, you don't need a friend. You could just measure these two locations yourself 1 year after another, right? Same day of the solar year. Second of all, yes, you put the stick in the ground. I will explain the Eratosthenes argument, right? You put the stick in the ground, you measure the angle of the shadow, and then you draw on a sphere, you draw the relationship between the arc. So the distance between the two cities is the arc length, right, over the sphere. You have the difference in the angles, and from this you calculate the radius. Like there's a cosine.
And nobody ever did that. Nobody ever did that.
Sure. So the point is that
Peter, I'll just get rid of you. I'll just get rid of you when you say sure to me, because nobody's ever done that. You can't go out and do it.
Nobody has ever done that.
Do it.
Nobody has ever done that. But that's the argument. That's the Eratosthenes argument. Now, dude, just to show you what I meant earlier. Somebody asked you, does gravity form things into spheres? And you said yes. Can you tell me why in your own cosmology asteroids are not spherical?
Oh well, asteroids are spherical. I mean, it depends on the shape. Like some asteroids are spherical, some are like weird shapes and stuff like that. But they're not spherical because they don't have enough thing for it, or is it mass? You know, they don't have enough mass for the gravity to overpower. Right. Yeah.
Okay. Hold on.
Yeah,
just
because
step by step.
Yeah.
I promise. These are pointed questions. Give me pointed answers. Don't give me your entire manifesto. I know you have a manifesto. Just don't provide it.
Yeah, I'm so sorry. I know you're so smart. Okay, cool, I'm very sorry. Yes, please carry on, Peter. Yes.
So what do you think is the reason? So I think you're right. There's not enough mass, but like, what's the issue there? Why do we need more mass to form a sphere?
Well, I mean, that's a really good question. Because look, we need more mass because gravity is proportional to mass. Without the mass, gravity is too weak to do anything. You know,
but why is it too weak? I'm going to give you a hint. Is there something in its way?
Well, I mean, look, low mass is weak gravity, isn't it? So high mass is strong gravity. No mass is what? No gravity, right?
I understand, but like low mass would still generate acceleration in your model and form a sphere. So there has to be, this is a strong hint now, there has to be some other force in the way of gravity in that situation of an asteroid. Yes?
Well, but it's not God, obviously. You know, I mean, even massless particles like light, like photon, they change direction in the field. You know, like it's not the same thing as gravity.
The answer. The electromagnetic interactions between the particles forming the asteroid are strong enough to overcome the gravitational attraction. If the asteroid, I'm explaining your own model to you, if the asteroid is much bigger, then the gravity will overcome those internal structures of the asteroid. So the correct and form a sphere. That's your own model. So now, there's actually an equation that tells you how much mass of a rocky object would be required for that to happen. Now, so the correct answer to the question you were asked is Sometimes gravity forms spheres, and sometimes it doesn't. And it depends on the internal rigidity of the object and its mass. So if I told you that the Earth was flat, but still told you that mass attracts mass, as your model says, I could then say the internal structure of the Earth can prevent it from forming a sphere. So that's thinking critically right here.
Okay, yes, all right, but I mean, I don't know what side you're on because you're giving my model and then you're turning it into like your own work. I think you're doing some psychological manipulation here, right? But I won't fall for that.
I'm using this opportunity to teach you your own model because, like many baby glurfs that come here, you don't even know it. Secondly, I'm trying to show you where the disagreements are and where they are not. As a flat earther, I'm telling you that the issue of mass attracts mass is not directly related to the shape of the Earth. It's not an automatic win if you said, oh, look, mass attracts mass, boom, we live on a sphere. No. There are more factors here that you would have to rule out and explain to arrive at that conclusion. And so far, nobody has.
Well, yeah, look, Peter, I know what you're doing,
I would prefer we stick to the topic of curvature so that we can identify whether the Earth is a sphere or not.
Absolutely. Let's just do that. Let's not talk about gravity unless we want to talk about gravity.
All right, exactly. Okay, so since you don't believe in gravity, you know, we can just hop to another topic then, because you did a really bad way of.
I believe in gravity. It has nothing to do with the shape of the Earth.
There's a difference between saying it's one of the inputs into the shape of the Earth and saying it has nothing to do with the shape of the Earth. It's just some of the forces that cause a mass to accelerate. So it's the sum of the forces, and it's one of the inputs.
You know, in some sense, everything has to do with everything, right? Protons, electrons have to do with the shape of the Earth because the Earth is made of protons and electrons, like everything else. So, like, in some sense, everything has to do with everything. Yes, you're correct.
See, I think that's a disambiguation as well. Like, I'm not saying everything has to do with everything. I'm saying that that's probably, you only need like 2 or 3 input forces to derive the amount of mass you need for things to become, asymptotically approach the shape of a sphere, right? Like, so we're not a perfect sphere. We're an oblate spheroid with higher harmonic, mass changes around the surface. Like that's why you get the geoid model.
Who's the goofball talking? Is that Josh? Josh, you don't know anything about mass. You don't know anything about mass attracts mass. Please, don't give us a lesson.
I'm just letting you know.
All right, curvature of the Earth. Where is that measurement at?
So why is it that everybody knows how gravity works, but nobody can tell us how gravity works?
We understand the effects of gravity. We don't understand the causal function. That's where you get into like Higgs boson and why does mass have mass, right? We understand that there's certain materials, there's elements that are made up of different, amounts of protons, neutrons, electrons. And then if you have, a certain amount of those atoms, moles of an element or a compound, you multiply that by, a constant, which is, little g, and you can figure out what the acceleration of all of the other mass around it would be towards that, control volume of mass. And because of that, we can figure out that, because we understand, these different elements and these different volumes and different densities, we can figure out, we can normalize everything by those amounts and drive towards a little g constant. We don't know why it's that, but we know how to apply it to that. So it is a bit of a pragmatic fallacy. I agree.
One more time, avoiding the curvature of the Earth. Please, someone make another one.
That's the point of why Globers come in here. We ask them, hey, you got the curve of the Earth? Gravity. Gravity makes things into balls. I say, no, gravity makes things flat. That's why your horizon's flat. Oh, yeah, no, that's refraction and gravity.
I was going to say, Yoder, I disagree with that because you can look at, the other planets and you can derive their composition and understand their angular resolution combined with their composition.
No, you can't.
What? You just okay? So celestial spectroscopy is just out the window.
Yes, it's out the window. You can't look through air and decide that whatever's on the other side of all that air is something else.
I disagree with that assertion, but I'm glad you acknowledge the fact that you're throwing that out the window.
Yeah, still not Earth curve measurements. Talking about everything but the thing that would actually prove.
Oh, you wanted to talk about what planets are made of when you shine a flashlight at them.
Well, you're not shining a flashlight. It's a spectrum analyzer, because when elements reflect light, or when things decay, or basically any spectral emissions, there's unique fingerprints that are one-to-one representations of the chemical compounds that it's composed of. We do it in the lab, right? It's accurate in a lab.
In a lab is different. You don't have a bunch of air you're looking through.
Oh no, you can do it across the room in a lab, right? You do the experiment in high school chemistry where you lit some stuff on fire.
You can do it farther than 250 miles. Then do it 260 miles and tell me what you get.
Well, you can do it over any distance if you have a sensitive enough sensor and you understand the atmospheric conditions that you have to zero out for. It's kind of like noise canceling headphones.
Okay. Now, you've done some spectroscopy on an object on the Earth that's 206 miles away. At what height were these two objects when they observed each other?
Oh, you can do radar ranging on any of the planets to understand how far away they are.
Yeah, I'm talking about this thing that was done here on Earth. All right, you've looked at an object using spectroscopy on the Earth that's 200 miles away. What height were these objects? The looker and the thing that's being looked at.
This is all hypothetical. I think you misconstrued that we were discussing an actual experiment at some point along this conversation.
Yeah, and I'm trying to identify whether it can be done on the Earth, and if it's done on the Earth at 200 miles, what is the amount of curve that's between those two objects, and was curve observed, period? Because if you're at 6 foot observer height and you see 200 fucking miles away, what the fuck's going on? It's definitely not a sphere with a radius of 3,959 miles. If you're at 3,000 feet, 200 miles is not functional. What the fuck's going on?
Yeah, assuming there's no medium around us, correct?
So we have to assume there's no medium, so we have to do it in a vacuum chamber. Who's got a 250-mile vacuum chamber I can borrow?
Or you could just, go to a high enough vacuum or high enough altitude where there is a vacuum naturally.
No such thing.
Disagree with that assertion as well.
It's not an assertion. You made the claim. Go ahead and prove it.
No, you just made a claim that there's no such thing.
Yeah, there's not.
Okay, then I'm telling you I'm disagreeing with that assertion.
You're all over the place, Glover. Stick to a point.
No. Just trying to keep things civil and understand when you're saying you're making a claim that there is no such thing. I would love evidence of that.
Yeah, prove a negative.
I'd point you towards the standard atmosphere from 1976 that proves that the pressure density of the atmosphere using weather balloons asymptotically approaches zero.
So does absolute zero approaches zero. When do you hit it? At what point do you hit absolute zero?
It's not possible.
He said asymptotic, to be honest. He said asymptotically approaches zero, which means it never becomes zero, right? You know what an asymptotic function looks like.
There's no such thing as a perfect vacuum.
You guys are breaking up. That's why I can't hear everything. I'm driving.
Okay, he said asymptotically approaches zero, which there's an echo, which means it's never zero, but very close to it.
How do you know it's not zero? How do you know it's close to zero?
Well, I'll point you towards, once again, the external pressure sensor REL system that's on the outside of the ISS and has publicly published pressure sensor data.
They must have just put that out there recently, huh?
No, it's been published for a while. It's in my profile if you want to go read the paper.
No. Yeah, it sounds like they put that up there recently.
No, REL's been up there. I think it's since mid 2010s, early 2010s. I'll have to double check. But the primary author on the paper, if you're interested in reaching out to them, as well as the engineering unit, which you can go, test and verify that this thing works like they're claiming it works. I think it's at the University of Arizona in Phoenix.
I'm just going to go buy one and put it in my vacuum chamber and see if it works.
I'm just trying to provide you evidence.
I agree with you. I'm going to get your evidence, go buy one, put it in my vacuum chamber, and see if it reads what my vacuum chamber reads.
Okay. But there's no such thing as a pure vacuum, and because of that, combining high altitude weather balloon data, you don't even have to believe in space to identify that the pressure gradient of our atmosphere as you go up in altitude asymptotically approaches zero. So there is a specific altitude where once again, Newton's second law, sigma F is equal to ma. There is an altitude where the pressure is low enough that the force of gravity, even if you don't believe in gravity, right? You can see that there's a downward acceleration at 9.81 meters per second square. There's an altitude where those two cancel out and you have equilibrium.
What is this conversation about even? I'm so lost.
Yeah, not the curve of the Earth, that's for sure.
No, just gas not needing a
oh,
container.
Jesus, you're gonna unpack this now. My God, do you have a list of all the trigger topics and tangents that you want to go on, and you're just going down the list like click, click, click?
Yeah, pretty much.
Okay.
I believe the way we got there was someone was asking me if we could do long distance terrestrial observations without the medium, and they asked where we could get a vacuum chamber that is long enough to do these types of measurements. And I posited that there is a very large vacuum, just 100 kilometers up. So
yeah, but they were very specific. They said terrestrial. They meant a person standing on the ground, observing another point on the surface of the Earth over impressive distances. Can we do that without the medium? The answer, Josh, is no, we cannot. Right. So, saying just no, we cannot would be a much better thing, moving the conversation forward, than nerding out on fucking density gradients.
I appreciate that. I do identify as a nerd.
Well, I also identify you as a nerd, so we have that in common.
Yoder just doesn't like Cavendish, it seems, in the comment section.
Why would you talk about Cavendish in 2025 when discussing mass attraction?
Holy shit, dude!
If you have gravimeters, if you have superconducting gravimeters that put Cavendish to shame.
Oh no, I agree. It's just the beginning. There's been a ton of technological advancements that you're able to get 5-10 more significant figures on small g. But it's just it's the watershed paper, so it's the one I usually refer to.
Wow, yeah, we've never heard that before.
Oh, I understand that.
It's like today, thanks to you, we've heard about Cavendish and Eratosthenes, I believe, or was it the other guy? Sorry.
No. Yeah.
Right. Okay. So those are foundational. For moments for our VC here. What else are you going to tell us?
I don't know. I just like to listen to the conversation and sort of provide my
How about
perspective
curvature?
as
Could you
needed.
tell us something about the curvature, maybe?
From a terrestrial point of view, I don't believe it's observable.
Oh, okay. Well, when I was a
or at least.
So, from a terrestrial point of view, you don't think to see the curvature of the Earth? I really want to be clear, right? You're meaning from left to right, not away from you. Like the reason why the sun disappears and the reason why we can't see that boat is because of the curvature of the Earth. That would be your claim. I just want to be clear which type of curvature you're talking about.
Well, from a terrestrial point of view, I don't think that anybody in this conversation understands the properties of the medium well enough to definitively say what's causing these effects. Which is where we run into the interesting dynamic surrounding reliance solely on your five senses and direct observation of phenomena, as opposed to
what effects are you talking about, Josh? What effects are you talking about?
Oh, the effects of the medium. Looming, miraging, just light traveling through a medium.
How come on your globe Earth everything is flat?
I'm not saying everything is flat. I'm just saying that we don't understand the effects of the medium well enough to definitively have a conversation where we can convince the other party of anything.
We don't understand the medium that we shoot light through well enough to target things at distance. Like
whether or not to understand where the optical location is the same as the actual location.
What the thing that we blow up with a targeting system, the most accurate targeting systems are lasers. You're saying we don't understand how light passes through the medium when we use it all the time to, these days, protect our borders and countries and early warning systems and blow that shit up. Right? Directed energy weapons.
Do you know where the early warning systems are?
Do you understand what I'm talking about? You're saying that we don't understand the medium, but we use it all of the time. It's just a stupid claim, dude.
I disagree with that, but that's fine.
We don't understand the medium, Jedi, so you're not allowed to have airplanes anymore. Call the FAA.
Yeah, I'm not allowed to use lasers anymore to target things at distance or to find range. Can't do that anymore.
You get the visual feedback. I'm just saying you don't understand it. You don't understand it enough to claim that the actual position is the same as the optical position, right? So with the laser, you get the feedback of the targeting.
At the speed of light targeting system.
Oh yeah, at the speed of light. Correct.
At the speed of light, blowing it up with a laser weapon. It's a targeting system, and it's also light.
Do you understand how a PID controller works? It's every single time step for the weapon system that you're guiding using a laser is using the visual feedback.
Stop talking.
I'm saying it every single time. I'm saying it is accurate, but it's due to it's a differential control system. So it's at every second, the sensor on the weapon is looking for the laser light, the feedback, and then it controls and points towards that place. And every single time step, it still does that at whatever time step the control system is tuned to. And as you get closer and closer to that object, the error due to the effects of the medium approaches zero. So it is accurate, but from that initial distance, the delta between where the laser actually is reflecting from and where it visually looks like it's reflecting from could have a decent amount of error.
Sounds like we understand the medium perfectly well.
Well, no, we just have a good control system that's able to eat through that error over time.
I guess it sounds like we...
So in conclusion, the Earth is flat. We spoke to Noro or Rai. How y'all doing?
Hello. Doing good. How are you?
Good. Have you been in here before, or did you just decide to stumble into a flat Earth channel?
I've never been here before.
Okay. Well, are you under the impression, as we all were at one time, that the Earth is a spinning water ball in a vacuum?
To be honest, I have no idea what the Earth is.
Okay. Well, not so much what it is. I mean, the Earth is the Earth. What its composition is, or how we would describe its surface, is kind of a different matter. So, would you say? I mean, I know you're saying that you don't know. Would you like to know what the Earth is, as far as the surface measurements are concerned?
Yeah, it would be nice if I know, of course.
Okay. Well, there's a really easy way to figure it out. We all know, it's something that we kind of instinctually understood and know since we were kids, that water finds its own level. And so if that's the case, and 70% of the known world or Earth is covered in water, that means that water is level upon the surface.
How do we know that 70% of the Earth is covered in water? That could be a lie, though.
Well, what I mean by that is that that is like I said, the claim, right? 70% of the known world is 70% water. Now, if somebody,
that's probably a lie. I don't.
Well, if it's a lie, no, it's not a matter of them, bro. It's a matter of vast oceans. Navigable oceans that are quite large. There's a lot of water on the Earth. No one's saying anything. It is what it is.
Yeah.
So if your observation and experiences of a mostly covered in water Earth, and we know that water is level, that is a flat Earth.
Oh, yeah. Could be.
Yep.
Maybe it's a cube.
Yes.
Could be a cube as well.
Where's the corners at? Why could it be a cube?
We're living at the top, then there's the bottom, and there's the sides. Still flat, but it's a cube,
Well, it would have flat sides, but we would have to go ahead and find these sides. Most importantly, the corners.
The corners are like it's a wall that you cannot really cross, I guess.
Really?
Could be. What do you think?
What do you mean it could be?
Could be that way. I mean, I'm giving possibilities here.
Okay, like I said in the beginning of this particular conversation, we're talking about the surface that you and I both dwell atop. We're not talking about the overall shape or composition. Is that sinking in yet?
Oh, the surface we're standing on? Yeah, it could be flat. Yeah.
Yeah. Oh no, it definitely is. It shows no evidence or measurement of anything other than that. Everybody's measuring it that way. Everybody's using it that way. Everybody experiences it that way. So, just by empirical nature of the surface of the Earth, it is flat.
Yeah, so they're probably lying about the gravity thing, right?
I don't know who are they and what is gravity, because I've been getting I think there's at least 5 different types of gravity, so it would kind of have to be one of those that you're speaking of specifically. So I don't know. Which gravity are you talking about?
They say it's the force that pulls us down to the center.
Yeah, that one's kind of outdated. That one's been superseded by a bending and warping of the space-time mathematical conceptual medium.
What do you think? So it's a lie, right?
Well, I mean, I don't know if I would call it a lie. It's just someone's idea of what could be, although It really can't be that because, space and time are not physical. So it's only conceptual. It only exists in mathematics. It doesn't really exist in reality. So, I mean, somebody could say that.
Not flying then? How can we stand?
I don't know. What do you mean flying? Why would we be flying?
I mean, why would we stand? Why not flying, for example? Why not fly?
I mean, this sounds more like an existential question as to why the Earth is the way that it is. Why do the more dense things tend to go downwards, and why do the or more dense things go downward? Why do the less dense things kind of separate themselves above that? I don't know. That's just the way it is. I don't think there is a causal mechanism. To me, it kind of seems like just another natural law.
See, well, for them, they kind of explain that with gravity, but I don't know. What about you guys? I have no idea.
No, we don't. I don't think anybody here would ascribe a causal mechanism. We can only describe what is occurring, because for there to be a cause, we would have to have something to vary and manipulate to get this stuff to do what it's doing, just seemingly naturally. So it seems to be oriented and created this way or designed this way. If you're going to ask me, it seems to be designed in this way for our practical uses. If you're going to pour yourself a cup of coffee, you want the dense liquid to go down and displace the air within the cup. That seems like a design, not necessarily anything being caused, more like a law. But that's just me.
Yeah, I mean, I went to Norway. It was like the north of Norway, and there was this creepy thing that the sun doesn't go away. I don't know why. Sometimes the sun keeps in normal countries the sun goes and come back. How is that possible in Norway that the sun doesn't go down? I don't get it.
I don't know. What is the sun? And by the way, that only happens for about half the year, right? The other half, the sun does go away.
Yeah.
Yeah. So it is like the other lands that only get sunrise and sunset. Right. I don't know. I don't know what the sun is. I don't know how far away it is. I don't know why it does what it does.
Okay. I thought you have an answer. Sorry.
No. All we can do is describe what's occurring. I mean, for certain, it isn't a burning ball of gas within a vacuum that would violate the natural law that we describe.
Those scientists in NASA, they're probably lying to us that they can, that they can fly, go to the space.
Yeah, I don't know. I mean, it's all on TV, right? So those guys can put whatever fiction or nonfiction they want to on the television. It doesn't necessarily mean that they're lying. Maybe that they just let people believe whatever they want to believe. I don't know if you can consider that a lie or not.
They probably, whether they're lying or they actually did that. I mean, when you see them saying that they went to the moon, and they landed on the moon, it's kind of, I don't know. They are whether lying or they are saying the truth. I have no idea.
Yeah, hard to say. But it doesn't really matter. We know we don't have to pay attention to the TV anymore, right? Because it's always going to be fiction or nonfiction, and they're not going to tell us which one it is. So since we already know that the Earth is flat, and the idea of a burning ball of gas within a vacuum is silly and absurd and violates natural law, we can just kind of ignore whatever they tell us at this point. Don't you agree?
It depends on what you mean by natural law.
Natural law, like the first law of thermodynamics: matter cannot be created nor destroyed.
But that's
second law, entropy. Those are natural laws. That could be a
lie as well. I mean, we don't know.
No, it's not a lie. It's natural. It's observed reality. It's not anything to do with a
thermodynamic
cause.
Is observed reality. Are you kidding me?
And it's just a description that we give to the matter and the energy that we experience in the physical realm.
I mean,
no, we do.
Out there in the space. I have no idea.
You experience it every day. It's natural law.
I don't. What do you mean experience natural law every day?
So you don't experience entropy? You never drank a cup of coffee and it got cold after a while?
That could have many explanations. I have no idea.
No, it's not an explanation. It's just a description of what occurs. It's called natural law. Are you okay?
So when you drink something, another thing would happen if you... Yeah, right. That's what you mean.
No, I'm saying that when people drink cups of coffee, if they leave that coffee on the table for a certain amount of time, it's warm and then it gets cold because the energy...
there's no because. You can't know what is because you're not explaining. You're just experiencing. You don't.
Yeah, that's why it's called natural law.
Yeah, don't say because we don't know why.
When did I say because?
There is no because.
Why did I say? When did I say because? I didn't mention a cause. I said this is your experience.
Yes, the cup of coffee, when you leave it on the table, it gets cold. That's what we know.
Right. That's the description. Yeah, that's natural law.
You call it whatever you want.
That's not me calling it that. It's everybody calling it that. Except you. Apparently you think that it might be a lie that your coffee gets cold.
No, that's an explanation. But what do you call it is up to you, right?
Do you know the difference between explanations and descriptions?
Yeah.
Okay. What's the difference?
Description is when you actually tell something that you see with your eyes.
Right.
And explanation is when you tell why is this thing happening, right?
Right. Nobody here is proffering any kind of cause or why it's happening. It just is. That's why it's called a law. It always happens no matter what.
But sometimes it's not always the case.
Okay, can you give me a scenario where it's not the case? Let's use entropy, for example.
I mean, they use some ideas in space we don't know about.
Oh, what are you talking about? A place that's an ever-expanding vacuum beyond an arbitrary line called the edge of the atmosphere? Oh, yeah, that's all fake.
Yeah, exactly. And also they say that the energy cannot be created. What do you mean? How did you know the energy cannot be created?
We do not experience a scenario where energy or matter are being created currently.
But that doesn't mean it was never created before.
We're talking about our actual experience. So in the experience that all mankind has had, there is no creation or destruction of matter and energy. That's what we experience.
Yeah.
That's why it's a natural law.
They would say energy will never be created or destroyed. Not can never be.
Okay. So I see that you're appealing to the future in the current state of affairs that we have. The current state of affairs is matter cannot be created nor destroyed. Currently, that is our experience, and it has not changed since the beginning of recorded history. So,
yeah, so we're only talking about the present. We're not talking about the past, because we don't know what happened in the past.
Fair enough. I guess we really don't. But right now, matter is not being created or destroyed. It seems to be in cycle. It seems to be in a recycle cycle.
Yeah, probably.
Yeah, that's why it's a natural law. That's just what we observe. It's a description.
Yeah.
So, the idea of space, that violates natural law. Water finds its level. Light things go up. Heavy things go down, generally. All seem to be natural laws.
That's the creepy thing about them. They give an explanation to a lot of things on Earth. For example, the example that I gave to you about Norway, they say that the Earth is kind of a bowl, and the sun doesn't really reach that point until 6 months pass. So they kind of give an explanation physically which I don't really see true because they could be lying. I thought you have an explanation, but I think you
No,
don't.
why would there be an explanation if we already know that it's false? Because the Earth is measurably flat, so you already know it's not right.
It's not measurably flat. It's
Oh, really?
They
usually do you have measurable curvature somewhere that you could show me?
It's pretty obvious the Earth is flat, guys.
Yeah.
Stop being stupid.
Yeah. So that's what I'm living right now. Like, I'm seeing Earth as flat. I think it is, but it could be a bowl as well, as they say. Because
wouldn't it have to be curved?
It could be a big bowl. Like,
how big?
Really big bowl. And
how much curve would we expect to see about how big it is?
I don't know. Because
a bowl or ball?
A ball.
What fucking crack are you hitting, dude? What is that?
I have no idea. That's what they say.
So anyway, yeah, if you say it's a really big ball, where would that curvature be at?
I mean, you don't feel the curve, I guess, because you're too small compared to the Earth.
Well, okay, fair enough. But where would we be finding any of this curvature, measuring it, experiencing it, all that stuff?
I don't know, but like it gives the explanation of Norway, for example, and what is happening there.
But it doesn't, because the Earth is measurably flat. You hear this part where I'm using the word measure? It's measured flat, so it cannot be a ball.
Oh. See, they have an explanation for some things, and you have explanation for other things.
No, their explanations are just stories. They're kind of like fairy tales because they don't demonstrate any of the things that they're telling you the story about. Like, take space-time, for instance. Space-time is purely mathematical. It's just conceptual. It doesn't exist in reality. Do you think it's a good explanation to have something that isn't physical doing physical things?
No, of course not.
No, right. So would it make sense then that they would be saying that the sun is a burning ball of gas within a vacuum, already denying and breaking the second law of thermodynamics around an Earth that doesn't have any curve?
Yeah, they are lying in this, exactly.
I didn't say that they were lying. I'm just telling you that that's their story. You're accepting their story, maybe. You just think, well, it makes me feel better that somebody has a story that I could believe in, even though the story doesn't make any sense. Doesn't mean they're lying.
I mean, nothing makes sense, right? Even the flat Earth doesn't make sense because we don't have explanations for a lot of stuff, right?
I'm sorry, the flat Earth only declares that the surface of the Earth is flat.
Come on, but like, come on, let's do like them. Let's make physics. Let's explain stuff. Can't we?
They're not making physics. They're making stories. They're making fictions and fairy tales. Do you want us to start making things up that aren't even possible? You think we should do that?
No, like there's based. The science is based on those stories that they're telling.
There is no science. What science are you talking about?
There is no science.
No, what science are you talking about? You use the word. I'm curious. Is there an experiment being conducted?
The technologies they're using right now are all, or most of them, are based on what the stories they're telling. For example, GPS and
GPS. What is GPS? Do you think that there's some kind of machinery orbiting around a ball Earth that doesn't exist?
That's what they're saying.
And that the Earth. Okay, well then, if you know that the Earth is measurably flat, then that story is also bunk. And that there is no mechanism by which you can tether a piece of machinery around a non-existent ball called gravity. That doesn't exist. So what technology are you talking about? There's no machines flying around a ball.
So how do you explain the internet?
The internet runs through cables and towers. Are you okay? How old are you?
I'm 23.
Oh gosh, so you don't know that your internet is fed through towers and cables?
No, I know. Of course, I know, but they always say that there is this, spacecraft that is flying, and our conversations are all going there and coming back to another space on the Earth, so you can. That's what they're saying.
That's not the claim. No, actually, they even admit that somewhere in the ballpark of 95 to 98% of all communication is through cables or towers. Now, if they're making a claim that the other 2 to 5% is due to some kind of machine making a orbital path around a sphere Earth, well, we can just go ahead and count that out because it violates the second law of thermodynamics, and the Earth is not a sphere. So their story,
just like Starlink, just like what Elon Musk is doing.
I don't think he's doing anything. Do you have any evidence that there are machines hurling around a sphere Earth tethered by a non-existent force or bending of space-time called gravity?
I have no proof for that. He is saying that. I don't know. I have no proof for anything.
Right, so he can tell the story, and people can buy the internet, and most likely it's coming through a tower. What do you do?
Oh, I see. So where are those, space rockets going when they launch them?
No idea. I've been to a rocket launch, though, and it just kind of did a parabolic arc and went downrange. That's what I witnessed. I didn't see it go into space, I'll tell you that, whatever space is supposed to be.
I've seen one go into space. That's what they said.
Really?
That's what they said.
So you didn't say it went into space. You went by what they told you, but not what your eyes told you?
My eyes saw the rocket going, and then you can't. Yeah, there is a point where you cannot really see the rocket anymore.
Okay.
So you go to this screen where they show you where this rocket is going, and you see the same thing. Like the rocket is going the same.
They continue the story on a screen because now you can't see it with your eyes. So the thing on the screen, was that real?
Can you see everything with your eyes?
No, not all things. That's why I'm telling you. So now they move to a screen, and you begin.
Sometimes
I don't have to trust anything. You can trust whatever you want. But, I mean, if you're just going to believe whatever you see on a TV screen, I'm going to tell you right now, in this day and age, with AI and deep fakes and everything, you're going to get ripped off.
Not TV. I'm telling you, like they show you a screen in front.
A screen, right? So a television screen, or a computer monitor, or your little cell phone screen. Yeah, the little fictions that come through the screens called movies.
No, but what if I am the one who, placed the camera on that rocket? Like I'm the one who.
Are you the guy? Are you the guy?
What if I'm the guy who placed the camera on the rocket?
Are you that guy? I don't want to deal with hypotheticals. Are you the guy that did that?
Well, I'm going to do that soon.
Really? That's fantastic. So when you place the camera on the rocket, whatever happens on the screen after it goes out of your eyesight still could be a movie.
What do you mean?
I mean, you just placing the camera on the rocket isn't going to tell you whether or not what you're seeing on the screen after it goes out of eyesight is real. The screen doesn't tell you that.
Why not?
Do you think that everything that you see on a screen is real?
It's my camera.
I don't care if it's your camera. Is it in your hands?
You mean that they probably changed the screen of my camera, right?
No, I'm not saying that they changed the screen of your camera. You know what they could be doing?
Probably do that.
Well, maybe. I don't know. But the point is that there's no way for you to know.
So until I go myself, right?
Yeah, until you actually go to a place that violates the second law of thermodynamics, you're not going to know.
No, but like if I went myself, I would see what is going on, right?
Listen, if you want to live in the hypothetical world, if you did something, then it might be true. I mean, I guess that's up to you. In the meantime, the Earth is measured to be flat.
in the meantime. But what if I went myself?
Yeah, listen, bro, you can do all of these mental masturbations if you want to about what if. That's up to you. I can't answer that for you, but what if is kind of like an appeal to the future and also just a pointless exercise of
That's
mental
what I'm studying
masturbation.
right now. That's what I'm studying right now.
Okay, so when you study and they're telling you that the Earth is a ball, but there's no measurements of it, which answer are you going to give on the test?
Do you think I'm believing them?
I don't know. Which answer are you going to put on the test?
I'm going to put whatever they want me to put, of course.
Exactly. That's my point. See, because
but that doesn't mean I believe them. Sometimes I study a bunch of nonsense that I don't believe, of course.
Okay.
I've been studying, for example, the Bible, which is a bunch of nonsense that I don't believe.
Okay.
And yeah, I have to put the right answers on the paper because it's a matter of grades. But when it comes to this, I can go myself and, see with my own eyes what is going on up there.
Up where?
When you go, there are birds flying, right? I want to reach the bird first and then reach the airplanes second, and then go up and more to see what is going on. The more you go, the more you discover what's there, right?
You're talking about a flat Earth then?
Yeah, well, a flat Earth, whatever. Once you go up, you can see whether it's flat or it's not.
Right. How high up do you have to go?
As higher as you can.
And how high would that be? Because right now you're describing a flat Earth when you're saying high and up and all that stuff.
I would know once I go. I would know once I go.
How high do you have to be?
Look, if I went certain height and I didn't see a lot, I would go more.
How high would that be?
I have no idea. I have to know. Once I go there, I have to know. Because I have no idea. They have some calculations that I don't believe. But once I go myself, I would know,
Right. So you're looking at basically no curvature as far as any of the major science communicators are telling us, is that even at the height of the ISS, which is 250 miles, you cannot see any curvature. So
I don't care about the calculations that they share. No.
Okay. So
that could be
you'll have to start at 250 and see if you can go any higher than 250 miles. Or you could just measure the surface of the Earth where you're at and know for sure if it's flat. I mean, you don't really have to go very high.
I don't want to know if it's flat or not. I want to know, look, if it's flat, then it has a limit on the sides, right?
Possibly, yeah.
Since it has limits on the size, when I go up, we can calculate. Do you know the size of the Earth or the flat Earth?
I have no idea.
But you can calculate it.
Calculate what?
The size of the. See, do you know how to calculate the surface of a cube? I mean, of a square. Or
so you're talking about? Are you talking about area? Well, what shape are we dealing with there? Because you kind of need to know the shape so you could use the correct formula. So what is the shape of the Earth?
I have no idea what is the shape, but you should know because you can travel all around.
No, you can't.
Why not?
Well, most of the time, if you want to reach some of the more extreme areas of the Earth, let's say Antarctica, whatever that is, it seems to be pretty well guarded. No, it seems pretty well guarded. In fact, there are many accounts where people have attempted to do some kind of free exploration of anything past the 60th parallel and been turned away at gunpoint. So somebody is guarding whatever's going on around Antarctica. So I actually don't know the full limits of the Earth. I don't know which direction I should go to find the limits of the Earth. So it would be possible to actually get a size or a shape.
I've went to the if you mean the South Pole, I've went to the South Pole as they call it, and they only show you. Yeah, they only show you.
That's fantastic. So you went to 0 degrees south, did you?
What? Sorry.
You went to 0 degrees south?
That's what they call it. Not zero.
No, 0 degrees north.
Not the center. Not the center. Because they say that the center of that place it's impossible for you to survive in there. That's what they keep you on the edges, you know.
So you went to a ceremonial South Pole. What does that have to do with anything?
Yeah, exactly. I've went there, and basically, if I was able to go there, then we can calculate
No.
the surface of.
Sorry, friend. I'm talking about exploring it freely to find the end of the Earth. You went to a ceremonial South Pole. You're talking about something completely different. Are you trying to disrespect me about what we're talking about? You going to a ceremonial South Pole is finding the limits of the Earth? Excuse me?
Okay. I want to understand something. I don't know. I'm trying to understand the Earth here. Okay. For example,
you're talking about finding the limit of the Earth, and you think that's equal to going to a ceremonial South Pole?
No, I want to find the limit of the Earth by going to the South Pole, of course.
Well, then go do it. See what happens.
They said that you can't really survive in
Why not?
Once you go.
Well, that's what they say. I mean, if you want to find it, don't let them discourage you. I encourage you to go find the limits. Don't worry about the weather. I mean, that's what explorers do. They do things in spite of the dangers of it.
Yeah, exactly. I will once have the chance to do so. I was, I was really young. I was 20 years old. I couldn't do anything. I was just in a trip.
Yeah.
But once I get older and I have this ability to go and search, I would probably do such things.
Okay. Terrific.
What do you say about those, when you are, for example, in the US and somebody else is, for example, in Europe, and they don't have the same time period. Somebody is in the morning, the other is in the night. How do you explain that?
What do you mean explain it? I mean, the sun moves, so the angular relationship between those two people is different, mostly because of the distance they have between each other. So,
the Earth is flat. If the sun is a lamp, it's just like a lamp that lights up everything. Don't you think?
It is? Do you think it lights up the whole Earth, even though it's dark in some places and light in the others?
How do you explain that then?
I don't really have an explanation other than it doesn't light up the whole Earth. It's just the experience that we have. The sun is in certain places when it's not in other places. So it's more probably localized than you think.
But you can explain it since it's the same every day.
Why would I be able to explain something that we only describe? It's only a description. What causal mechanism should I be giving you in my story?
I don't know. It's like you have to know why. Don't you? Aren't you curious about this?
You understand? I don't have to do shit. So you telling me I have to do something? You can pack sand with that.
I thought you were curious about. I'm curious, to be honest.
Well, I'm very curious, but I don't have any way to actually determine other than what my actual experience is. Do you think that there should be some kind of causal mechanism between why there's light in one place and the other place?
That doesn't make you stop and not
what
do
would you
anything.
suggest?
At least try. At least try.
Why aren't you trying? Why don't you suggest something?
I am trying. I'm trying.
Okay, so give me one of your suggestions.
I thought you guys have the answer, so probably.
No. Why did you think that? See, that's another thing that you did on your part that was an error. You made an error believing that we were supposed to do something that you expected us to do, which is pretty rude, if you ask me.
No, I don't mean to be rude. I'm sorry, but.
Oh, okay. Well, then maybe you shouldn't come in here assuming people have to give you an answer for something that is just basically what we already experience, but is a little bit more involved. Like, I want to see if you have some kind of, you can offer me some kind of solution to this thing as to why it happens. What do you have so far?
I have no idea.
Oh, okay. Me either, and most people don't either. So, expecting us to know why this thing occurs.
Most people have
they made something up. They made it up. But if like I said before, if the Earth is not a ball, then you can just throw their speculations out the window because it's not tenable.
Then what is the sun that we're seeing? What is the moon that we are seeing?
It looks like a bright light in the sky. That's how I would describe it.
Bright light in the sky. Yeah. So you are describing everything you see with your own eyes, but without an explanation of why or what is that exactly.
How would I do that?
Exactly, that's the question. I would like to I would try to look it up.
Yeah. So the sun is a bright light in the sky. It certainly can't be a burning ball of gas within a vacuum.
Why not?
Well, I mean, have you ever tried to set burning balls of gas on fire within a vacuum? Like, it's just gas, right? So why would gas essentially gather together into a spherical shape inside of a vacuum, when our experience was whenever you put gas into a volume or a vacuum, it spreads out equally in all directions. So the coalition or the coalescence of that gas into a sphere in a vacuum, a very high vacuum, violates the second law of thermodynamics. So it can't be that.
It's like, imagine with me if there is like a glass, a glass surrounding the sun, not letting the energy that is inside to go out. So it's like a ball made of glass, probably.
So the sun is probably a ball made of glass, says you.
Just like a lamp, for example. The lamp has light inside it, and it's surrounded by glass. Could be that way too.
Yeah, there's still a problem. How thick is the glass? Now that you're speculating, now that you've come up with a new idea about what the sun is, what is the environment in which the sun is in? Is it a vacuum or is it a pressurized system? What is it?
Vacuum.
I got you.
No, I didn't hear you. What is the environment in which this glass ball sun is in?
We know the answers of the questions step by step. I guess we can't know everything at once. So I'm giving you. You said give me a proposition. I'm giving you one of the propositions, right?
Okay, this is your proposition. How would you prove it? Okay, let's discuss it. Go ahead and prove that to me. That way we can decide whether or not we're going to keep this idea.
We have an experience of a lamp being inside glass. So it could be the same, because
can you prove it to me, please? Can you just prove it to me? I don't need to hear you tell the story again. Prove it.
What do you mean prove it? How can I prove it? It's just a proposition.
Well, then I'm going to have to go ahead and throw your proposition out because you don't have anything to back up what you're speculating about. Right. So you gave me one. I'm dismissing it because it's just an idea that you have with no evidence.
No, I'm not giving it to you to prove it or to believe me. I'm giving it to you to discuss it.
Why are we discussing something that would make no sense, since you just want to imagine what it could be? I mean, that's a waste of time.
It's not. I'm trying. You said at least try, so we are trying right now.
Yeah, I know. The next thing to do after you come up with an idea is see if it's even tenable, or how you would be able to prove something like that. Okay, go ahead and check and see if there's a glass ball surrounding the sun.
Yeah, so do you think that's not possible?
I'm asking you to show it to me. I don't care about whether or not it's possible. Who cares about what is or what is not possible? It's about what is. How come you guys live in more of this fantasy land where maybe it could be one thing when in reality it is what it is?
Yeah, I don't know.
I don't know either.
I'll try to find an answer.
Okay. In the meantime, it certainly is not a coalescence of gas within a vacuum.
Then what is it?
I have no idea. As far as I know, it's a bright light in the sky. And it rises in the east and sets in the west. That's what it does.
Yeah. Disappears at night, go back in the morning. Sometimes it doesn't come back. Sometimes it hides behind the clouds.
Sometimes.
Yeah. The clouds, which are some kind of things that fly in the sky, I have no idea. I just call them clouds.
No, I mean we've gone up to the cloud level. It's condensation or small droplets of water. We already know what those are.
Did you go there?
Yeah, I did actually. I've been in a plane and we went through the clouds and it all collected on the wind or on the windshield. So on the windows, it's pretty simple to experience.
You can't know what's that.
I can't know what that is. I can't know what water is on the window.
What? Water? Is that water? It's not water.
Yes, it's water. Oh, so it's not water. What is it then?
I have no idea. Prove it.
You have no idea.
Prove that it's water.
Should we go get a sample? Should we get a sample of it? You think no one's grabbed a sample out of the clouds, dude? Are you out of your mind? See, this is what happens when you guys lose terribly.
Do you believe them?
Come in there and troll a little bit. And then when you realize that your worldview is so ridiculous and all you know how to do is imagine things, affirm the consequent, and then do hypotheticals in your own mind, when someone points out something obvious, you revert to, oh, I know what I'm going to do. I'm going to do the same thing they did to me and go, well, how do you know? Well, if you don't know what water is at this point in your life, at 23 years old, and if you don't know that the things that come out of those fucking clouds when it rains is water, then I don't know how to help you.
No. How do you know that they are water, actually?
It falls on my head when it's raining, dickhead.
Why are you cursing right now? Sorry? What did you say?
Because you're being ridiculous, bro.
I'm not being
You've never
ridiculous.
been you are being ridiculous. What falls on your head in a rainstorm?
It is water. But how did you know that? How did you know that the clouds are water?
Oh my gosh! All right, you're going on mute. I'm sick of you.
Okay.
When it descends into absurdity and you guys just are bankrupt, this is what you do, and there's no point to speaking to you at this point. There you go.
So I have a question for you guys, and it's a genuine question. With the whole Chicago skyline thing, isn't it possibly the case that for an object that is large, so here's the thing, right? For like a light post, I think your argument is valid, like it's cogent. You shouldn't be able to see that object. But if an object is big enough, it'll go over the horizon. Does that kind of make sense? How do you know that's not what's happening with the skyline?
What do you mean by over the horizon?
So, like, okay.
So big enough as in a mountain, you can see the base of it, or tall enough? Which way are you going?
So I'd be like, when you see, when an object starts to disappear over the horizon, it goes bottom up. That's because, well, you don't believe this. That's because the Earth is curving underneath it. What I'm saying is...
That's the claim.
Yeah, that's the claim. Just bear with me. I'm saying, how do you know it's not... So, like, okay, an object disappears over the horizon, right? You're standing still at some observer height, and the object is receding until eventually it can't be seen anymore. Now imagine that object grows by 100 miles, like, of length. You would then be able to see the object.
So it's to do with your angle of resolution, or angular resolution. What is it? 0.02? Once it's below that angle, you'll have trouble resolving it. So if you've got a bigger item, like a mountain, for example, it just means it can get further back until perspective makes it appear small enough to get below that angle of resolution. That's all that's happening. So as things get further away, perspective, they appear to get smaller. So something small, like a tennis ball, for example, wouldn't have to go too far until that angle gets too small and you can't resolve it. Something large like a car, or larger, I should say, like a car or a truck, would go a little bit further. Something very large like a mountain would go a long way further back. Does that make sense?
Yeah, I get that. That is true, but specifically with objects over the horizon, it's more than just angle. It's more than just how far away it is, because if something's over the horizon, there's no amount of magnification that will allow you to see the object. Which is what you're implying.
At least we agree on that simple fact. If something is hiding behind something, it ain't coming back out. So it doesn't matter what you do or what kind of magical lenses you've got. So what you've got, you've got a combination of things happening. So number one is perspective. Things appear to get smaller as they get further away. Another component of this is your elevation in comparison to the object that you're looking at. So say your eye line is 5 foot, I'm just picking a random number, and the item you're looking at is a large container ship. The container ship will appear to shrink uniformly, but when your eye line is, it's only 5 foot up the container ship. So as the ship shrinks from the top down, bottom up, left to the right, right to the left, to converge at your eye line, the bottom will hit your eye line before the top will. And it's an effect called foreshortening. And if you do, probably tech drawing or art classes, you would have a lot more interaction with that. So its appearance is it's shrinking evenly from all sides, but the problem is because you're so close to the bottom of it, the bottom will hit your eye line before the top or before the sides. That's why it appears to disappear bottom up.
That doesn't make any sense. If it's disappearing bottom up, something's obfuscating it. If the Earth is flat, you should just be able to take a telescope and magnify it.
It's to do with compression. So what happens is because of your angle of resolution or angular resolution and your ability to resolve that, because the data or information that's below your eye line there's so much of it compressed in such a short space, you can't resolve what it is. So it just blurs into the background. And that's exactly what happens when we watch ships sail away. Because you're so close to the bottom, it's compressing into the water, and you can't differentiate between water and ship because that angle is so narrow, you can't tell what it is. And that's all that's happening. It's really
you actually
easy stuff,
prove that, because I don't agree.
Well, you can agree with whatever you like, but there's some pretty cool pictures in the side chart that AI Overlord 2.0 just chucked up.
Yeah, but you're doing, like, pictures don't explain a mechanism. You're proposing a mechanism.
Please don't do that on the microphone again.
You don't need a mechanism.
Well, that's what he's giving. He's giving a mechanism. Some kind of compression is happening.
Yeah, but you don't even need to do that. You just need to demonstrate that it occurs in a situation where the alleged claim of something in between point A and B is clearly not occurring. And then if you can demonstrate that, then you've proven that it's not necessarily an obstruction that's causing it.
Yeah, but that's the thing we're trying to prove, right? You want to prove that there's no measured curvature.
No, see, you can't. It's not about measured curvature, because you're inferring curvature from a claim that the only reason why I couldn't see something if it was being blocked by an object. So that's your burden to prove.
It's not the other. No, I'm not inferring curvature from that. I'm saying that due to the curvature, this is what happens. But curvature is what's in question. That's what we're trying to establish.
Okay, so then you can't. Right. So if you say due to the curvature, this is what happens. Why would you be saying that if you haven't proven it?
Oh, because I already believe that the Earth is curved. If you don't, then I wouldn't expect you to believe that that's why what you're seeing is happening. Right. I would expect for you to question that until curvature is established. That's what I'm saying.
Wait a minute. So you're expecting someone else to question your claim until curvature is established. Shouldn't curvature already be established?
No, that's not what I said. I said I already believe the Earth is curved, so of course I'm going to believe that the reason things disappear
yes, but you're
bottom
trying
up.
to convince us, not yourself.
Yeah, I'm not trying to convince you that things disappear bottom up because of the curvature yet. We have to establish curvature. We're not there yet.
Excellent. So prove curvature, and then we'll talk about the ships disappearing bottom up.
I've tried to run the Rainy Lake experiment before, but I mean, to be honest, I don't. I actually don't think
pretty junk experiment, if you want to call it that. Observation. Look, this is the thing. I lived on the coast my whole life, and in a location where there's it's like a hub for cruise ships. And growing up fishing and surfing at the ocean a lot, we would be sitting there waiting for fish and whatnot, and watching the cruise ships actually sail out into the ocean. Most often, what happens is it just gets smaller and smaller, and it kind of just fades off, right? Because the visibility is not far enough to see the extent of the ship's path. Or if you have really good visibility, the ship will just become too small and you can't resolve it anymore. You can still see the horizon, but you don't see the ship anymore. Now, sometimes you would have waves, okay, like ocean swells. If you have ocean swells, the ship will appear to disappear bottom up, but not if there's not ocean swells generally, right? There are some miraging effects that could happen, but if you have a look at this giant ship in the side chat here, which I'm just uploading now, okay, just think about this one, okay? So he's standing at the shoreline. He's zoomed out completely. You can't see the ship at all. Okay, and when he zooms in, you see the whole ship again. Now, we can see that there's no waves here. If you added ocean swells into this situation, it would look like the bottom of the ship is cut off, because it would be hidden behind the ocean swells, even though the ocean swells, because you're looking over them at a shallow angle, it's going to look kind of flat still with the ocean swells present, but it's going to look like the ship's disappearing bottom up. This is what happens most of the time. So it doesn't always start to disappear bottom up. Now, if it were a globe, it would start to disappear bottom up at a certain distance. So from this height, it would be just 3 miles away, and then it would start to disappear bottom up. Now, we've got tons of observations where we're specifically checking for that geometric horizon distance to see, okay, the object should start to disappear at a certain distance bottom up as it moves away from the object. And it's over and over again confirmed that doesn't happen. Okay, so we're questioning, how do we know the geometric horizon exists in the first place if there's no evidence of it at all?
Well, because you're not accounting for refraction, that's the issue.
Yeah, but people butcher the word refraction. So even, right, let's just pretend the Earth's a globe. Even according to the globe earthers, right, like the subject matter experts in refraction, like Andrew Thomas Young, right, and all of the mainstream explanations, they'll say that there are refraction effects that can happen that would cause something to become obstructed bottom up. Even though it's geometrically unobstructed, it's going to look like it's unobstructed, right, like sinking and whatnot. Okay, so it's the
biggest issue with his refraction. As soon as he makes a claim to it, he loses all claims to geometry.
Yeah, let me clarify. So when I say refraction, I'm not talking about why objects disappear bottom up. I'm talking about you say geometric horizon, that's not actually where the horizon is due to refractive effects. So the actual horizon, the effective horizon, is a little further. That's why you don't see it disappear bottom up.
No. The geometric. Okay, so let's go over a specific observation. Okay, and let's dig into this a little bit. Okay, so I'm gonna test for the geometric horizon here in this test. Okay, so 1 second. I'll just upload a quick GIF. Okay, and a screenshot from the Earth curvature calculator. So have a look in the side chat.
I'm driving.
Oh, okay. Well, that makes it a bit harder.
Hold on.
Well, I'll try to explain it, okay? So in this observation, he's got the camera height at 3.5 foot. Okay. It's a crystal clear day. It's a calm ocean. There's no waves at all. Okay, so 3.5 foot camera height, that means the horizon on the globe should be at 2.29 miles away. But he has a wind farm out in the ocean that's a known distance away. Okay, so we can see 6 wind farm towers out in the ocean, crystal clear. Okay, the furthest one is 11 miles away. and the closest one's 8 miles away. So 8 to 11 miles. We don't see any sign of any horizon before the windmill farms, right? We can actually see the water just completely flat, going up, flat, until beyond 15 miles away.
Right.
Okay, so what we're questioning is that geometric horizon has to be there, right? It's like a physical cutoff point. Okay, it has to be there. Let's say we hypothetically remove the atmosphere. Okay, you would have to agree that there is the horizon line would be visible at 2.29 miles if the Earth were a globe.
Yes.
Okay,
Yeah,
so
if there's
and
no
we're just adding the air back in, and now all of a sudden everything's flat, completely flat all the way up to the horizontal horizon at 15 miles. Yes, because there's no obstruction. Hold on a second, let me finish, and then you can respond. Okay, so we don't see any obstruction at all. Okay, so physically, geometrically, actually, the bottom 52 foot of the 11.2 mile windmill tower is hidden behind the curvature of the Earth, right? The physical geometric horizon is at 2.29 miles. Now, we can't find it. It's not there in the observation. Okay, so how do you know such a thing exists? Do you have an observation that's taken specifically, right, the hyperspecific refraction conditions into account that aligns with the globe and that clarifies there is such a thing as Earth curvature and a geometric horizon, which is a byproduct of the Earth curvature? Do you have anything that validates that, right? Or because otherwise, it's just a concept, essentially.
It's a criticism of your measurements. Basically, your measurements don't. So the reason why it's not obfuscated is because the light.
What's wrong with the measurements? What's wrong with the measurements? How about we just break it down one step at a time? You've got an issue with the measurements, Nables. Don't cry on me. You've got an issue with the measurements. So what's the issue with the measurements? From a specific height, the horizon should be at a very specific location. It's not
accounting for the fact that all the light is being shifted upward.
No, that's got nothing to do with it. It's a calculation. We are assuming a radius of 3959 miles. We are given an elevation. From that elevation, we can calculate where the horizon should be.
That's the issue.
Yeah, so how did you validate that the light's bending upward, right? So if the light was bending upward, that would make the object appear to be sinking. So you haven't got that right. You would have to say that the light is bending downward towards the observer. Okay, how did you establish that that's happening?
Oh, that's a well-known phenomena. Whoever's taking the measurement, they must establish that, to what degree it is happening. That's on the burden. That's the burden of the person taking the measurement.
Well, no, actually, no. That's not how it works.
Why?
Why would it always be bending downward, right? So does light just bend towards the denser medium?
It's continuous, so it would bend continuously. It wouldn't be like a
no. So this is nothing to do with Snell's law.
If we were to grab a laser and shoot it, it would naturally bend down. That's what this gentleman's saying.
Yeah, what he's trying to invoke Snell's law here. Snell's law has nothing to do with the single medium situation. Nothing at all to do with it. Okay, so even in Snell's law, you're going against what you're saying. Even though you can't use Snell's law here, Snell's law just means the light deviates towards the denser medium. Okay, so this would be atmospheric refraction, according to the mainstream terminology. Okay, and it would be a gradient, not a sharp boundary, but the light still the same thing would happen. The light would deviate towards
I said it wouldn't be Snell's law.
Section of the medium that's more optically dense. Yeah, that's what would happen. So it doesn't. Okay, so if you have cooler air higher or cooler air lower, the light's going to deviate towards the cooler air.
Hey, hello? Can you hear me?
Yeah. So you have no idea that the light would be bending downward in this situation.
I don't know if you can hear me. I said it wouldn't be Snell's law. I said that 6 times.
You did mention Snell's law.
Yeah, I mentioned it in saying that it wouldn't be an instance of Snell's law. Anyway, the light would still refract since it's moving through a denser medium.
What do you mean a denser medium?
From a less dense medium. So where's this happening at?
Throw it
on that picture there.
Actually, no, denser. Or denser? Is it more? Basically, as you go from...
Hold on a second. Okay, so when you have atmospheric refraction, it's about the vertical optical density gradient between point A and point B. And then the light will be heading from the object that you're looking at back towards the optic. Okay, so it can bend or it can deviate a little bit towards the denser medium. Okay, so the optical density is primarily controlled by temperature. So if you have an inferior mirage, right, that's the opposite of a superior mirage. The light doesn't always bend down or up. It depends on the temperature gradient or the optical density gradient. Okay, so you have no idea what's going on with the optical density gradient or the refractive index gradient in the observation. You're just trying to reverse engineer it to make it work on a globe. What I'm asking you is how do you know that you have a globe in the first place? How do you know that you have curvature in the first place? Because when we make these observations, it doesn't match up with the globe. It doesn't match up, not by a little bit, but by so much that you would have, like, let's just say we pretend the Earth's a globe and we're using the refractive coefficient, right? Trying to make this work on a globe using the globe version of atmospheric refraction or terrestrial refraction. You would have to have so much refraction that would essentially make the Earth look flat.
Source?
Even though we have crystal clear conditions, right? We don't see any miraging or anything like that. You're saying that there's such extreme refraction it would make the Earth look flat. That's ridiculous. And what I'm challenging is that how do you know that there is actually curvature in the first place? Rather than trying to reverse engineer it, how do you know it exists in the first place? Do you have one test that's been done that validates that there is actually drop over distance?
So I'm not no, I don't have that. But I'm simply pointing out issues with your methodology. Like there's issues. You can't conclude what you're concluding. That's the problem.
What's my conclusion?
Your conclusion is that there's no measured curvature.
Yeah, my conclusion is, right, that we can see zero evidence of the geometric horizon, right? And we can see the bottom of objects that should be hidden by a 5-story building. Okay, that doesn't match up with the globe. Okay, that's my conclusion. That's my conclusion here. It checks out with it checks out with flat. Okay, we don't see any curvature. So if no, I don't need to.
You keep saying that, and
no, I don't need to. I don't need to account for refraction because I'm not making a specific claim with this. I'm saying that this doesn't match up with the globe. Okay, there's no sign of the geometric horizon. And you're saying it does match up with the globe, but you have no idea what's going on with the refraction.
Actually, DJ, his claim earlier was that the horizon is actually further than what we claim it is.
He did claim that, yeah.
Yeah, that my response was that that's what, if you account for refraction, yeah, that's what you'd observe.
Okay, so just visually, okay, this doesn't match up with the globe, right?
No, false.
So
really?
You're claiming it
so visually it does match up with the globe?
Yes.
So why is the horizon behind the windmills and it should be quite clearly in front of the windmills?
Because it shouldn't be. You're not accounting for refraction, that's why.
So refraction would also bend the windmills up too?
Yeah.
It's not doing that.
Okay, so how do you know? How do you know? Do you have a single observation where you've accounted for refraction that matches up with the globe?
Well,
anyone throughout all of history, just one observation, right? That validates that. Okay, we've accounted for refraction in this observation, and it matches up with the globe, right? You don't have anything, so you don't even know if it exists in the first place.
It is your burden of proof. You're the one that claimed it. So, Nables, just to pin this down right now, as soon as you blurt the word refraction out, you lose all and every claim to any geometry in regards to that image. You do understand that. So if you're going to make a geometric claim, you are more than welcome to do so, but as soon as you go refraction, game over. No more geometry for you.
Okay.
And look, just quickly. Okay, so if you put this observation into Walter Bislin's Earth curvature calculator, okay, it has a refraction slider, and you have to slide that slider up to the point where the K factor, the refraction coefficient, is set to 1. That means that according to Walter Bisland's write-up on the refraction coefficient, there would be so much refraction that the Earth would just be appearing flat. Extreme refraction. Okay, that's ridiculous because this was done on different days, right? Still the exact same things happening. So in all of these different observations that we go out and take, there's so much refraction that it just makes the Earth look flat. And you don't have a single observation that validates the Earth's a globe.
Did someone post that slider?
Yeah, I can post the slider.
I appreciate it.
I can post. I've already put in all of the details of that particular observation that I'm talking about into the slider.
Yeah, bro.
Screenshot.
Bro, that slider actually slides up to a 60 billion mile effective Earth radius.
Yeah. That's what you have to set it to have no hidden height.
I mean, then you're just saying that the Earth appears to look flat. You just said that earlier. I mean, because basically what you're telling us right now is that the geometry and the measurements that we should have, the geometric horizon that should be physical, and a physical hill edge that's blocking ships. Oh, it doesn't. So the Earth appears to be flat, but I have to Earth refraction. So therefore, you're throwing away your geometry plane. You're throwing away your physical Earth edge.
So, like, if there was no atmosphere, yeah, that would be the case. But I'm telling you that the effective horizon gets shifted because of refraction.
How do you know it's there in the first place is the question. How do you know the curvature's there in the first place? That's the question. Because the observations don't match up. So how do you know it's there?
Okay, at this point, I'm not even saying I know it's there. I'm saying that your measurements don't, you're concluding that because you have incomplete measurements.
Okay, so we're not making, one second, Reg, sorry. Look, we're not making a specific claim to the horizon being the physics. Hold on, just let me finish.
Oh, sorry, yeah, my bad.
Right, look, we're not saying that the horizon is at X distance because the Earth's a particular shape. We're saying that our definition of horizon matches up with the actual definition of a horizon, the apparent line where the sky and the ground meet, right? That's what the horizon is. That aligns with what we're seeing, right? It can vary, right? The apparent comes into it because it can vary depending on different weather conditions and whatnot, different observer heights, that kind of thing. You need a geometric horizon, right? That's what you're saying is being manipulated by the medium of the air. How do you know that that thing that's being manipulated and shifted around due to the refraction exists in the first place?
I'm not even saying I know that at this current point because that's what's in question. I'm saying that for you to conclude what you're concluding about the Earth...
But that is what you said. Don't sidestep.
Don't interrupt. Wait, don't interrupt, please.
No, you are just going to walk straight past your claim and pretend you didn't even make one.
I mean, that is the globe mainstream claim. I mean, whether you say it or not, that is the claim of the globe, that there is a geometric, that the horizon is a geometric physical hill that is blocking things like bolts. That is the mainstream claim of the globe.
That is true.
We even have a measurement that is measured linear with miles and kilometers, right? Which will be usually described as flat measurements because they are linear. But there is a physical claim to it, which is a globe. They have a radius value of 36 or whatever you want to call it. Now, you like to change it. You say it's pear-shaped and it's not. But there is a physical claim to it. So for you to sit up here and say, "Well, I'm not making that claim," well, then you're not basically representing your claim of a. No, hold on. Then you're not representing this claim, which is in the mainstream, which all you guys, so-called scientists and astronauts and government officials actually believe in, which is a globe with a radius value of 3959 and all of this nonsense.
Yeah, but that's what we're already assuming, right? For the sake of argument. Otherwise, you guys wouldn't be using those calculators. Like your argument is by contradiction.
Hold on. It's not an assumption. We have been taught this in school since we were 7 years old.
No, that's not what I'm saying.
A matter of fact that we live on a sphere.
Okay. What I'm saying is, what the argument on the table is right now is that assume that the Earth is round. Take some. Wait, hold on. Can you let me finish?
Great. Hold on. No. We're going to establish this first. Are you making the claim that we live on the globe, the mainstream version of it, or not?
Not at this current moment, no.
Okay, so you don't have a globe at this point at all?
Correct.
Great. So you don't have any physical measurements, any physical observations whatsoever at all?
Yeah, that's what you guys have. That's what we're talking about.
Right. So we have all the physical measurements because everything is measured linear and everything is measured with angles, such as elevation angles. All of those are matter of fact a flat Earth measurement because all of those measurements is being measured horizontally.
Yes. So the response measured. That's not how you conclude the Earth is flat. Not because the measurements are wrong.
I'm not concluding nothing. You are, sir. Me. Because you just threw the globe out the window because you say you're not making the claim that 7 years up.
Mm-hmm. Yeah, you guys are the ones making the claim that your measurements allow you to conclude.
You're the one who's making the claim of refraction. So you've got an issue now. Do you stick with your claim of geometry or do you beg for refraction? I'm easy either way, but there's a meat grinder at the end of each of them.
No, it requires refraction, yeah.
So you lose all claims to geometry. So everything is pure optics. There's nothing to do with physical geometry, and you've just given the flat Earth to the flat Earthers. Thank you very much. Welcome to Flat Earth. Please enjoy your stay.
That's a false dichotomy. You're saying it's either. Hold on.
You already told.
1 second.
You already told us that the measurements was flat. You already told us this is how we actually measure it. You already told us that the physical horizon isn't physical. And you already told us that you're not even prescribing to the mainstream version of the globe that we was taught since we were 7.
I didn't say I didn't prescribe. I believe that.
All the window for refraction, right?
Huh?
Threw away the entire globe claim for refraction. I asked you straight up. I said, so you're claiming the mainstream version of the globe. You said no.
Yeah, I'm not making a claim right now. That is what I believe, but we're not even there yet. We're responding to your claim that the measurements allow you to conclude the Earth is flat.
Well, there's zero measured curvature. So what's the problem?
The problem is you're not accounting for refraction.
Look, no, this is the thing. This is the thing.
So it's optical. He just made it quite clear, DJ. I just said there's zero measured curvature, and he said quite clearly you didn't allow for refraction. So in his mindset, it is purely optical. There is no curvature. Everything's refraction. Therefore, flat and it's refracted. The reason you see curvature is because of refraction. So therefore, it is flat by default.
He's already conceded. Look. Just let me say one thing quickly, right? He's already conceded. Okay, he said that he doesn't have any observations that validate that there is any curvature or a geometric horizon, and then he's mistaking our observation as us saying this observation is proof the Earth is flat. Okay, we don't need to prove that, and we're not trying to prove that with this observation. We're testing for the globe curvature in this. Okay, so everyone already experiences the Earth as flat, even if it were a globe, right? Even from your experience, we all experience the Earth as flat, and we can't detect any curvature.
You have
okay, so once again, in this observation and the observations that we're doing, we don't detect any curvature, so it further validates the primary observation of everyone that there is no curvature. Okay, so that's like the default. That's the axiom that we're beginning with because that's what we all experience. Okay, so you've already conceded that you don't have any evidence that it is anything other than that. So that's the conversation is over. That's a concession and a W for the flat Earth side.
Are you open to
because
can I respond or are you guys just going to keep talking over me?
this.
Just let
and
him.
then we
Just
also,
let him respond. Just let him respond to what I just said.
And that you're the one that's making the claim here. We already experienced the Earth is flat. You agree to that. You already agreed that the Earth is being measured flat. You agreed to that, and you already agreed that the horizon.
I never agreed the Earth was measured flat.
Okay. So you didn't agree that the Earth was.
No. Can I respond now?
Right.
Let me respond.
Miles or not?
No. Just let me respond. I don't know what you're saying. Let me respond. Here's where we're at in the conversation, and I just request that no one interrupts. Like I let all you talk. Let me talk. Your argument is like logically, like if I were to put this into a deductive first order argument, this would be deductive. Assume that the Earth is a globe. Given this fact,
you weren't taking the globe side.
Wait, hey.
You made it exceptionally clear earlier on that you were not taking the fucking globe side, so you can't insert that. Try again.
I'm not even doing that.
Yes, you just did.
No, I didn't. And
you just said assume it's a globe. No fucking way. You said you're not taking the globe side. So try again, please.
Then he immediately goes to the globe.
This isn't my argument. This is your argument.
If you have
listen. Hey, dude.
If I'm
Navels. I'm the boss here. Okay, so when I want to speak, I get to speak. Now, for the love of God, let Nabels finish what he's saying. Thank you. Go ahead, Nabels.
Very, very much. What's your name?
Who cares? Take your time to speak.
Okay. Your argument is assume the Earth is a globe. If it's a globe, we ought to observe this. We do not observe this. Therefore, our assumption must be false. This is called an argument by contradiction, reductio ad absurdum, whatever you want to call it. This is your argument, not mine. What I'm saying is that this is a valid argument, right? If the Earth is a globe, we ought to observe this. We do not observe this, therefore the Earth is not a globe. That's valid. But the reason why it is unsound is because you are concluding that we must observe X, Y, and Z based on geometry. And I'm saying physics changes what we observe because the light gets bent downward. And so the object appears more upward. And so, and we have evidence for this. Miraging is, we even have a name for it. When there's strong temperature inversion over oceans during the day, we observe objects appear where they're not. Superior, inferior, whatever you want to point out, this is what we observe. And so I'm saying, because this is a known phenomenon, you have to take this known phenomenon into account in order to calculate what we ought to observe. Once this is done, go and retake your measurements, and if they still don't agree with what the globe predicts, then you are right. But I am almost certain.
Okay, excellent.
Okay.
Excellent. So, that being said, a laser transit measurement methodology was done over a body of water 25 miles in length. They accounted for refraction. They had a weather station on both sides. And even if you put in standard refraction, it only alters the observation in the order of feet, but you need hundreds of feet. So that measurement is sufficient to debunk the globe geometry by 2 orders of magnitude. And rest assured, friend, 2 orders of magnitude is sufficient.
So you're saying there's some people out there that measured what the globe would predict and actually took into account refraction and still didn't get what the globe would predict. You're saying that's been done.
I'm saying they debunked the globe by 2 orders of magnitude.
Okay, where do you have a link?
Yeah, dude, I got a whole documentary and an associated PDF with the event, and it's actually not just one test; it's 17 tests. They start out small and they work their way up to big. It'll be the greatest 2 hours of your life you ever spent. Half an hour to read the document, and an hour,
with lasers?
a little over an hour. Yeah, bro. Hold on a second. I'll post it for you.
I wonder the laser thing now. Which one is it?
This is just my immediate. This is not me being argumentative, but it kind of is because I'm a contrarian. But I question everything. How do they account? Like okay, if you think about what a laser is, it's focused light. The visible light we're seeing normally in the day, it's not focused. How do they like they're basically saying they're the same, like they can conclude the same things? I would be skeptical.
What? No, dude, a laser is better because it's
focused light. It's focused light.
Oh my god.
Yes. Right. So how do you know that it would refract the same? Like just based off of what I know physically, focused light has more energy per square meter, and what refraction is, it's basically microscattering due to the interaction between
right.
light.
So if that's true,
mm-hmm.
then using a laser would be the best way to get rid of all the ambiguity of refraction. So a laser would be more precise.
But by how much?
By a lot.
What's a lot?
Well, 2 orders of magnitude debunking the globe. That's how much.
But give me the specific quantity of like step change in the value of refraction between like
it's your
focused
claim
light
of refraction. You're the one who's begging for it. You supply us with this data.
No. He's the one that's made the claim that like a group of people have done this. So the burden's on him.
But he's not made the claim to refraction. You, my friend, have. So you're the one who's got to provide the data for said refraction, not AI.
Refraction's a known phenomenon, right? I don't need to provide
You're
data.
the one who's making the claim to it. You're the one who's got to back this claim, not anyone else.
Yeah. Yeah, because if you're going to make the claim of refraction, and then you're going to make the claim of it has to vary to a certain point, and you want him to give you the specifics of it and say that it needs this specific value of refraction in order to debunk the globe, you're going to have to provide that specific value. You can't ask him for it.
Sorry, what's the specific claim you think I made?
Making a claim of refraction. It's not for me to basically explain it. You have to explain it. You're asking him, wait a minute, you're asking him, right? He said there is something that debunked the globe with a laser test. He said by 2 magnitudes. He gave you a specific value. You're making a claim of, well, I know about refraction, so it have to take account of this specific value. What a value did you guys?
I didn't make that claim.
Hold on. As in, he have to overcome a physical condition in the atmosphere, which is an oxymoron. In the atmosphere, you have to make the specific of what he have to overcome to begin with.
I didn't claim that, so that's just my response.
You said, well, if you know enough about refraction, where there is nothing. So if you don't have anything that he have to overcome in the physical atmosphere, which you're claiming that it's refraction, which you haven't described what refraction you're talking about yet. If you're not going to explain any of those things, you can't simply ask him to take account for it, because you're not making that claim, like you said.
Yeah, I just simply called something into question, and that was just my initial response. I haven't even seen the PDF. He has to send it.
Okay, but what you calling into question, you don't know about, it seems like.
Okay, if you want to, like, I don't know how to argue against that. Whatever.
Do you know about it?
Flat Earth core? Yeah, I do. Is this Flat Earth core?
No.
Yeah, I've seen this.
It's field engineer core.
Yeah, this is Flat Earth core. FE core. I assumed it stood for Flat Earth. Does it not?
No, it stands for Field Engineer Core.
Oh, okay. Field Engineer Core. Yeah, I've seen this. there's so many problems, but I guess let's just get to the biggest one, the refraction.
Let's just run through them one at a time, my friend.
No, that's not productive. You should always address, whenever you're arguing, you should address the biggest problem first. That's my opinion.
You can't tell nobody how to argue. Just address the problem that you have with it.
Yeah, hold on.
So without watching it, you're going to tell us refraction, because you've already told us that, is the main issue.
Hold on. Let me just pull it up.
What are you guys reading? Watch it first, so you don't poison the well. JJ, in the side chat. Nice and easy.
It actually might be... I might be able to...
So how about not poisoning the well first? How about you watch it, assess it, and then get back to us?
I think he said he's seen it.
Yeah, I've read the PDF. I haven't seen the video. Do you want me? Is the video? Does it add anything to the PDF?
Okay, what is the biggest problem in the PDF?
Yeah, I'm gonna pull it up on my PC because I'm gonna try and stream it. I feel like that'd be helpful. Hold on.
On top of your head, what's the biggest problem? Name it.
The biggest problem would actually be the lack of proper. How do I put this? Statistical properties of the measurements, but that's like
statistical properties.
Yeah, it's gonna start like.
What are you talking about, dude?
So like for example, well, hold on, don't make fun of me. Like I haven't made fun of anyone here.
Let him do the example. I want to know about these statistical properties.
Yeah, and I'm pulling up on my PC. Right, this is flat Earth. Where is it? Where is it? Where is it? There it is. Okay, flat Earth. Is this flat? There. Okay. Here. Okay. Let me share my screen. Actually, let me not do that because that's going to take longer. Go to page 7.
Holy crap.
Well, we don't have to go over it if you don't want to. That's fine. We could just go back. Actually, you know what? Give me a minute. I'm gonna set up everything.
Okay, this is this. Page 7, you say.
Is somebody else giving it to you, sir? I mean, is this your argument or somebody's giving you this? Yes, somebody's giving them this.
Dude, page 7 is still the introduction.
No, somebody's giving them the argument. Somebody's giving them the argument. He said, page 7, he said. Statistical properties. You heard this? Usually what I hear, they always say that mathematics is wrong, it's incorrect, they don't know how to.
Dude, gunnery, statistical properties of gunnery, if you hit the target, is 100%, correct? Am I right or wrong? The answer is if you hit the target, you've hit the target. Therefore, hitting the target is a 100%.
Oh, yeah, you're gay, dude.
Oh, yeah, that's because I hit your target, bro. Man, that was close. Whew.
We fucking.
What statistical properties did you apply to that conclusion?
Oh man.
Oh boy, here it comes.
Wait for it.
Yeah, actually, I have nothing. No, I'm good.
Wise choice.
All right, brother, no worries. You just listen, hang out. We don't mind.
No, I have nothing to. I mean, dude, I'm not as smart as you. Maybe, actually, I think I am, but like, I don't.
No, you could be, but you're clearly inebriated, and so let's just say I'll leave it to the sober people to talk. You can just listen. How about that?
Well,
I agree. Good decision. Thanks. Anyway, Homie Slice, I looked up page 7 here. Hold on, let me go back to it. I gotta open it again. Give me a second.
You're good. I'm taking my time too, man. You're all good. How's your night going, by the way?
Page 7 will land you on the introduction.
I feel like we don't humanize.
I like how this thing doesn't open.
Hold on, really quick. I feel like we don't humanize with each other, so I sense some hostility from some people. I'm not even complaining.
No, we're not being hostile. We're just being thorough. So, page 7, the required accuracy depends on the needed deliverable output. Accuracy refers to how closely a measurement or observation compares to a true or established value, since measurements and observations are subject to errors. By analysing the error source models of curvature testing, the optical configuration design of the testing device was optimised.
Yeah.
The precision of the TLT measurement...
Pause. Sorry. So page 7, you read the part that I wanted to go over. In this document, could you read it from there again?
This document?
Second paragraph.
Well, the accuracy refers to how... actually, you're looking at the next one down. So you're looking at the whole... that'll be page 8.
My apologies. Yeah, you're absolutely right. Page 8.
Anyways, page 8. The terrestrial laser targeting TLT survey method can be used with sufficient accuracy on large distance curvature measurements. Compared with other curvature test methods, the method used in this paper has proper accuracy and practical advantages. In this document, we are introducing TLT measurements up to 40 kilometres, 25 miles, conducted by our research team as late as the 23rd of April, 2018.
Pause. 40 kilometers, 25 miles. This is the part I wanted to highlight.
So what's the issue with 25 miles?
Plus or minus what?
What's the issue with 25 miles?
25 plus or minus.
So you want a range plus or minus, say, 3 foot or...
What are you talking about plus or minus, dude?
The range of uncertainty.
Dude, are you kidding?
Yes.
No, I seriously want to know if you're kidding, dude, because what is the 25 miles?
It's a measurement, no?
Yes. But what measurement of what?
It's a TLT measurement of up to the maximum.
Holy crap!
You said a measurement of what?
Hold on.
It's the
sufficient large distance curvature measurements.
No, it's not.
That's what it says right there. TLT survey method can be used with sufficient accuracy on large distance curvature measurements. In this document, we're introducing TLT measurements up to 40 kilometers.
Yes, but the
so what's the 40 kilometers represent? Did you read the whole document?
It's an upper bound.
No, he saw that one paragraph and thought he could rip it apart.
Okay, I'm going to ask this. No, hold on. I'm going to ask this. I want a straight answer. Did you read the whole document?
No, not the whole, just excerpts.
Okay, then. So the 40 kilometers is the longest range test that they did. So they had the laser on one side of the lake, and 25 miles away, they had the target location.
Uh-huh.
Okay, and they shot the laser over 25 miles to the target.
Yeah, I got that.
Okay, so you want them to write down what the quote-unquote plus or minus is, but if they say it's up to 25 miles, and maybe their plus or minus might be in the actual measurement that they did at Lake Idsil, which was a 25-mile shot. And since you didn't read it, you wouldn't know.
Can I respond?
Sure.
Okay. So this team used TLT measurements up to 40 kilometers.
Now, let me explain real quick why they said up to 40 kilometers. Do you know why? Because they did 17 different tests, some at small range, some at medium range, and some at long range. So I think like some of them were like 8 miles, some were 14 miles, some were 7 miles, one was 25 miles.
Okay, yeah, so they conducted 17 tests from low, medium, long range.
Mm-hmm.
And what? Wait, sorry.
I know you think you have a point, but
no, I'm actually not even making a point right now. Wait, I'm not making a point right now. I'm just being. I'm asking a question because I want clarification.
Go ahead.
Can I?
Yeah, go ahead.
It says under the main principles of the experiment, the study effects of terrestrial refraction in the different ambient conditions of very small incident angles close to non-uniform density transition zones above water surfaces. That's where, that's where light bends gradually. Like that's the area where it's going to be bending a lot.
Which way? Up or down?
Wait! Don't! I don't want to.
It's a gradient. It goes gradually. That's
dude. Who cares, dude?
That's gonna derail, man. Come on, hold on.
Yeah, stop derailing.
Okay. My question is, what apparatus did they use for these 17 tests? You said a laser?
Dude, they use lasers, yes. I'm not sure if they use the same laser for all of them.
How do they measure the distance?
Hey, dummy. Listen,
that's not nice.
No offense.
Let's not do that.
No offense. But to be honest,
you guys ask these type of questions all the time and then berate us when we don't have a quick answer.
That's fair. Exactly. That's fair, dude. But the problem is he already said he looked at this.
I looked at pages 1.
No, but you guys presented it.
Hold on. Yeah, that's true.
And he made it quite clear, Ice JJ, that he had examined it. So please
but it's over 100 pages. Examining it is different from under fully internalizing it.
Ice. Dude. Just get muted, fool. Thanks.
The heck? Okay. Look,
Listen, dude. I'm not competing with Ice JJ for you to get your chance to speak and for me to answer your questions. So you can just stay muted. Okay. So go ahead.
Yeah, I appreciate that, but I would like. Let's just establish a tone of respect. That's all I want to say. My question is, what apparatus did they use? How did they measure the distance?
Mabel, you said you already read this. You already were familiar with the test. If you already looked at this before AI even presented it to you.
You know what? Maybe I didn't take a careful enough read. Maybe we can go through some of it together and you guys can educate me and not be rude. Let's establish a tone of respect.
I think it's rude for you to say that you are familiar with something as if you already know what this is.
Sometimes people are mistaken about. Have you never made a mistake in your life about thinking you know something and not knowing something?
I got you.
Are we not human, man? Like I'm just saying, like. Are we not here to have a discussion? Like we're not.
That's not what happened. You said that you'd read it. You directly said that you'd read it, and that there's a whole list of problems that you've already established with it.
Yeah, the biggest problem. The biggest problem. Yeah, bro. You said the biggest problem. The first thing you said was up to 25 miles.
Okay. All right.
What were the error bars on 25 miles? That was the biggest problem, dude.
Listen, man, I embellished. All right, you know what? I'm human. I embellished.
All right, you embellished. I'll accept that mea culpa. So let's all move on.
Okay, please, thank you. And if I'm here to be educated, how about this? I've never read this. How about this? Let me be absolutely honest with you guys. I've seen this. I've taken a glance at it. I've never thoroughly read it, and I would love to be educated on the work you guys have done as independent scientists. Cool. Can we call that cool?
What science?
Science is the process of making an observation in the natural world, forming a hypothesis, testing it, and interpreting results.
And testing it with what?
That depends on, like, that's super context dependent.
It depends on. We just taking measurements.
I got you. But
right. So speaking of measurements,
I assume
Speaking
you
of
guys are
measurements,
scientists. Are you guys not
okay,
scientists?
cool story. Cool story. Let's move on.
Like, yeah, why do we got to pick over the details? Anyway, what apparatus
All right,
was used?
hold on, brother. Hold on, brother.
What's up?
Let's just go to one. So I'm trying to find the start of the biggest one. Because why start with the small one when you can just go to the most major measurement they did? So calculation measurement 6, target 4. Okay, so let's just go to page. I want to make sure that the one we're going to talk about has all the things addressed. So it must be measurements. Yeah, let's just go to measurement 7, target 4. So that starts on page 94, I think.
Okay, 94. Let me follow along.
Measurement 7, target 4. Yeah, that's the end that then leads to the conclusions.
By the way, whoever made this, I would label the pages just for people who have.
Yeah, you always label pages.
Yeah.
I hear you on that. I'm
here.
I give him an F on that one.
On the 20, my mom's talking in her sleep. Hold on. Ha. She does that sometimes. One time I had a full-blown conversation. She was dreaming that she was talking to her therapist about me, and she was. I mean,
we don't need to know this.
Okay. Okay.
Best
all
not
right,
to.
Gotcha.
So we're looking at the 7th measurement. Cool.
You or David?
You
I gotta
too.
mute up. Hold on.
I mean, FE Core is very precise in this documentation. I mean, besides the labeling, I mean, it's not much to really read.
Okay, so page 94 has the photo of the target position. So let me scroll. So the reason is because they actually panned the laser to different targets on the lake. So we got to go all the way back. Oh my goodness, man. Sorry. Don't want Lake Balaton. Okay, so a second measurement.
Like ISIL 6 and 7.
So laser position at Lake ISIL is actually on around pages 42 or 45. That's when it begins. So Lake ISIL Netherlands measurements, April 2018. It shows you the laser location, and then it shows you the target locations on the map. So for their distances, it appears they're just using this map. Okay. So they used Google Earth mapping to draw a ray from the laser location to the target location and then get that distance. Okay, so that's how they got it. Now there are 4 targets that they did. So let me zoom in here. Now the reason why they did 4 targets Yeah. What happened? Yeah, bro.
Oh,
man, we've been working. What have you been doing? Slacking?
Taking care of my disabled brother and disabled sister.
All right. Fair enough.
Thank God I live in California. I mean, I fucking hate this state, but I'd be cooked without it, ironically. It's a parasitic relationship, almost.
So we were saying on on page 42, there's a map of Lake Yeso presented, and it shows you the locations of the laser and the targets.
Okay, is this from Google? It looks like Google Maps. Is this from Google Maps?
Yeah, Google Earth.
Okay. So then that means Google took these measurements. So, I don't know, that's not like a gotcha. That's just that means that Google either does or doesn't have public data on the statistical properties of their measurements. It may or may not be public, but it exists. When they took these measurements, they also took all of the relevant statistical properties.
Crap, that's it. I'm gonna
I'm gonna be honest. I I don't know if it's a complete failure, but I think you're failing to make your point. What do it matter if they referencing Google Maps? That's just a map. I mean, the way it's stated in here, they're just presenting the location.
Okay, I'm back. Have you guys spoken amongst yourselves? Hello?
What up?
Yeah, have you guys spoken amongst yourselves about what I said?
No, my headset died. I have no idea what you said.
Yeah, well, he was trying to say that Google Map is the one that took the measurements, but they only referencing Google Maps, right? Basically, the location of where the measurement is being taken.
They're just using it as a visual.
No, what they're actually using for their underlying test structure is the WGS84.
Yeah.
So what's that? WGS84.
Yeah, if you read the intro, like the first few pages, etc., you would have learned that.
Okay. WGS84 model. So you guys do use models.
Yeah, so the WGS84 is one of the reference ellipsoids that geodetic surveying is interpreted through a matrix and laws of formation, as outlined in books such as Higher Geodesy by Helmert, etc., etc. Okay, it's well established. It's considered the standard among many fields. Okay, so we don't need to revisit the error margins or the statistical probabilities.
Oh, okay. Sure.
Right, because their goal was to test the WGS84. Okay.
Against measurements, which have statistical properties. Thank you.
Okay. But the WGS484 itself is taken as a given, and then the other parts of the measurements would be what they actually did. Right. So if they're at a particular location, and the WGS-84 says that this location and that location are this far away, that's what they're testing. And it also says that there's this much curve in between those 2 points. That's also what they're testing. So the scrutiny that you should mainly be applying to them is things that aren't already the established thing that they're trying to test. It should be their measurements that they're making. So in other words, if I was a judge and we were in a court case, I would say, listen, the WJS-84 is not their burden to put on trial. It's already established. They're presenting counter evidence to the WGS-84. So if you want to adjudicate the WGS-84, go and sue the company that made it. All right, so now that we see how they did it there, they got the Google Earth, they got the WGS-84, they got the claimed distances from point A to point B, and also the WGS-84 has claimed curvature between point A and point B. If you notice on page about 46, they even put in the scale of the geoid undulations, right? They even put in the tides. Lake tides are known to have amplitudes up to 10 centimeters in larger lakes. In case of Lake Idsil, the average shallow depth of 5.5 meters, 18 feet, and the relatively low water volume of the lake suggests this effect would be even smaller and within our measurement error margin. Right, then it says how they did here. The lake temperature ranges from 7 to 14 degrees Celsius. The ambient conditions along the entire length of the laser beam wasn't available. They used data at the end positions. The data showed there's no significant differences in temperature and humidity between the start and end points of the measurement. So now I'm going back to the 90s to get to measurement 7. Measurement 7, there they show you the readouts of the meteorological station that they had. Temperature and humidity at 2 meters, 6.56 feet, right? Altitude. Then you got the target for observation location, the little photo right there. Then you got the laser beam hidden height calculation measurement. So it shows there the calculations based on a spherical model results in a target hidden height of the measurement 7 at target position 4 of 90.81 meters, 297 feet. Okay. So a straight line laser would pass over the target to the target ground position 297 feet. Now, obviously, the target has some height to it because it was 2 meters. Then you've got curvature correction, right, from an ideal sphere to the WGS-84. There's the math right there. So the calculated difference of curvature drop on the WGS-84 spherical model for the location in which they were in, right, from the laser to target is plus 2.56 millimeters. So it varies from an ideal sphere by 2.56 millimeters. The height of Lake Idsil above sea level is 0 meters. All right, then we go into here, measurement 7. So they got the air temperature, the atmospheric pressure, the air humidity. Then they got the, hold on, let me scroll and zoom in here. Then they got historical weather reports there for the days. Look, they even have an uncertainty of the calculated index, the refractive index of air. Right? They got all that right there, Holmes. For all the refraction calculations. Then you see here on page, in about 101 to 103, it starts the refraction calculation. So angle of incidence, right, 0.002 degrees, refractive index calculation based on the modified Edlund equation, N1 equals blibbity blop bloop bloop, nanometers, wavelength of light, blah blah blah, angle of refraction, Snell's law, zibbity zibbity zap, angle of deviation, shablooty shablam. After that, they conclude the ambient conditions refracted the laser beam downward by a maximum of 0.131 millimeters. There you go. All right, positions and height of target 4. Right there they have the latitude and longitude of the target, right? They have the GPS ellipsoidal height and the geoid height. Target 4, latitude, longitude. Oh, sorry, the first one was the laser position. Second one, the latitude and longitude for the target position. Right? The GPS ellipsoid height, 0 meters. The geoid height, 41.847 meters. So you notice that 41.847 from the 42.409 only gives you less than, let's see, for the 2.4, less than 1 meter of variance, okay? And then they calculate it for you here, 22 inches. So the differential in the geoid height was only 22 inches from target location to laser. Oh, man. Did I have you guys on mute? Or is anyone trying to speak?
I can hear you.
Okay, perfect.
Following along.
All right, so next page, experimental results. Experiment results of the 7 tests, because I just read you the longest test. Loosely, should have been following along in the document. Then you would understand the blah, blah, blah is bent. Okay, experiment results of the 7 tests indicates there is no curvature on the lake surfaces. The testing results agree with the analysis of error sources. Feasibility of optimizing optical configuration was verified. In summary, the testing results of the lake surface were plus or minus 0.2 meters. Relative accuracy was in 1%, confidence level 98%. Our experiment results verify the possibility of point-to-point long-range wireless communication system. I'm not sure why they added that. It must have been mentioned earlier. So the TLT measurements meet the accuracy of the experiment design requirements and provide a definitive deliverable output. The surface of Lake Balaton and Lake Itzel is not convex and curvature is not detectable. Right? Through analyzing the error source of the TLT and making the measurements and corrections for the geoid, we determined that results of the experiment definitively prove our hypothesis of non-convex water surfaces. So the conclusion, all large bodies of water should follow the geopotential surface. We proved these lakes are non-uniform with the WGS-84 model. The WGS-84 model is incorrect. Now, why did they say that? Well, because the laser hit the target, and according to what page 99, it would have had, the laser should have been Let's see, 200. Should have went over the head of them by 297 feet, but it hit the target, and the target was only 2 meters off the ground. 6 feet, approximately 6 feet. So that means the globe is debunked by 2 orders of magnitude. So then they have the actual things in tables here. So let's find the one of the table for that test. Lake Igsil 7. Okay. Imperial. Well, let's just use Imperial since that's cool. Let's go. So on Lake Igsil 7, why does it say 357? I don't frickin' know. Or is that inches? Why the heck did they do it like that? Oh, inches, yeah. Why would they do it in inches? You little... Man. Well, either way, spherical target hidden height at Lake Igsil is 3,575 inches. Correction to the WGS4 later to target was 0.085 inches. Okay, mean sea level was 0. Refraction was 0.00512 inches. Expected target hidden height 3,575. Variance to the geoid height was 22 inches. Right?
What was the variance to sea level, did you say?
Okay, so the mean sea level at Igsil is supposed to be 0. Let me go back up here to where they actually wrote it to make sure. Curvature correction. Hold on, my thing died. It has the GPS ellipsoidal height at 0 meters. That should mean a 0 sea level. But I just read it that they somewhere in this one of these pages real quick here. Give me a second.
Yeah, I heard you say mean sea level at 0. It'd be interesting to see if any other point that they've taken that means sea level would be anything other than 0.
Yeah, but I didn't mean sea level as obviously mean sea level is considered the baseline, so it'd be 0. But so if something is considered at 0, then it's considered at the baseline. So 0 feet above sea level. Dude, they literally had a sentence in there that I read, and now I can't find it. Holy crap. it real quick, reread it.
That's okay. We're recording this, so I can go back, yeah?
Okay, measurement 7, the spherical model, target hidden height, WGS84, laser to target, correction, MSL, correction, refraction expected. Oh, the height of Lake Edgehill above sea level is 0 meters.
Yeah, that's it.
All right, did our homie leave? Guess so.
I'd say he left when he scrolled down and there was one of the pages that mentioned the refraction and how it bent the laser upwards
Yeah, I hope not.
so many millimeters, and that wouldn't have fit the model he required, and he would have looked at that and went, oh dear, that's a problem. Or if he was smart enough, he would have. Yep.
They claim you print something in, and then I'll be going over. Set up perform.
I noticed a couple of you in here that I haven't sent a friend request to. Flat Earthers, I mean. So I just sent out a couple.
Yeah, that link you sent is seriously flawed. If you can let me send something in the chat, I can send a short description of
Which
some of the
link is flawed?
issues.
Which link?
The one you were going over, like FE core experiments, description, and so on.
Well, if it's flawed, you should have been going through it with AI. He would have appreciated some help.
Yep, Mike's back to you, Overlord.
Yeah, AI
actually AI that
points out a bunch of the flaws, but even with later we need AI. I mean, but yeah, I mean, run it through AI immediately.
No, not run it through AI, as in AI Overlord.
Man,
at the top of the chat.
Just tell us one of the flaws. What, do you got to wait till it premieres in theaters?
Yeah, I mean, very basically, I mean, one of them is that they're measuring refraction, and you even quoted this, only at 2 points, the beginning and the end. But this is in non-continuous zone. I mean, this is in the area where refraction is like the strongest and varies drastically. It's non-continuous. It changes along the path, and there's no measurements for that at all.
So if they've measured it at the strongest points, and it's only out by 0.131 of a millimetre over, how long was the seventh measurement? 25 miles? So we're out by 0.00512 inches at 25 miles, and that's the strongest point of the refraction. I don't think the weakest is really going to do anything.
You misheard me. I know. I did not say the measurements. No, they only took a measurement at the start, the point of observation, and the point where the
JJ, they took
the area that they're
out by 0.00512 inches at 25 miles.
Yeah, I'm trying to explain something.
Yeah, what part of 0.00512 inches at 25 miles don't you get?
I mean, do you understand? I mean, I'm trying to finish my sentence here.
JJ,
because they're using
at 20 miles, that's 270 feet of drop. At 30 miles, it's 600 feet of drop. Okay, so you're out by not even half of 1 inch. So you've still got to acquire a lot of drop.
And I'm trying to explain to you how they're missing it, which is that their measurement for refraction is only at 2 points when it is it changes.
So if we take it at 1,000 points, you're going to get more refraction.
It's not working.
Because you make claims that you can't substantiate, my good friend.
I can't finish the claim.
You can't substantiate them, so there's no point letting you. So what you're saying is, if they've made 2 points. What? They've measured 2 points. So let's say they measure 1,000 points. Are they going to magically get more refraction in order to get a ball? Yes or no?
Yeah.
You're an idiot.
No, that's just facts. If you measure more, you will get more refraction. You get drastic swings in, refraction along the path, especially over water. Like the area, like shooting a beam of light over water and saying, "Look at this." It's not. It's like this doesn't look at like the measurements of the physical properties of the Earth. It's like saying, like waving a thermometer through a steam vent and saying, "Oh, look at this." It's like it's ridiculous.
What you're suggesting is actually ridiculous. So what you're saying is that after the laser leaves, right, from point A, it's perfectly bending around the globe all of these different distances, because they're doing all of these different tests over different distances where you would have drastically different amounts of curvature. You're saying it's perfectly bending around the globe in all of these different tests and hitting the target within millimeters consistently. That's crazy what you're suggesting right now.
They're using refraction corrections. I'm talking about the things that they're using are methodologically just unsound. So you can hit a beam.
But you're saying
with refraction.
How about us, JJ? How about you make JJ? You've made the claim that they're methodologically unsound. How about you make them sound so we can use your formula when we do these tests in the future?
Well, they would need more measurements. They'd need measurements across the path of the.
So how do you explain the fact that in some of the tests the refraction is going the wrong way?
Because refraction changes drastically along the path. They can go down.
So you're telling me
that's mirage is
that's your default refraction changes, but it's going the wrong way, JJ. Did you not listen to what I said?
Oh my God.
Did you not listen? If it's bending the wrong way, that means it's leaning towards the globe. And you still don't get enough.
Hey, no worries. So JJ, all you got to do, bro, it's very simple. Go over to Walter Bislin's, put the observation into his calculator, and then use the refraction.
It's not that simple.
Oh my God, dude. Okay, JJ, let me make it very simple to you.
Yeah, the point is it's not.
No, JJ, let me make it very simple for you. I get to finish my sentences by acquiescence or force. You pick. Okay.
No, I love it.
All you got to do is go to Walter Bislan's, put it in there, and it'll give you the refraction that's required to make that observation. Once you have that number, then you have something interesting to talk about, which Matrix may be interested in.
Yeah, I'm talking about their own measurements. So if their own measurements don't line up with, if I can't rely on their measurements, then there's no point putting them into something else.
JJ, the laser hit the target. Okay? That's what happened. Okay,
Yeah, I'm saying that your claim of refraction along the path doesn't. They don't even
no, you don't even understand. Check this out. It's simpler than that. Okay, if the laser is hitting the target, right, and a straight laser, unrefracted or unaltered in its path, right, would pass over the target approximately 300 feet. That means in order for the Earth to be a globe, the laser had to have curved around and reoriented itself to hit a target below 300 feet. Okay, by 200, well, there was about 10 feet, let's say, so I think it was 290, so about 280 feet. So just go into Bislan's and find out how much refraction would be required to curve a laser that much over that distance.
Again, it's not continuous.
Once again, I just did that, and I had to max out the refraction slider to 1. It's in the side chat screenshot.
Right. So it's either going to be continuous, and so over the entire arc there's going to be subtle amounts of change, or it's going to be non-continuous, where there's going to be very little change and then dramatic change, which means that pocket of dramatic change needs even more extreme conditions than the rest of the non-continuous arc that it's supposedly traveling in, JJ. Don't you get that?
What?
I know. Sorry, I forgot. I'm dealing with retarded globers. Let me make it more simple. Maybe I'll draw it in crayon.
Yeah, draw it in the crayon. That'll be easier.
Okay, so if you're traveling 1,000 miles an hour in a hot rod specifically designed to win the land speed record, okay, and there's a brick wall at the end of the track, you have to slow down before you crash into the brick wall. So option A is you start slowing down way before you hit the brick wall, and then you only have to apply a certain amount of slowdown so you don't break your own neck. Now, if you try to stop all at the end of the brick wall, your neck's going to snap in 2 pieces. So you either make slow, gradual changes over a long period of time, or you make extreme changes that have extreme impacts in a very short amount of time and distance.
Yeah, I mean, they're having an issue of like their calculation of refraction is off. Despite, I mean, according to GPT-5 thinking, 5 to 8 orders of magnitude, or their interpretation of what they're seeing is wrong. Like, for example, do you know what attenuation is? The idea that a beam can scatter. It becomes weaker, and so then you see it creates different dots that go in different paths. What if it's that, especially at that range? That's what attenuation is going to be happening. That you don't know if the beam did not start scattering at one point because it starts fading, and then what they're catching as a laser hitting the target is really just one scattered part of an attenuated beam.
No, that's not how it works. See, they actually took a photograph. Check it out. They took a photograph of the beam centroid. Lasers have a Gaussian distribution. You could apply an algorithm. It'll tell you that you're looking at the center of the beam.
An algorithm, okay.
Oh my God, dude! I forgot.
That sounds like assumptions to me.
Do you want me to draw it in finger paints? Crayons may be too highbrow for you.
No, but that's hypocritical. Setting an algorithm.
No, it isn't. No, it isn't, dude. Pay attention. Lasers have a Gaussian distribution profile. So if you're looking straight at a laser, the glow off is going to fade off in a Gaussian distribution. And if you apply an algorithm that could tell you whether it's a Gaussian profile or not, it can tell you the center. Holy crap, dude. Holy frickin' crap, dude.
Yeah, again, if you're dealing with a lot of attenuation, I don't think that's really going to make much of a difference.
Yeah, go get the definition. Go get the definition of attenuation, and then come back and read it, and then tell me how it applies to the situation.
Yeah, it's when it slows down. It has less force, and that causes scattering.
You can see the beam hitting the big target that they created there in the side chat from the PDF.
Yes, that would be one of the scattered beams.
Yeah, what's the circle of uncertainty, dude? Is it 300 feet? Holy frickin' crap. Holy frickin' crap.
So it's sectioning out into separate beams, the scattering sectioning it out into separate laser beams, and one of them happens to be hitting this target.
Sick, bro, sick. Hey, bro.
I mean, they claim relative accuracy within 1% and confidence level of 98%. But I mean, given I mean,
man, dude, I didn't
uncertainty
know.
Of all this like
JJ, let me apologize to you. JJ, can I apologize? Can I apologize? I didn't realize that you were trying to say that they shoot one laser and then it turns into 17 different laser paths that all just shoot up different shorelines. You know, kind of like in Quake 3 Arena when you get the multi-laser homing missile. Holy crap, bro. You're onto something.
I mean, to some extent, yes, if light scatters, that's something that can happen. And when, and their confidence level is 1% and 98% relative accuracy within 1%, but they don't have any kind of data measurements to back that up. That's ridiculous. These guys are. This is just like. Oh my. I mean, I'm reading through this. If you let me post in the side chat, I'll just post like an AI analysis. I'll give you the prompt.
Why can't you? Why can't you post in the side chat?
Not provoked. I'll give you the prompt too. I just like.
Why do we need an AI run through of this when we've got you to run through it like you've done?
Because it would be a much more efficient way of getting the point across.
So what you're saying is you're not qualified for this conversation.
Hold on, because it's over 100 pages, the document you've sent. I have not seen this before, and it would be much more efficient. Like, just simply just...
So if you have not seen this before, how are you to judge it?
Well, I have been going through it since you've sent it, but again, that wasn't that long ago. But whatever. Look, if you let me post, I'll send it.
Maybe you should read it a bit more, mate.
If not, then, whatever.
You copying Craig rebuttal word for word, bro. You gonna say you didn't look at it?
No, I've been looking at it since it was posted. That's what I'm saying. I have not seen this before it was posted. I don't know how is this complicated for you?
Definitely see you're copying it word for word, bro.
What am I copying?
You're trying to claim that the lasers is bending with the Earth due to refraction. That's why it's hitting the target. And you also trying to make a claim that the light is scattering. Light is going over the target, which is not. It's not even in the presentation.
Yeah, that's because the presentation is flawed.
So you're saying the presentation is lying.
Yeah, to some extent, yeah. Or it's wrong. I don't know their intentions. They're wrong.
It came wrong because it definitely hit the target. That's the claim in the presentation.
No, but hitting the target. No. But the issue is hitting the target happens with refraction, and it happens with a bunch of things also.
It
happens with attenuation too. But the question is, how do you account for that? And they're accounting for it. It's horrible. It's in fact negative.
Well, maybe you could enlighten us on how to account for it correctly.
Either you're saying the presentation is lying, or you're saying that the physical laser beam is curving with the Earth due to refraction and continuation, which you haven't even described yet.
Yeah, absolutely. Yeah.
So which one is it?
Well, no. Attenuation is just when it gets slower and weaker because it's a laser beam, and then it fades out, and then when it does that, it will it sometimes will scatter, but it becomes a kind of dim beam. But refraction is the curving because
it was somehow curved. It hit the target 25 miles away.
Yeah.
This guy's acting like lasers are like shooting a shotgun into water with flechette rounds, where they just go all over the place and end up, hitting a fish over here and then a fish over there.
That's what he said.
Not at all.
That's exactly what I just asked you. You said yes.
They bend slightly down, curve.
You said they scatter out into separate beams.
Well, no, attenuation is when when a beam becomes weak enough. So when it goes far enough that it starts losing its strength, it starts dimming. It can cause scattering.
It hit the target. It hit the target. It hit a target 300 feet below the Earth. This Earth tangent. So that means no matter where they set it, it would hit that target.
What?
That means so basically you're making an argument that the globe with these laser tests is unfalsifiable. That's what you're trying to say. You're trying to make like this is confusing.
No. I'm saying that their own description is, their measurements are flawed. Their description is flawed.
You didn't even read it. You didn't read it. You just put it into ChatGPT and you're just parroting whatever ChatGPT told you.
Look, I've been
Hold on a second, JJ. Hold on a second. I want you to look at the picture that I put in the side chat, and we can see a section of laser beam on the target. Hold on, just listen. Okay, I just put the picture in the side chat. What is that green beam on the target there that's only in a small section of the target?
That is scattered light.
So you're saying it deviates into separate sections of beam?
What?
You're saying that's a small section of the beam, right? And the other bits are scattered elsewhere, and it's separated into separate beams. That's what you're saying.
Potentially.
Well, you just made that up, and that's ridiculous.
No, it's not made up.
Okay, a single laser beam can appear to scatter. A single laser beam can appear to scatter out or spread over distance, but it does not literally split into separate laser beams.
Oh no, it doesn't have to split around. Yeah, but it can scatter in a sense that it directs somewhere else. Like,
okay,
this is not radical.
Why is there a concentrated beam on a particular section of the target as if the laser beam is hitting the target?
Oh, yeah, well, it's very simple. It's very simple, JJ. Give me one example of a laser having done this at any time in history that's been recorded.
Scattering like that? I don't know. Yeah. I'm not an expert in lights, but I can tell you, like.
Now he's not an expert.
No, but this is the point. You're appealing to. You're making this logical fallacy.
You're
appealing to who I am, who's saying it. But this is why I'm saying. Okay, let me just.
Oh, dude, you're making a claim. You're making a claim that something happens. I said you give me one example of it ever occurring in history. And so now you have no idea what you're talking about, dude.
Can I post something in the chat?
Yeah, why not?
Because I'm not able to post.
Yeah, well, I don't know why you're not able. Why aren't you able? Did you get banned from posting? Or you don't have enough rank?
I don't know. I haven't been able to post.
Try now.
There we go. I can post now. Well, there's even this is not that, but there's even with the Rayleigh criteria, there's even Rayleigh scattering. Yeah, Rayleigh scattering.
Yes, but
that's red.
When do lasers do not travel straight and do not hit targets horizontally? That's what we're trying to figure out. Because you're saying that lasers go everywhere, which defeats the purpose of a laser.
No, I'm talking about optical illusion. Potential optical illusion. It wasn't. I'm not saying that's what happened. I'm saying that's a potential optical illusion.
This happened. Actually, you're trying to say that the lasers are all over the place, so eventually it will hit its target either way, whether it's focused or not.
Well, to some degree, JJ, listen, to some degree, JJ is correct, and I'll explain. It's very simple to understand. Okay, if you shoot a laser straight in a room, okay, now go to the side of the laser in an observation window. So you're looking at the laser perpendicular. to its path. Now fill the room with fog. You're going to see a green line going across the room, right? That's the laser. But that's not the direction the laser main light is traveling. Those are the portions of the light that are being hit on the particles and then being redirected to your eye. So in that manner, you could argue, well, that's the laser being split off into separate quote-unquote beams, but they're not beams at that point. The main beam is the point that's traveling straight ahead. What's being deflected off is no longer part of the beam.
But how do you know that's not a reflection or deflection?
Beam's still hitting the target.
What? Right. The main beam is still hitting the target, but what you're seeing going off on the side isn't the main beam, dude. And by the way, if you apply the Gaussian profile, listen, if you're looking at a laser on sideways, it's going to look like a straight line going across your field of view, right? If you apply a Gaussian profile to that, you're not going to get a centroid. But if the beam is hitting you, you are. I mean, I don't know why this is so complicated.
I don't know why this is complicated at all.
Well, listen, homie. Listen, Reggie, I don't have anything simpler than finger paints to draw a picture for this kid, so I don't know what to do. Maybe I just need a set of shapes with colors. A red triangle.
Maybe he needs Schoolhouse or Rock. You need to, I don't know, make a jingle, a song for him.
You said that they only measured at the beginning of the lake and the end of the lake, and they didn't measure the continuous ambient atmosphere along the entire path of the laser. Okay, let's say that's true that they didn't. Why should they? Justify why they should even bother.
Because that would tell you whether or not whether or not you're hitting a target because light is bending or because it's a straight line.
Well, wouldn't the video footage or photographic footage of the light hitting the target prove that it's doing its thing?
No, but it doesn't prove why it's doing its thing.
Who cares? The result at the end is it hits its target. Ta-da!
Well, if it's because light's refracting, that means it's bending over a curved surface.
So you're making the claim that refraction causes lasers to follow the 8 inches per mile squared average.
No, that's not true. What he said isn't true.
Now, this is
if you prove light is simply refracting, that doesn't prove it's bending over a curved surface, dude.
Right.
Correct. But if you prove that
you invoke
measurements that you're seeing, if it's refracting and you're hitting a site at 20-something miles, if there's a bunch of refraction going on and you're hitting what's supposed to be line of sight, then you know it's not a straight line.
Okay, how much refraction would be necessary?
No, but with any refraction, if you're seeing line of sight,
holy
that
crap,
much distance,
dude.
and there's any refraction would mean that you're not on a flat surface.
Hey, why every time we ask this, how much refraction is necessary? I asked this.
He said any refraction. So if there's 6 feet of differential between the laser and the ground, and there's a sufficient amount of refraction to only vary the laser within a circle of uncertainty of 6 feet, he then thinks that means you're not on a flat surface. Are you kidding me, dude?
No. The refraction that you see along this path,
I've heard you.
Not any refraction. The refraction that you see along this path is and we know there's refraction. And if it's line of sight, then if there's refraction, then it's not a flat surface. Like if things are shifting upwards, like just like that, the ships in the horizon video. Like there are times when they are sinking below, and there are times when they are higher. If the time when they are higher is when you think you're line of sight, then you're obviously not on a flat surface. That's when you're seeing mirages.
What? That doesn't follow either, dude. Like you literally can't even make a sentence that results in the surface being necessarily curved. Why is that? You seem to have an issue, brother.
When things are wavy, they're higher than they should be, but it looks line of sight, then line of sight means it's not line of sight because it's wavy.
Holy crap, dude!
So it's
wow. Hey, listen.
That's a very basic
make an argument that leads to the Earth being a globe necessarily because of refraction. Go ahead.
I mean, that was it.
No, it wasn't, dude. Not even close.
I mean, that's the line of sight. I mean, it's not because of refraction is not the best way you're going to, get the measurements of the Earth, because by definition, you're looking at bending of light that is variable along different areas and temperatures and altitudes.
Be asking you,
but the refraction that you would see, like,
sir, dude, calm down. You the one that said that refraction is obstructing the measurement to begin with. Therefore, you have to take account for refraction. So AI asks you a very valid question: is how much refraction is necessary, dude, to cause light to bend to the curvature of this big Earth with this radius value? Because you don't have the radius value at this point. We haven't given you the globe. Listen, we haven't given you the globe. We haven't given you the radius value. You trying to prove that there is a radius value. All measurements are being taken flat at this point. All measurements are being taken to be assumed to be horizontal at this point. Even if the light is bending traveling straight. You don't have a curve yet that you have proven. So you have to somehow convince us or prove to us that the light is actually bending to the point where it's curving. So you're going to have to definitely tell us how much refraction is required for the light to curve over a physical hill you guys call the horizon. Valid question. No, you can't just say, any refraction. You could put a little bit of refraction and it would curve over this 30. No, you have to do some type of math to tell us what refraction that you will have to account for the curve that basically cause light to bend, curving around a surface with a radius value. Answer the question: how much refraction is required for this?
Okay, the exact number. I don't even know which specific observation you're talking about. I don't like the point that I was making was that it's a non-continuous gradient along the path, which means
so the fact that you're going to stick to is you can't give us the number.
No, but it's going to be different numbers throughout. It's going to be non-continuous.
Okay, what about this? What about this measurement that we're taking right now?
Like it's like if Earth is like hold on, if you're on a ball and Earth is just a ball and it's bending,
you haven't proven
it's curved and light is curved. Yeah, if it's curved, if it is curved, if refraction, if you're on a curved surface and refraction is causing it to bend downwards, and it's non-continuous.
So
what that means
is validate those claims.
Hold on. What we're talking about is whether or not this could be refraction. You asked what refraction could be necessary.
Would have, should have, could have. If you are claiming light is following a ball around, bending downwards, as you pointed out, you can show us either photographic or video evidence of one of these lasers bending downwards, conforming to an 8" per mile squared curvature rate. If you can do that, I will happily listen to you and your quote-unquote proofs of refraction all day long. I won't even interrupt. And I'll smile whilst doing it. Please provide this laser bending downwards.
Yeah, because right now
open air, laser bending down. You can do it.
Yeah, because you're not on the ball yet, and you're saying that the thing that AI presented to us, which is the FE core, which is a laser that has been shot and hit its target.
I didn't even get to the AI yet, but we'll go on.
Okay. That hit its target. You're saying that's due to refraction in the laser beam that's actually curving around to hit its target or actually scattering. So you should be able to show that even in this example. But right now, you don't have a ball. You haven't proven a ball. You haven't proven curvature yet. So you can't assume curvature and say, if curvature, then this. You can't assume that at all. You have to tell us the specific refraction point, actually describe it and define it and say why is light bending to the point where it appears if the light laser beam hits any target is due to the Earth being curved. The laser beam is actually going with the curve of the Earth.
Yeah, and I'm trying to explain to you that there's going to be many different points of like along the path where it refracts. So by measuring the first and the end, that's not enough. I can give you one number alone is not going to do it, because if it's refraction that causes we're testing, like, hold on, whether or not refraction can explain the fact that laser hits it. Okay, am I able to speak or not?
So you're lying.
Can I speak or not?
You're saying the exact same thing, and you're giving us the same bullshit.
We're seeing whether or not refraction is the cause of the laser hitting the target.
Great.
And if it's refraction, assuming that the Earth is a completely flat, level surface, is a false assumption to test whether or not it is atmospheric refraction, which is inhibited by a curved Earth.
Yo, Glober, you don't know what refraction is, Glober.
You're not falsifying refraction.
Glober, the more refraction, the less you see,
this
Glober.
is one of the basic methodological issues, that they're not actually testing refraction.
Glober, you don't understand refraction, Glober.
They just don't understand it.
Glober, you don't understand what refraction is, just so you know, Glober.
Aren't you guys tired of this after, like, what, 5, 10, 15 years of the same shit all the time?
Yeah.
Oh no, we get new special eds in daily. Example, let's go, Joe.
Shit. It's actually quite entertaining.
Yeah.
Okay, JJ. So, do you have a counterexample that does take these confounding factors into account that validates that there is such a thing as Earth curvature and a geometric horizon? Do you have that?
Yeah, I've given you stuff before, but because I've just freaked out.
But it's got to be analogous. It's got to be like a laser test, right? Because we're talking about laser tests. So do you have one?
Yeah, I'm pointing out the massive methodological flaws in doing
No. Just answer. You've got to answer my question. Okay, so I understand what you're saying about how you could have, say, a pocket of hot air or a pocket of cold air at, say, 4 miles, and then at 10 miles you could have a different pocket of air, and it could affect the way that the light's traveling across, right, from point A to point B, but they only took measurements at point A and point B, whereas there's all of these other points in between that could cause deviations, okay? Valid point. Fair enough. Okay, it's still hitting the target over all of these different tests. That's why they didn't just do one test. They're doing a stack of different tests. So if you're saying the laser's doing all of this crazy shit between point A and point B and still hitting the target at the other side, that's a pretty crazy claim. So maybe you should be the one that has, that shows something that does take all of these different points along from point A to point B into account. Okay, so you've established that you have a very reliable idea of what's going on with the refractive index between point A and point B, and it aligns with the globe, right? But I know that you don't have that, and I just want you to admit that, or show that you do have it, and then we can go over it.
Yeah, but he doesn't even have the globe. He hasn't proven it yet. Nor have he even established that yet. The only thing that he have is refraction. But he has to somehow prove to us and show us, right, something specific about refraction and give us the scale of this refraction where it will cause the light to bend to a point where it will follow a radius value of the globe. That's all I'm asking. I don't understand why that's so hard for him to do. You don't need a bunch of numbers for that.
So JJ, do you have what I asked you for, or don't you have it? Don't say that you've tried to give it in the past or something like that. Like, do you have a counter laser test that does take these variables?
Friend. He doesn't have
I know
shit,
that.
Friend.
I want them to admit that, though.
No, they won't. No, he doesn't have shit.
Okay.
This guy.
There you go. If you're just going to talk over me.
Listen, I haven't... Sure. Listen, I was talking and you started talking over me. Shut the fuck up. So these globers, what they think is refraction is...
where do you want to go from here, right? We're not claiming any type of these gravities here. Okay, so you only need gravity to have a globe, right? For all of the crazy nonsense that comes along with having a globe, right? Like a ball floating in a vacuum with water and gas attached to the outside of the globe, right? Then you're going to need some special gravity to be able to explain these things. But in reality, water needs a container, right? Things rise or sink due to relative density. And water is flat on the surface. It's very simple, just as we all experience and can test empirically.
I see.
Yeah.
Yeah. I mean, since I don't have like really much knowledge about it, I'm just, making comments on things that I read or hear and trying to have some thought. And I don't know.
Yeah, you're good.
Yeah. We're just.
Well, if anyone has any more questions, feel free
Yes,
to
I have a question.
jump in. Go ahead.
Do you know a Cavendish experiment? Cavendish.
Cavendish, yeah. Mm-hmm.
Yes.
Yep.
It's
So
about
what was
gravity.
what was he trying to measure
It's
with
advance of
Cavendish?
gravity.
No, what was he trying to measure with Cavendish?
You don't know Cavendish?
Yeah, I know Cavendish. I was just checking
Okay,
if
then.
you know. Doesn't sound like you know Cavendish.
No, I know him. I know the of him.
Okay, so what was he trying to achieve?
The gravity.
Incorrect. Do you need to go and look it up?
Yes. I can show you a video and the side chat.
No, you don't show me a video. I already understand. I don't need to be shown a video. I need you to explain to me, right? If you understand, right? So was Cavendish trying to determine the density of the Earth? Was that his goal? If you have to pause for the answer, it just shows me that you don't understand. You've not looked into Cavendish, and you don't understand what Cavendish was trying to do.
I understand you, but the language doesn't.
Yeah, he was trying to determine the density of the Earth.
English.
With the Cavendish experiment, right? Cavendish was trying to determine the density of the Earth, right? All it shows is a tiny torsion movements under highly sensitive conditions. He had an indoor setup with air currents, electrostatics that weren't accounted for, vibrations, thermal drift, right? All of these things capable of producing the same effect. Right? No one's ever independently replicated that, especially under a vacuum or in isolated conditions where they've taken the possible confounding factors into account. Right? It also doesn't prove the cause of the effect. Okay, so we want to prove that gravity is the cause of an effect, not just show an effect and then claim that it's because of gravity. It's just an assumption. Safa, do you have any more questions?
Well, not at the moment, but I've been thinking about these things like last week, and like my Instagram explore page is just full of now universe and the space and what there has been and what's going on. And yeah, it's been seriously making my mind busy with that. And wow, it's seriously infinite. Like thinking about it is infinite, and the universe itself is infinite. I don't know. I'm like trying to, take myself away from these subjects because I'm really into it, by the way. I really love to think about it, but the more I think, more it just pulls me in. And yeah, seriously infinite. But
Yeah, they're trying to wow you with some
CGI graphics of the so-called heliocentric universe, what you'll probably find is most of the graphics they're showing you are just CGI generated.
Well, yeah, it is probably, but what do you think in general? Like,
Well,
you're
it's
saying
just
that.
a bit. It's like a big theoretical mathematical concept. Okay, so it exists in math, and then they'll turn that into graphics and things like that, and they'll say, "Oh, on Uranus, the planet Uranus, it rains diamonds, and it smells like farts, and then on Neptune, it also rains diamonds, and then we have exoplanets where it rains sideways glass rain, and then we have all of these crazy claims, right? That you can't validate anything they're saying. It's just a belief system, and it's all just based off a mathematical concept, not off empirical evidence, not off reality. What we can do is actually go out and test the surface of the Earth to see if it's a globe. Okay, and when we go out and test the surface of the Earth, it can't possibly be a globe, right? If it's a globe, it has to have curvature. Okay, so they tell us that 70% of the surface of the globe is covered in water, oceans and seas, right, and lakes. So when we go to a large body of water, it would have to have a certain amount of curvature to it, right, because of gravity and because of the shape of the planet. So, one second. Sorry, my wife was just leaving. Okay, cool. Yeah. So, gravity. Sorry, what were we talking about? We're talking about the curvature. The curvature.
Curvature, yeah, water curvature.
Yeah. Let me give you an example really quickly. I'll just give you an example. Can you see the side chat?
Just a sec.
Yeah,
where is it? Full screen. Okay, wait. Oh, yes, I can see it now.
All right. So in this is an observation. I haven't posted it yet, but I'll post it now. So there'll just be some things uploading, right? So this is a 21-mile distance across the lake.
Yes.
Okay, so here's a screenshot from Google Maps just showing where the observation is taking place. This is the Great Salt Lake in Utah. And it's a good place to do observations because it doesn't have a lot of humidity, so you can see very long distances.
Clearly.
Yeah, it's very dry air, so we can see very clearly through it. Okay, so in this observation, this guy is setting up his camera on one side of the lake, and he's setting up his camera on a tripod 5 foot above the surface of the water. Okay, and he's going to zoom across the lake and try to test for the curvature. Okay, so over this distance, 21 miles, on a globe, you would have to have 293 foot of curvature. Okay, so 293 foot, that's almost 100 meters. And that's taller than the Titanic, right? That's the Titanic boat, right? That was 175 foot tall. Okay, so this is a big amount of curvature that we're talking about. Okay, so I'm going to put some math in the side chat, super simple math. Okay, this is the globe Earth mathematics. Okay, so anyone can go to Google and you can type in Earth curvature calculator, and you can put in the eye height, right, which is the height of the camera, 5 foot. Okay, so that's what we've put in. Then we've put in the target distance, which is the shoreline on the other side of the lake, 21 miles away. Okay, then you hit calculate, and we come up with a distance to horizon, 2.7 miles. Okay, so you know what the horizon is, right, on the globe, right?
Yes. Yeah, I know. So
okay, cool.
With these numbers, we should see a curvature, right?
Well, we should see a horizon at 2.7 miles. And then we shouldn't be able to see any water beyond the horizon.
Okay, let me ask you this. There was another test, like this one, I guess. And they were, I believe, if I remember correctly, they are putting a light on it. And it was proving that the Earth has a curvature. It's the globe. And have you watched that video? Let me
Yeah,
check if I can.
it's a flawed
Well,
test.
yeah. What do you think about that? Yeah. What was wrong
It's
with
just
that test?
it doesn't. Okay, what's wrong with it is the
Yeah.
fact that the people that made that documentary, right? They
Yes.
were making a video to make Flat Earth look bad and to look stupid. Okay, so they edited the footage in a way that made it look like the Flat Earther proved himself wrong, whereas they didn't actually show any footage of the test, right? They didn't show the setup. They showed 50 seconds worth of footage, which was mostly just close-ups of the Flat Earther's face, right? And that guy's a dumbass as well. You know, Jaren, his name was Jaren. So they basically were just trying to make it look like he disproved the globe, right? They didn't show the test, right? They didn't show the setup. They showed him carving some holes in some cardboard, right? He was supposed to use a laser, but apparently the laser broke, so they decided that they were going to use a flashlight.
Yes.
Okay, they didn't get the math right. They didn't show the setup. They didn't. It was just basically a terrible test.
I got you. So it's a scam, basically. It's not
pretty much.
It's not
pretty much
actually acting as its purpose. So let me ask you this: what about? So you're saying that world it's a flat circle, right?
No.
Okay.
Okay, no, definitely not. We're not saying that the Earth is a flat planet or a flat circle.
Oh, okay.
That's what some people misconceive what we're talking about with flat Earth, and they think that all they try to do, right? They think of the globe in outer space, and then they change that globe in their mind into a flat disk.
Oh.
Okay, that's wrong. That's crazy. We don't claim that. That would be stupid if we were claiming that, and nobody should take us seriously if that's what we were claiming. Okay, so we're not claiming to know the shape of the Earth, right? We're not claiming the Earth is a planet in the globe Earth version of outer space.
And what is it like? What's
Completely different system. Yeah. So when we don't know, I think nobody knows the true shape of the Earth in its entirety. Flat's not a shape, right? So when we say flat Earth, flat's not a shape.
We can
it's like
think of
smooth.
a lot of shapes. Yeah.
Yeah, flat, smooth, bumpy, right? They're descriptions of surfaces. Okay, so when we go out and test the surface of the Earth, there's no curvature, and that's the context here of flat Earth, right? That's what we mean when we're saying flat Earth. Most of the surface of the Earth that we're aware of is covered in water, and that water is not curving over distance, and that's where the term flat Earth comes from. Okay, obviously we have hills and valleys and mountains, but most of the surface is flat water. Okay, so it's like a topographical plane, right? Because there's topography, but most of the surface is water, and the water is flat on the surface when we measure it.
Yeah, water will always be, flat on the surface. It's not. Well, the water you wouldn't count water as the Earth.
Well, it is part of the Earth. If you look up the definition of Earth,
exactly.
even the gas is considered part of the Earth. Right,
Yes,
just like the tires are part of a car, right? And all together, So the Earth,
everything,
Earth isn't just dirt. Yeah, everything is. It's like all
part of
parts.
an Earth.
Exactly. So the water is part of the Earth.
Yes. So if you need to go to center, you don't measure the shape of an object with what on it. You just take away everything on it, and then you see the shape, right? Because which one? What was the other one?
Yeah. Think about this though. Think about this, right? Okay, so if you have the Pacific Ocean, it covers a large portion of the globe, right? So you can't have flat water and curving Earth underneath the water, right? Obviously, because of gravity on a globe, you would need gravity, and then because of gravity, right, you're going to have the water will be curving at a specific rate, right? So when you look at the pictures of the Earth that NASA claims, right, you see water curving, right? So you don't have any flat water on Earth, right? You have curving water because of gravity. Okay, so we can calculate very easily how much curvature there would have to be over a certain distance of water.
Yes.
Okay, so over this 21-mile lake, you have to have 293 foot of curvature. That means that the shoreline on the other side of the lake would be hidden behind the horizon and obstructed by 223 feet based from the height of the observer, okay? But in this observation, we don't see any curvature, and we don't see any obstruction. Okay, you have to have that obstruction. You have to have that curvature if the Earth's a globe. And every time we go out and measure and take these observations over the surface of the Earth, we don't find any curvature. And that's not possible on a globe. You have to have the
Okay.
curvature.
Let me ask you this: what do you think about the moon? What is moon?
I have no idea. I can't empirically test what the moon is.
No, exactly. I'm not expecting you to give me like a scientific like moon is blah blah blah. Whatever. No, I'm asking: have you ever watched moon like with a telescope?
Yeah. Uh-huh.
And the shape is circle, right?
Yeah, it looks circular. I would even say it looks like a sphere to me, but the Earth has no. Yeah. So just because, so
No, I'm
think
not
about
saying
it.
just because of that. Like Mars, Saturn, all of them. When you look at them, they are all in a globe shape. They are circle at least, as far as we
Right,
can.
but what are they, and how far away are they, and what are they in? Right, what medium are they in? And can you really tell exactly what shape things are when you're looking at them from a distance?
I mean, yeah, with those telescopes, I think it's a circle. You can call shape.
Okay, if you look at the raw images, through a telescope, it's pretty difficult to tell what shape something is, right? It's a very blurry little light that you see in the sky.
Yes.
It's not until they run it through, like they stack thousands of images and then they enhance it to try to make it look more like the pictures that NASA show you that Mars should look like. Okay, but we don't know. Okay, they're claiming it's a certain size, a certain distance away, and it resides in a space vacuum. Okay, so we agree that we can all see something in the sky, but exactly how far away it is, exactly what it's made out of, how big it is, and what medium is it in, we don't know that, right? We can't test that empirically. We just have to take their word for it. Like I could show you some objects right now. So if you have a look in the side chat now, okay, there's 4 objects. Okay, can you tell what shape they are just by looking at them?
I mean, they are circle, right?
But do you know what shape they are? Because a circle just means like
one of them looks like an egg. I'm not sure what it's called in English, but yeah, like
they look like spheres, right? It looks like 4 spheres.
Yes, I would say.
Okay, but what if I were to tell you that only one of those is a sphere? Would you be able to tell me which one?
I don't think so. No.
Right. So, and how would we test to know what they are?
I mean, I don't know, with these lake tests, I guess.
Well, what if someone, went to them and checked what they are?
I mean, yeah, also that, but
that would
really
work.
Huge. Yeah, exactly. That will work.
Right, but what if we can't do that? What if we can't ever check what they are? We can just see the little tiny blurry things that look like round dots in the sky.
Yes.
So we don't really know what they are, do we?
Nope.
Okay, so only one of these is a sphere. One of them's flat. One of them's a ball. One of them's flat. One of them's a ball.
Yes.
And
so
one of them's a sphere, and one of them's half a sphere.
Okay, so I guess the third one, I mean, from the left is flat, right?
Third one from the left.
It's okay. Okay, from the right, it's second one. From the left, it's third one. Yeah, is that the flat one?
No, I think that one's a ball. I'm just trying to find the GIF that goes along with that shows you what they are.
Yeah.
So I think the one on the far left is the globe, is a ball, and then the one next to that. Okay, so the one on the far left is a ball. The pinky one is the flat one.
That's
and
the
then
flat
the one. Yeah, then the third one from the left, right? Is a bowl, right? It's a bowl.
Okay.
So you're looking at a concave bowl, and then the one on the far right, I think that's like a half a sphere.
And
a hemisphere.
And the left one is the sphere. here, right?
Yeah, I think so.
Yeah,
But it's
the
very
first
difficult to
one on the
tell.
left.
I don't remember if I might have flipped this image upside down, so I might even be wrong myself. That's why I'm just trying
Yeah.
to find the I'm trying to find
Because
the video.
like
The point is that look, the only point of this is it's very difficult to tell what shape something is empirically just by looking at it in the sky.
yeah, but
right?
we
I'm
can
not-
agree that all of them has a curvature, right? No matter
yeah,
if
but one
they're
of them's a
flat
bowl,
or
right? Well, you're looking at
yeah.
you're looking at the inside of a bowl, right? And the flat one doesn't have curvature. The flat one has curvature around the outside, right? Like a circle.
Yeah, he's missing the point, isn't he? You can't tell the shapes of those things just by looking at them. So when you look at the moon, what are you actually looking at? Unless you can go there to confirm what you think you're looking at. That's the point, you see. Right. That's the point he's trying to raise. Bear that in mind. Not all what you look at appears to be what it seems.
No,
This is my main point. This is my main point. Look, let's just say I were to grant you that some things in the sky are balls. Okay? That doesn't mean that the Earth that you're standing on is also like what you can see in the sky, right? You can have light bulbs on your ceiling that are all round, right? That doesn't mean that your floor is also round. Okay? The Earth doesn't have any characteristics that any of the things that you're looking at in the sky have. Okay? You don't see any curvature here on the Earth, and when we test for the curvature, there isn't any. Okay? We experience a flat stationary floor, right? Like the floor of the universe, you could think of it, right? Or the foundation of this system that we live in. It doesn't have any relevance to the things that you can see in the sky. That's like me looking at a tree and thinking, oh, well, I must also be a tree because I can see trees over in the distance, right? It's terrible logic. But I understand the logic because we're all taught from a young age that everything is in this big space vacuum and that we're a planet. You know, we're like all of the other planets in this big space vacuum. So it's perfectly logical that you are to make that assumption, right? But the flat Earth system is a completely different system. It doesn't exist inside the heliocentric model of outer space. It's completely different. Yeah. So you could think of the Earth system more like an enclosed system, kind of like all of the ancient cultures depicted, right? All of the ancient cultures depicted a flat surface within an enclosed system. And I would argue that the globe Earth violates natural law, right? It violates the second law of thermodynamics. Okay, it violates multiple gas laws, right? Because they say that outer space is a big giant vacuum, right?
Yes.
Deep space is a 10 to the negative 17 tall vacuum, and we're inside that vacuum. Okay, so we're a ball that's covered in water, and then there's gas all over the outside, right? So we have 14.7 psi gas pressure here that we're breathing, and all of this is existing within inside a giant space vacuum. Right, that's the claim. That's not possible due to the laws of nature. Okay, gas fills available space, right? You can't have a gas pressure system inside a vacuum chamber. You can't have water inside a vacuum chamber. So what we're saying is that we have gas pressure. Okay, gas pressure requires containment. We have water. Okay, water also requires the gas pressure, and it also requires containment, right? So to have a large body of water, you need a container. Okay, so if you have a bath or a pond or a pool or anything like that, it's a container, right? The low spot in the ground would be containing the water, whether it be a pond or a pool or a puddle or a lake. And then the surface of the water, right, due to the way fluid dynamics works, is that the water would collapse on itself and it will form a flat surface on the top of the water. And that's what we can go out and measure. If the Earth were a globe, that water would have to be curving at a specific rate. And when we go out and test it, it's not doing that. It's flat.
So let me ask you this. How many tests are there that proves Earth doesn't have a curvature or it's flat? Like correct tests. And how many? Yeah. What is it?
Thousands?
Thousands.
Yeah, there's thousands, and then from the globe side.
I'm really, by the way, going to research about it and see. I'm not trying to just argue or give you opposite things. I'm seriously want to go and check it.
Sure, I'll put a good
how
one.
Can I find it?
Yeah.
Send me a
All
good
right.
one, and I will check it with like I don't know Google, ChatGPT, and see how is it, what's going on there.
Sure. You got to remember that ChatGPT is just going to feed you the mainstream narrative unless you really push it. You need to push it beyond beyond just its parroting of the mainstream. Like my ChatGPT. Okay, so if you have to formulate these questions in the right way when you're talking to an AI with these observations, right? So you could put in, okay, let's go over one right now. Okay,
Yeah, let's say what
I
give me
can
a
put
test
it in.
name.
I can put it into my ChatGPT as we're going over it.
Yeah, let's do it together. I'll do mine and you do yours. And tell me what's the name of the test, and I'll just ask ChatGPT what's this test and how correct it is. And
Well,
you do.
ChatGPT is not going to know this test.
Why not?
Because ChatGPT, right? Regular ChatGPT, it just pulls. It's just basically like a Google search engine, an advanced search engine.
Yeah,
So
if
it's just going to pull whatever it can find. Yeah, but this is censored information on the internet, right? So flat Earth information is shadow banned.
Okay.
On Google, on Facebook, on YouTube, right? So I'm going to post you a link to the test right now, but you can put the details of the test into the chat.
Yes. If I'll just say give those numbers that you gave it to me, and let's say we run this test, should be able to see a horizon or not, something like that.
Okay, so
You
the
know,
first thing you could so the first thing you could do is go on your ChatGPT right now and ask it. Yep.
Okay, just a sec. Let me. Yes, go ahead.
Okay, so say I'm going to perform an observation over the ocean on a still, clear day.
Over the ocean, still clear day, you said, right?
Yes. Right. Okay, so if I place my camera at 3.5 feet observer height.
Camera 3.5 feet, you said, right?
Yep, 3.5 feet observer height. What distance would the horizon be if the Earth were a globe? Or what distance would the horizon be from that observation height? You don't have to mention a globe, it will automatically think that.
Yeah, what distance? The horizon, you said, right?
Yep.
Horizon. I'm sorry, I couldn't hear the last part.
Yeah, what distance would the horizon be from that height?
Height, and would we able to see it?
Well, don't ask it if we'd be able to see it. Of course, we'll be able to see it. You can ask it that though if you want. That's fine.
Yeah. I just right now it's thinking.
Which AI are you using, by the way?
ChatGPT. I just Google ChatGPT. Yeah. What do you think about it?
My ChatGPT will say that your ChatGPT just regurgitates mainstream information. Which is fine because we can just what you're trying to do now is learn how far away the horizon would be.
Still thinking. Yeah, it's stuck now. Okay, yeah, they don't want us to see, huh? But no, it's seriously still thinking. Should I refresh the page? Okay, let me copy that and then refresh it.
Right, I'm gonna type the same thing in.
Yeah, you do it.
Okay, so I'll copy paste everything into the side chat.
You can read it if you don't want to. Yeah, copy paste it. Me answers now. So
I gave it a bit more detail.
Oh, okay, all right.
Yeah, you can read it, or you can you could just read the answer, right? It should give you an
Yeah,
answer of the distance.
it gave me the quick answer. So if your camera lens is 3.5 feet above the sea surface, the geometric horizon where sea and sky meet will be about 3.69 kilometer away. That's 2.29 miles and 1.99 nautical miles. I guess this is about sea.
Yeah,
With normal atmospheric reaction on a clear day, the horizon can appear a bit farther, typically 8% farther, roughly 2.49 miles, 4
Yeah, that's correct.
kilometers away. Yeah.
Okay,
And he was
okay.
giving me how he got that with the,
Yep.
and
Okay, so let's look at some information now
saying
before
that
we
it should be.
Exactly. Okay, so this is the specific mathematics here.
Yes.
Okay, so I've put this in the side chat. So we have an eye height level of 3.5 foot, and then we have the distance. The target distance is 11.2 miles. Okay, because we have a windmill farm out in the ocean that we're going to be looking at. Okay, and it says, just like your ChatGPT said, the distance to the horizon would be 2.29 miles.
Yes.
Or we could account for standard refraction as well, and that would take it up to about 2.4 miles or something like that if you add 8% on to account for refraction. Okay, so now let's look at the observation. Now we're going to test for that. Okay, so we're going to test for that horizon now. Okay, so I'm just uploading the observation. Okay, so this guy's name is Dr. John D. He holds a PhD in optics, and he's the one that's doing the observation. Okay, so this is just a clip out of a full-length video. Okay, so he set his camera up at 3.5 foot height at this shoreline of the ocean on a clear day with no waves.
Yes.
And there's a wind farm out in the ocean. So when he zooms in, you can see the wind farm towers, the windmill towers. Okay, the windmill tower on the far right, that's the furthest one. That's 11.2 miles away. Okay, so if we didn't have the distance markers, right? So the wind farm is a distance marker because if there was no distance marker, we would have no idea how far away the horizon is. Okay, you're just looking out into the ocean and you can't gauge the distance to the horizon just with your eyes. Because we have the distance marker, we can now tell that, okay, the horizon is not in front of the windmill towers. Okay, so we don't see that horizon at 2.29 miles. In fact, we can see the water is just flat all the way out past the 11.2 mile windmill tower. And you can see the windmill tower touching with the water as well. Okay, so we don't have that horizon at 2.29 miles or at 2.4 miles, accounting for standard refraction.
Yes.
Okay, that horizon has to be there if the Earth's a globe. Okay, you shouldn't be able to see any water beyond the horizon. Okay, so here's a diagram showing you. You know, the horizon is where the sky and the ground appear to meet. That's the definition of horizon. You can look that up if you want.
Yeah.
Okay, so you shouldn't be able to see any water past 2.29 miles, and the bottom 50 foot of that windmill farm should be hidden by the curvature of the Earth. But we can see the water goes way past the horizon where it should be, and then way past the windmill towers, and you can actually see a boat off in the distance far beyond. Okay, so this doesn't align with the globe. So what do you think would be the next question to ask your ChatGPT?
I would ask, give me the correct test, has been happened over the years, and show me the correct test that proves Earth is flat. Show me the over years how many tests that proves it's flat and how many of them proves that it's curved.
Well, I'm showing you a test now that disproves the curvature.
And
right, we're not using this test to prove it's flat because it's obviously flat. If there's no curvature, then it's flat, right? If you have a surface that's not curving, it's by default flat. Okay, so what we're doing is we're looking for the curvature. Okay, so we have a test here that debunks the curvature rate of a globe. So you could actually ask it now, say in the observation.
Well, these tests you didn't test them, right? You are also consuming whatever they put on the internet as the test, right?
No, anyone can
Uh-huh.
go and repeat these tests themselves, right? I used to
okay.
live on the biggest saltwater lake in Australia called Lake Macquarie, and I did at least 20 tests myself over large distances of about 20 kilometers.
Yeah.
So I've gone and repeated this just for my own personal clarification. Okay, so this isn't like outer space stories that you can never test. This is an empirical test that you're seeing the entire test done start to finish in high definition, right? Not something that you don't have to rely on faith. We encourage people to have a look at multiple of these tests. And then if you want to, you can go and do this yourself, right? So then you can know that, yes, I can see too far, and the observation doesn't match up with what would have to be present if the Earth were a globe. Okay, so this is empirical evidence.
Well,
it's not faith-based evidence because you can go and check it yourself.
Okay,
if you need to.
can we see it by our naked eyes? The curvature, I mean. Because when I asked
No, we're not looking for
ChatGPT
curvature. We're not looking for curvature. We're looking for obstruction due to curvature.
I mean,
So you're not going to see a curving horizon, okay? So if
exactly.
you're going to
because
see
you're
a
not
flat
that big.
horizon, okay, but it just told you that the distance to the horizon, right, would be at what distance? What distance did it tell you the horizon would be at?
2.9, something like that. Let me check.
Okay, ask it.
Yeah.
Yeah.
No, it's it's 29 miles.
Okay, and why is it at that distance?
Well, I don't know. It's just
Well, it's because of
I
the
didn't
curvature of
write
the
it
Earth,
down.
right?
Yeah.
Okay, so
But-
you should be able to see any water beyond the horizon.
But let me ask you this: when I ask if we can see it with our naked eyes, it says over that distance. So you can't directly see Earth's curvature with your naked eyes from ground level because the Earth is very large compared to your height. But you can detect its effect in several clear, visible ways. Let's break. It just keeps going. So at human eye level, 1.7 meter or 5.5 feet, the horizon is only 2.7 kilometer, which is 2.9 miles away. Over that distance, the surface curves down just about 0.002, way too subtly, whatever, I can't read it, for our eyes to notice. So the horizon looks flat simply because you are very close to it, relatively to Earth's size. So
Okay.
that's also,
Okay. So listen
why,
carefully. Listen
Yeah,
carefully. We're not looking for horizon to be curving. We're looking for things beyond the horizon to be obstructed behind the curvature of the Earth, right? Behind the horizon. Okay. So ask it right now. Say, okay. So if there were a windmill farm, if there were a windmill in the ocean, 11.2 miles away, would the bottom portion of the windmill be missing behind the curvature of the Earth?
Where you gotta slow down, I can't type that high. Yeah, 11.2 miles away.
Yeah. There's I can write it in the side chat if you want.
I mean, I just got if there was a windmill in the ocean, 11.2 miles away.
Yeah. 2
And
miles away.
Yeah, you type it down.
And I'll just type it down.
Where are you from, by the way?
Australia.
Nice.
I'm in Poland at the moment.
Cool. Are you like majored on these fields, or what do you do?
Oh, I'm a bit of an entrepreneur myself, right? I run online companies, but I've been researching this topic and the fields surrounding this topic, such as optics and refraction and things like that, for the last 8 years. So I know a bit about these particular questions and optics and light and things like that. So
so we can say that the last 8 years, you don't think Earth has a curvature, or it's not exactly close,
yeah, like
right?
the last 7 years. The first year was the research.
And
And for me, it's been the last 10 years that
Last
the Earth
10 years.
has
And how
not.
about
Yeah,
you? How about
yeah,
you?
it's
Where
been
are
10
you
years
from?
of
And
this.
are you majored
Yeah,
in
I was
earth
born. I was
field?
born in England, London, England. I'm an African who was born in London, England. I am now talking to you from Japan.
Nice. I love Japan. It's beautiful.
Yeah, and where are you from, by the way?
I'm from Turkey.
Where?
Turkey.
Turkey, right?
Yes.
Turkey, right? Yeah, Istanbul. Okay.
Yeah. Have you been there before?
No, it's a place that I do want to visit for its historical
Yeah,
content and architecture. Yeah, I haven't been there yet. Go ahead.
My wife's parents just went for a holiday. It was beautiful there, but they said it was like 46 degrees Celsius or something like that.
Oh wow,
really
man, a heat wave. Yeah,
It
nice.
gets really
crazy
hot.
heat wave. But it was beautiful, like really, really amazing. The photos they brought
environment
back.
wise. Yeah, environment wise.
Okay, here's the question in the side chat. Okay, so
Gotcha.
I'll read it out as well while you copy paste it. So if there was a windmill in the ocean 11.2 miles away and the observer height was 3.5 foot, would the bottom portion of the windmill be hidden behind the curvature of the Earth?
Mm-hmm. Okay, now it's just giving me the steps to do it, but let's see conclusion. Okay, I'm reading the conclusion at 11.2 miles distance and 3.5 feet observer height, roughly 75 to 80 feet of the bottom of the windmill will be hidden behind the curvature of the Earth, depending on refraction.
Okay, so ask it. Yeah, so it already told you before that you can add 8% for standard refraction on there. Because we have very clear conditions, right? We don't have any crazy refraction or anything like that going on. We can see in the observation that it looks the same as it looks from close up. Okay, so have a look in the side chat again. Okay, so it actually got the math a little bit wrong, right? So it said there should be more hidden. Really, the answer is 52 feet that should be hidden from that observer height.
Hidden, right?
So
yes.
ChatGPT doesn't do very well when it comes to basic math sometimes for some reason. But anyway, it gave an even worse answer for the globe.
Yeah, but you know why is that? Because if it's taking the windmill, the height of the windmill is like 300 feet. We didn't specify the height of.
But it doesn't matter what height the windmill is. It doesn't matter if the windmill is 100 miles high or 10 or 1 mile high
we
or
should be
50 foot high.
Yeah.
Because the bottom portion, we just want to know how much of the bottom portion should be missing. Okay, so have a look at the observation. We see that there's zero of the bottom portion of the windmill missing in the observation. And then I posted a close-up photo of the bottom of the windmills as well, just so you can see that in the observation, it looks the same as it's very clear conditions.
So with your calculation, the conclusion, according to ChatGPT, is like with naked eyes at 3.5 feet height, you would see the top part of the windmill, but the bottom 52. Yeah, so 52 feet would be hidden behind the curvature. It will look like emerging from the water, not sitting fully on the surface.
Correct. Which is not what we see when we go out and make these observations.
So let me ask this. How can I observe?
What was the question? How can you observe what?
How can I observe the curvature of the Earth simply? Like as a casual day, it's just giving me some answers. Like watch a ship disappear bottom first.
Standard global stuff.
See, that's what we're testing. That's what we're testing right here.
Climb higher, watch the horizon more move away, and look out the airplane window on a clear flight. Observe different stars in the sky. Use a long lens across the lake. So I guess the most practical one for me, since I don't have a big telescope or I'm not gonna climb any higher, mountain. It will be just watching the ship disappearing.
Okay, so we just debunked that with this observation.
Mm-hmm.
Okay, so ask at what distance would the ship start to become obstructed behind the horizon from a 3.5 foot observation height, right? It's the same answer, right? It's going to say that, let's just say that this windmill was a ship.
Mm-hmm. So,
okay, at the bottom 72 feet, it said in your answer, would be hidden behind the horizon, but that's obviously not the case. In fact, we can see a boat in this observation that's 14 miles away, and there is no obstruction, and you wouldn't be able to see that boat at all if the Earth were a globe. So
yeah,
you could ask it now.
I'm asking, like, at what distance would ship disappear?
Well, yeah, what distance would the ship start to disappear from the bottom up?
So distance, horizon, blah blah blah. Ship visibility. The bottom of the ship disappears first because of the Earth's curvature. If the ship is tall, let's say 100, you can see the top, blah blah blah, below horizon, the maximum. Okay, give me the answer. Okay, that means the ships would still be visible at 50 miles. The bottom would be hidden behind the curvature. Okay. So when the ship totally disappear, because so let's say there's a ship passing through like Pacific Ocean. According to these tests, we would be able to see no matter how far ship is. If we check with a telescope, like really high one that we are checking the space with it, we will be able to see the ship.
Yeah, but the air is not completely transparent. So if you check the weather report in any location, it will tell you the maximum visibility rating. So even if you have the world's most powerful telescope, the ship's still going to fade away into the density of the air.
Yeah, you would have to remove all the air, turn it into a vacuum. Then that's the only way you're going to see it, because on a normal day, there's so many weather systems over a given distance. Let's say you've got a distance of 2,000 miles. Well, within that distance, you're going to have weather to contend with.
Okay.
Right?
So, yeah, that's also correct. I asked like the totally, disappears at distance less than this. So less than 14.7 miles, you'll see some or all of the ship. At distance greater than this, which is 14.7 miles, the entire ship is hidden behind the curvature. So I think we can, 14.7 mile. How far is this in kilometers?
It's about 22, 23.
Yeah,
so,
22, 23 kilometers. Yeah.
So 22.
But that's completely hidden, right? So even when it's at 10,
so
even when it's at 10 miles, at 10 miles, it would be hidden by a 50 foot approximately. The bottom 50 foot
like
would be missing.
So after 15 miles, we shouldn't be seeing any ships, according to this.
Yeah, none of the ship at all. But I guarantee you will see that ship. You'll be able to see it.
I'll see if I can see it.
Yeah, you'll be able to see it. All right.
You can't see it. And we've got observations that show ships, that show features past that height, past that distance.
Yeah, that's it. Past that distance. That's right. Yeah. And laser beam
so the horizon from
targets have been hit.
The horizon should
targets have been hit.
The horizon should be at 2.3 miles from that observer height, right? So less than 3 miles away. That's where the horizon should be, right? The horizon line. As soon as the ship goes past the horizon line, the bottom of the ship should start to disappear behind the curvature of the Earth. Okay, we're not seeing that horizon line at all at anywhere close to that distance that we're showing.
Weird.
Right, have a look at this next observation. Okay, so we've got something similar to a ship in this next observation.
Which one?
Okay, we have some oil platforms. Yeah, I haven't posted it yet, so here it is. This is out of a video. Yeah. It's just a clip that's out of a video.
Yeah, I already posted it. I think if you're talking about the black swan, I posted it already. You just scroll back, it's there. I posted the video and the picture.
Yeah, I
Right, so
watched
let's-
those videos.
Okay.
Yeah.
So let's just have a look at this one. Okay, we have an 8-foot observation height. That means the horizon should be at 3.4 miles away. Okay, but once again, we have some oil platforms. Okay, and we can see that the horizon is beyond both of the oil platforms. Now, the closest oil platform is 6 miles away, and the furthest platform is 10 miles away. Okay, so we can see the horizon is far beyond the second oil platform. On a globe, that horizon should be at 3.4 miles away, halfway to the first oil platform, basically. But it's not there. Okay, so picture the oil platform as a ship, if you want to, right? It's the same kind of thing. We don't see any of the oil platform missing, right? We can see the whole oil platform, and we can see the horizon beyond the oil platform. On a globe, you shouldn't be able to see any water beyond the horizon, right? All of the water should be hidden behind the horizon, because the horizon is where the sky and the ground appear to meet, right? You don't see water past the horizon. Okay, so here's another observation that doesn't match with the globe at all. We can see in orders of magnitude further than you would be able to see. You can add 8% on if you want for your standard refraction, but that's not going to help, right? That's going to make the horizon about 3.7 miles away. It's just we're seeing the horizon far beyond 10 miles away. All right, so I'm going to show you an even longer distance now. Okay, so this is the Great Salt Lake in Utah.
Yes.
Okay, so this is a 21-mile observation. That's about 34 kilometers. Okay, so over this distance, there should be 293 foot of curvature. So since we're talking about boats, right, you know the Titanic?
Yes.
Pretty big boat, right? So the Titanic was 175 foot tall. Okay, so in this observation, he's got his camera set up at 5 foot high. And if you picture, right, just as a hypothetical, the Titanic is where the observer is. Okay, the giant Titanic. If the Titanic were to sail from where he is over to the other side of the lake, at 2.7 miles, the Titanic would reach the horizon. And then once it goes beyond the horizon, the bottom of the Titanic would start to disappear behind the curvature of the Earth as the Titanic sails over to the other side of the lake 21 miles away. Now, once the Titanic is at 10 miles away, the bottom 66 feet of the Titanic would be hidden behind the horizon. By the time the Titanic got to the other side of the lake, you shouldn't be able to see the Titanic at all. It would be completely hidden behind the horizon due to the curvature of the Earth. But in this observation, he can zoom all the way across the lake. We don't see the horizon at 2.7 miles. We don't even see a horizon over the entire 21 miles. He can zoom in and he can see the shoreline on the other side of the lake. Okay, zero obstruction. Right? So you can see, once again, all we're seeing here is a flat water, no curvature. There's 293 foot of missing curvature here. It has to be there if the Earth's a globe, and it's not there.
I'll check that. I will really check that.
Yeah. No, that's all we ask people to do, right? You don't have to believe what we're saying. Just look into it. You put on your critical thinking cap and try to debunk it
yourself. Exactly.
Yeah.
I'm never type of guy just defends an idea. I'm just trying to find what can be a counter to my idea and dig into that, because maybe all the answer will be there anyways. If I don't make the research with you, I wouldn't understand what you mean. So
right.
in order to find what is correct or incorrect, I need to check all of it.
I agree. That's what I did.
Yeah, exactly.
Yeah, don't believe what we're saying. Just look into it and come to your own conclusion. That's the only way that this works.
Yes. Because these days, whatever you do, whatever you make the research, it's like always, it's not that 100% correct anymore with the internet that we are using right now. So
That's right.
Anyway, it's really good talking to you. Thank you so much. It was
you're welcome.
Great, it was a great conversation
I appreciate it.
with you. And Jin, thank you so much. And yeah, you guys have a great day.
Awesome, man. You too. Are you heading off now or what?
Yeah, I'm heading off. I'll go out.
Okay.
Yeah.
All right, man. We'll enjoy the rest of your day and see you next time.
Thank you. You too. You too. See you guys next time. Bye bye.
I get what you're saying, but I just like.
This goes to the question you ask all the time too, Sheepdog. Where like, if the Earth's not curving, then what is it? They can't even entertain the idea for a second that the Earth would be flat, because then their mind will continue on the downstream connotations of that. So they don't even want to think about it for a second. Because hypothetically, if I said to just a normal person, hey, hypothetically, just imagine that you live on a flat Earth. What would be the metaphysical consequences of that? That's fucking scary if you're a fucking hardcore atheist Goldberg.
Yeah. No, the thing I was going to hit on. The thing I was just going to hit on, the reason why I thought you were talking about like whether it was a sphere versus an oblate spheroid. Like the thing that I always try to point out to people, and this is off topic, but I just wanted to throw this in there. When they're like, "Oh, it's not a perfect sphere; it's an oblate spheroid." Look, if the oblate spheroid is 7,000 pixels in diameter, and you're complaining about 26 pixels, I think you have a problem.
Mm-hmm.
But anyway, yeah, no, you're right. It absolutely has downfield connotations, and you were going to touch on that, Deb.
Yeah, I was going to say that a lot of things change whenever you realize it's flat. I mean, gravity goes out the window. NASA needs to refund us a lot of money. I mean, everything falls to the ground. That's what they're scared of, to be honest.
You know what happened for me? All of a sudden, I stopped imagining myself being somewhere that isn't reality. And this world itself became a lot more interesting. I started looking into like what the different plants of this world are capable of doing when it comes to interacting with animal, the animal side of things, right? Like when they eat it. Why do dogs eat grass when they eat it, or why do animals eat certain things when you don't know what's going on? Oh, it's because they were feeling this, and so they had to do this. What is it? A crow
there's natural remedies for everything on this planet for us. I mean, we don't need anything.
Yeah. No, a crow will go and...
Someone wrote a book about all different species of animals that eat certain things to get fucked up. There's something, it was like 200 different species eat shit to get fucked up.
Yeah. Yeah, I've heard of this too. But I was just going to say...
The dolphins and the pufferfish, dude.
Yeah.
You ever seen? Yeah, it's freaking crazy, bro.
They do it to get high.
I can't remember who told me this, but I think I remember hearing somewhere. It had to have been when I was in high school, so it was a while back. But someone, I think it might have even been one of my teachers, said that we actually know less about our own oceans than we do about space. And I was shocked.
It's correct, yeah. So, hey, I'm going to take the piss out of Shiva right now, Sheepdog. Check this out. Now, Our observation is dolphins playing with pufferfish. Now, according to Shiva, our hypothesis has to be in the form of a mathematical equation. So, what is a mathematical equation for dolphins playing with pufferfish? See how stupid that is, dude?
It's so stupid.
Maybe we could do a mathematical equation on why pigs can breathe out of their buttholes.
Oh, I saw that today. Jesus. Stop it, bro. Cut it out.
I couldn't believe it. This video come across my feed on Facebook.
Is that actually true? I couldn't watch it.
Yes.
I was afraid of what I see.
No, this lady was like, oh my God, I thought my pig was going to drown because he wouldn't lift his head up out of the water. And his face was like buried in this like kiddie pool and he would not lift his head up, but his butthole was above the water. And so he was, apparently she found out that her pig can breathe out of his butthole. And so I looked it up and yeah, some mammals can breathe out of their butthole.
Some mammals can exhale out of their buttholes only, though.
Count me in on that one.
There's a joke somewhere in there.
Oh, God.
Globers can probably breathe out of the butthole.
On, dude. Fucking before this gets worse. Fucking him play.
And the intro is that one RF emitter of that tower is focused direct in line with the horizon. The second is angled upward 6 degrees above that. They do this so that the plane's radar equipment can sense the signal strength of both. The pilot's primary flight display shows the results shown here in the circle of a process which is merely a comparison, constantly made by the aircraft receivers of the strength of those two radio frequency signals. When the received signals are the same strength, the primary flight display indicates that the craft is currently on the prescribed path of descent to the runway, typically a negative 3-degree slope, because as you see here, the midpoint between 0 angle from the bottom one and the 6-degree angle from the top one is 3 degrees. This slope is also called the glide slope. Airports, as a matter of safety, constantly update their local runway barometric pressure for the benefit of the pilot, in proper precise calibration of the altimeter on board the craft. This ensures the most accurate measurement of altitude during the test. So the objective is to fly a Cessna on a fixed altitude ILS intercept course, crossing the signal at either 20 or 90 nautical miles from the runway, and we are taking barometric altitude reading at the intercept point as well as a distance measurement using the ILS system hardware seen here. The approach and measurement can be made several times during a single flight in order to reduce the uncertainty. As you see here, the pilot will circle the approached runway multiple times. This figure is a representation of the approach pattern and distance for the CYVR airport in Vancouver, Canada. As shown here, choice of airport will critically depend on whether the approach path is completely over water. The pilot will file a visual flight rules plan. Those have no mandatory flight levels to maintain for an approach pattern which conveniently uses an airspace which is farther away and at a higher altitude than the avenue which is typically involved when ATC is setting up a standard runway approach routes to the airport. The pattern should be flown at a fixed altitude of 6,360 feet above runway altitude. In flying at a static altitude, we eliminate any delay in the altimeter's reading of altitude, thusly optimizing its accuracy. In cases where the craft's autopilot hardware settings may only, I'm too far here. In cases where the craft's autopilot hardware settings may only permit 100-foot altitude resolution, the duty to fly at the proper altitude will rest on the pilot's ability to manually maintain the proper altitude, because the pilot can still visually see increments in between As you see here in the circle, this primary flight display altimeter has a 20 feet resolution, but we can see the 10 feet in between of the 20. The independent variables, meaning the factors we control or change on purpose, are the speed of the craft, the altitude of the craft, and the angle of the beams from the ILS tower. The dependent variables, meaning the outcome we want to measure, are the alignment with the 3-degree angle and the distance to the ILS tower, both shown on the primary flight display. A more detailed description of the entire process will be handed as a method document, which the pilot will use both as a guide to the flight particulars as well as the data collection he will need to fill out. We will do a run-through of that at the end. Just a quick overview of what he needs to fill out. So, the prediction is, as shown here, the Earth is flat when flying at an altitude of 6,360 feet above the runway altitude. The craft should intercept the glide slope at 20 nautical miles from the ILS tower. If the Earth is convex, the craft should intercept the glide path at a point substantially closer, approximately 19 nautical miles to the tower. The math to that is the following. In the case of scenario A flat, we apply this sine function, opposite divided by hypotenuse, and solve for the opposite divided by vertical side, the opposite or vertical side. The sine.
Now, I want everyone to pay attention to how much detail he's laying out here compared to what McToon laid out. Now, McToon laid out a fucking very simple thing. Said we'll make a model to predict where the sun is. And she was like, yeah, great, awesome, cool. Now, this dude's up and he's laying out very detailed with specificity exactly the procedure for measuring, instruments used, independent variables, dependent variables, inputs, outputs, outcome, all the shit Shiba wanted. Now just watch what happens.
In function of that 3-degree angle applied to the distance of 20 nautical miles yields a vertical distance above the runway of 6,360 feet. Hence, a craft which flies an approach of 6,360 feet above the runway altitude should intercept the 3-degree angle at a distance of 20 nautical miles from the ILS tower. Conversely, in the case of scenario B, the globe, the same sine function will yield conversely, the same sine function will yield the first vertical component of that distance of 6,042 feet. Add to that, due to the supposed globe's convexity, the value, which comes from the standard 8 inches per square miles, which is very accurate for up to 1,000 miles. The result is 318 feet. We obtain this value by applying the cosine of that same 3-degree angle in order to produce the x, or ground distance, component of 115,288 feet, or 21.83 miles. The total of these two components also yields a vertical sum distance of 6,360 feet to the ground from the craft. At this point, the craft should be 19 nautical miles from the ILS tower. Conclusion: this experiment involves a use of a collection of hardware which has been utilized for decades, where lives are at stake in assistance to pilots of all kinds on approach to the runway, a process which makes use of a very necessarily precise light-based guided system. This method is easily replicable and repeatable. Replicable meaning multiple trials in one go, and it is as well repeatable at different locations and by different people. As the time it takes a Cessna to travel 1 nautical mile while flying at around 100 knots is approximately 36 seconds, there exists a rather large margin of separation between those two distance values. This method objectively serves to eliminate virtually all uncertainty in the distance measurement itself. Through sufficient replication by a number of pilots flying at a number of airports, all uncertainty can be completely eliminated. So a video introduction I show now by a side-by-side animation which shows what the pilot will see in the PFD when on approach. The glide slope indicator involves a pink diamond, as we saw in the beginning, moving vertically on the gauge. When the diamond is in the center, that is the moment of interception of the 3-degree path. When the diamond is 1 dot above, the craft is intercepting the angle of 2.65 degrees. That is the point where the recordings of each approaches should begin. And we see the approach begin here. And you see the diamond here and there. The altitude is fixed. We let this run through to have this on camera, and I show just a quick summary of the file that the pilots will get. You see the nautical miles are different, and the angle starts at a different time. So I stop this and start the method. Wait for me to pull up to show you the method. It's just 5 points, 5 sentences in there. Method file is here. Screen share. Method. I don't see it. I will screen share the full screen. How do I do this? Full screen. Objections revised. Pull it up. Here. Section method is here. Okay. Screen share again. Workplace. Where can I screen share? Here. Full screen share. Full screen. Method document. Close the assistance here. So we see that we show the pilots that step 1, he chooses an airport. The entire approach must be over water. Step 2, which plan he needs to file. Step 3, check the weather conditions, as we show in the document later. Use the meta source for that, which is a public source. Recorded parameters must include airport temperature, wind speed, wind direction, barometric pressure. We pretty much thought that it's of not so much importance, but we want to make sure the data set is very clear. Step 4, plan the recording. It's about the recording here. Before takeoff, make sure that you put the camera stable in front of your PFD screen or help someone with assistance. Make sure that your altimeter is properly calibrated. And when you take off, begin the flight patterns we showed and try to repeat it as much as possible, but of course it's dependent on costs, and perhaps 5 or 6 passes should serve. as adequate to minimize the random error. You can do more, and then land and secure the craft. Use the camera also to make a screenshot of your file which you fill in, and forward all recordings to the author. And yes, so date and time, runway, ILS name. So this the ILS angle from this airport, the altitude, and then in 1 hour steps, 2 hours before the flight, 1 hour before the flight, what is the data, temperature, wind direction, etc., all of that. Relative humidity, visibility, and you get this from radio. You can just record that. It's not hard to get. Yes, that's it.
Right. So, so we have 2 experiments being proposed. One, so this experiment, Kevin, is you need an airplane, right?
Yes.
So not everyone can do, but those you have to somehow go get an airplane, and then you have to the airplane can make multiple advances towards the tower by circling, and each one of those will give a data point, right? Each time it circles back, right? All right. Okay. So maybe since you just finished, we'll ask, and then we'll go back to the globe earthers. Globe earthers, if you want to ask any questions about this, again, today is merely looking at the formulation of the hypothesis. So Kevin, in your case, you're saying that there's a formulation of the globe earthers. You've actually claimed that you formulated it, and then the flat earthers will have, and then you proposed an experiment. So any of the globe earthers have any questions that you want to raise?
I have some questions about the precision. So, Kevin, you listed off the variables you were going to capture, but I missed what I thought was probably going to be the most critical one, is the margin of error of the slope angle, and the margin of error of the second, the width of the beam, and third, the margin of error of the width of the beam.
The width of the beam is 0 degrees is the one. The second is 6 degrees, and because you have you check the interception point of those 2 beams, you can see the interception points, and it's in between. You measure the strength of both, and when they are at the same strength, you measure that multiply. It multiplies. I saw it on I showed it on the how the beams come out, but there is no because there are multiple lines which are on a line of those interception points. There is nothing out of that line. It cannot be out of that.
Okay, so you didn't answer my question. What is the margin of error of the slope of that beam? You say it's 3 degrees, but it's not exactly 3 degrees. It's 3 degrees plus or minus something. What is the margin of error, and how do we know that margin of error?
The slope angle is 3 degrees on most airports.
Plus or minus something. What is that plus or minus?
It's 1% based on 35 nautical miles, what we tried, but we are in less miles, the margin of error, and
Wait, hold on. Is he literally saying that, like, when you do a math measurement, geometry measurement, like, okay, you got a triangle, and your slope is 3 degrees, your hypotenuse is 3 degrees, or whatever. I kind of missed what he was saying, but there's a plus or minus in, like, the angle measurement for a triangle? Like, I'm confused.
sorry, Sheepdog. I wasn't paying attention. I'm waiting for them to start talking about the Earth. So
This is the part that goes over my head because I hated taking geometry, and it was my brain just does not agree.
I bet you wish you paid attention now, huh?
Well, it's one of those things, you know. A lot of the arguments made on either side, it involves a lot of that stuff, and I'm just like, oh man.
Yeah, I get weirded out because they call it an experiment. More so, it's just it's really just a measurement. But I'm a little bit more aware that Matone is asking about this margin of error. It doesn't seem like, far as the distance of him taking this angle measurement, especially when he's talking about nautical miles, which is supposed to be parallel to statute miles. It don't seem like it's even far enough for him to even talk about a slope to begin with. And even if he's going to even put a slope in there, he was going to need a level in order to compare that slope to. Still not doing nothing with nautical miles at all. So I don't know where like Matone is trying to go with this. It's just basically still proving.
Well, that's not McToon is talking about. It was another guy that presented. Some German guy presented like the flight path of airplanes when they're getting ready to land on a runway, and how they take an angular measurement based off of a right angle triangle as they're coming into land, and they're trying to strawman this into a science experiment, and they're trying to be like, oh, well, what's your plus or minus? Like, bro, I didn't know you could have a plus or minus on a triangle. Like, I think it could be a 30, 60, 90, but it could be plus or minus 5 degrees. I don't know.
Say like it's some type of slope. But yeah, a triangle is a triangle. So I don't understand. Like that's what I was saying. It's kind of weird that Matone is talking about there's some type of plus or minus on. He's saying there's a margin of error. But I don't. You don't have to.
You missed the beginning opening statement. So this is all based on the scientific method for the geometry of the Earth. That's the title of this conversation.
This ain't science. So I don't know where he's going with that. There's no independent variable here. You don't have to talk about none of this. Like, it's geometry, math.
I agree with you, man. That's why I'm confused when he's like, well, what's your margin of error? Margin of error on a triangle? On a 30-60 triangle? Like a right triangle? 2070? Like, what do you mean margin of error? Like, there's only one measurement, bro.
I literally think Matone is just an idiot. There's no margin of error in the measurement. This is like if I'm doing like anything a home improvement, you know, I mean, I'm taking a measurement. I mean, what would be the margin of error? I'm just taking a measurement. Like, I don't. Yeah, I think they make it confusing than what it have to be because they try to make it a science project when it's not. It's really just category error. It's really mathematics.
Yeah, I mean, measure twice, cut once, I guess, but like that's just because like people sometimes are lazy when they move across the measurement or whatever. So just be sure before you make that cut, because you don't want to have no excuse for a piece later or whatever. So I agree with you, man. That's why I'm confused. Like how are you? What's the margin of error you're going to do for a right triangle?
Right. I think Matone just confused. I don't know.
No, he's not confused. I think he's sticking to the script of how they're going to make this a scientific method approach. Because that's what the whole thing is about, is like using the scientific method to determine whether the Earth is flat or round. That's basically what he said in his opening statement. Not McToon, but Dr. Shiva, the guy who's hosting it.
Yeah, Dr. Shiva, I don't know what he's talking about. There's no science here. I mean, he should know that. This is geometry. Plain and simple. So I just think Dr. Shiva just don't know what he's talking about. I mean, he went to school, right? So I mean, you can't say he really don't know what he's talking about. I just think he's not really too familiar with this topic, because he should know the difference between mathematics and measurements and science.
Yeah, no. We'll try to get you a copy of the video. But man, he makes a whole bunch of fallacious reasoning in the beginning of the video. I'm gonna go ahead and hit play again for everybody. Keep moving forward. If anybody has anything to say, speak up. We'll try to pause it as quickly as possible. Okay.
There's still this 30 seconds time frame in between, more than 30-second time frame.
Okay, I'm sorry, you still didn't answer my question. What is the published margin of error of that angle of the glide slope?
It depends on the airport. Whatever airport you go, you have a different angle of the glide slope. You maybe don't understand the method.
No.
The method is...
What is the margin of error? Not the angle. The margin of error of the angle. I know that published glide slopes are 3 degrees or varying amounts of degrees, but what's the margin of error? Because at 20 nautical miles away, it's not going to be a pencil thin line. There's going to be a variation because the installation isn't absolutely precise. So we need to know, because at 20 nautical miles, any margin of error is going to be magnified when you're 20 nautical miles away. So what is the margin of error of the different airports you've looked at?
He's just making a claim. Like, he's not really explaining.
There's a idea that the...
What's up, Ray?
Matone is just making a claim instead of like setting like an example of what he's not clarifying what he's talking about. He's just basically just making a claim saying, well, we know this, but I'm like, yeah, but you're not actually clarifying what you're talking about. Because I literally just think that Dr. Shiva just don't know what Matone is talking about.
Well, so Dr. Shiva apparently has like 4 doctorate degrees. Very intelligent guy. Like, I think he's got his degrees in healthcare, right? So, like,
he's got 4 engineering degrees, and apparently he said that engineers don't lie, scientists do.
Yeah, he got like 3 like chemical. He's like a chemical engineer. I know he got 3 chemical engineers. He was the one that tried to expose the whole COVID thing.
Yeah, he was one of them that tried to get out in front of that. But yeah, so that's pretty much what he's doing. He's strawmanning the flat Earth. The whole thing was basically meant to, like Indio said, it was to basically point out how crappy flat earthers are and how they don't know anything. But in doing so, he's using the scientific method incorrectly. He's basically putting it on a model and then using the scientific method on the model instead of like what we observe out in nature. So he's using the scientific method completely wrong. It doesn't even need to have science in certain aspects of the conversation, right? Can you do science with it? Yeah. I mean, there's observations people have done where there is science involved, where they change the temperature of the environment that they're in, or maybe increase the pressure or something like that. But again, that's like a different conversation. This is strictly a math thing. And this guy, I don't remember the name of the guy, the flat earther that's talking, but he did a good job pointing out that flights, when they're coming into land, they use a right angle triangle from 19 miles away, which is interesting.
That the beams can multiply outside, but it's not in our observation. So I don't see that there's a margin of error beyond 1%, what I mentioned. I don't.
But that's just a guess, right?
No,
you're just guessing 1%.
We tried that. It has to be absolutely precise. You cannot do it different because millions of dollars and lives.
No, hold on a second. No,
millions of dollars depend on and lives depend on how the airplane descends. So you cannot.
You're correct, but
it's one degree more or less.
Kevin, if that glide slope is 3.1 degrees, the plane will still land just fine. And if the glide slope is 2.9 degrees, the plane will land just fine. So there isn't a security or not a security. Hold on just a second. I'm not done talking. Okay. There isn't a safety problem if there is a 1/10 of a degree or a 2/10 of a degree margin of error. The plane will still land just fine. And then the second thing is, what is the width
It's not
of
about
that
landing.
beam?
Sorry, it's not about landing. You ask a question, but we are not landing the plane, and it's not about if the plane lands fine. The plane will be at an static altitude, and we have the sine function. It's Mach. And we are not landing the plane. It will land fine, okay, 2 meters above or below what it's expected, but we are not landing the plane. We are looking.
Yeah, I didn't claim that.
You said the plane will just land twice.
So gentlemen, let me just jump in here for the audience here. I just did a very simple, I think this is what, Kevin, you're bringing up. Let's say that center line is that 3-degree line, okay?
It depends on the airport. Most airports have 3 degrees. You can.
Well, let me finish, Kevin. You got to stop when someone.
But you asked the question if it's 3 degrees. It's not always 3 degrees. It can be 2.9 on some airport, but it's
so let me just finish. That's what we understand. Your experiment proposes 3 degrees, and in science, if you've used any instruments for measuring anything, typically the company that provides you that instrument will provide you a plus or minus margin of error if you've done a measurement of any kind of thing, So if that center line is your 3 degree, which is what you're formulating, it could be above or below based on error. It's essentially in a cone, right? It's essentially a region. That is not going to change the nature of the airplane landing safely. However, I think the issue is that can have a significant impact based on the margin of error on the calculation.
Yes, but it's in.
Let me finish.
Okay.
Please. Okay. So the question is, are you aware of what because you're using instruments to measure this? Are you aware what the margin of error is? Because the margin of error varies. That's going to you have to put that into your hypothesis, and that's going to affect the output, which is going to affect whether the Earth is flat or round, and you're essentially introduced something.
Is this guy the moderator?
Dr. Shiva is, yeah.
Why is he making the argument for Matone?
I have no idea. This is how it always goes for the Globe side when a Globe Earther moderates.
Why is he making an argument for Matone? Because Matone couldn't even explain it. And then him and Matone is talking about two totally different things when they're talking about margin of error. So he's making instead of letting the guy answer his own question. It's not the guy's fault that Matone don't know what he's really talking about.
No, I don't disagree, man. I think the guy made a very valid argument. Were you here for McToon's argument?
No. Yeah, I just heard the guy presentation. I mean, I guess his name is. I heard his presentation, and it seemed like he was spot on. Besides the fact that he attempted to say that it was a science, it was some type of experiment with a hypothesis, but It seemed like he was just basically talking about geometry. He was basically saying, hey, this is how planes utilize right angle triangles in nautical miles and statute miles in order to land planes. I don't know where they coming with the margin of error. It seemed like the only thing that they're talking about with margin of errors would be more factored in pitch data, but in this, you don't need that.
Yeah, no, and if you had been here in the beginning, not that it's your fault, man. I'm just letting you know. McToon didn't even make a 2-minute long argument. Maybe it was 2.5 minutes at most. And Dr. Shiva didn't even ask any questions. Just moved right on to the flat earther. The whole idea was that to create a model for McToon, create a model for the location of the sun based off the rotation of the Earth. And based on your time, the sun should be in a specific location. That was his argument.
So Mattoon should be the one explaining those details, because that burden is on Mattoon to prove that the Earth is rotating, and that burden is on Mattoon to prove that the Earth is a globe in this first place. So Mattoon shouldn't be having no 2-minute presentations whatsoever. I mean, it seems like this guy's talking longer than Mattoon is.
He is, and he was very detailed, and I appreciate what he brought to the conversation, because you can tell he read into it, and he has a good understanding about just this portion of the flight, and like how it's at its distance, this is the triangle that it makes.
Inconclusive, up a priori. So the issue is, do you know the margin of error? I think that's Mike's question.
Yes, and I answered him twice. He can look it up. 1%, 35 nautical miles away, and this will not affect this experiment. You can still would have 30 seconds of change of both predictions. The vertical margin of error was measured at 1% of the vertical height, and you are in between. The experiment still works very well for both.
Well, you haven't done the experiment, so you don't know if it's going to work.
There's something similar work happened, like pilots observed their.
Yeah, but time out. Again, this is, in science, you have to do the specific experiment using the specific. If you did something else, that's not this experiment. So we want to talk about this experiment. Has this experiment been done? This exact experiment? Okay. So this is a proposal. That's great. But the issue is, if you work out the math in your equation, this is just some feedback to you, you're going to have to include that margin of error, because that margin of error is going to affect the output.
Yes, it's 1/5 of the difference. And it is, yes.
I have I can show a little more detail maybe for the audience. If I can share my screen here, I have it up.
Okay, hold on. Go ahead. I think you can share.
Yeah, I'm sharing it right now.
We don't see it.
You have to select on your tab at the top of the screen. You should see that my presentation is being shared.
Does everyone see it? Oh,
Dan says he sees it. Okay.
I don't see it for some reason. Is it being broadcast to everyone? Let me see if it's being broadcast.
Yeah, it's on the.
Oh, okay.
Okay. They see it on YouTube. Okay.
Okay, they do. Okay. I'm sorry.
Yeah.
Go ahead.
So here's an approach for an airport in Denver, Colorado, and down at the bottom here it shows the exact same thing that he's talking about. This is the ILS slope there, and it's got those the gray borders around it, above and below, and that's showing the margin of error of the width of the beam, not the margin of error of the glide slope. The glide slope margin of error is not stated in here. And this is the same for every airport. Here's another airport, another airport, another airport. All of these have that gray top and bottom to the glide slope. You see that there? And so that's showing that the glide slope isn't an exact 3 degrees. It's a broader angle. And so here's a diagram that I put together showing that, you've got this in the middle here. This middle slope is showing the exact 3 degrees, but based on an approximation of 0.7 degrees, which is what I get as when I've done some research on what is a potential average value, but we'd need to get the exact value for any particular experiment we did. But you can see here, when the airplane maintaining constant elevation will enter into that cone at 26.1 nautical miles in this example, being the center of the beam at 20 nautical miles, but there's no way to measure that directly, and then exit that at 16.2 nautical miles. Now, this is my my computation for flat Earth, and my computation for the globe here is similar. It's just a slight different one, and it enters in at a different point based on the two models. Now, here's the problem. Here's those two overlaid, and you can see there is a different intercept based on globe, this curving one, which is exaggerated. Don't take that to mean exactly what it is. The horizontal scale is not to scale with the vertical. And then the intercept here for flat Earth is on the top there, and it's a different width, different entry point. But the problem is now, if you don't know the glide slope margin of error of the center, you get this. The center is at, but you actually can't measure when you're at the center very well. You can measure when you enter and measure when you exit that beam. And so what actually happens is this is just looking at the glide slope margin of error, the unknown margin of error. Kevin doesn't know it.
No, it's not the margin of error. You're showing something wrong. The gray section was merely showing the 0.35 degree spread, and the pilot expects this to see on his gauge.
Exactly.
It's not showing.
So it's not
but
possible.
It's not showing error margin.
Yeah, so it's not possible to measure precisely the kind of precision that you want.
23%.
This is just a second. I'm still talking. This is just a visualization of the margin of error of the glide slope. Now, if we add in the unknown width of the beam, because we're just guessing at 0.7, then this in big boundary here gets even larger. So there's no way to differentiate exactly precisely when you enter and when you exit and get to the center of that beam. There's no method to do that.
Why this is 23% error margin you propose is preposterous. You couldn't land any plane with this.
Oh, you can easily land the plane with that. You see down at the bottom left of this where they converge. So no matter what, you'll get to the runway at the right elevation, because the margin of error shrinks as you get closer to the runway. So when you're out 20 nautical miles, it's fine to have a really wide beam, no problem for safety at all, and any pilot can land the plane just fine, and then they get guided down, and it gets tighter and tighter as you get close. But you're not proposing to be close. You're proposing to be 20 nautical miles out, where you do not know the margin of error of the angle or the beam width.
But it's not 23% as you propose.
I don't know where you're getting 23%. I just drew random. I didn't put any numbers in here.
You have showed.
The 0.7. Yeah, the 0.7 is what I got doing research. Yeah, but so if you had any documentation of the width of the beam, then that would be useful. But I've not been able to find any hard documentation, because, like I showed, these different airports, they don't document
and exaggerate it like
exactly
crazy.
You can't 100%. You can't approximate, and so you would need to provide, and we don't have that. When we look at the documentation that airports have, there is no documentation that I found of precise beam width. They just have this rough gray area here around it.
Radio frequency, it's in a low frequency. I can look it up for next time. Never mind. I can look up how the lower the frequency, the stronger it is, and the less it diverts. So I will look up the exact value. But we were in what we looked up was 1%, and your 23% were not in any way.
Kevin, if you're talking about beam divergence, it has less to do with the frequency, more has to do with the antenna design. Also, in your presentation, you said that you were measuring the distance off the ILS system. Is that using the DME system within ILS?
Which system?
How are you measuring the distance, the glide slope distance from the plane to the airport?
Yeah, you have it in your, I showed it on the bottom left. It shows on the primary flight display.
Right. So that's that. Okay. So because you don't know, that system's called DME. It's part of the ILS system, but it's a separate system entirely from it. Do you know what the margin of error is for the DME system for just random airports as far as the range difference?
Dr. Sheba again talking?
Okay, so it's 0.2 to 0.5 nautical miles. So when you add just that error margin into a 1 nautical mile difference from your, not even discussing Mike's idea about the beam width, just the measure of the distance, your now margin of error has taken your 1 mile and taken it to possibly half a nautical mile.
It's near zero. Say again your numbers. It is in 20 nautical miles.
You said there's a mile difference between when we enter, if it's globe or whatever. There is a half nautical mile margin of error for the DME system that measures the distance.
Show me the reference. I don't believe this. It's the error margin is near zero. If you had half a mile error distance, again.
Because your distance isn't necessary to land, the glide slope is. So your distance could be off by half a nautical mile because where the DME is located and where the transmitting antenna is located on the airport is going to affect what the DME measurement is. And a DME measurement measures the glide slope length, not the overland length.
Fine. Oh, but
so those two systems, so anywhere from 0.2 to 0.5 nautical miles on the high end, you've now taken your margin of error of 1 nautical mile between the globe and the flat Earth and made it half a nautical mile. And that's before you can even address the beam width issues that are expanded upon at 20 nautical miles away from the airport.
With that, we're exaggerated. We can show this. We will look for the reference, but even if it's half nautical miles, the error there with the distance, the experiment is still valid. You could still
wait, Kevin. Let me just step in here just to explain to the audience. There in science, when you do measurements, there's something called margin of error. Okay, so you take a measurement and you think something's 1 inch, and if the margin of error is half an inch, that means it could be 1.5 or 0.75. You understand that, right?
Yeah, but you cannot come up with some numbers.
Wait. No one's coming up with any numbers. Stop.
Yeah, 0.5 miles.
No. Stop. Don't interrupt. You kept saying Mike was coming up with 23%. He didn't say that. So take that off the map because I don't want that to be perfectly.
I showed them off.
He never said 23%.
It showed 0.7.
He said that the beam width, he gave an example. The bottom line is, so let's be clear because what I've seen happen is people are taking words and then say, he said this. It's not what he said. Okay? So let's stop it right there. That's not science. That's called bullshit. So let's stop it. He didn't say that. What he is bringing up in a very rational way is a concept of margin of error. If you don't know the margin of error, any measurements you make thereafter are subject to being highly dubious. Okay? Or you have to incorporate that into your hypothesis. Okay?
Yeah.
Okay. So that's all we're saying. So in order to do that, Dan is saying the DME, he knows as an expert in the field, and you should go do it independently, is half a nautical mile.
I haven't shown any reference. It's 20 miles. Don't believe this. 100 miles maybe.
Wait. So where do you have the reference of what he's saying is false?
Because I saw some tests from 10 miles.
No. Wait. Stop. In science, there's something called a citation. You have to give a reference. So if you don't have the reference, don't say, he said something.
Yeah, he didn't show reference.
Dave Flat Earth said something.
He didn't show reference. Exactly, no. He didn't show reference.
Okay, let's define reference. A reference is a reputable source where someone's done the experiment and it's being used. So I think what's outstanding is Dave has proposed here that he has a reference. Okay,
I like to see.
Okay, but you don't have that reference right now. So you can leave it as an unknown. Agreed? It's an unknown variable in your area, and perhaps you and he should connect offline, but in our white paper, we're going to say the margin of error is not known for your measurement.
Yeah, no worries. It's two researchers.
So just as
got it.
So Kevin, just so you're aware, it's an ICAO standard of 0.25 nautical miles plus 1.25% of the distance being measured. So I gave you the benefit of the doubt by just saying 0.5 at the high end. So if you want to do the actual math of it and everything else, the operational accuracy is a half mile or 3% of the distance, whichever is greater. And that's reliable up to almost 199 nautical miles. And that's from the ICAO.
So Dan, why don't you send that reference over? I think
I'll send it over right now.
That the landing of an airplane using the glide path can happen very safely and securely. That's independent of measuring something in that range that we're talking about concerning the Earth being flat around, okay? One is a measurement issue. The other is a plane landing safely. And I think Mike's point is when you're 26 miles away, you're in some region, but as you get closer, you're always going to be able to land the plane. But in your experiment, you're proposing that you have to measure this at 26 miles, which is a significant distance away.
So just a quick, my observation on this, he's strawmanning the hell out of it, right? Like the whole thing isn't about landing the plane. The whole thing is about being in a, like a level pattern above the Earth at a specific altitude as they get ready to engage with the beam. And that location becomes a right triangle once they engage with the beam and start their descent. If anybody disagrees with me on my understanding of this, please speak up, because I'm learning more and more about this particular thing as the discussion goes on. Seems like the guy that did this, Kevin, did his due diligence, but now he's being picked apart by 3 different people.
Yeah, it seemed like it's 3 different people, and they all saying something kind of different. It sound like what they're saying. It sound like they're on the same page, but if you really listen to what they're all saying, it's kind of they basically all making different arguments. So they scattergunning them, number one, and then even the guy even admitted it in the last part of what he was saying. He was saying that Mattoon is making an argument based on the plane not land. You will still be able to land the plane. So Mattoon is strawmanning them by saying that the guy is saying that he won't be able to land the plane correctly. And then the other guy is saying that he's incorrect because he don't have a reference, so therefore he's making an unknown claim since he's making a claim of science, which is this is not science, it's a category error, it's mathematics. And then there's a third argument with another guy that's basically saying that he's incorrect because he gave him the benefit of the doubt, I guess, of some reference that he made a claim of. But like you said, I didn't hear him earlier. So, but they're not really.
One of them was saying that because he doesn't understand the names of the systems being used, and he's using the abbreviations, right? He's not even using the actual name of the system. He used the abbreviation to get him to like, well, what do you mean? And so you don't know. Right, like that was one of the arguments that I was hearing.
Yeah, and it's like, well, they're not really letting the guy really explain. He do know, so like so that he say one sentence. I mean, you're really not hearing what Kevin's saying right now. So they let him. They heard like a little bit of his presentation, and now they just jumping on the guy.
Yeah, I can't wait to see if they even get to McToon's argument. Supposedly also there's because of the situation where people are not experts in their field, whatever they misunderstand or unable to give evidence for in today, they have like a week to use basically what he said was an open book source where you can, do any kind of search, Google, ChatGPT, Grok, whatever, and help create an argument with references that will lend credence to your argument. Another straw man.
I think that's really fair because if the guy is arguing against the mainstream, you know.
Yeah, I mean, you're running uphill in ice.
If he's making an argument and he's going against a narrative of the mainstream, I mean, where is he going to find looking through the mainstream media in the first place? So,
no, I agree.
Against Christianity, why I'm gonna pick up the New Testament to prove something that I don't agree with in the Christianity. I mean, the only thing I could do is just show a reference point that I don't agree with, you know.
Right.
Or if I don't believe in something in Scientology, why would I go? Like, oh, find me, go to the Scientology book. Like, why would I go there? Like, I'm just going to point out something in nature that doesn't make sense, you know. So, I mean, we could go basic fundamentals of measurements and geometry.
No, it's the Yui Hartman.
Okay. If I have to.
What's up? What's up, Kingsley?
I think he was hot micing. But yeah, but I was
he was in here before, but go ahead.
Yeah, but that's kind of like, you know, that's kind of like not fair what they doing with him on that point. That's all I was saying.
No, you're right, and I mean,
say that somebody else said something. I don't know, somebody named Mike or somebody. They tried to say that he said that Mike said something, and I don't know.
You missed like maybe 20 minutes before you started, because like you came in right when Kevin was starting his thing, right?
Saying man, like when Kevin was making like probably like the middle part of his presentation, right before I interrupted him.
Yeah. Oh, okay. So, wow. So you came in at the end of his presentation, and then like if you listen to how everything opened up from the beginning, and then what Kevin presented, you'd be like, oh, damn, dude, like he actually put some effort into this, and so kudos to him. There was a third flat earther that was supposed to be there, but and Indio said that originally it was supposed to be a 6-on-6, but they were strawmanning everything out of the gate, and it's a long story. But there was a third flat earther that was supposed to be there, but after sitting in the room with everybody, he realized that the other two flat earthers may be believing in things that they can't back up with real world observations, and so he backed out at the last minute. So you know, I don't know the whole story, but I'll say this just to be objective. If that is the case, kudos to him for recognizing a trap and seeing it. Like I got to give Kevin his dues. He's making he's holding his own. But you know, if this whole thing was a straw man to make flat earthers look like the problem, then kudos for him for backing out at the last second.
All of these are like that with McToon. McToon's never going to agree to record something and put it on the internet if he's not going to win the argument.
Oh yeah, like Indio said that Dr. Shiva was talking about these things prior to McToon even getting involved, but I think McToon's been involved a lot longer than what we're being told. Or maybe somebody else put Dr. Shiva on, and then that's kind of like in McToon's circle, and so that's where we're at. But Dr. Shiva definitely understands this a little bit too well. Anyway. See, Planet Truth, initially they were going to have PhDs there against the Flat Earthers, but then McToon obviously contacted Shiva and told him even a baby flurf could destroy a PhD. Oh yeah, that was right. McToon did say that in a debate. Flat earthers can destroy PhDs. That's what McToon said. So they ended up getting anti-flat earthers instead. Shiva is arrogant, but not a complete idiot. I agree. I agree.
I don't understand what having a PhD matters. I mean, it's Globers that don't pay for PhDs that believe something, and it's a PhD that paid all this money for his education to believe something, believe the same thing.
Well, PhDs generally are well read, and they typically have a higher capacity for retention. So I give them that credit.
Yeah.
All right, I'm gonna put it back on play.
Between a PhD is just, I mean, and an anti-flat earther is that an anti-flat earthers have its own rhetoric, and they easy to lie within a debate and straw man you. They good with debate tactics. Where just a PhD is just gonna just go over what he's already studied. He's gonna come with the mainstream narrative, and he's just gonna repeat what he learned in college. I mean, you probably would get a more honest conversation with a PhD than an anti-flat earther, because a PhD will school an anti-flat earther more on a mainstream rhetoric than an anti-flat earther teaching a PhD. So it's not like an anti-flat earther is smarter than a PhD. It's just that a PhD is more honest. Like if you read a book, like say it's like if you going over a topic with a PhD and you read the topic, pretty much the PhD is only going to talk about that topic and how it's actually been written in a textbook or how it's actually been studied. Where if you talk to an anti-flat earther, he'll probably try to gaslight you into believing something and come up with his own narrative to win a debate.
Yeah, but what if you talk to a PhD and you tell them something they didn't think of before, and then they realize they wasted all their time and all their money going to school to learn something that's a lie? Don't you think they're going to be a little bit biased? I mean, I would.
There's
PhDs that have changed their minds, so
yeah, they're going to be. But for the most part, they only going to go off of what they read. Where anti-flat earther is going to make up some other thing. They're going to try to spin it in a way where they're trying to win an argument. Like a flat earther could even show them something in their own textbook and use it as a hostile witness against them. And then the anti-flat earther will go, "Oh, well, no, you're wrong anyway." Like everything that the flat earther would say is wrong, even though you're using their own education against them as a hostile witness. Where a PhD would be like, "Oh, well, that's correct." But it also says this in the textbook or something of that nature. And you have to point out, well, why it's wrong or why you disagree with it. And then that would probably force a PhD to actually think about it in reality and be like, "Oh, well, maybe this is wrong or something." Or maybe you just say, "Well, it says it. I'm just going to believe it because I went to school for 8-10 years studying about it. So what do you know?" Well, the anti-flat earther would just say, "Well, you're wrong. It doesn't say that. It says this. It doesn't mean this. It means this."
Yeah, I agree with Joe on the anti-flat earther. But the PhDs, yeah, there's some out there that will be honest and they'll realize that they missed something there. But then there's some that are like, they spent so much time, so much money on their education. They want to hold themselves higher than you.
Yeah, I think that's quite arrogant. They all gonna think they're smarter than you.
But at the end of the day, it's a pissing contest, right? Like you gotta figure they went to school for such a long time and then like as they were graduating, right? Like even after they graduated, they went through a phase where like they went through a mentorship and they were told like you have to be arrogant. You can't let anybody take your PhD from you. You have to stand on it, right? And then it becomes like a marketing tool more than anything else. At the end
Sounds like religion.
It's sales. That's all it is. It's sales.
Yeah,
They're selling you on the idea that they know something you don't.
Yeah, it is a marketing tool. I mean, school, college is a business.
Oh yeah,
degrees is a marketing tool,
and it's not cheap.
Nope, no sir. All right, I'm gonna go ahead and push play for a little bit. Let's see. I'm not sure how much is left. Wish sure it's a timer on this.
And as you get farther away, if the margin of error, whatever that margin of error is going to significantly affect your delta, or whatever your delta H, the height. Is that the point you made, Mike?
Yeah, the entry point when the plane is coming in at that same elevation, they'll get into the entry point where you'll start where the instrument will say you're in the zone earlier than right at the center of the beam, because if it was just at that very center, if it was super pencil thin, you'd hit that and then instantly you'd be past it. The pilot needs to know when they enter it, give them time to adjust the plane to decrease elevation so that they can stay within that zone. If it's pencil thin, they'd be past it and they wouldn't know.
Yeah. So I think the outstanding piece in that experiment, or let's put it this way, so you don't take this personally, in your model, the margin of error must be included.
Real quick, when they talk about this beam, and they're talking about elevation from what?
Obviously from the baseline.
Yep. So they're talking about an elevation angle.
Yep.
In the beam.
Never mind the was it the 29 miles or 19 miles that the plane is away when it catches the beam, right?
Right, but the purpose of them catching the beam is for the plane to land, right?
Well, so the beam doesn't land them. They just have to, like, have you ever played a piloting game? Like, you have to stay within the tolerance level as you're landing, and if you're above it or below it, it beeps at you.
Yeah, that's what I'm talking about. But that is to make sure the plane is level when you land it.
It's to make sure you're taking the correct angle. Because if too steep or too shallow, you'll overshoot the runway. Too steep, you'll come in hard and crash.
Yeah, you come in hard and crash. But you still have.
And that's why Kevin made the argument at the beginning when McToon tried to get in on him. I'll just say this real quick. McToon tried to get in on him early, and Kevin was like, "Bro, there's millions of dollars and hundreds of people's lives at stake. They can't afford to make a mistake of any margin of error."
Yeah. Because Matone is making like, oh, well, it's never precise. But landing a plane is, you definitely have to be like, I don't get what Matone is trying to say here. Matone is trying to say like it's never precise. There is a margin of error. You will be in error. The margin of error means that you are in error. There's just a certain average of error that you're going to be. Like, no, the purpose of the beam is for you to have the correct angle to land the plane, and you have to have the correct pitch as well. So I don't know where Matone is getting that. Matone will have to show where he's getting that from. That's what I would have asked him. Like, you have to show where the plane, you could just land the plane at an average of incorrectly, because that's what you mean when you say error. Error means it's incorrect. That means the angle is not accurate and it's not correct. That's what error means. So what do you margin of error?
With all due respect, dude, I'm not too sure how significant this point that you're making is. Okay, because it's one thing to have a three degree descent, right? But does 2.999998 degree of a descent make that much of a difference? Because technically speaking, you're right. There's an error there. There's an error there by. Hang on. Let me finish my sentence, please. Right?
Let me finish. You cut me. Hold on. You cut me off.
I thought you were done. though. Go ahead. If you weren't done, please go ahead.
You cut me off. You guys are making a point of saying a margin of error as if you're not supposed to be precise when you are landing a plane in descent. And the beam is utilized for what? Is it utilizing for you to still be in error while you land in a plane?
By a certain amount, that's the argument. So precision, right, is just by how much you are off by anything, right? It's just you take a ruler or whatnot. Look, if you weren't done, please don't let me interrupt you. I thought you were done, so I wanted to just throw this point in here. But if you guys had some more to go on, please do.
Don't cry about it. Make your point. But there is no argument.
So I can speak then. Okay, I thought you were going to go ahead then. But I'll go. Okay. The point is, dude, there technically can be an error. This is what precision is all about. So when they're asking about how much allowance can there be, this is not a statement of we're obviously in the wrong or we're making a mistake because we're off by so much of an amount. Okay, it's highlighting that we're always off because in that entire sort of environment, right? You're out in the plane. There's ups and downs. There's all sorts of things. How much is that? Is there an allowance for that to allow while maintaining our numbers being within the bounds that we can expect? That's all it is.
Okay. Did you hear the first point that we made? Right. When you're landing the plane, you have to be at a correct angle while you landing the plane. You can't be too steep. That is the purpose of the beam in the first place. If you're below the beam, you come in, you descending, you're going too steep. You may crash, or if you're too high, or you're too high up above that angle, which means the pitch is too far up, you're going to fly past the run.
Well, I'm going to add this in real quick. I tagged 20 Cup, but if you need me to tag you, I can. So there was when I did a Google search, it said signal integrity. The ground equipment is designed and maintained to strict International Civil Aviation Organization, ICAO, and Federal Aviation Administration, FAA standards. For the ground equipment, the glide path angle must be adjusted to maintain a tolerance of 0.075 times the nominal glide slope angle. Example, for a 3-degree glide slope, the tolerance is plus or minus 0.225 degrees.
Perfect.
And then the point that I'm making is that it's a null point anyway, because none of that invokes a globe in its first instance. You're still measuring, you're still doing geometry, measuring angles, going or flying horizontal on a runway.
No, you're right. And I just want to make the statement real quick that the 0.225 degrees plus or minus, that's where the pilot's judgment comes into play. That's why they remove the computer error malfunction, and the pilot has to land the plane going into the landing. So again, it's not significant enough to throw a pilot into turmoil and say, "Oh my God, I can't land the plane."
Of course not. Or it wouldn't seem like that to me. Absolutely, yeah. So technically speaking, anywhere plus or minus 0.225 degrees, if they're within that range, they're doing it correctly. There's it's off by 2.225 degrees, or 0.225 degrees. So you can argue, they're in error by plus or minus 0.225 degrees, but it's tolerable, right? That's all I wanted to get at, because the term, it makes it so strict, that meaning insinuating that they can't deviate by 3 degrees at all, otherwise they're, quote, in error. It's like, yeah, that's why it's called a margin that's acceptable. That's all he was trying to point out. I'm not saying that the argument was very valid or was of any value on their side by going into this. There's probably more that we can speak of. I don't want to tangent off.
What he was trying to do? That they're flying the plane at a set elevation, and when they get into the glide slope, they're going to measure the distance to the airport.
Yeah.
The globe distance is one thing, the flat Earth distance is another. And what the bitch was is that the device is not precise enough to measure the distance.
Right.
Okay.
Right. So
and his citation was just nothing. Like the citation was an actual, like, hey, here's the equipment manufacturer says this is it. No, it was like some fucking goddamn manual. Or not even a manual, like I don't know, I have to pull it up, dude. But it was garbage. It was absolute garbage for a citation. It's not an acceptable citation. If you're going to talk about the limitations of equipment, you need to know what why is, like, what is the hardware or software reason that it's that precise? Is it because the wavelength? Is the precision based upon that? Because say you have 1 meter wavelength, that's the maximum resolution you can actually get, right? So is 1 meter, right? You can only be precise within 1 meter at a 1 meter wavelength. Like, obviously you can't have sub wavelength measurements. Anyway, that's not the point. The point is that citation was just like garbage, like from a brochure or something. I find it very hard that they can't measure a distance within 0.6. Was it 0.6 of a mile or 0.6 kilometers? Do you remember which one they said it was?
Yeah, I think it was a mile.
To me, I don't know, maybe I missed this. They got really far away from that part of the conversation, and they're now focusing on, like, basically what he does not know about FAA guidelines.
He became the topic. He became the topic, dude.
I remember that. They were digging into him like it was like the main show.
That was the show. That was the main show. Kate, I don't know why you guys that was the show. This show, there was one flat earther, 2 globe earthers, one obviously anti-flat earther for one of the globe earthers, and Shiva, who's pretending to be a globe earther or pretending to be neutral, which he's obviously not, right? Who's making running commentary, disparaging comments, baseless fucking claims, making up his own bullshit definitions, didn't do what he said he was going to do in the first place with 6 flat earthers, 6 globe earthers, flying them out to Cambridge. He didn't do any of that shit. Didn't have an ethics declaration. Didn't fucking have everybody in a room with a fucking whiteboard. He didn't do anything he said he was going to do. The whole purpose of that is it's the same thing. It's literally the same Duffy shtick. It's what all these guys do. Yeah. I'm going to have something. I'm going to invite flat earthers. And when the flat earthers join, I am going to make them a spectacle.
Yeah.
I'm going to try to make a spectacle out of them. And that's it. That's the whole purpose.
And yeah, because I thought, like, Dr. Shiva was one of the participants.
No, he's the one putting it on. He's supposed to be the neutral benefactor of the whole thing. So, Reg Joe, he had a interview with Dave. With Dave, he said, I'm going to have all the participants sign an ethics statement, an ethics declaration, saying they're not going to lie or do all sorts of stuff. I posted to Shiva on X. Are you going to sign the ethics declaration that the people participating have to sign? He blocked me. He blocked me as soon as I posted that shit. That should tell you everything.
That should tell you everything. Yeah, these guys do the same thing over and over again. And it's funny, Mattoon is always in the middle of it.
That's what I was saying earlier. I'm like, how does this dude end up injecting himself into everything?
Yeah, I noticed earlier on, I only watched maybe about 10 minutes before they started getting into the presentations. right? And maybe about 20 minutes or 30 minutes worth of that Kevin dude's presentation. I didn't watch the rest.
They only analyzed his. McToon said, we'll just do an observation of the sun.
Yeah.
And Shiva was like, yeah, that would be super easy. And that was it. That was the debate about that. That was over. And then the other dude said what he was going to do. That was not analyzed at all. She was just like, yep, we'll just go with that. But Kevin's was hyper analyzed.
I saw that was the first. That shit stuck out like a sore thumb to me, man. I was like, I asked myself, did they? Was it because they didn't grant time to scrutinize any of any of their points, or maybe it was delayed or delegated to later on, or just because nobody stood up to ask any questions that there wasn't any? I wasn't sure about that. You know, like if you guys saw the whole thing, maybe you can confirm.
The part?
Yeah, where he's like, "Oh, you just take an angle to the sun, and somebody else will take an angle."
He didn't even have that. He didn't even have the model or anything. Well, we'll make a model where you can look, or you can use a webcam, and you can look at the azimuth and elevation angle of the sun, and from anywhere on Earth. Oh man, that sounds great.
Yeah,
that's it, dude. That's trash, dude. That's trash.
It was like 2 minutes. It was like 2 minutes, and she was like, "Yeah, okay, no problem, thank you very much," and moves on. I was like, "What? No questions? Like, does nobody have any questions, or are they not allowing for it?" Like, I wasn't sure. I thought maybe they would open that up later on.
Who gave the most detailed presentation?
Kevin.
Yeah. Who got the most?
Kevin by far.
Kevin.
So I'm not even gonna lie. Like when I heard the thing, I just thought it was an opening statement, and then when they started laying into Kevin, I'm like, wait. I thought we were just like giving like a brief overlay of what was going on, and then once everybody got their thing out, then we would have the discussion, right?
That's what I thought. I thought everybody was going to present their thing on the table, what they wanted to do, and then they were going to go through them, which ones were feasible, which ones weren't, like how much time they would take, how much time they would cost, right? You get all because that's usually how you do it, right? You get all the proposals, and then you weed out the proposals, right? You go through each proposal one by one and critique them and analyze them, get cost benefits, whether it's dispositive of flat Earth versus globe. Because the McToon one and the other guys wanted or not, as soon as he said fucking there can be ducting, that means if he doesn't get a radar horizon, he can just say there's ducting. Right?
Yeah.
So you can't disprove the globe in his paradigm, because he said there can be ducting. Right, okay. So you think the radar horizon is supposed to be 30 miles. Okay. You got a detection at 100 miles. Well, that could be ducting. So when we measure no radar horizon, the blockage you say is there. Now you're going to invoke a special pleading weather condition that somehow allows the globe to be flat.
Yeah, it sounds like the fucking RF
Same thing every time, dude. Yeah, that's what it is. It's refraction in UHF, right? And he's like, there'd be no radar, there'd be no horizon on a flat Earth. Well, the horizon's not physical, and the properties that make a visual horizon on a flat Earth are the same things that would make a radio horizon on a globe. And because the wavelengths are longer, it's going to be further away. Because when you have, like, say the wavelength in UHF is like 1 meter to frickin' 100 meters between the wave peaks. So that's your resolution, depending on whatever the wavelength you're using. Visible light's in the nanometer wavelength. Right? Yeah. So if you do the simple formula for diffraction, the diffraction limit, the Rayleigh criteria, and you plug in the wavelength, okay, obviously you're going to have a horizon at a longer wavelength farther away. It's super simple, but he thinks the horizon, radar horizon, is a physical globe horizon. But within radar itself, right? They have subrefraction, they have refraction, they have super refraction, they have ducting, right? So no matter what your radio condition is. They have a meteorological condition that, so you start with the globe, right? Earth's a globe. And then if it goes 30 miles when it's supposed to go 10 miles, you have super refraction. If it goes 5 miles when it's supposed to go 20 miles, you have subrefraction. You don't really know if you do, but it has to be there because, Earth's a globe. And there has to be a weather condition that's stopping the radar from traveling. Because it can't be Earth curve, so it has to be something else. So we'll just invent a meteorological condition.
Like I said, I commend this dude for putting together a very nice presentation at the beginning before it got interrupted.
I was going to say, AKA circular reasoning.
Exactly. It's all it is. Globular reasoning, spherical reasoning, infinite circles.
Do you think anybody made any money off this? Like any of the people that are in this debate or the channel?
For sure.
Okay. Step outside. Oh, go ahead.
No, you're good, man. I'm going to speculate. I don't want to speculate.
Chris Stevens' channel, ain't it?
Yeah, McToon always has fools who will give him money.
McToon was broadcasting.
Like the way I view this, it's like a UFC fight. Like no matter who wins or what happens, like everybody's making money. And I think they're just doing this and they're just poking the flat earth bear over and over and seeing the reactions, that they're getting, and they're getting views. They're not serious. They're not being serious about this at all.
Well, no, the goal, like India said originally, was to just eventually get around to pointing out how flat earthers know nothing and then talk only about flat earthers.
That actually is an interesting question. Do y'all get, grifters and stuff often?
There's grifters everywhere, dude. It doesn't matter what it is.
The world is a grift.
Barbie dolls is grifters.
Everybody's trying to make a buck. Honestly, as much as the globe earthers make, I don't get mad at all when a flat earther wants to make $1. I really don't.
Yeah, but I'm really not sure that one. I mean, I know it was everywhere, man. Boy, at a time,
make some money.
All right, give me a second. I'll put it back on.
Yeah, my apologies for the long derailment there. I just wanted to hone in on something earlier there. Didn't mean to detract too much time.
Okay, do you believe in the other land? What?
No.
You didn't let me
Belief
finish.
requires right, but you said a key word right there, right at the very beginning. Do you believe? No, there is really no reason to believe anything unless you
don't
know
believe in
it.
anything?
No, I believe in I believe in like I told you, I have a theology that I kind of follow.
Okay,
But as
so I'm
far
asking
as
if you believe.
okay, very good. Sorry about that. I very much cut you off, and that was rude of me.
Okay. Do you believe do you believe in the possibility that on those land masses that wouldn't be documented, that there would be people living on them?
Man, It's a big old question. And the answer to that question would be, honestly, I'm not trying to be a douche or nothing. Yes, there could be, but I cannot prove it. So I would think that it'd be a Hollywood production. If they showed it to me, you know, it'd be like Jurassic Park or something. I'd be like, whoa, that made a lot of sense. Maybe I should believe that. There's no proof.
Do you believe that Australia exists?
Oh, of course. I know
Wow,
people.
here we go. Here we go. It's
I know
almost
people
time for you to take a triangle test if you don't think Australia believes, Glober.
Is Timbo down there? I think I see him. Timbo, are you from Australia? No, I know people from Australia. I know it.
Why do Globers all of a sudden think Australia doesn't exist?
Hold up, hold the fuck up. Hold on, hold on a minute. Timbo technically
Yesterday,
isn't
the
from Australia.
Globers
Sorry.
understood Australia was real. When they come in here, they think it's fake now.
I'm asking what you believe. I'm having a conversation. I don't know what you're implying, buddy, but can you relax?
Do you believe Finland exists?
Australia isn't a belief system, Goofy. Australia is not a belief system. You don't go to church.
Right, it's not about believing if Australia is
It's
there.
not-
I know people from Australia.
Why are you arguing about belief? I'm asking if you believe Australia exists as a flat earther, right? Like, what is your
Because
little
one
doctrine say
definition of the
about
word
it?
belief is acceptance without evidence.
No, you keep
That's
on
not
saying
what-
believe.
that's not
believe,
what flat
believe.
earth is
Belief
about.
requires. Yeah, no, belief
Right.
is not.
So,
what
do
we
you
do.
believe the Earth is flat?
No.
No, it's measured that way.
There's no requirement for
Why are
belief.
you so defensive? My goodness.
Just understand the words, dude.
I'm asking you polite questions, and I'm getting yelled at
Just
and called
understand
slurs.
the words. There's
We
no.
don't believe
What is he
it. We
talking?
don't believe that the Earth is flat. We don't believe the Earth is flat. I mean, that
No one's
requires
yelling, by the way.
religion.
No,
There's
no,
no
people did come in and raise their voice, and they did yell. That's not, I don't have to believe that because
That's
that
what we're trying to
happened.
tell you. That's what we're trying to tell you. We don't believe it. We know that the Earth is flat. We know it is. We've done the measurements. We've done all the stuff that you guys, most of the globe earthers, haven't done.
So, okay,
Oh, yeah.
you just have an aversion to the word belief. I see that, right? You know that the Earth is flat. You don't
I
believe
mean,
it.
no, we can
It's not
prove
an
it.
aversion, it's just using it correctly.
There's actual evidence that shows that the Earth is flat and that your globe has died.
I'm sure there is.
Maybe he
Right.
only believes he has parents. Maybe he doesn't know that. Maybe it's just a belief system for him. He goes in the closet and prays for parents.
See, that's the guy I'm talking about. That's being defensive.
No, it's
No,
pointing
that's the
out the
same thing,
difference
like-
between knowledge and belief. So
No,
I
no,
pointed
because
out
the
earlier,
way he's
some
wording it, he's
definitions of the
talking down
word
to me,
belief.
right?
My God. Some definitions of the word belief is acceptance without evidence. We're talking about things that you can know, which requires no belief. Like was pointed out, the analogy of your parents.
Right, or
Okay.
your birthday. Or your birthday.
Right. So you're throwing the word belief, like, because requirement, like you think you have a problem with the word belief. So you know the world, the Earth is flat, right? I'm sure not all flat Earthers agree on every single thing, right? Because there are flat Earthers that are out there that believe
I mean, you'll
Australia
get
doesn't
people
exist, right?
speculating. Yeah, you'll get
Right.
flat earthers
Yeah,
who
but you
know
get
that
people
the Earth is
speculating that,
measured
right?
flat, and you get them speculating about ice walls and other lands.
Right.
Right. So that's what I'm asking about. So when I ask if
things
you
which
believe,
things
if
which
you believe
determination of the Earth's. Hey, one sec, bro. Things that such as that are not related to us determining whether the Earth is flat or not.
Right.
Right. I just want to make that clear.
Right, which we believe that we've proven. No, we don't believe stuff. We see it, we measure it, we tell you that, man, that didn't make sense. We come back and say, hey, we measured the Earth and it didn't equate. That's not a belief. We actually did that. So we aren't believing nothing. But the thing about it is do you believe that there's an ice wall? Do you believe that there's a firmament or a dome over us? Or do you believe that there's containment here? Of course, yes.
Outer
we
lands.
do believe that
if I'm going to ask a question and inquire about,
no, we're talking
if I'm going
like
to
a
ask you
lot
a
of
question
other.
and inquire about what you think or know. Right?
It's not as a flat earther, bro. Listen, some of the things that flat earthers might speculate about are not exclusive to the Earth being a sphere or flat, right? So they're just ideas, right? So, because I could easily just as easily say all globers don't believe in the moon landing because some globers don't believe in it. So don't stereotype, please. It's not like you're not asking flat earthers what they believe about this and that. You're asking them how they know that the Earth is flat. That's what you should be asking flat earthers, because it's nothing else to do with anything.
Right, T-Dub, you nailed it there, because
that doesn't make sense to me. So, it doesn't make sense to me to word it when I'm asking you a question about something that I don't know, to ask whether or not you know that it is this or this.
I'm just letting you know. Okay, go ahead and ask another question, and I'll tell you whether that is related to our reasoning for the Earth being flat or not. And then we can just move away from that if it's not.
Well, okay, I understand. I understand.
He described it perfectly. So a lot of globe earthers that think that we're living on a spinning ball shooting through outer space or a globe, they don't believe that we landed on the moon. That doesn't make them a flat earther. That just thinks that we didn't land on the moon, right? Because of all
and I'm asking what you specifically, as a flat earther, believe, because some flat earthers would believe that, right? But you're saying it has nothing to do with flat Earth?
Well, I mean, I have my
what we had
beliefs.
for dinner as well.
Right, I have my beliefs. I mean, everybody has different beliefs. Like if I asked somebody in India what they believed, and is it different from what I believe, I'm sure I'll get a different answer. I mean, I have my beliefs. However, I have some knowledge too, some wisdom, some actual evidence that the Earth is not a spinning ball shooting through outer space. I have evidence that says that. So that's what I know. If you want to know what I know, I can tell you what I know. But if you want to know my beliefs, we can go into a different channel and I can tell you.
What would you say?
All of my beliefs.
What would you say about the flat earthers that say that they know that Australia doesn't?
We don't give a shit about flat earthers.
There aren't anyone. There aren't any. There aren't any.
Yelling.
There aren't any, bro. I'm letting you know there aren't any.
He's trying to make a point by raising his voice, but yeah, there aren't any. That's true.
Okay, first of all, the guy that's raising his voice, why are you raising your voice? Why are you so defensive?
Because you don't understand English.
Yeah,
I do understand English.
Oh my god, bro! What if you got conscripted? Jeez.
What if I got conscripted? I've come here to ask. I asked a simple question, and you're all yelling at me.
So just go for the Spitfire.
No, what we want to know is
tone policing.
The thing that we want to know is
because I'm not going to engage with people that are going to yell when I ask a simple, respectful question. If I'm going to ask you a respectful question, treat me with mutual respect.
Australia 5 minutes ago. I told you about Australia.
I'm not trolling. I'm not trolling. I wasn't in the call then. I joined now. This is my first interaction with flat earthers ever, by the way. So thank you for your rude introduction.
No,
I don't know why you're defensive and yelling.
This is the first time you've ever encountered any true flat earthers?
Yes, yes, ever, actually. So me coming and asking stupid questions and being berated for it is rude because I showed you mutual respect. Do you know what mutual respect is?
It won't work in here.
We want to know. We want to know.
Gaslighting's not going to work here.
I'm not gaslighting anybody.
The only thing that we
come across, friends. So you've come across a lot of information on the internet about flat earthers, but this is your first time actually speaking to flat earthers, right?
Yes, 100%.
So you're coming in with a lot of misconceptions, and the guys are jumping up and down because they want to solve these misconceptions for you. But ultimately, mate, welcome to the channel. It's good to have you. Please do feel free to ask your questions. We'll try to ask them as best as we can.
Right.
However,
that's all I've come to do is ask questions to find out what you know. Man, if you don't like the ones,
what's your question, mate?
So for the most part,
the question, the first one, the Australia one, right? Like that was my first question.
Kay, please, for a moment, let the guy speak. Thanks.
Okay, thanks.
So
Yep,
the
sorry,
Australia one. Right. So as far as I know, this was some weird claim that started coming along in around 2015 and 16, kind of attached to the flat Earth, saying that Australia was some kind of psyop or something. I don't know, sounded bloody ridiculous. But yeah, no real flat earther says that Australia doesn't exist. There are flat earthers in this call at the moment that are actually from Australia, and they'll definitely tell you in the background of didgeridoos and fucking kangaroos fighting that Australia definitely does exist. So there's a lot of shit on the internet, dude. You might have come to the right place.
Yeah. Okay. Perfect. That's fine. That's fine. I just wanted to understand what yous as this group of flat earthers believe. Oh no, right? Okay. That's a simple question. I don't know why everyone had to call me a glober and then like call me a troll.
You're a globe earther.
And yell. Well, I'd say I am. Yeah, 100%. But like you're using it in
I was trying to help you out. I was trying to let you know, what we're about. That it's not what you've seen on TikTok or anywhere else. Like, it's not all about ice walls and outer lands and domes and stuff like that. Right? Like,
we all started. We all started.
And Special K was trying to point that out to you as well. Like that, we're just here to talk about what we can actually go out into reality and verify for ourselves regarding what is claimed and presented to us from birth about our reality. That we live on a big spinning ball inside a solar system, inside a never-expanding void, right, of a vacuum of space, right? While we don't experience any of that. We don't. We just don't. You go outside, you don't experience that. It's quite contrary to your natural experience of everyday reality. Right. So then we go out and we look at the surface of water, large bodies of water, and we realize that it's not curving at any particular rate, which means it's just flat, which means it can't be what they're trying to tell us. They, as in academia, media, right? Just all this idea that you're on a big spinning ball in outer space, it can't be true. And that's what we're all about. We're not about presenting you an alternative cosmology where we explain how the sun and the moon work and why the stars doing what they do, or seasons necessarily, or any of the other things that the globe claims to have knowledge of, right? And is reliant upon the Earth being a big spinning ball in outer space. We're not here to replace it. We're just here to share the information that we have that tells us that empirically and objectively that it's not a spinning ball.
Okay, understandable. I respect that answer.
Right.
So I'd say I have a lot of misconceptions, and like I'm coming into talking. I want to talk to people that believe these things, right? Oh, know these things. The word like I'm going to struggle with that. Sorry, but
that's all right.
Obviously, I have a lot of misconceptions, and I want to talk to the people that know these things, right? So. And like understand why it's like that, and like what you think and what you attribute as scientific evidence and so on, right? So like, why? So is the basis of like flat Earth being the fact that you can't see curvature and like how it's measured, right?
Kind of,
so,
yeah, kinda.
Yeah. Right.
Yeah, you're on the right track. But yeah, no, we've all been there before. And here's the deal, like. You want to say that you want to understand it or whatever. Yeah. It's really not that hard. You have a globe, and they tell you how big it is and how wide it should be, and we went out there and tested it, and it's not that. So then everything else, whether it's the size of the sun or how far away the sun is or the moon and the landing on the moon or anything else, any of the pictures they show you from NASA or anything else, we went out and measured your claim and said that it wasn't real. Your claim sucked. I mean,
it's not by a little bit.
Not by a little bit. The claim of the globe sucked. And so here we are. We have no claims about anything else. We have claims that your globe sucked.
Okay.
So that's it.
Okay.
Yeah. Any other questions, man?
Do you what's your thoughts when it comes to well, he was talking about photos from space and so on, right? That kind of show the globe as a round object. Do you think that is all faked or something? Do you think it's doctored or what?
Okay, so we can go into the individual pieces of evidence that show the Earth to be a sphere in some kind of image, and we can look how the image was constructed. It's never really a photograph. Someone's taken a click image. But ultimately, it comes down to this. We've got to verify that image to be true, right? They showed that the surface of the Earth is curved. That means that we should measure that curvature over distance, especially over a distance of water, right? Where, according to the story, gravity pulls everything in towards the center of mass, so the surface, the water, will be curved upon its surface. When we go to measure that, we don't measure that claim in the picture that, say, NASA give us. So to verify that image, we should have to measure the Earth to test the claim to see if it is curving or not. Being as we don't measure any curvature, that picture that we've got from whoever can't be true.
I get what you're saying. Okay. Right. I understand that. I understand the logic. Okay.
The logic's pretty simple, dude. If we're told 70% of the surface of the Earth is water, and water is observed, measured, and then practically used as a horizontal reference datum, then the surface of the Earth is horizontal. Horizontal is contradictory to curved. So the Earth can't be a curved surface like a sphere.
Okay.
Right. So if you can grasp that or accept that without any religious or anything else, you can say that yep, no, they've proved it to me that that's true, then everything else falls apart. Like the solar system, everything, because the globe has to be this certain size in order for everything to work that they've ever taught you about the globe. So if we've proven that your globe has flaws to a 999 percentile, you have no proof of a spinning ball Earth, then everything else falls apart as well. So talking about anything else other than these measurements that can be made by you and me together, we could go out and do it. Measure this stuff and say, oh, where's the curve? And so I would straight up welcome anybody after they've done that to the flat Earth. I mean, it's flat. It's measured flat and everything else. So every other question that you have after this one, after we've figured out that it's not spinning, that it's not curving, that anything else is irrelevant. You could say, well, what about space or the sun or the moon or the stars? No, we want to come back to this measurement. We've measured it and it's flat. Welcome to Flat Earth.
Are the sun flat as well? Is the moon flat as well?
Is the sun and the moon flat? Now, we can't tell you that because we can't go to the moon and measure it. We can stand on the Earth and we can measure between point A and point B, and now you want to talk for me, that's fine.
Crying? Who's crying in here?
We did go to the moon.
Yeah.
So what are you talking about?
Belief's broken again.
All right, I got him. Never mind.
Thank you.
Wait,
yes, ma'am.
This flat Earth, what are your thoughts on the moon landing?
Quite a lot of us will suggest that the moon landings didn't take place in the way that we're told, right? Because the moon is supposed to be in orbit around the Earth, being a sphere. The Earth isn't a sphere, so already that story starts falling apart. We'd say that the moon landings kind of took place as to say, maybe add credence to the story of, look how far away we can go from the Earth, and when we turn around and look at it, it looks like a sphere. back to that claim again of an image being a sphere and we should be able to measure curvature, which we don't. So it looks like some kind of, on one hand, propaganda piece to add credence to the whole heliocentric solar system model, and two, some kind of technological flex by America, to scare the rest of the world, because all look at the Americans that are going to the moon now.
Right, yeah, understandable.
Amen.
This might be a
he
weird
nailed
one.
it right there.
This
He
might be a
nailed
weird
it.
question. I personally believe, do you remember that Katy Perry thing where when they were in space? I think that's fake. I think that's fake as fuck.
Yeah, man.
I don't know if that has. Do you think people going into space like that is like fake, or do you think it's like let's say like the space station? Or
Right. Okay. So I don't think Katy Perry and was it Blue Origin or whatever it is went high enough to mathematically see the curvature of the Earth. And you got to be at least or beyond the International Space Station, and it didn't go that high. We just seem to think. I say we. The public just seem to think that because the Earth's a sphere, you go high up, you're going to start to see the curvature of the Earth at 100,000 feet just in the stratosphere. That's not mathematically true. It's just I don't know, mate. I don't think this happened in the way that we're told, right? It's not a curved surface that we're going above.
Right.
Well, could the Earth be could it be round, but it be way too big to be able to measure it being?
No.
We're too small?
No, because that's a contradiction. He would measure over distance a rate of change of slope, no matter how big the slope is, right?
Right.
Now, it's fortunate, right, because we're told the radius value of the Earth, 3,959 miles, diameter twice that, and circumference 24,000 miles. This also gives us a rate of change of slope, right, of approximately 8 inches per mile squared. It also gives us a geometric horizon for an observer at altitude at 1.225 multiplied by the square root of the observer's height in feet. Just to keep that relative to, that's when you go to the beach and you see the horizon and you're 6 foot. The distance to the horizon, if you're on a sphere, is just under 3 miles away. So the consequences of the claim of the radius give us an Earth we should definitely observe curvature on, and we should definitely measure a rate of change of slope. Because over 10 miles at 66 foot of descent from horizontal, that's crazy.
Okay.
And that's what you always come back to. That right there. Whether you think Katy Perry went into space or nothing, you should always come back to what Jedi just said. The Earth is not a spinning ball according to what they told us it was, based on the measurements that we've taken. So go on with whatever else you want to think.
Okay. Well, I've never questioned it to be honest. It's not really.
Neither did we, dude.
Yeah.
That's like me 10, 11 years ago, back in 2015. I'm nearly 50 years old, dude, and I'd never questioned up until it got shown to me on the internet or somebody was talking about it. I thought it was a foregone conclusion that you didn't even need to question, right? So welcome to that club.
Yeah. Right. Okay. So, what about people sailing, circumnavigating the globe? Oh,
what about it?
What how can you sail from one place, right, and make it all the way around?
How do you end up where you started from?
Right.
Yeah.
Go in a circle. It's built into the word circumnavigation. If you're going to navigate east or west, you're going to do that around a pole. East and west are circles of direction around a center point. So for you to circumnavigate the Earth, you just went round in a circle around a pole. Call that pole north.
Okay.
Yeah. It's like walking to the mailbox. Walk down to the mail about less than a mile away. Walk down there and then come back around.
Someone's got some crazy feedback going on. So somebody got that microphone open.
I think it might be is it better now?
Yeah, it's better now, buddy. Yeah.
All right. Yeah, I know. If I walked to my mailbox and then I took the long way home, whatever, I just walked in a circle. back to my house. I went down to the mailbox, walked in a circle. Kind of a small scale example, but that's what they do. You start off and you go around and you come back to where you're from. It doesn't mean it's a globe. Doesn't mean it's a globe.
Or you could take your dog for a walk around the block in so many
Yeah,
ways. Yeah, something short like that.
Right?
Okay.
So yeah, it's not about going to the mailbox. It's about just walking in a circle. Walk in a circle. You can do it. I can do it in my living room. Start at the ceiling fan, walk around until you get back to the other side of the ceiling fan. Pretty easy.
Yeah. I see what you're saying.
That's
a lot of this stuff is pretty easy when you think about it. You just don't really think about it, like you said.
No, you
But
don't.
when you
Yeah,
do,
you don't.
it's quite simple.
Well, it's just like, why would they say it's a globe? Like, why would we have that conclusion? Be told to us if
We're
it's
going to have
not,
to
right?
figure out who they are, and then we're going to have to go ask them, and then we're going to have the problem of asking a liar why they've lied, if indeed that's what they've done. The best we can offer you, mate, is some kind of reasonable speculation. The word that gets brought up an awful lot is control. Now, it might seem weird, right? But if you control someone's perception of reality, what reality is, how it got here, how you got here, your purpose within that, then you've got a lot of control over people's perceptions, right? So that is one of the reasons I would suggest that they'd lied to you. It's control of your perception of reality. It might even go as far deep as your perception of God, even. I don't know, dude. It gets well deep after a while.
Yeah, for sure. Okay. Well, yeah. I mean, I genuinely just want to understand, like, why you, like, how all this stuff works. All right. I don't want to like take up all the time in the chat too if other people want to ask stuff.
No, you're teaching others as well. They're listening. They're listening and they're hearing what the questions that you have are the same questions that they have. They're listening. If they want to pipe in, they can, but usually they come in and say, Earth's a ball, Earth's the globe, or flat earthers are stupid. But no, with your questions, you're doing a very good job. I think that it's a good conversation. I don't think that you're off track in any way. You're very respectable. And Jedi, by the way, you're a freaking champion. You should change your name to Jedi Champion.
Armor as it is, mate. You're fine. Any other questions, Dave?
Yeah.
Well,
just go ahead.
If the Earth is flat, right? Where's like what about like the edge? Like how? Like what's the explanation?
Don't know.
Like have we never been? Don't know.
Yeah. I mean, me personally, mate. No, I definitely don't know. Right? No flat earther that I've known has experienced what is commonly called the edge, the limit to our environment, whatever that is. This is one of the reasons why no flat earther can actually make a claim to a shape of the Earth, because to figure out the limit, to figure out the shape, you're going to have to go to the edge, right, and then map that edge. Yeah, we can't do that. If someone has, they haven't turned around to us and told us, being as these people are possibly trying to tell us the Earth's a sphere, and this would be counteractive to that claim. So I don't know, dude, but I haven't experienced it, whatever that would be.
Okay. All right. I'm going to talk in like a hypothetical, right? Like hypothetically, Earth is flat, right? And there is an edge, right? Do you think that there would be, like, do you think it would, like, it obviously, do you think it would have been found by like governments? And like that's would be like, for example, like why you can't freely go somewhere like that, or like
maybe not.
Maybe
I mean,
not.
potentially. There's a lot of areas on the world that you can't freely traverse anyway. Right, you need special permissions to go. You know, even things like passport, but harbour masters, plan of route. Even if you're going to dangerous locations, you're going to need people to rescue you. Right, these places include north of the 60th parallel, north, and below the southern 60th parallel, the Arctic regions. Right. So again, areas to question, but it's kind of hard to freely traverse across the Earth. And for me to do it, I'm going to need an awful lot of finances and resources to do so. Even if I did have the plane, I'm going to need food and fuel to go on, which could be in potential of hundreds of thousands, if not millions of miles. I don't know.
Yeah. Okay. Right. Yeah. So like
it may be right. It may be right. It may be that certain individuals have been assigned to explore as far as they can, and reported back that if they were to attempt to go any further, they'd die. And like there could be ongoing investigation into exploring that, right? Rather than those extents, rather than to find an end, right? Like who knows, bro? I'm speculating here. Like just to be courteous with you for a moment, right? But in your hypothetical, right, I could envision like authorities that don't necessarily want the majority of the population to know their secrets, right? To know what they've discovered, conducting an ongoing investigation into, exploring just how far it does go, right? And that Antarctica, whatever that is, could be a hub, right? A base from which to continue to do that, right? Because even Globers will tell you and ask questions. Why is Antarctica so secretive? Like, and what is out there? And they describe its environment as being very deadly and harsh and inhospitable, right?
Right.
But look. I don't know. Like if I was younger and I'd come across this and I was I would be so curious. I would be out there. I would be attempting to explore all I possibly could, but I'm not. So it's going to be left to other generations if they intend to try it.
It's kind of hard to go to your tourist agency and get a flight to somewhere that we haven't been before, please. That's really hard to do. Always go to some known airport or something.
Understandable. Okay.
All exploration now is really highly regulated. I mean, there's regions, like whether it be on the ocean or on land, that are just so difficult. Like your access to it is none to very limited. And even some countries, in their areas that you go to, you have to be supervised. I mean, it's crazy, but that's true. So, who knows, bro? You said earlier, about is it possible that there's other lands that are unknown, upon which are populations which are to us unknown. And I'll tell you right now, even with our known land, there's people that nobody knows exist and isn't really held accountable for anything.
Yeah. I just think it's a cool that's a thought experiment that I thought was interesting. That's why I asked the question, right? Because if there is, and let's say the world is flat, and let's say it's super real big, right? And there's more stuff around the outside. There could be civilizations similar to ours, right? They could be asking the same thing, right? You know what I mean? It's interesting to think about. What's the thoughts then on global climate change, right? Because isn't that whole thing doesn't that hinge entirely on the world being a globe? Or no?
Is it?
I'd say so, right?
Can you repeat that, please?
Climate change, right? CO2 in the atmosphere getting trapped around the Earth, right? And melting the polar ice caps and so on. Wouldn't global warming hinge on the fact that the world is a globe? Or no? Am I wrong?
No, not necessarily, because this is just a system that we're living in, right? So in terms of physics, a closed system, and we know it has to be a closed system because there's certain amount of volume of gas that we can experience, right? And by laws of thermodynamics is dictated that must be a closed area, right? Like a volume, a defined volume, right, within which such a system could exist, right? Dynamic as it may be, so the only way that you could even have like problems with a climate would be by having that closed system, which is perfectly fine and in line with what we're talking about.
Okay.
All you need for a climate change problem, right, is the energy and the system, energy into the system, or that energy being increased or decreased would cause climate problems, and does as we experience seasons, right? That's climate change. Right there. It's funny how they take these terms that we should just be naturally accepting as being true because we experience them every day, right? And every year, and turning it into something that we should be fearful of. It's just crazy.
Yeah.
Right.
So could there be another explanation instead of the one that they told you? Always.
Well, understandable. Well, you brought up seasons, like
the sun.
I mean, I'm not like the sun. It would just be the sun.
Yeah, the sun does that. You notice in
Yeah,
the
but
summer it's higher in the sky and you see it for longer. In the winter it's lower in the sky and you see when it's summer for us in the north, it's winter for them in the south. That's for when it's high in the sky for us and we see it longer, it's lower in the sky for them and they see it. So really, it's the sun. We know the sun rises and sets on different locations on the horizon every day throughout the year. It's the sun that does that.
Okay.
It's observable.
Yeah.
Just to be clear, right? Because we didn't say that the Earth was a shape, just because you've come in with some misconceptions and stuff. We definitely don't say that the Earth is a disk. We don't say that the disk is rising upwards at 9.87 meters per second squared to cause the vector of downwards for gravity. We don't say that shit. We're also not the third disk from the sun, as in all of the planets, they are now disks because the Earth is a disk, everything's flat. No, we don't make that claim. It might be easier to understand that our claim is as simple as this. The Earth is flat and stationary under the sun, moon, and stars. That's pretty much what we observe. So the sun, moon, and stars, those are the things that are in motion. The Earth is flat and stationary underneath those things that are in motion. The size of the Earth, the shape of the Earth, we haven't got a clue.
Okay. Well, I was always under the assumption that flat Earth meant like the Earth would be a disk then. All right. Okay. Interesting.
No, we're not saying it's a disk. We're saying that it's measured flat. That's it.
The internet says it's a disc.
Oh, yeah,
TV says it's a disc. Memes say it's a disc. That's because they're all made by globalists.
If I think of any more questions, I'll come and ask them. Thank you for your time.
More than welcome, buddy. Join us anytime. Like I says, 24/7.
Thanks for coming. Very respectable. Loved it.
Guys, excuse me for interruption.
You can speak, buddy. Speak.
I don't believe that the Earth is flat.
Why?
Because why not?
Well, you see it. It looks flat, right?
No, like the sun and the moon.
Yeah, that's not the Earth.
They all have the square square, the cycle shape.
So?
The sun and the moon and stars.
Are those things the earth?
No, why should the earth be different than them?
Why should it be the same? You think the earth is like those things? Why?
Repeat?
If you think the earth is like the sun, the moon, and the stars, that they're the same thing, why do you think that? Can you think of anything that's the same? Are there people on the sun? Are there trees on the moon?
It is a good question to ask you as well.
Why do I think they're different? Hold on.
Yeah.
Got an ambulance. Yeah, so I think they're different because everything we observe is different. There's nothing the same. There's no water there. There's no people. There's no trees. There's no life. There's no plants. There's no animals. Nothing is the same. Like, why would I think it's the same?
Do you believe there's
Can you at least concede there's nothing the same that you can see in your life?
No. Do you see it's not the same in the religious perspective?
It's not the same in any perspective, other than a government cartoon, right? An image.
Are you religious, by the way?
I don't know really what that means. Do I believe in God? Yes.
Yeah.
Do I go to church? No. I don't go to mosque, church, synagogue. I don't go to any of those places. To me, religious means practice, right? You go there, you go to the mosque, church, synagogue, and you worship with a community. I don't think that's the same as believing in God. That's a different thing.
No, I mean, if you believe in God, this means, you know, that this very different perspective.
Yeah, and if you believe in man, that's a different perspective too, because that's the other side, right? Either you believe the words of God or you believe the words of men.
We all believe that this is different because of God Himself, like this specific design.
Well, if God says the earth is flat, but men say the earth is round, who do you believe? Do you believe men or God?
That God say earth is flat. Can you give me the source?
In the Bible, in the Christian Bible, well, in the Hebrew Bible too. In Job, it says that the earth is like clay. Hold on, listen. In Job, it says the earth is like clay pressed by a seal. And if you know what that is, when you press a seal into clay, it makes it flat. No one pressed pressed the seal into clay and made it into a ball. That'd be quite the trick.
So, is this move have any changes in our life, like whether it's flat or not?
I don't know. Go tell your family right now you're a flat earther. See what they say. Go in the other room. Go, Mom, I'm a flat earther. See what happens. See if it changes anything.
Yeah, exactly.
It'll change something. They'll think you're crazy. Right?
Yeah.
Okay. Why would they think you're crazy? One minute, you're not crazy. You say Earth is flat. Now you're crazy. Why? Just because you said those words? I think they're crazy. Look, when you go,
Convinced
look,
you to believe. Yeah.
I was already a globe earther. Okay, I believed in the globe for 50 years.
Excuse me, someone is asking for me.
Okay, no problem. I don't know why they ask us what would change our mind. We already changed our mind. Show me you can change your mind. Dumbest thing ever said. Flat earthers are closed-minded. We ain't so open-minded that our brains fell out.
Yeah, when the flat Earth started taking off in 2015, the first thing I did was look at all the evidence against flat Earth and found it incredibly lacking.
Me too. The very first thing I looked at was surveying, right? Like that's where the answer is. They're measuring the Earth. That's where the answer. They measured a globe. Turns out they never measured a globe. They took a bunch of measurements and put them on a globe, but they didn't measure the actual globe.
Yeah,
Because I know a lot about like 3D graphics and how you can take any flat plane and put it on any, wireframe model. I'm like, they're just taking a flat surface and wrapping it around a globe. And then Rob Simmons at the same time is saying, yeah, that's exactly what we do. I'm like, okay, they admitted it. Case closed.
Exactly. They got very clever at making things fit their model.
I got to figure out how to sell intellectual duct tape. Have you seen there's recently, I can't remember, it's like Danny something, I think his name is. It's a YouTube channel. He interviews Bart Sibrel and an Apollo astronaut at the same time together. They're sitting there talking about how it was impossible for a rocket to go to the moon, that they would need to put rockets into orbit to refuel the rocket to go to the moon because it would take too much fuel just to get into orbit. And they turn it to him, and he starts talking in the third person. Like, bro, I thought you went there. Like, what are you talking about?
Yeah, didn't they say that the rocket would have to be the size of the Empire State Building to make it to the moon?
Dude, it's like, yeah. And then it became 7 rockets and like 20 rockets and like all, like, I think they're like at 32 rockets or something now. You know that Smarter Everyday YouTube channel? That dude, like, said he did the calculation, it was like 27 rockets. Now, this guy believes in the moon landing, and his dad works at NASA. The wheels are falling off the moon hoax, man. I think that Apollo guy is going to meet an untimely demise, man, because he did not acquit himself for someone that said he went there. Because if I was there and I did something, people are like, well, it was impossible for you to do that. I'd be like, bro, I was there. I did it. Well, you can say it was impossible, but we did it. He wasn't even like that. He started talking in the third person. I'm like, what the? Like, bro, you were supposed to be, you should be telling us your experience, not talking about it in like some abstract way. It was very strange.
Yeah, I found it just strange that the one Apollo astronaut said, oh, we were just passengers. Really? Is that why you went through thousands of hours of training just to be passengers?
They're probably patient zero of MK Ultra.
Yeah, there's this dude on X who says, oh, the moon landing hoax theory collapses under its own weight. And he goes, there's no whistleblowers. I said, yeah, because the whistleblowers are dead. And that taught everybody else to keep their mouth shut.
Yeah, they're not whistleblowers. They're daisy pushers. They're pushing up daisies.
Yep. Like there should have been thousands of scientists who at the early 60s said going to the moon is impossible. But they decided getting research grants was more important.
It's also things like that get memory hold. Like you don't hear or see the books from that time from those people because those books don't remain published. They get pulled out of republishing, and so you end up with only like a sparse few copies here and there. And if you don't know, you don't know.
So I was listening to one of the Apollo detectives guy. He was talking about how he got into the moon hoax, and he read, I guess, one of the books, the moon hoax books, Dark Moon or something like that. And his dad was really sick, so every night he had to basically for 12 hours supervise his father and had to like be awake. He doesn't explain the circumstance, but he spent that entire time just downloading all the NASA images, all the NASA PDFs, and going through them, all the contractor documents, like everything, and highlighting all the reported problems that they said they had. And of course, there's thousands of them, right? And then going back and checking if any of them were ever fixed. And he was saying none of them were fixed. They didn't fix any problem that the contractors had in the development of any of the parts or pieces or technical problems. They just like, oh, we got this technical problem. It'll be okay. And just manufactured it anyway, allegedly.
It's the same even with the documentation. It's like they made the program, they made the LEM, and then somebody said, "Oh shit, we don't have a proposal for the LEM." So they quickly made one up that's only like 1,000 pages or something. He goes, but if you look at the scale of that project, typically a proposal should be anywhere from 25,000 to 50,000 pages.
Oh, I bet. Dude, that would be like a serious piece of technical machinery. Like every nut, bolt, rivet, everything we need to be hyper analyzed and then redesigned and then redesigned and redesigned probably like 5 times.
Yeah, especially when you're doing something new for the first time. You need documentation up the wazoo.
You know, and that's like Gem Panda's. His only argument for the moon landing is they couldn't have faked the paperwork. Well, they didn't fake enough paperwork. That's the problem.
Yep. And they never tested a rocket engine in a vacuum.
They never tested it outside of a vacuum.
Yeah. And they're not able to get the test vehicle to land itself on Earth, but they did it properly 6 times on the moon.
Yeah, I have a clip that's very apt for when you say the first moon landing astronauts were most likely MK Ultra victims. And here's a ex-CIA official and a judge basically confirming that.
When Alan Dulles brought in all the Nazi scientists and so forth, they went to 2 places. They went to CIA and they went to the National Aeronautics and Space Administration, which in our world we call it not a space agency. And as Kathy O'Brien has said so clearly, that's where the bulk of the mind control has been done.
It's pretty clear to me.
But look at how weird they act. They don't act like normal people. Dude, they're put out there as like superhumans, but they have to be like crazy autists. Because think, not only do they have to be like expert engineers, they're also expert pilots, they're also expert repairmen, they're also expert mechanics, and they're expert photographers, and they're like expert level everything.
Yeah, it's difficult enough to take a photograph with a film camera when you can see through the what you're looking at. But these guys had it mounted to their chests, and they only could push a button. They couldn't see anything else.
Oh, and you had, back with film, you had to know the light levels to adjust the exposure. So all of them are also exposed perfectly. Right, at just the right light level, turning a dial that they had no way to know what setting the dial was actually on.
Yeah, you set up the camera, then strapped it to your chest, and then you couldn't do anything with it other than press the button for the shutter. But the batteries worked perfectly in that vacuum and at those temperatures. The film worked properly, even though it was exposed to cosmic radiation. Just amazing, all this stuff.
But listen, they trained in the desert and took a bunch of photos that looked just like the fucking moon in the Arizona desert, training to use the camera, but not with spacesuits, but like with their regular stuff on. I think they trained for a little while in the suit, but that was like 6 hours of training. But that wouldn't be normal because the suits wouldn't be pressurized and they wouldn't have the weight on them, and there'd be a whole bunch of differences. You know, because you always train in an environment you're not actually going to be in, because that makes you better.
That's how that works. And how dare you question the intelligence of this man?
I'd go to the moon in a nanosecond. The problem is we don't have the technology to do that anymore. We used to, but we destroyed that technology, and it's a painful process to build it back again.
If you just watch NASA and listen to these people for a while, it's the whole glamour just wears off.
Dude, you saw what Feynman's opinion of them was. I swear to God, dude, they killed Feynman. They killed his ass. They gave him the same thing they gave Arafat. They fucking stuck some polonium under his desk and killed him. He was part of that shuttle stuff, and he died right after. He must have the proximity to him dying and him doing his report excoriating the impossibility of their numbers and him getting cancer. I don't know. It couldn't have been like a year or months. He probably already had cancer when he issued that report. And maybe they were trying to kill him before. He just didn't die quick enough.
Yeah, he worked on the Manhattan Project. How come the radiation there didn't kill him?
I have a short recording here from a lady at the World Economic Forum.
Becoming much more proactive. We own the science, and we think that the world, should know it, and the platforms themselves also do. But again, it's a huge challenge that I think all sectors of society need to be very active in.
Since we're just in silence, I'll play another small clip. This is from Brett Feinstein, for people who don't believe that there's a crisis within science.
We have a situation in which everybody sees the problems. And so when Sean does a 4-hour podcast, which I think maybe 3 hours I'd recommend to anybody, because Sean is one of the best explainers and also extremely good at mathematics and keeping true to actual physics in terms of his understanding. He then goes into this thing that there is no crisis in theoretical physics. And as one of my physics colleagues said last night, the first rule of Physics Fight Club is don't talk about the problems with Physics Fight Club. There's a self-evident crisis. I can show it to you numerically. Somehow, the idea is that a small number of people who are either at the top of the physics influencer pile, which is where I would put Sean, or at the top of the prestige pile in research, have held a view that is completely at odds with reality, whose key feature is the exclusion of different perspectives.
So I'm downloading the rocket clip. Well, I'm downloading the whole video, but I'm going to clip that clip out where they're talking about the number of rockets they would need to go to the moon. It's really good, and then we can play it.
Yeah, Grace, I picked up a moment ago, but I wasn't able to talk back. I really liked how you said that. That's dogma, not science.
I'll have that in just a moment.
If a GT and a half could lay out a life in a minute and a half, how many minutes would it take 6 GTs to lay out a dozen lies?
All right. Almost ready. Now, just background here. Who's talking? This is the Danny Jones Show. Charles Duke, former astronaut, U.S. Air Force officer, became the 10th and youngest person to walk on the moon, allegedly. Apollo 16 mission in 1972. And Bar Sabrell, filmmaker, who has written, directed, and produced films arguing the moon landings between 1979 and 1972 were staged by NASA under the control of the CIA. This is the first ever debate between an Apollo astronaut and a moon landing skeptic. So let's rock and mother roll. Now this is a clip. It's just talking. You'll figure it out. I don't want to poison the well.
When was this filmed?
Recently. This was done December 1st.
Wow, that's cool. Yeah, play it.
Is the botnet working?
I don't hear anything yet.
I can play it if you want.
Yeah, it's in the chat, dude. Just
saying it himself. There's not enough fuel to leave Earth.
Oh, there it goes.
Let's hear.
It is
Von Braun
commonly
saying that.
believed that men will fly directly from the Earth to the moon. But to do this, we would require a vehicle of such gigantic proportions that it would prove an economic impossibility. Calculations have been carefully worked out on the type of vehicle we would need for the nonstop flight from Earth to the moon and return. The figures speak for themselves mathematically. 3 rockets would be necessary, and each ship would be taller than the Empire State Building, 100 stories. Apollo rocket was about 30 stories, and weigh about 10 times the tonnage of the Queen Mary, or 800,000 tons times 3. The Saturn V weighed 2,500 tons. That's a difference of 30,000% times 3. Now go to clip 18 and you'll see that Elon Musk just said.
All right, Bart, pause. Where did you get that quote from?
It's from his book, Voyage to the Moon, written by Von Braun.
Is there a way we can find that quote on the internet?
Probably. I mean, we bought an old copy of his book.
Okay.
And it was written by him and quoted by him.
Okay.
So
if it's on the internet, Steve will find it.
What's the purpose of this discussion?
You don't know.
The purpose of this discussion is
that we didn't go to the moon.
Allegedly.
You're just
that's what I'm
proving
thinking
if you're acting like you don't know, it just proved that you're acting during the interview. So he's not the only one who said you need multiple fuel trips to go to the moon.
So Von Braun, he's saying Von Braun himself was quoted saying that the Apollo missions would need multiple fueled
3 rockets, each one 30,000% heavier than the Saturn V rocket.
Yeah.
And then Elon Musk said about 6 months ago, if you go to clip 18, he said the Starship, which is 3 stories taller than the Apollo rocket and with the boosters on the side, carries twice the fuel as the Apollo rocket. He says it will take 15 launches, or the equivalent of 30 Saturn V rockets, in order to leave Earth orbit. We even have a video clip of Von Braun saying everything, the best rocket he can build can only leave Earth orbit.
Let's play that clip. Let's play the clip of Von Braun from the horse's mouth. Let's get what he's saying. What clip number is that so Steve can find it?
What clip?
That one I didn't include, but
how can we find it?
Just go to Sabrel.com. It's one of the links of the book.
I don't understand this conversation.
Well, read this article.
We did it.
I understand that's your position, that you did it and you went and you walked on the moon and you brought back the moon rocks. But why would Von Braun say that it was impossible to get to the moon without multiple fuel trips?
I don't know. I never heard him say that.
Well, we got a video allegedly.
Okay.
Well, and look at
when did he say
the
that?
clip of Elon Musk.
I want to see the clip of Von Braun. Show us where to find the Von Braun clip. Let's stick to one thing.
Says he doesn't have it.
Well, if you go to Sabrel.com and then go to Moonman Links, look for the one that looks like old 1950s color. And there's one of Von Braun. I don't know what clip it is, but in the meantime, while you're doing that,
no, wait. You're getting too far ahead of yourself. We're here now. Where do we go?
Scroll down. Keep scrolling. Keep going. Keep going.
Maybe you can find it on YouTube. Maybe you can find it on YouTube or something.
Yeah, I decided not to bring it, but Von Braun says the largest rocket that we can build, it's with Disney Film, can only achieve Earth orbit. He says it word for word in a quote from my book. And now we have Elon Musk. If you go to the clip of D18, he's saying the very same thing. Look at D18. Read the headline and read the highlighted part.
Okay. This is a headline from spacepolicyonline.com. Okay. At least 15 Starship launches needed to execute the Artemis 3 lunar landing. SpaceX will need to launch at least 15 Starships to execute the Artemis 3 lunar landing, NASA said today. So NASA said. So SpaceX will need 15 Starships to execute it, says NASA.
Right. And
Starship
they
cannot
carry twice the fuel.
Starship cannot fly directly to the moon, but must refuel in Earth orbit before setting out for deep space.
Yeah, that's what the clip of Von Braun says that I didn't include, that you can go to the moon if you do multiple trips of fuel and ferry the fuel first. And now, you're going to love this next clip. Go to clip 19. This was said less than a year ago by a rocket scientist who works with NASA. And he says it's going to take possibly more than 15 trips of fuel in order to leave Earth orbit and go to the moon.
So we didn't do it. Is what you're saying?
I don't know why you
Go ahead,
keep
play it.
acting surprised.
Go ahead, play it.
You're just proving you're acting. You know, you came in here and reminded me of a phone call we had 20 years ago when I
Hang on,
said
pause it.
I have proof we didn't go to the moon when I found the footage.
So,
Might
okay,
be
who's this
some
guy?
Issues in how people communicate about it. Like there's some architecture problems that people are unwilling to talk about these days because of how they got there politically. And I was like, you know what? I just want to go say the thing that nobody's saying. So that's what I decided to do. Now, a lot of people I respect, when I was doing my research and asking these questions, they said, be careful, Destin. If you say certain things, this might change your relationship with NASA forever. And I thought about it and I decided, you know what? This is the truth. And this is what needs to be said.
I did not understand until this week when I really thought I was going to embarrass myself in front of you guys and then decided to further embarrass myself in front of you guys. I didn't realize that in order to get the human lander to the moon, we have to launch a bunch of additional rockets to tank up in low Earth orbit. I didn't know that. And I'm like, well, how many rockets do we have to do that with? And they're like, 6. And then I start, because
Who is this?
He's a rocket scientist building rockets for NASA.
What's his name?
I don't know.
That's would be important. to know.
That guy, he's a YouTuber. He has a channel called Smarter Every Day.
Smarter Every Day on YouTube.
Okay, so he's saying it's going to take multiple.
Let's finish playing the video.
Yeah.
I know people. I start calling people. I was like, dude, really, how many rockets is it? They're like, well, boil off. And okay, so I was like, some people are like, well, it's looking like 8. I was like, 8 rockets? We have to fire 8 rockets to fire 1 rocket to the moon? And then they're like, I mean, that's what they're saying, but it's probably more like 12. Really? And then I was like, you know, I'm an engineer. I know how to do this stuff. So I started to account for like nominal schedule slip and boil off. And this is how many rockets it's going to take to fuel up that thing to get it to the moon. I've done the math. If you had any questions.
I found the Von Braun clip. It's D17 there, Steve.
Okay.
Von Braun says the biggest rocket you can build can only achieve Earth orbit. You need multiple fuel trips to go to the moon.
Okay.
Says it on camera as well as in print.
All right. This will be good for Charlie to see. Charlie, watch this one.
Here to reveal a plan for a trip around the moon is the chief of the guided missile development at the United States Army's Redstone Arsenal, Dr. Werner von Braun.
A voyage around the moon must be made in 2 phases. A rocket ship taking off from the Earth's surface will use almost all the fuel it can carry just to attain a speed great enough to balance the pull of gravity. Unpowered, it will then keep circling the Earth in an orbit outside of the atmosphere. This is the first phase. However, if we can refuel the ship in this orbit with fuel brought up by cargo rocket ships, it can set out on the second phase, the trip around the moon and back.
So 3 people just said, Von Braun said it twice, that you have to make ferried fuel trips to have enough fuel to leave Earth orbit. You had him say it on camera, you had Elon Musk say it, and you had a rocket scientist building rockets for NASA saying it. He also said, I just discovered this, because he is taking the Apollo launches on faith. You know, my bank web page says that my money is backed by the faith in the United States government that kills their own presidents, kills their own soldiers, and fakes moon landings, right?
So, Charlie, what do you make of that video of Von Braun saying that you would need to refuel in Earth orbit to get all the way to the moon? And because it would take, he said it would take all the fuel in the rocket to get that orbit around the Earth, and then you would need to refuel again before going to the moon.
I've never heard that before. Actually, they built the Saturn V.
Yep.
And the Saturn V
Yeah, I clipped it there just because he just starts talking in the third person. He doesn't even know what to say.
Must be a challenge to know. I mean, what do you say? You know, you have all your handlers watching you and everything else, and so you can't say something wrong. What would you say? Other than
he didn't get the updated script, right? He was probably trained on a script back in the 1960s, and he stuck in the. Are you saying we went there? We didn't go there, and he just says that over and over again like an automaton.
This will be a
back
really
moon
good
rocks.
clip to present to the Globers, you know.
And you know, look, I'm not even going to spill the beans on the smarter everyday dude. I want them to start slandering him. Okay. His dad worked on the James Webb Telescope and has worked at NASA for something like 30, 40 years. This kid grew up mingling with these people. That's why he said, "Oh, I know a bunch of people." He does. They know him from like when he was a little boy. He's known these people. He's totally integrated into their culture.
That makes perfect sense, you know. You'd expect a backstory like that for, you know, the poster child of science to the youth on YouTube and
He's
stuff
also
like that.
the one. He's also the one that went around with Don Pettit and said, "What do you do if you get a leak?" He's the guy that asked him that question.
I thought that was Veritas or something like that.
No, it's smarter every day.
Was it? Is it the same dude? It's just
Yeah,
changed
he's
their
also
name?
the dude who showed the baffling behavior of the balloons.
I'm not aware of that. What, describe that to us.
It's when you put a helium balloon in a car and weight in the car. So one weight is hanging from the ceiling. The helium balloon is tied to the floor. When you accelerate, the weight goes backwards, but the balloon goes forwards.
Yeah,
That's weird, but there's actually an explanation to that. The explanation would be that the air in the car moves backwards, right, and pushes the balloon forwards.
Yeah, but it bunches up at the back, essentially.
I find that an acceptable answer. I mean, you don't have to, but I think it is. It's plausible. The only way to know what they should do is like put some smoke in the car, right? Colored smoke. See if that actually happens.
Yeah, that'd be interesting. Like I just don't think there's enough actual testing. There's too much like, well, I believe it might be something like this, and that's just where it ends.
Yeah, because there's the 0G planes. They got helium balloons in those, and when they go into 0G, the balloons go to the floor, which I thought was crazy. Like I'm like the air thing doesn't even explain that because they're in free fall. They're in neutral. They're not even. They can't be. They're not. Well, I guess they would be accelerating technically.
Could I comment on something regarding the clip?
Oh yeah, not
just quickly.
I played it for comment.
Indio, do you have the source for that? So I want to put it in my Flat Earth Central server in the library there.
Did you? Yeah. Do you want the YouTube link?
Yeah, something like that. That'd be good.
I'll DM it to you.
Yeah,
this was
awesome.
done on December 1st, so
awesome.
Yeah, this was very recent. This was the actual astronaut versus who was he against?
Bart Sabro.
Yeah, I wanted to say it was him, but I wasn't entirely sure.
I'm not even a big fan of Bart Sabro. I think he does say stuff that actually he can't back up sometimes. This is
Well,
not one of those things.
At least he substantiated everything in that clip there, and that's pretty damning by itself. But what I wanted to comment on, but I need clarification, is when he started speaking about the rocket engineer at NASA just finding out that it's going to take like 6 rockets, and kind of his is like, how do you just find out something like that? You know what I mean? Wouldn't your head be in all them numbers every day, all day? How does that just like blindside you? I think that was pretty telling in itself.
Dude, he's at a debate about the fake moon landing, and he's like, "What do you mean you're saying we didn't go there?" Like 3 times. Like, dude, are you senile? Like, fucking, didn't you read your email? Like, how did you get here? Like, like, where am I going? Going to a debate. What are we debating? You're not going to the moon landing. Gets there. What are we debating? Like, come on, bro. I mean, seriously. His responses. Like Bart Brown didn't even have to say anything about the rockets. Like, just the response. Hey, people said you didn't go to the moon, and then he starts talking in third person. Like, that's cuckoo for Cocoa Puffs, man.
Yeah, I mean, we talk about handlers and all this, but like, handlers put him in this position. Sure.
Look, bro, if I said, "Hey, man, what'd you cook for breakfast?" and you started talking about how frying pans work, right? Like, I'd be like, "What? Like, apparently you didn't have breakfast, or you lost your mind." Right? Well, frying pans go on top of the stove, and they get heated up, and occasionally eggs are broken. Like, yeah, I want to know what you cook for breakfast. Like, I didn't need a freaking. It's great. Nobody does that. No, like, only psychos talk like that.
You sure it's not early onset dementia or something?
I mean, I guess it could be, but
not maybe early onset, but early stages of dementia. I mean,
yeah, I clipped out that one part. They also go over the radiation. They go over the moon rocks. They go over a bunch of other stuff. But the only part I heard was that one part. David Banner, he's a flat earther. He's a British flat earther. He like live streams on Saturday, and he was playing that, and I'm like, holy shit, dude, this is gold.
Sure, yeah. I wonder what the end game of putting these things out to the public is, though. Like putting these astronauts in this position, you know, because they're just like, I wonder if they're trying to create like a soft landing environment to finally admit, yeah, the original moon landings were bullshit, right?
Well, you also got to think about,
right? We're going for real now with Artemis and all that.
Yeah. Well, I mean, think about it though. The people that ran that, right? So say it's a secret compartmentalized, like super secret compartmentalized, right? There's only a few people that know. If you have a couple deaths, now people don't, like, what if his handlers died? And his handlers were like freaking 90 years old. You know what I mean? How did they pass the torch? Maybe he just outlived the people that were in the program. And there are no handlers, and he's stuck in his Manchurian Candidate mind control loop. Poor guy.
Yeah, something like that.
No one said the word that gets me out of it. I'm stuck in the fucking loop.
Oh man, what a story it would be to truly find out the goings-ons behind all this stuff, you know? The God's Eye view.
That'd actually be a good book. You could probably write that book. Dude is brainwashed, but he's still conscious. But the MK Ultra programming's got him like in a hypnotic loop, and he's aware of it, and he can't get out until someone says the freaking trigger word, that releases him, and all his handlers died. He's just being tortured. He wants to tell everybody that the moon landing's fake, but he can't.
Have you seen The Irishman? Yeah. The
movie? Yeah.
Yeah. You know, right at the end when De Niro, he's old, he's done, right? And the FBI agents are there. It's like, who are you fucking protecting? Everybody's dead.
Yeah, that's funny. That's why, it has to be related to bloodlines. There's no way that this power structure can last for so long if it's not passed through bloodlines. It has to be. How else could it continue? Because all the people, all the dirty people, right at the top, the elites, they all die off. And unless they're passing it through some hereditary or they're anointing successors, right? How can it continue?
Yeah, it's actually it's bloodlines, and it's the esoteric structure of their differences.
Oh, like initiates, right? Oh, yeah.
And so that maintains the structure, prepares the next generation, and then the bloodline kind of use nepotism to keep each other on the top of the pile.
In any other words, it's called inheritance.
You think the people that came up with the idea of faking the moon landing, did they not think that they were going to get caught, or did they think either they thought getting caught didn't matter, which it probably doesn't, right? Even if they came out and said, "Yeah, we faked it," everybody like, "It's okay. It was the Cold War. We understand." Everybody would do that. Everyone would do that shit, especially the boomers.
I think what I think's best and most fair to say is that is kind of human nature, that most humans are members of the Church of what's happening now. So once they tell the audience to unplug chip A from their brain and plug in chip B, they've forgotten what they've been told while chip A was in.
Yeah.
Well, the Ukraine war is almost over, so what do you think's next?
I'm not sure, but I think they're pretty convinced that they're going to be fine as long as they just stretch out any accountability until you're dead. And you see that happening all the time. People get protected. Like Epstein didn't traffic to anyone but himself, apparently, according to Cass Patel. But after those people grow a little bit older, you'll get 10, 20 years, you'll get oh, these people did bad stuff, brr, brr, brr. And that'll be used as justification for other things. But it's in the now, you generally don't get anything. So there was heavy pushback against alternative thought back in the day. You were painted as crazy and put in an insane asylum.
Back during our current president's first term, there was this thing going around where he had supposedly saluted a North Korean general. And of course, that's how it looked in the picture. And what he was doing is he was returning a salute while a big number of them were all kind of saluting each other and stuff. And, there are still people that talk about him just as if he just walked up to a North Korean general of some sort and saluted him, even though it's been long debunked. And that's how, once you've told the lie and it's accepted, most people will never let go of that lie. So I would suspect, I just, maybe in the grand scheme of things, maybe the truth is the moon landing is one of the least, maybe it's actually one of the smaller gigs that they've pulled off. I certainly wouldn't be surprised that, because they pulled off some big ones.
Yeah, but I think you're probably right. It's the smallest, but it's like the shiniest. You know what I mean? It's the most audacious.
Yeah,
It's crazy. Like, it's a crazy claim, dude. You got to think those things up there, those little dots. We went to one.
Yeah, it's also it's we conquered the heavens, is what they're saying.
Yeah, it's certainly just a recreation of the Tower of Babel. There's no doubt about it. But I mean, what's more audacious, saying that they went up to a rock in the sky, or believing in the indestructible passports? I mean, to me, the indestructible passports is far more audacious.
Well, the government can violate physics whenever they want. So
Worse was the building that collapsed despite having almost no fires.
Yeah, I had a friend of mine. He was all angry a couple years after that happened. And I mean, he was furious because there were some people sitting in a restaurant talking about how maybe that didn't go according to what the news told him. And I told my friend, I said, I'll tell you what. I said, go home. When you get home, just go search for number 7 and tell me what came up there. Just go on YouTube and just search number 7. And he didn't call me for a week. And then finally, he called me out of the blue that next Sunday, and just talking like nothing happened. And I said, hey, I didn't hear from you all week. I knew you were busy, but did you look up what I asked you to? And he said, yeah. He said, those people at that restaurant were right. That was all a hoax. And he started spouting off stuff that I had not even heard. And he said, yeah, that's why you've not heard from me in a week. He said, I've been watching these videos for a week.
it's pretty audacious to claim that no one in Washington, D.C. saw a fully loaded commercial airliner do a freaking corkscrew dive into the Pentagon, nor did any of the 200 cameras surrounding the Pentagon. They all missed it too. That's pretty audacious.
There they had these wonderful indestructible
and no debris. I forgot that the Pentagon. It automatically just eats metal debris.
Yeah, even the engines disappeared.
Yeah, and there were these indestructible wooden wire spools there. Just unbelievable. I mean,
now I'm going to play devil's advocate for a second. Should the government respect people that gullible? Shouldn't they just treat them like a bunch of fucking idiots if they're going to be that stupid?
I think you have your answer.
I've said this before, yeah.
Your question is your answer.
I mean, why are we whining about it? Maybe they deserve it.
You know, you've all probably heard me on my little tirade, and since this is Speculation Sunday, I'll give it again. You know, if somebody's not ready to go through a door or go past a gate, you know, maybe it's best that we don't try to drag them through a door or a gate they're not ready for. If they're that gullible, that means they're not ready to go to the next gate. Just maybe it's just what they need.
Well, that's what I think about like 80% of the people that come in here, They're just chilling, hanging out in whatever kind of arbitrary other channel that's, challenging nothing fundamentally. It's all day-to-day stuff. And then they pop in here and have, everything shattered in one go, right? They're not ready for that.
No doubt, and in a moral sense, if you drag somebody through a door or a gate to somewhere that they're not ready to be, like it or not, you're kind of responsible for their condition to an extent. So my kind of theory is maybe it's best that we keep that in mind. Maybe throw out a few breadcrumbs so they can come back when they are ready.
Yeah, I used to say something along them lines. Say, if you're kind of involved in burning someone's house down in any way, you should probably be responsible in helping rebuild it too. But I don't care at this point. Like, the world is going way too fucked, way too fast. I don't have the time to be rebuilding these guys' houses.
Yeah, that's kind of my point. In that case, just don't light the match and let them leave a few breadcrumbs so they light the match themselves, I guess. But
now, I guess my opinion's changed on it because, like, realizing the reality of the world is not that fucking terrifying. Just grow a set, We're coddling these people with that kind of thinking,
Well, but also we don't also know what their mental situation is. We don't know what world they live in. Like, for instance, if they've got a kid, if it's a kid of some sort that's 16, 17, or 18, and they've got a parent like Brenda, what could possibly happen? We don't always know what happens on the other end of the Discord line. That's the only.
But I mean, that's minutiae that you'll just never be able to account for, and you'll just be endlessly tripping over yourself trying to, walk on eggshells, essentially.
Well, I don't think we need to walk on eggshells. I just think that, like, the moment somebody starts to break down or something like that, rather than keeping them in the spiral, just, hey, sorry, it sounds like this conversation is not ready for you. Come back to us tomorrow. Come back to us another day when you're a little more reflected. Adios.
Yeah,
pal.
I agree with that. I fully agree with that. That we should invite people to leave far more often, or even just turn our back on them and move to someone else instead of constantly pestering. One flat earther leaves, another flat earther comes in and has their hours time with them, That type of stuff I agree with.
Yeah, 100%. Yeah. I mean, I'm not, now don't get me wrong, I'm not for mollycoddling somebody, but if somebody can't handle the conversation for whatever, or we get the idea that something ain't right, it is best to move on. But regardless, I just find it interesting that the stuff that people will believe, like, once upon a time, they told pregnant mothers, oh, take this thalidomide, it'll be good for you. They did all kinds of stuff, all kinds of health and science scams out there that they pull off. Sometimes I wonder if they gave us the moon landing so it keeps us busy and not focusing on the really important stuff. Not that the moon landing's not important, but just, there's so many other brilliant scams that they pull on us just right in front of us. And most people aren't ever any the wiser.
Yeah, it's no doubt that they put stuff out there. We just go back and forth on and waste our times while they just get on with what they're doing. That's why I think, Glober's really react the way they do to Flat Earth, because the book opens and the book actually closes in this topic. Every other topic, right? Because I believe everybody, believes in some conspiracy of some level. Even these Globers that would deny it. I mean, they are conspiracy theorists fundamentally, because they spend all day claiming this or that about the opposite political party, conspiring against their interests, yada yada. They are conspiracy theorists. So, but with this topic, it's like, yeah, the ground measures flat, and that is that. And that's uncomfortable.
Yeah, no doubt. It's interesting. I was in talking about Washington D.C. I was in Washington D.C. last month, and so I used to not. I didn't actually ever live there, but I practically lived there. I spent a good number of weeks in 2000 and a good number of weeks in 2001, and then in 2002, just northeast of Washington D.C. And so I was having some interesting talks with a couple people. One guy, he's the public relations director of a industry group based there. And so we were talking about the supposed National Guard there. And he was like, said, I kept seeing this stuff in the news, and he's like, they're showing these neighborhoods to where the National Guard is. And he's like, not only are those the wrong neighborhoods, he's like, what's reported in the news about living here is nearly always wrong. And so I get on the subway to catch the bus and see how it's perfectly clean. Everybody looking at me saying, yes, sir, no, sir. Extremely polite. And it becomes very clear that maybe the biggest scams that they pull on us are the ones right in front of our faces that we could go verify if we wanted, but very few people ever will. He was just of the bend that, it makes for good news theater, infotainment theater, that gives them good screen time. Because then you have some news stations talking about, oh my God, it's so dangerous, they bring up the National Guard. And then you've got others showing, why is the National Guard coming into these neighborhoods? And so it's certainly an interesting sign of our times.
I don't know, man, because I'm not going to speak for him, but for me, the AE map is broken as well. I share that with him, but I have
it works for its purpose. It's not broken for its purpose. It works for its purpose.
For its purpose, yes, but as a representative of the true world, I think
he wasn't trying to do that. Gleason's wasn't trying to make a photograph of the world, dude.
I understand.
Or a drawing of it.
And I'm not speaking to what its original purpose was. It's just that flat earthers, a lot of flat earthers, at least before, proposed that the world was like that. The flat world is such that you have a central north and a southern ring all around. And I think that has been broken by real world.
Why they said that? Why they did that? Why they invested on the Gleason's map? It wasn't because of the evidence or anything like that. It's because they felt compelled to have an explanation for everything. Because, the shtick. Explain this, explain that, explain this everything. And they thought they had to replace every element of the globe with some flat earth version of it.
Mm-hmm. But my point is, any kind of map that you can, conceive is broken without wraparound. There is no quadrupole, dipole, Gleason, whatever it is. None of them stand like the observations that have been,
Mobius strip, bro.
Yeah.
You know what a Mobius strip is?
Yeah, I do, of course.
Yeah. So you just flip around.
But
right?
I haven't seen a map that's a Mobius strip yet.
Well, I mean, I'm sure there's some topological frickin' space that frickin' Klein, what do they call it? Klein bottle or something. There's all sorts of weird topologies and shit that could work. I'm sure. Probably infinite number. I mean, that's why I said it's like, as far as you don't know, it can't work, but like, I'm not an expert in fucking topology and differential geometry. I know a little bit of differential geometry, but I'm not an expert in topology. There's some weird shit in topology that they do. They're like, that's a whole branch of fucking mathematics. Now think about that. There's a whole branch of mathematics just dedicated to the surfaces of shit.
Mhm.
That's crazy, dude. How can surfaces even be that complex where it should have a whole branch of mathematics? That's why when people say, hey, the surface of the earth has to be this or that, I know how complex topology is, and I'm like, maybe. What can I?
Yeah.
You know, there's probably some freaking goddamn Japanese nerd writing a 900-page fucking paper on how fucking weird topologies can actually exist.
Yeah.
Some
Like the
27
age-old question:
dimensional
is the surface of the sphere 3D or 2D?
I mean, I just don't even presuppose reality works that way. Like I think we got everything backwards. I'm just starting to reach the conclusion that we just got it all backwards. Dude. The whole idea that reality is like a blueprint drawing. That's how reality really is that it's like an engineering drawing, draw blueprints, build things, build houses. And that's a better representation of reality than how we actually experience the world in the observer-centric sense. They're projective and we see out and everything seems to be in our own experience relative to us. That is actually the way it actually is. And that we're like, well, fucking reality can't compute the fucking the observer effect for 9 billion people. Oh no, we can't compute that. Doesn't mean reality can't compute that.
Mm-hmm. So for the record, if you were to imagine, like, theoretically, people from like somewhere in the north all going in different directions, traveling in straight lines, different directions, do you think that they would eventually meet up?
I don't know.
Like, do you think
probably not.
I think they would.
Well, if they said, hey, we're all going to walk toward Polaris, they probably will meet up.
No, I'm saying they're traveling like opposite directions from Polaris, for instance.
Well, they're going to lose sight of Polaris eventually.
They're going to what? Yeah, they're going to lose sight of Polaris. And I'm saying I'm confident
maintain
that
their direction or orientation after that.
Well, let's just say theoretically they're dead reckoning or going in straight lines or what have you. Theoretically, right?
Go realm. I don't think that they would meet up, dude. I don't think there's a South Pole.
See, that's what I'm saying. Like, I'm confident that they're traveling on a flat Earth, and still they will meet up at the South Pole. You know, like.
I mean, do you need fucking money, man? You want to go ask fucking Alex Jones? He wanted to do an Antarctica thing. I think these directions are fucking arbitrary, and I think they're just based upon some coordinate system we choose. And I think if a bunch of people agree there's a point and we're going to call it, and everybody walks towards that point in the sky, they will meet up. But when they're separated, that point, their orientation relative to that point, what that actually is, geometrically outside of everything, know if that's even knowable.
Okay, so given that there is some sort of uncertainty depending, like on the GP of the sun, for instance, on the equinox, you wouldn't say that
I don't
the
believe
path
in
of
the
the sun.
equinox percent, dude. What are you talking about?
What?
I don't believe in the equinox, dude.
You don't
There
believe
is
that?
no
Well,
equinox.
what do you mean? The sun rises in the east, sets in the west. You know, like exactly.
Equinox means equal day and night. There's no place on Earth that has equal day and night. Ever.
Well, I didn't know that. I just know that
Well,
equinox.
that's what
is
I mean,
like,
equinox, right? Equal night. Nox means night. So
I guess, yeah.
Yeah, so
Never thought about that, but
at the on
like
the
it's still
equinox,
east
at
to
the
west, right?
equator, and equator means place where fucking there's 50% day and night on the equinox, right? So they both reinforce each other, right? So you got the phenomenon, which is the equinox, and then you got the location where that phenomenon happens would be the equator. The phenomenon doesn't happen, so that location can't exist. You understand?
What about the
location where that phenomenon happens?
Okay, I wasn't aware of the phenomenon, like it being equal day and night, but it makes sense etymologically. My point is,
Yeah.
as far as I know,
Well,
the
I'm not
equinox
trying
is
to make an
sun.
etymological argument. I'm just saying, even geometrically, like that should happen geometrically, but it actually doesn't happen in reality.
So in reality, it doesn't actually rise due east and set due west.
No, it's not 50-50 is what I'm saying.
Yeah, forget that. But I'm saying in terms of the azimuth, does it rise due east and set due west?
Yeah,
Basically, what I'm asking is,
I
do
don't
you
know
think?
if it's exact. I don't know if it's exact.
Okay, but I think we can
But you're
agree that it's not going to be
into another
zigzagging.
problem. Percent. The equator, the east is defined as the direction the sun rises on the equinox. So you're in a definitional problem. Like, yeah, does the sun rise east on the equinox? Yeah, of course, because that's how we define what east is.
Okay, well, forget
No,
that
we
it's
run
east,
into this problem
then.
where these are all like definitional problems where we set up this whole fucking thing with these words, and it's like saying the sun rises east on the equinox. That's almost like saying the same thing twice.
Okay, fine. Forget that it's east. Can we agree that on like at least on that day or whatever, that the sun's rising and setting are are exact opposites in terms of the azimuth?
As far as I know, that's what happens.
Okay.
So I don't have any direct evidence.
And I think we can both agree that the path isn't like
For
a
the
shadow of
purpose
the
of this
sun or what
conversation,
have you.
I'll say yes, it happens.
All right. And I think we both agree that the shadow of the sun isn't like zigzagging. It's not like some weird irregular path.
Yeah,
It's consistent.
yeah.
Okay.
I'll just
So
say
the
it goes
question
in a
is,
straight line. It doesn't take an arc, a visible arc.
all right, you think it's a straight line?
Yeah, east-west, right? Rises
Yeah.
90 and sets 180. So that should be a straight line to you from your visual perspective, right?
Okay, but like let's say we had a bird's eye view, it could still be curving and rising due east, or like not necessarily east, but polar opposites. It could go 180 degrees, but still be a
Yeah,
curved
but what I
path,
mean that it's a
right?
line, right? So if you were looking east, you'd watch the sunrise. It would rise in a straight line. Then once it got overhead, you have to turn around, and it would set in a straight line, right?
Yeah.
It would drop. From
My point is like it would help us to know whether or not it's actually straight line or a curved line in terms of making the map. Because if it's a straight line, then like the Gleason's is out. Anything with a curved equator would be out. You understand? If it's a curved line, then the type of Mercator, anything with straight latitudes, at least for the equator, would be out. You understand? Like the dipole model, for instance.
I understand. Well, how do we determine which one it is?
I think it moves straight. I think if I was thinking like one way you could do it is by stitching together like equatorial mounts that just travel on one axis, and they have like the sun perfectly in the center of the field of view, and they're tracking the sun's movement. And as one mount loses sight of the sun, the other one catches it, and they're just like stitched together for a large portion, or like a long distance, and that would confirm that it's straight-ish.
Yes, that might work.
The other way would
I
be
want to
dead
see someone
reckoning.
fly under the sun at 1,040 miles per hour in like a F-14, right? And just keep the sun at zenith. Like, look at your speed, 1,040 miles per hour. Sun's right over your head. Just fly that for a while.
No, but you could still be flying in a very slight curve if that's the case.
Yeah. No, I just like to. No, I would just like to see to verify the speed of the sun. That's what I'm talking about.
Got you.
Because I've seen some stuff on like how fast the subsolar point moves over the surface of the Earth that didn't even match itself, much less the globe model. Meaning, these people, they did a tropic measurement, Kahana noon, right?
Mm-hmm.
When there's no shadow. So when the sun is going right along the tropics, they found 2 locations on the tropics, and timed when it was Kahana noon in one spot, and then how long it took it to be Kahana noon in another spot on the tropic. They did this at 2 locations. And the speed at which it traveled the subsolar point over the surface, according to the globe surface distance, didn't match. They didn't match each other.
Yeah.
And it was like way off. It wasn't even fucking close.
So it can't be something like attributed to topography, for instance. It was way off.
It was off by like why would topography have to do? You're only measuring noon. The time difference between noon in one place and noon in the other place.
Well, I was thinking like it was the transition that they're measuring the speed of the shadow moving or what have you. Because if that's the case, like,
why do we not see the shadow? Right now, Kahana's noon. We don't mark the time. We have a place that's along the tropic, frickin' say 10 kilometers away. Now, when you mark the time, it should not. You should be able to see a shadow on that stick. And then when that stick eventually shows no shadow, it's solar noon there. Mark the time. Now you can calculate based on that 10-kilometer distance how fast the sun moved from being above one stick to the other stick, right? And then you can calculate how fast the sun moved across the surface of the Earth. Now they did that in Hawaii and another place, and it turned out that one was different by a lot. I want to say like one showed like a surface speed of like 700 miles per hour, and the other was like 1,300 miles per hour. It was something like that. Don't quote me on any of this because I don't remember the figures off the top of my head, but it was significantly different. Significantly, like this don't even make sense. But it should be like identical. The miles per hour should be identical.
It should be, yeah. What's the Glober like excuse for it? Do you know?
Well, no, I've actually never showed it to any Globers. The guy that did it, he's like a fucking Russian guy.
I feel like that would be a proof against the globe right there. I thought initially what you were talking about was that like they actually tracked the shadow of the sun, and they noticed that overland, some places it was speeding up, and overland it was slowing down. That's why I was saying maybe topography, because if it's going up a hill, for instance, you'd expect it to be moving slower, and then as it goes downhill, it would be going quicker. That's what I thought you meant initially.
His name's Sergei Mastubov. I don't know where he found the kid in Hawaii. He doesn't even say what his name is. They just were like live streaming it. They were like constantly live streaming it. And this was done a while back. This is I could probably find the video somewhere.
But how would that work on a flat Earth too?
I don't know. It's just
like unless there's some atmospheric magnification going on.
Well, the problem is that we have preconceived notions about what the sun's doing, which aren't correct.
Yeah, we know next to nothing.
Yeah, like Dave made a model. They don't check this shit. You think they checked if the sun's moving over the surface of the Earth at 1,040 miles per hour at the equator? Of course not. They never checked. This is what happens when you can construct a world which most of the elements of it are based upon a calculation. Like you have like a few data points of different things here and there, and then you construct this whole fucking thing out of calculations. And then you make claims like, well, if the sun's moving at 15 degrees per hour up the sky, and the Earth is a globe of 25,000 miles circumference, then the sun has to be moving over the surface of the Earth at 1,040 miles an hour. All those are calculations, right? whoever went and confirmed that the 1,040 mile per hour sun motion is actually a thing. Yeah, like I brought this up to Professor Phil, dude. He fucking flipped the fuck out. He didn't like that. Everybody at the Tropic of Capricorn gets cancer. They're under the sun on the solstice, right? Like, I don't know. How would I know that? Where is it? Where's the Tropic of Capricorn? How do you know when you get there? Well, because you're under the sun on the solstice. Like, it's fucking circular logic, right? Like, how do you know when you got there? That's like a lot of these things. They're like, well, if you go to this spot, you're going to see this. Well, how do I know when I'm at this spot? Because you saw that?
That's a good point.
Like the dude yesterday with China. He's like, prove to me China doesn't exist. Well, I'll prove it to you. Like, how would I prove it to you? How are you going to know when we got there? How are you going to know when you're in China? How can I prove it exists to you? You're either going to make up the name China and say, I made it up. Yes, China exists. Or you're going to ask somebody else, hey, am I in China? That's the only way to know if you're in China, right? You can't know you're standing on some dirt somewhere. How are you going to know that dirt is China dirt?
What did he say?
Oh, he was just
spiraled.
I don't even know. Yeah, it was kind of incoherent. He thought he had a gotcha too because AB cooked them, Radwin cooked them, or Professor Triangle, and like then he came up with that. Well, you can't prove China exists. Yeah, just because China's an abstract concept agreed upon by people that there's some dirt somewhere that everybody calls China, and if everybody died, there'd be no place called China anymore. He says, prove to me. He asked me to prove that to him. He asked me to prove that China would not exist if everyone died? I'm like, bro, I said everyone died. Me and you aren't here. How am I going to prove anything to you? Dude, it was fucking crazy. It was pretty funny though, in a way. It's funny watching their brain just turn into mush.
Yeah. It's like sometimes the video's buffering, but it never plays, you know?
Yeah, exactly. I just couldn't believe it, man. He was just like, I'm like, if nobody exists, China's not here. Prove that to me. I said, if nobody exists, that means I don't exist, you don't exist. I can't prove something to you if I don't exist. And I definitely can't prove it to you if you don't exist.
But yeah, for the record, I don't think it's a Mobius strip. Because then we'd have curvature. And
it's a Mobius strip that's so big you can't detect the curve.
It's a flat earth.
That's the funny one why they like circumnavigation. You'd have to turn left or right. Nah, man, it's a circle that's so big you just seems like you're going straight. Same shit they say.
Yeah, I don't think anyone would go for the Mobius strip because you'd still have like people on the opposite side. So flat earthers would be like, what's keeping them from falling? And globe earthers would be like, you know, it's too sharp of an edge.
Hey, Ish, why are you being so unoriginal?
No.
You're very unoriginal. Earth is, I mean, you gotta be some kind of genius.
What do you mean?
It's corny, dude. It's old.
What is? I didn't say anything.
What you typed in the chat.
No, I just random.
Earth is a square.
I mean, since no one is saying anything, might as well.
Well, I mean, I heard somebody saying that, like, because we can't use, there's some, like, alternative theories that can't be proven, so we can't use them. I don't know what theory he's talking about.
See, look, my point stands because look, I sent a random text and you responded.
And what's your point?
My point is the Earth is square.
Okay, what's your evidence?
Bro, what?
Hold on, CB. What's your evidence?
What do you?
Yeah, evidence. So we're empiricists. Claims
So
need
what do you-
evidence. Hold on. Claims need evidence. So what's your evidence?
Wait, let me. I'll give you evidence. What is your belief? Do you think it's different? Do you
I don't
it's
think the Earth is a square. I have no evidence the Earth is a square.
So what do you think it is?
What do you mean?
How did he start the sentence with "I'll give you evidence"? So what do you think it is? What?
I don't know, dude. I was just playing along. He's too
Yeah,
freaking slow.
before I give you evidence, I want to hear.
You don't have any evidence Earth is a square, okay? Just
facts.
What you're trying to do is get out of me is what my evidence is the Earth is flat. We've been playing this game a lot longer than you. You're not going to come in here and be clever because you're not clever. You're the dumbest person in this chat right now.
Oh shit.
Oh. Okay. It's fine if you think that way. It's okay. I'm not gonna.
Why would I think the Earth is flat? Why would I think that?
No, I'm simply asking you. Like, I think the Earth is square. Okay.
No, you don't.
And
no, you don't. You're trolling.
Yeah, you don't. You definitely don't.
I mean, what makes you believe that?
What? That the Earth is square?
Do you need evidence to like?
What makes me believe the Earth is flat? Well, let me ask you this. Why did people think the Earth was flat before they thought it was a globe? What was their evidence?
I never said.
Hold on. What was their evidence before the globe? What did they use?
What do you mean, like to determine if the world is flat?
Yeah. So before the idea of a globe was amongst humanity, people thought the Earth was flat. What evidence did those people that thought the Earth was flat use?
And how is that relevant to my question?
Okay, answer the fucking question, bro.
Bro.
It's a simple question.
But you didn't answer my question.
Dude, I asked you for, you didn't answer my question. I asked you for the evidence of your claim, and you've been fucking dicking around. These games aren't going to work, Ish. I'm going to just fucking mute you and kick you out of here.
Bro,
you know what that means? When I mute you here, you get muted in every channel. And when I kick you out, you can't even cry about it.
Why are you being so rude, though? Like,
okay, because you're playing games and you're trolling.
Okay, look, let's start over. Look, I'm gonna.
Yes, let's start over with not trolling.
I'm not trolling. Let's set aside.
Okay, then give the evidence here at the square.
Let's set aside my belief. Can we agree on
belief? We don't have beliefs here. We're not doing that.
I'm simply asking you, what do you believe in? What do you think?
I don't have a belief. That's what I'm trying to tell you. You're not understanding. We don't have a belief here. We all observe everybody. The Earth is flat and motionless. That's what you see every day. That's what you experience every day. If you fly in a plane, go up in a balloon, climb the top of a mountain, go to the ocean, the Earth looks flat and you don't feel it moving. You see the stars moving, you see the sun move, you see the moon move. You don't feel yourself spin. That's what we experience. I don't believe that. That's what we experience.
And
if you want to make up in your mind that something else is going on, that's on you.
Thank you for at least telling me what you think, because I wasn't going to disagree with you. If you wanted me to,
this isn't an agree-disagree thing.
I only asked.
I'm telling you, like,
what is your thought? Jesus,
let me ask you this: Does the Earth? If you go to the ocean, does the Earth look flat?
No.
You were going to say no? Yeah. If you go to a lake, does the earth look flat? If you go to the top of a mountain, does the earth look flat? No matter where you go, you can go anywhere on earth, the earth looks flat. Okay. Now, at some point in time, someone came along and said, oh, dude, it just looks flat, but it's actually a giant ball. Now, those people need evidence. Okay? They have beliefs. We don't. So the common thing globe earthers do, they try to drag us down into their cesspool and pretend we're on the same level. We're not on the same level. We have experience that we can refer to, whereas none of y'all do. You understand? There's nowhere you can't tell me to go anywhere on Earth and say this is where you'll see the globe, right?
And what about all the facts that the majority of facts that people present? What do you think on those? I'm not going to name
what facts are those?
Okay, let's start off with the wheel. You know, when they roll it and then forgot the name specifically.
The wheel proves the Earth is a globe.
What about the moon? The travel to the moon, looking back at Earth.
What? You think people went to the moon for real? You think human beings flew to the moon?
I'm asking you. I'm sure people have asked you this before, right? No?
Ask me what?
Same thing I'm asking. What about the proof of people traveling to moon?
Oh,
right?
the proof, you mean the claim? The proof that would be that they flew to the moon. Hold on, dude. The proof that people went to the moon would be the telemetry data that showed that the rocket went to the moon. But they claim they lost that. Yeah, NASA claims they lost that the telemetry data, the data that shows where the rocket actually went. You can easily Google this. Google lost Apollo tapes. So, where's that proof again?
Bro, that's crazy.
It is crazy, isn't it? You think I'm making it up? They actually NASA actually investigated NASA to figure out where the tapes went.
Man, this is my first time being in this.
There's a report on it that you can read that NASA put out about their missing tapes. It was 3,300 bankers boxes full of tapes that disappeared. That would fit a tractor trailer and a half. Somehow they lost them. This isn't my story. This is NASA's story.
And what about
the question is, why would you believe it?
Explain the weather at least. Try to
explain the weather?
How does that work in your...
Which weather? The sun heats the surface of the earth. And then we have differential heating. Okay, so we have convection currents.
Okay.
Right?
Mm-hmm.
Sun doesn't heat the earth evenly, right?
Okay.
We have currents. And because of all thermodynamic systems, meaning systems which have different temperatures and pressures, okay? They try to reach thermodynamic equilibrium, okay? This is what causes weather. Low pressure system, high pressure system, warm currents in the ocean, cold currents in the ocean, downward flows, Hadley cells, all these things are different properties of the weather on the earth. And it's just the system, the gaseous fluid system that we live in, trying to find a thermodynamic equilibrium, but that'll just never happen.
Okay. Okay. I'll hear you out. Now I have another question. Do you believe that there's satellites up in the sky?
Wait, before you ask the satellite question, can you kind of summarize what you think Indio just said?
No. Look, I'm gonna ask you. Question, right?
Why am I gonna give you Sheepdog's bringing up a good point? Why am I gonna tell you anything when you're clearly not listening?
I mean, when you ramble for 3 minutes, how am I gonna listen, bro? I can.
You asked a question and I gave you an answer, and it wasn't a 3-minute ramble. You're not listening.
Here, let me
Okay,
simplify
before the
it for
3
you.
minutes, let's take the first. Let's just take the
Yes,
first.
thank you.
10
Simplify it for me. Thank
Let's
you.
take the first
My
10 seconds
God.
of what I said. What was the first 10 words I said before I got into it?
It's even better if you write it in the chat. I'll read it carefully,
Yeah,
word by
you
word.
never listened. What do you mean? What about satellites? What about them?
Do you think
You got
they're
any
satellites?
primary knowledge about satellites, or is it just a story you heard?
I'm saying, do you think they're satellites? Do they exist?
You know, satellites are just repeaters, right?
Exist in what sense? There's things in the sky
Yeah,
that
satellites
we'll call
exist.
satellites. Even this goes all the way back to the 1940s. They used to fly these hot air balloons, and they called those hot air balloons satellites. The vernacular changed, but that's what they used to call them. Okay. It's part of a program called Skyhook, Ross, by the National Reconnaissance Office. I'll give you transcripts of freaking people talking about it in the National Reconnaissance Office about what they did. They put hot air balloons up. They had a gondola with a camera. They went to 120,000 feet. When their film roll was full after about 6 weeks, they'd fly up with an airplane, punch in a keep code, and an explosive would go off and pop the balloon, and they would catch it out of the air. They called those satellites. Okay? Now, satellites
look,
exist
I'm
in
not
the
gonna
sense
lie.
that there's things in the sky, but they don't
I'm
orbit
gonna
a globe.
I'm gonna interrupt respectfully. It sounds like fiction to me. Like,
The
because I
National
have never heard of
Reconnaissance
this.
Office is fiction.
Bro, what?
Okay, I'll post in the chat. It's from the National Reconnaissance Office, which is a U.S. government agency. You think
And
they
I'm
make
just-
spy satellites? They make spy balloons.
I'm going to simplify what India said about weather. The sun warms up the earth, and as the sun moves across the sky, the earth warms and cools, creating currents. And then there's also high pressure systems and low pressure systems in those currents. And because of that,
What do you mean by high pressure systems and low? Can you explain that farther? I'm not asking to like. I'm trying to be
The
reasonable.
barometric pressure is higher or lower.
Heat increases pressure, which expands, which decreases pressure, which causes dynamic.
Expands what? Expands what? The water volume?
Air, gas.
Yeah.
You know, gases expand when they're warmed up, right?
Yes.
Yeah. Welcome to flat Earth.
Why the
Yes.
fuck would you believe that Earth is a flat?
We don't believe it. It's true. How do we know?
You said, so you get.
So if
yeah,
I
I
said to you, if I said to you, I want you to prove to me the Earth is a globe, where do I go on Earth? Where do I go?
You can ride on a jet or like a plane. You can go like high in the sky and you can see the you can see the curve.
Looks flat to me.
No, dude, no. It's not high enough, dude. You don't see curve from an airplane. I don't know why you guys say that shit. Not even within, not even if the Earth was a globe, would you see curve from an airplane?
If
So
it
where do I
wasn't
go?
globe, no, I wouldn't.
Well, you couldn't tell me anywhere to go, right? So if you said to me, hey, where can I go where I see a flat Earth? I would just say Atlantic Ocean, Pacific Ocean, Indian Ocean, Great Lakes, or any lake, any pond, any body of water. So we don't believe the Earth is flat. We can see it is. Whereas the globe, you can't see that it's a globe. You just have to believe it. Or you have to believe somebody else that says that they saw it, but you'll never see it, right?
Okay. I have a clip on YouTube.
Tell me one thing I said that's not absolutely objectively true. There's nothing I said that's false.
I will tell you. I will tell you. It's if I show you this video.
Video of what?
It's a footage of the globe.
How do you know that?
Because it's someone who went to space.
How do you know that's what they're saying? That's what the video shows. How do you know that?
Because there's evidence and there's many eyewitnesses.
Okay, no. And we're talking about this specific video that you're going to give us. How do you know that that's what the Earth looks like in that video? That they went to space and then they took it. What if they went to space and the Earth's actually a freaking cube? Okay, so how do you know that that video is an accurate representation of the Earth and they did what they said they did? How do you know?
Because I've seen the curvature with other people.
Oh yeah, from where? We already covered this. I just did this. You already said from a plane, but that's not true. So where?
Yeah, from a specific height.
Yeah, what height?
If you're on a plane, you could look at it.
No, you can't, dude. Not even 128,000 feet. In fact, not even 250 miles. That would be 400 kilometers. Not even from there.
I flew at 45,000 feet from New York to Kuwait City, Kuwait, and it was flat. So what?
But if you want to observe it, you need to be like farther away, right?
How far?
But that's in a plane.
Can you give us the mathematics which will tell us how far? Of course not.
Okay. So you guys say that.
Now here we go, you guys. It's not about you guys, bro. You're gonna try and dodge the topic by talking about us or talking about the conversation. You guys are NPCs. You guys got the most predictable dialogue tree in the history of man.
Let me guess. You're going to ask the question if the Earth is flat, and then we're going to respond, yes, the Earth is flat.
Yeah. So this is.
What are you talking to?
We're just illustrating the horrible position that you're in. Is that you have that your worldview is based upon trusting a third party in their claims of what they think or what they say the Earth looks like. Now, not only is that a problem, but the main problem is that you can't evaluate that claim for truth because you've never seen the Earth from that point of view. So even if they show you an image that they say, that they tell you this is what the Earth looks like, since you've never seen the Earth from that place, you can't even say, well, no, the Earth don't look like that. I was there, and when I was there, it didn't look like that. Or it did look like that, right? You can't say that. Like, if you showed me a video of a horse, I could go, nah, that's not a video of a horse. That's a goat. I've seen a horse before. That's a goat right there. Right? So
I've been there.
You can't do that. No, now you're just lying because you're just desperate, dude.
No, you made a claim. I haven't seen it. I have seen it, yes, personally. I've been launched to space. What do you have to say now?
So just desperate lying, dude. It's so funny.
Am I lying? Prove it 100%. Prove I'm lying. Prove I'm
not to prove you're lying. You're trying to reverse the burden of proof. That's a logical fallacy.
Can you prove it? Can you prove it?
I don't need to prove it. You haven't presented any evidence. You disprove evidence. You don't disprove claims.
Which is more believable, observation or some mathematical bullshit?
Well, we have observation, and you don't have
proof. Everybody who's ever been to space. Why
are you pretending you have observation? We've demonstrated that you don't.
I've seen it. I have seen.
Yeah, you're lying.
Hey, I've got to wait for him to prove it.
Math can lie.
What's your name? What's your name? Everybody who's been to space. Everybody who's been to space, their name is listed. What's your name?
I was on a rocket that wasn't.
Yeah, give me your name. Give me your name and give me the rocket.
So, Nightmare, there's something called Hitchens' razor. What can be asserted without evidence can be dismissed without evidence. So, produce the evidence or shut up.
Do you think evidence is required to prove something?
Yes.
What if
something about the physical world? Yes.
Okay, cool.
You're making an empirical claim, and evidence proves empirical claims.
Okay. Do you think there are other planets besides the ones in our solar system?
Here we go.
Other than what?
Than the ones in our solar system?
Are there no?
No.
Why would I think there's planets other than the ones in our solar system?
I think there's none.
No.
You think there's galaxies?
There's no outer space vacuum, brother. There's no vacuum of outer space with things that are trillions of light years apart. That's fucking nonsense. He left.
Wow.
Well, we
By
found
the
out
way,
his real religion.
For the record, I'm not asking anybody to dox themselves, but if somebody's going to make an extraordinary claim like I've been to space, then your name's on a list somewhere, and so that's the way you can prove it right there.
Well, it's a perfect illustration of where they go. They realize they literally have nothing. He came in here like, yeah, I know the Earth's a globe, and realized he looked in his basket of goodies and it was fucking completely empty. Came to the picnic, there was nothing in his picnic basket.
Is he back?
No, different guy.
Anyway, no, you're right, and Hitchens razor, that's the absolute truth. Like, if you don't give evidence, I can dismiss it. That's how people conduct business all the time. Oh, my business does good. Oh yeah, prove it. Oh, I can't. Okay, dismissed.
Yeah, it's a matter of like pragmatism, right? If all claims are true unless you disprove them, then oh my God, bro, because you can claim everything. I saw a green alien, I saw a red alien, I saw a blue alien, I saw a purple alien, I saw a purple alien with frickin' fangs, I saw a purple alien with frickin' no teeth, I saw a purple alien with frickin' 3 eyes. Like, you could just endlessly make claims, right? And all of them would be true unless disproven. Obviously, that's stupid, so we don't do that as human beings.
Just like the sky is green argument.
Can you explain me the thermodynamic law and how it's related to the argument of flat Earth?
Gas pressure without a container? That one? The second law of thermodynamics? High pressure goes to low pressure? Is that what you're talking about, Diogenes? Diogenes?
Yes.
Okay, so
that's what I am talking
if the space is a vacuum, how come the gas pressure on Earth doesn't go into outer space? How come it doesn't reach thermodynamic equilibrium with the vacuum?
I don't know.
Exactly.
With
Neither does anybody else.
Wait. With energy, with something.
They'll say things like gravity does it, right? But that would mean that gravity could do thermodynamic work. And there is no gravitational theory of thermodynamics or gravitational thermodynamic theory that would allow that to happen. Because if gravity could do work, you would have it changing phases of matter, you'd have it turning frickin' solids into liquids and liquids into gas and then back based upon how much gravity there was. Okay? There's no mechanism. If I look at a phase diagram, right, where it's gas, solid, liquid, supercritical fluid, in a phase diagram like oxygen, they'll have the pressure and the temperature. They don't have the gravity. It's not in the phase diagram. Okay? But that would have to happen if gravity could create air pressure, it would also have to create temperature, right? So all these things, the pressure, temperature, volume would all have to work together, okay? And you'd have to be able to incorporate gravity into it, but no one's ever done that. So when you just can't say the gravity like it's some magic word that does it. No, you have to explain it within the thermodynamics, within the second law of thermodynamics. Because like the kinetic theory of gases, there's no gravity in any of that when we model gas behavior. So, science is empirical.
Yeah, I mean,
it's not based upon theory, right?
I always have the question about how the cohetes. Oh shit, I don't remember the name of this airplanes that goes to the space and are pushed. You know, are pushed with the fire. But if there is no, I mean, the fire without oxygen is torn off. You know.
Well, they say that the oxidizer is in the fuel, and that's probably right. But the thing is, inside the bell housing of a rocket, there's actually a negative pressure. So it's our contention that rockets push off air, and they can't push off a vacuum. But they'll say, well, the Newton's second law was a reaction has an equal and opposite reaction because it's throwing gas out the back. Then it has to go in the other direction. But that boundary between the gas and the rocket is a negative pressure. So how that could possibly work, I don't fucking know. It's just something they say. A lot of these things are just something that's what I was trying to get to. That science is empirical, which means it's based upon experience or experiment, not theory, not ideas. So if you have an idea or a theory, that's fine. But it doesn't mean anything until you go do the experiment. Okay? So you can say gravity creates gas pressure. You can say gravity holds the air to the earth. But can you demonstrate it in an experiment? And the answer to that's a big fucking no.
Yeah, that makes sense.
And then when you look at the history of outer space, the idea was invented in like 300 BC before anybody could ever before there could ever possibly be evidence of outer space. They were already thinking of it. They were already thinking of science fiction and people living on other planets and all this shit. Like we're talking about before the Roman Empire.
All right.
And then do you think they're just lucky guessers that they guessed outer space exists and then 2,000 years later we're just like, oh yeah, they were right 2,000 years ago. They're such good guessers.
Because, like, you guys, like, I'm gonna say this in, like, the nicest way. You guys live in here, right? You guys, like, do the shit for, like, a living, right? So if I say one thing wrong, you already have a whole fucking livelihood of, oh, no,
Dude,
he said this.
what are
No,
you
no, no.
talking about?
Let's go on that. So, like, I have to be as careful as I could possibly be.
Hang on a
Right?
second, dude.
Yo, that's
Right?
crazy.
Am I
What do you
wrong?
mean make a live? Yeah,
You
very
said
wrong. Your first
you
thing,
said you
dude.
guys have a
I don't,
livelihood in here.
I don't
Wow.
make a livelihood. I don't make a livelihood on this. The fuck
He's
you talking
embellishing
about?
to make a point, guys.
No,
I mean,
Oh,
listen,
yeah.
if you have experience like working on cars as a hobby, and then you go into a room with other people that also work on cars as a hobby, and then some guy who's never changed the oil before walks in and has questions, he's going to get the same experience that you're describing right now.
You understand how you just proved my point?
Yeah, we have experience having these conversations. What's wrong with that?
Yeah. So if, again, I say
It's
one
hobby.
thing wrong, and now you're making about changing a fucking
Well, be
car.
careful. Since you already know
Right?
how it works, just be careful, dude.
Yeah.
That's all I could do. Like that's what I'm doing. It's hard. It's very hard.
It's all
Right.
good,
So
dude.
again, if I say something like that, now I'm compared to changing a car's oil. You know?
Yeah. I mean, have you heard of a branch of study called cognitive linguistics?
You have 15 seconds to say whatever you want, and nobody will say.
All right. Well, cognitive linguistics basically is how words form your thoughts and how thinking forms words, and they're linked together. So what we find is that when people come in and they have very slippery and loose definitions, their thoughts aren't well defined. And so because we have so much experience having these discussions and we've refined how we use words to communicate these ideas, We've got experience using the right word in the right moment to convey the right message. And if you don't have experience talking about the subject very much, you're going to fail to have the right words. It's a completely normal thing, so don't get yourself down.
What's the opposite of that?
Well, just not having experience, not having a domain of knowledge and a lexicon to go with it.
Right, because I'm not here. You guys are.
Right. Yeah, there's nothing wrong with you, dude.
Oh, I don't think there is. I do want to bring up something that, because I do kind of like poke my head in randomly. I don't know who it was, obviously. I don't know you guys enough to know like who says what. Someone was talking about the idea of not being able to see the curvature of the Earth. And then when that person said that, like there was like not four, that's crazy. There was like two people saying, yeah, you know, bunch of nods in agreement. And then I did ask them, I was like, well, why weren't you able to? They're like, well, we can't go into space and see it. I was like, okay, fair enough. Left, joined back. Same shit happened. They were asking me, whatever. Brought the same thing. I was like, so if you're not able to see, so if you have to go to space to see the curvature of the Earth. See, I have to use my words so carefully. You guys are crazy. Holy shit, hold on.
No, you're starting to understand the logic, right?
No. That's
nobody's been to space to compare the pictures to.
I say one goddamn thing, and you guys are gonna rip my heart apart. I already know.
No, chill out, man. Come on. I mean, what you're forming is a thought that goes something like this.
See, I haven't even finished it, and you're already doing it.
Hey, I'm enjoying this, man.
I haven't finished my thought, and you're already ripping my heart apart. What do you?
I like this. Hey, Jay, I'm tagging you in, bro. I'm off the hook now,
You
man. It's
literally
up to
said
you now, bro.
no as you're doing it. Like, come on, you know? You guys are crazy.
I'm crazy good at
it. I can call you names now. Which one do you want me to call you?
If you have to go, I'm gonna say this very comfortably. Okay. This person said, "No, I have not seen the shape of the Earth because I haven't been to space, but I know the shape of the Earth because of where I live." Does the shape of the Earth matter?
Yeah. In what way?
For example, could it be big enough that because you live on it, you can't see the curvature?
Then why would you come to the conclusion that there is curvature than anybody else?
Because we have sent stuff outside the Earth to see it.
Who's we?
Me and you. Humans. Us.
Yeah, not you. Not me.
Yes, you.
No, I have not sent anything to space.
But if you tied a GoPro to a balloon and let it go up, what do you think it would show?
It would not be high enough to see any curvature, even if Earth is a globe. We can prove this geometrically first, and then we can compare the observations that have been done to the geometric claim. So at 120,000 feet, okay, the math works out such that at 120,000 feet, a camera can only see 0.1% of Earth's total surface area. If Earth is a globe, would you expect to see curvature? No.
I'm sorry. So again, I don't understand why lying is weird, right? We can all agree with that. Like if you have to lie about something, and that's obviously not true. So your whole point's wrong.
Be a flat earther any day now because you don't like lying.
You said
now that
what?
Now that you know the Earth is flat and you don't like lying, don't say you live on a globe anymore.
You said a camera can do what?
Said that we can compare the geometric plane to the camera image. If a camera shows you curvature of a globe at 120,000 feet, there's something wrong because it doesn't match what is possible geometrically.
Wrong with what? The camera?
Wrong.
Maybe the fact you're using a GoPro.
Yeah, wrong with the interpretation of what you're seeing. Because yes, if you are beginning with a GoPro, you have a barrel distortion anyway. You're going to see curvature of the Earth when it's sitting on the ground, dude.
Do it with your phone.
Same problem. It's a low focal length lens. It's a very low focal length lens.
Okay. So the issue is now with cameras. Okay.
Yeah, and technology. It's a very austere environment up there. Very few cameras that are designed for our purposes down here can survive the conditions that are up there. It's freezing freaking cold. It'll deform the lens. It'll freeze the sensor at a minimum.
Mm-hmm.
And that causes distortions.
Mm-hmm. That just sounds very convenient.
It's not. I mean, in order to build a camera that can withstand those conditions, you need to laboratory test it.
Do you think do you think a camera can't do that? That's
If I go, yeah, if I buy a camera that hasn't been, if I buy a camera that hasn't been tested in those conditions, why should I trust it? Listen, you know how cold it gets up there?
Yeah.
How cold does it get up there?
Like not by heart, right?
It's also a massive decrease in pressure, and that's the other thing.
Yeah.
So if you've got back pressure built within the camera because it was made at 14.7 psi, and then you go to an environment that's like half that.
Why are we making up PSIs?
What do you mean? It's pounds per square inch of pressure of the atmosphere. It's called 1 atmosphere, right? So if you go to a place that has half an atmosphere, like way up there.
Why are you making up PSIs though for the camera?
I'm not making up PSIs. What do you mean?
Okay. Where did that come from then?
A barometer.
What?
He's talking about
what
the
a
air
barometer
pressure,
is.
not to do with the camera, just to do with the pressure surrounding the camera in the air.
Yeah, and within the camera.
Up with the PSI.
You measure it with a barometer.
Right, and you're saying
You're going to lose this one. You don't.
You're
up it down a
saying
bit.
that can't. That PSI can't work with what?
I'm saying that the materials that went into the design process and the manufacturing of a camera was not intended to be used in an extreme low pressure environment.
Which camera? You don't know what camera I'm talking about.
Any camera that is designed for use by regular people in regular situations, like everyday use.
Those are not put in vacuum chambers and tested for low pressure. Those are not done. Okay.
That's what you're saying?
It's true.
Okay.
So just to simplify it a little bit as well. When you have a low focal length lens, okay, just say the horizon is right in the center of the frame, right? It's going to look like a straight line. As soon as the horizon goes above the center of the frame, the lens is going to distort the horizon. So it's going to look like it's curving. It's going to be convex. When the horizon goes below the center of the frame, it's going to look like it's curving the other way. Okay, so if you have a look in the side chat, I was recording some footage. I think I was flying over Alaska, and I was filming because I was like, damn, it looks so freaking flat. I just want to film it so I can show people. Then when I looked at the footage, I'm like, damn, it looks like there's some curvature there. And then I'm panning through the footage as well. Okay, and what you'll notice is that it looks like there's curvature there in this image, but the horizon's way above the center of the frame. When I pan down a bit or pan up a bit, so the horizon's below the center of the frame, now all of a sudden it looks like it's curving the other direction. That's what I'm talking about. But mathematically, you wouldn't be able to see any curvature even if the Earth was a globe from that height. It's just a lens effect that you're looking at here. Now, even globe Earth scientists that hate flat Earth, like Neil deGrasse Tyson, he said that even from the Virgin Galactic, right, the Richard Branson flight, it went up to 300,000 feet. He said he did the calculations, and he doesn't think you would even see the curvature of the Earth from 300,000 feet.
Yeah, we know how he calculated it. I mean, because if you have 10th grade geometry, we can teach you how to calculate it.
Yeah, no, that's what I'm saying. That's why I was being very particular, right? Because you guys, like you said, like you guys already have this like built out and like dead on, right?
No, I mean you're not talking to a bunch of like conspiracy theorist basement dwelling autistic kids.
Bro, I'm on.
I mean, many of us are approaching over the hill, if not already over it.
I'm on Discord.
Many of us have had technical backgrounds and have worked in fields of, call it science and engineering.
At work right now.
Did you guys see that?
Yeah, you're talking to a vacuum physicist right now.
Am I?
Yeah, not me.
Yeah, I know.
The other guy.
Yeah, I know. I'm aware. Trust me. Did you guys see that? How long ago? It was probably like almost 10 years ago at this point, where Red Bull did that like Felix Baumgartner thing. That was probably like about 10 years ago now, right?
Yeah, it's brought up in here about 20 times a day.
Yeah. Oh, my bad.
Oh, hold on. Let me enlighten him on something with that. So that Red Bull jump, it's called. It was sponsored by GoPro. It was sponsored by GoPro. Isn't that crazy?
Oh, I thought the main sponsor was fucking Red Bull.
Nope, it was both of them. GoPro supplied the cameras.
Yeah. Okay.
Yes, it was to show how cool their cameras are. That was a stunt for them.
Yeah.
That's all. Let's show you how
exactly. It's marketing, right? They used a type of lens that makes it look like they're doing something spectacular and that they're much higher than what they really are.
Right.
Okay, and if you have a look at the footage, hold on. If you just look up the footage right now on YouTube and just pan through the footage, you'll see the same amount of curvature when they're at the ground level. And then you'll also notice that when the horizon goes below the center of the frame, it's curving the wrong direction, right? It'll look like it's curving like a globe, and then the camera will pan a certain way, and all of a sudden it looks like it's curving like inside of a donut. Just have a look at the footage. It's just a lens effect.
What's the name of Elon Musk SpaceX? His
Starlink.
Starlink.
Yeah, they don't have cameras on them.
None that we can see.
Yeah, good point.
Right. Okay. Guess not. So SpaceX, right?
Yeah.
How would you guys, or not? I'm sure someone here like knows their path around the disk. Right?
Nobody's claiming
We don't think Earth's a disk. We don't
Well,
that's not what flat earthers think. No.
What is their path? And how does it make sense to you guys?
How are you going to validate their path?
Yeah.
How are you going to validate the path that they're taking?
Show me how the
Have you seen how many of them are supposed to be up there? I mean, pick one and then validate the path that it's taking. You could probably look up the claimed path and then just believe what you're being shown on a screen, but you're just going to have to believe that. So I'm not saying it's incorrect or fake or something like that. I don't even need to do that because you just can't validate it. I can't validate it.
You can't see it in the sky?
Dude, have a look at a map of how many are meant to be up there, and then tell me how many you go and see when you go look up at the sky at nighttime. You'll see none, right?
Yeah,
Occasionally, I've seen two. I've seen two ever, yeah. But if you look up a map, they're like freaking like littering all over the sky, everywhere, all over the world. Apparently,
I've only seen it once in person.
Yeah, I've seen it a few times.
I was living in Bend, Oregon, when I saw it over the sky. It lasted like 15 minutes, not gonna lie. It was just a straight shot of just lights.
Yep. Yeah, we can't really validate exactly.
I literally called my mom who lived in Salem. I was like, bro, you see this shit? She woke up. She was like, yeah, I did. I was like, yeah.
So check this out. 14 minutes past the hour in the text chat, I posted some screenshots from job listings. Nothing about what they do is anything that anyone can independently validate, because what they're doing is trapped behind top secret and above compartments.
This was like 5 years ago, what I was talking about, to be. Not trying to talk shit. It literally was.
Yeah, look at those jobs. If you want those cool jobs at SpaceX, you're going to need an above top secret clearance to work there. This means everything they're doing is inherently unverifiable, proprietary.
No, I'm fine. I already graduated. I'm good, bro.
Yeah. Yeah, so what are they doing? Nobody knows. Nobody in here knows.
Right. Right. That's the... Yeah.
Kind of convenient, right?
No, it's very inconvenient. I mean, yes, it's convenient because it's inconvenient. I'm just trying to think, like, how to... I just don't trust you. Everything else is round, just not Earth. I mean, that's one of the easiest ones to say, right?
Yeah, Earth isn't a planet in outer space. There is no solar system.
What?
That's right. Everything you believe right now about outer space is not true.
Pretty sure most people in here would disagree with you on that.
No, he's absolutely right.
There's no solar system.
Well, not in the sense that you've been taught.
There's no planets. There's no moons. There's no suns.
No, we have all those things. We see the same things you do, obviously.
Yeah.
But we don't shove how we think about them through somebody else's imagination.
I live there too. Of course.
When we look at the same thing you do, we don't have a story to go with it that we can't verify.
What do you call it? A solar neighborhood? A solar family? A solar hello? Goodbye?
No, all the lights you see in the sky, stars, planets, sun and moon, are above the Earth. The Earth is the floor of the universe, if you want to call it that.
Everything? All of it?
Yeah, Earth is the ground, man. It's the floor. Space is above, whatever space is. Yep,
what
those
happens?
things move in the sky.
Knowing this, what happens in space that you get excited about?
Super weird question.
No, I think so.
Sunrises, sunsets.
No, that's not space.
You've never been to Jeffrey Epstein's
That's not
spaceport
space.
before?
That's not space. What in space do you get excited about? I'm actually
Jeffrey
just asking.
Epstein spaceport.
You think space is just completely 100% figured out? What do you get excited about?
Nobody said that.
The opposite. It's a mystery.
Apparently not, because every time someone talks about it, you have a whole explanation why they're wrong. It's not that big of a mystery, then, is it?
It is a complete mystery.
Well, no, because every time
Yeah.
someone tries to talk about it, you have your own little thing that you
Because
say
they're
no.
making up BS. They're coming at us with unverifiable claims and stories that we know are not true because what space is purported to be, how you believe it, how we were taught,
You're trusting
violates
this
every law
Discord
of
server
physics
over
that we can never
NASA.
test in reality.
You're trusting this Discord server over NASA, and who has what are you saying?
I'm not trusting anybody. I'm telling you that the outer space
Yes, you
vacuum violates laws of physics that we know and can test and prove to be true.
This Discord server is against NASA.
Can you tell
And
me
you're
which
okay with
law it
that.
violates, please?
What do you get
Principally,
excited
the
about?
second law of thermodynamics, dealing with
You're
entropy.
Again, lying.
Because you're going to have to explain that gravity reverses the entropic process of gas expansion, of free joule expansion of gas in a vacuum.
Yes, sir. And then
That's what
once
you're
I
going to have to
do-
claim if you
Yes,
believe in
sir.
heliocentrism.
And then once I do, I'll have to explain entropic gases, and then I'll have to explain 2,000 different things, and I'll have to explain again and again and again and again. I'll have
Just
to
one
explain
time.
everything.
All it takes
You
is one
can't-
time.
You can't explain one thing because you'll always have another thing that you want to be explained.
We can stay on one topic if you want. Which one do you want to stay on?
The very first one that I brought up.
Hold up. Do you understand why Mars
Do you
is
remember
a
what that
frozen
was?
death hole?
Can you say that again, please? I'm sorry.
Do you understand why Mars is a frozen death hole?
Because it's further away from the sun and
No, not
doesn't
you,
have
dude.
the.
Not you.
Oh, my bad.
The other dude.
By laws is a frozen death hole? What?
Mars, the planet, is a frozen death hole. Do you understand why?
Prove it.
What do you mean? Do you think Mars has land on it?
Fucking God.
No one said that.
Mars has land on it?
Yeah,
It's
do you
literally
think you can pick up dirt from Mars and bring it back to Earth?
What the fuck does that have to do with my fucking question?
It's a yes or no question, dude.
I would like my
Everything.
answer first.
It has to do with your cosmology, and I'm trying to get to the bottom of
What? The fuck does this have to do with cosmology?
Try to keep up.
it. Discussing how we think about the universe.
He asked a question.
Hold up. So me asking you a question about Mars refers to the whole entire universe. Is that what you're saying?
Yeah, did you not appreciate my Socratic answer?
No.
I'm sorry.
Sorry. Answer
You
still
think
no.
Here, I'll make it easier for you guys so you understand because he sometimes talks right over you. You think Mars is a dirt ball floating in a vacuum?
No, that's not what my question was.
I told you it was the green
Yes or
button.
no answer.
Hold up, I'm turning off a PlayStation 5. Okay.
Yeah, the question attacks your premise before you got your premise even out. Again, we're good at this.
Are you denying the existence of Mars?
No, I'm asking you for evidence that Mars is a dirt ball in a vacuum.
I never claimed that it was a dirt ball in a vacuum.
Then why would it be frozen? What's being frozen?
Okay, so.
Oh, okay. Oh, yeah. See, told you. I can see the future.
Can we make an observation
Does
on
this guy
the
speak for you?
temperature? Let's just say using infrared or just detecting particles that's on Mars with the telescope?
Yeah, how do you go from that to proving that it's a
No.
frozen
Are we
ball of dirt?
able to do that? Are we able to do that? Yes or no?
Yeah, we can make observations using technology. Yeah.
Yeah, so we can determine temperature. Yeah.
Depends.
It depends on what.
It depends. Well, I mean, do you know what the medium is between you and Mars?
Oh fuck.
Yes.
Oh yeah. Oh crap, he got me. Yeah. Did you know that space is 99% plasma?
Medium between us. That's not how we
Space
measure.
is
We don't
99%
measure
plasma.
Earth or Mars
Can you
with a
provide a source?
Yeah. How about Dr. Hannes Alphen?
No. Provide me a source.
Yeah, I'm gonna explain the source.
No.
Dr.
Give me a study. Give me a study.
Yeah, I'm going to explain it and then I'll post it. Dr. Hannes Alphen, he's a NASA scientist.
Is he?
Okay. He developed a paper and gave a seminal talk called Double Layers in Plasma Physics.
I remember.
Along with that, he also built in his laboratory a plasma sheet simulator. He addressed the entire world of astrophysicists and shamed them because they did not understand circuit theory, magnetohydrodynamics, plasma physics, or anything else, which he says constitutes 99% of what outer space actually is, and derided them for believing in gravity, which is 10 to the negative 39 times smaller than the Coulomb. So in Double Layers of Astrophysics, he describes this environment and provides numerous sources and references. Again, a NASA scientist. Would you like to see the paper? It's about 300 pages.
I wish he was my dad.
Give me the paper.
Okay, hold on.
Like, do we just forget? Like, do we forget real life at what point?
The guy who wanted to talk about Mars doesn't know anything about Mars.
Yeah. Yeah. This is why I was saying, like, I was afraid to like say something because
What the
like
fucking conversation's about?
you asked him a question about that, and now we're talking about who? Exactly.
Science fiction is not
Like
real life.
that's why. Like they
He asked him to back his claim up and with a citation, and that's what he did. And then he explained the citation, and now he's posted.
Fuck up, nigga.
That's not how
Okay,
it
yeah,
started.
all right, brain rot.
That's not how it started.
Yeah, we're not at the start anymore.
I've never heard about this plasma theory, so I'm interested.
We never will be with you guys. Always at
You
the
don't
end.
just stay at the start of a conversation throughout the entire
I'll first
conversation.
validate using chat, and then I'll read your paper if that's okay.
You refuse to
Do whatever you want, my friend.
And
what we're looking for is a measurement of Earth curvature. That's what we need, right? Because when we go out and test the surface of the
We're not
Earth
talking about
over
the flat
large.
Earth right now, dude.
Oh,
the subject matter.
hold on a second. Hold on a second. Procomi, if you interrupt, you're just going to get muted. Simple as that. I just got to push a button, and you get a little red thing next to your name, and you can't talk anymore.
Yep.
Right? The topic of the actual room is flat Earth, right? This is 24/7 flat Earth.
And you explained it because you said what we need. You explained it yourself. Thank you for.
Hey,
saying it
Master,
that
if
way.
you do want to actually have a
What
conversation, I'm
we
more than happy to have a
need.
conversation with you.
You
by the way.
said we twice. Yes.
I'm interested
You
in
guys
this.
are literally a group of people and who are in this. What we.
Yeah. What else would we be besides a group of people?
Yeah. And that is just. Yeah. Okay.
So please don't talk over each other, Procomi. Jay was speaking. Please stop talking over him.
Oh no, that's not true.
Double layers.
You weren't. You're talking.
Double layers. Pump.
No, I was talking.
You can read that out in your own mind, Procomi.
Yeah,
If you have something to add.
for him, and how he's
When
Yeah,
you
running
use
it
the
through
word
ChatGPT.
we as a group, yeah, you guys are more. You're not. This isn't.
Yeah, we're
science
something else,
that
right?
way.
Let me read a quote from the paper, okay? What Dr. Hannes Alphen was saying.
I
Yeah, I
don't know who
posted it in
that
the
is.
side chat for those who
Go
want to read.
ahead, Obi. I
Okay,
trust
so he's deriding again this community of theoretical physicists, where he himself is an applied physicist. He says the conclusion is that the astrophysics is too important to be left in the hands of the astrophysicists. The billion-dollar telescope data must be treated by scientists who are familiar with laboratory and magnetospheric physics and circuit theory, and of course, with modern plasma theory. At least by volume, the universe consists of more than 99% of plasma, and electromagnetic forces are 10 to the 39 times stronger than gravitation. Incidentally, that's why they never found the graviton.
No, so hold up. I see what you're getting at, but you're confused, okay? So
Okay, enlighten me, because I've read this paper.
Yeah, so it's that matter itself. So ordinary matter is 99% plasma. But not every point in space is filled with plasma. Okay.
By volume, right? By volume, it says.
Yeah. So something
Right,
like
so-
dark energy or dark matter makes up about.
Oh, that's something for real? Seriously? No, dark matter and dark energy is why you don't have curving space-time at microscopic and macroscopic levels.
Could be. I still don't think we understand what dark matter is yet, though.
Yeah. So why are you claiming it? All right, so here I'm going to post
Well, we
something
know
else
it's
here for
there.
you.
We just
okay?
don't understand what it does.
So-
Like we can observe
Right.
it.
So you think you know what satellites are. If I go to the NASA Goddard Space Flight Center to do satellite tracking and queries, if I scroll down, I want to query a satellite. If you can explain what this means to me, that'd be awesome. So if you want to query a satellite, it says the trace query identifies periods when one or more spacecraft are on the same magnetic flux tube of force, or periods when one or more spacecraft occupy a field line which traces down to a specific ground station. And you think everything's using gravity.
Okay, so given that you've used a NASA source, I'm guessing that entitles me to use NASA sources as well, yeah?
Yeah, and we can see if they conflict with each other. Because if they conflict with each other, how do you evaluate which one is true?
Yeah. So, yeah, what the individual was talking about, it wasn't space itself, but just matter in general is made out of 99%.
Space by volume, excuse me?
Space by volume. Space in general is majority
Yeah,
of
he
it
talked
is
about the
empty.
volume.
That's what it literally means.
He talked about the
Twice
volume of
space.
space. And this becomes obvious when you actually read the rest of the paper, at least the first, 20 pages.
What was the guy's name? I don't want to click directly on your link. I've been
Hannes Alphen.
Thomas what?
Hannes, Hannes Alphen, Alfven. The inventor of the Alphen drive discovered Alphen waves.
Okay.
He founded a whole field of physics called magnetohydrodynamics, upon which modern satellites are claimed to operate, as well as all the electrodynamic propulsion technology that's been done by NASA since the 1970s. For example,
Wait.
did you know that the space shuttle, hold on, I'm almost done. The space shuttle, one of its missions was to test the plasma sheath. And when those shuttle bay doors open up, a gigantic steel beam raised up and would shoot off a tether with a pod at the end. And this tether would extend miles. And they would use the magnetic flux of Earth in order to propel the space shuttle and to do braking in space, to slow down and power capacitors.
So I'm seeing Williams and Moorhead as the actual publishers of it. What did
The
you say
beginning of the papers is by Hannes Alphen, where he's part of the team. He's addressing a group of people at a conference, and this paper came out as a result
one of the
of that.
authors, or is he just one of the researchers?
Well, if I guess he's not a publisher. He would be the guy that those researchers went to. He would be the mentor of those who published the paper.
Okay, so now
Yeah, he's that guy. He's not some lowly dork. He's one of the most amazing physicists of all time.
Oh wow, this fucking
He
form.
died in 1995.
What was his last name?
Alfven. Alfen.
Oh yeah. Original.
All right, I gotta go.
So
I'll
it was
be
part of
back
the
in 15
committee.
minutes.
It was part of the committee, yeah. In the paper.
So listen, buddy, you said you just checked that today, the parallax thing, though. Can we maybe bring you back to a more fundamental question, like, what we were speaking about, the surface of the Earth, right? The surface of it. If you were standing on a globe or a sphere, you're standing on it, right? That's what you believe. You're standing on a sphere.